So team, from here we are going to start. All right. So earlier days, if I talk about any IT organization, how they used to deploy their application. All right. So we are going to start from the very beginning. All right. So earlier days, we used to have some physical servers. Physical servers means physical computer, you can say. All right. We used to have some physical computer, physical servers. All right. And there, if we want to deploy our application, we put some operating system, whether Windows or Linux or any other else. All right. Then we install Java over that. Then we install Tomcat, your application, and then your application jar or war file. Okay. This is how we used to deploy your application on the physical servers in the earlier days. And your physical servers were quite heavy. All right. For example, they were 36 core of CPU, 500 gigs of RAM, 2 terabytes of disk space. These types of configuration were there on the physical server. All right. So team, if you have worked on the Tomcat application, can anybody tell me how much RAM utilization it normally takes for a Tomcat application to run? Any brief idea, not the exact figure. Anyone? Okay, Shiju, 4 gigs. All right, got it. Ganapati Sundaram. Okay, long name, nice. Minimum 16 to 32 GB. Okay, that is on a higher side. 5 gigs. All right. Okay, got it. So that is the case, right? Okay, Shiju, T2, medium instance. Okay, you went to the instances. All right, great. Okay, so yes, team, a Tomcat is a very light application, not very light, but still it doesn't need your 36 gigs of CPU, 500 gigs of RAM, 2 terabyte of disk space. All right, so that is not required by a Tomcat application. So the thing is, with physical servers, there was a lot of wastage of resources, because if I'm running a Tomcat application on this server, I cannot run any other Tomcat application on the same server, on the physical server. All right. So there was a lot of wastage of the resources, and we used to have heavy servers, because you don't know when your application is going to get heavy. All right. So that is why, for the safer side, we have very heavy servers. But initially, there is a lot of wastage of resources. To move over these challenges, we move to virtualization. Okay. In virtualization, we have hardware level virtualization. What is that? For say, I hope most of you have already worked on that. Consider I have a laptop. This laptop have 36 core of CPU, 500 gigs of RAM, 2 terabyte of disk space, same configuration. All right. And I want to run multiple similar kind of application on this laptop. Right? That is my requirement, because I don't want to waste any resources that we used to waste in physical servers. To overcome that challenge, some organization came up with a solution, and those organizations were called VMware and Oracle. Oracle product is VirtualBox. Okay, so they started providing virtualization. And what is that virtualization actually is? If you have a physical server, or you have a physical laptop where you want to run multiple applications of similar environment, they used to provide you virtualization. And if I'm talking about VMware and your VirtualBox, these are the software that provide you virtualization. All right, and they are actually called hypervisor. So if you want to have some hypervisor, you're going to have some product like VMware or VirtualBox that is going to provide you virtualization. But what exactly the virtualization is? On this single laptop, I can have multiple machines, multiple virtual machines. They won't be actual physical servers, they won't be actual laptop, but I can create virtual machines. Okay, so that is your hardware level virtualization, or hardware level division of your resources among multiple computers on your single laptop. So earlier I was having a single physical server, now I can have multiple virtual servers. For example, I'm going to run a Tomcat application. Okay, in in that Tomcat application, I don't need all these resources. How much resourcing I need? I need 2 core of CPU, that's all. I can need hardly 5 GB of RAM, that's all. Okay, that is what I'm using. So what I have done, I have taken this much resources from this pool and assigned it to one virtual machine. That virtual machine can be of any flavor. It can be a Windows or Linux or Alpine or CentOS, any flavor, whatever you want. You just need some image for that. Okay, so then you're good to go. So you are not wasting the complete pool. You are just taking that much you need, and other resources are available to create multiple virtual machines. Alright, so you can run one application of Tomcat and one application of Nginx on the same computer with virtual machines which don't have any interference with each other because they are running on separate virtual machines now. And that's how you can create multiple virtual machines for your multiple application on the same machine using the same resource pool. Alright, and these virtual machines are complete operating system. Means if you are running a physical server and if you are running any virtual machine over your physical server, it is going to be heavy as well because it will have complete operating system of your CentOS over your physical server. Alright, so we were able to remove the challenges that we face in physical servers, but still some challenges were there in your virtualization. And what were those challenges? So here they are mentioned. For example, first challenge was your reboot time. So team, if you're going to reboot any virtual machine, it is going to take some time. Alright, depending on your flavor that you have chosen, it might take 2 to 5 minutes or 10 minutes as well for a single machine reboot. Alright, and we are in the era where we want negligible downtime of our application. If I'm running an application, I don't want any downtime. I want my application to be running 24/7. Alright, so if we talk about business, even the downtime of 2 to 5 minutes or 10 minutes is having a large impact. Alright, so reboot time was a challenge and we don't want that much of downtime of our application. Alright, second is your full operating system. Full operating system means, as I told you, if you are running a CentOS virtual machine, we have to download a image, alright, and that image is going to contain the full operating system. So those are actually heavy in nature. If I'll talk about any basic image of any basic operating system, it can range from 1 GB to 2 GB or 5 GB as well. So those images are actually heavy. Cannot increase it in the real-time dynamic allocation. Alright, for example, your application is running on this virtual machine. Your current allocation is 5 GB of RAM, but your load increased on your Tomcat server, on your Tomcat application. Your load has increased and your 5 gigs are completely exhausted. So in that case, you cannot increase the RAM assignment to this virtual machine on the go. Okay, you have to bring down this application and then you have to restart your server, and then you are going to assign more RAM. You can make it 5 GB to 10 GB or 20 GB as per the availability of your pool. Alright, but you cannot go on the fly for this. You have to take a reboot, and as I told you, reboot take 2 to 5 minutes or 10 minutes. So consider that your application is heavy, your application is in much demand, you have a good traffic on your application and your RAM is exhausted. So you have to increase the RAM allocation and you have to reboot your machine and take a downtime for 5 to 10 minutes. And when your application is in heavy demand, there is a large traffic. So how it is going to work? We don't want that. When our application is heavy in demand, we don't want to take an unplanned maintenance time at that point of time. So that is also a challenge with your virtualization. Next is your scalability. Scalability means consider that you want to create exact replica of this virtual machine with another virtual machine. You just want to do the load balancing for say, alright? So what you want to do, you want to do the load balancing. You have one virtual server and you want to create another virtual server. So it is going to take time. Or consider that you have all these resources and your pool is exhausted now. Alright, in that scenario, you have to bring down all the machines all together and you have to increase the allocation of your server. Then you have to allot allocation to the virtual servers. And again, it is going to take some downtime for all the machines. Okay, so team, these were the challenges with your virtual machines which we wanted to overcome. Alright, and to overcome all these challenges, your containers came into picture. Alright, so your containers are in the picture now, which has eliminated all the challenges in your virtual machine. Alright, we are going to discuss about them so that it is clear to you. Again, considering that we have the same physical server, 36 core of CPU, 500 gigs of RAM, 2 terabytes of disk space. Alright, we have the same server. Earlier, we used to install your hypervisor, your VM player, or your VirtualBox. But now we are going to install some container runtime engine. Okay, it is called CRE. We are going to install some container runtime engine. So what is it? It is exactly similar to your hypervisor if you compare, but these are the different software. At hypervisor, we have softwares like VMware, your VirtualBox. At CRE, we have some softwares like Docker, Rocket, Trio. Alright, so these are some containerization tools that I have mentioned here: Containerd, LXC, LXG, Rocket, alright, and Docker. Docker is the one which is in most demand. Alright, there are other as well. Some organizations are using different CRE as well, but we are talking about Docker here because this is the one which is in most demand. Alright, and here we used to create your virtual machine where we have to give fixed allocation of resources. Whenever we create them, whenever we reboot them, we have to give a fixed allocation. But in containerization, we don't do hardware level virtualization. In containerization, we do OS level virtualization. How is it different? It is different in a way that if I'm going to create a container, it is going to behave exactly the same as your virtual machine. Okay, so you can consider that your container is exactly similar to your virtual machine if we talk about the functionality. But where it differ? Alright, first major difference lies in your OS level virtualization, and it means that you are not going to share the resources in fixed definition. You're going to use the OS as a fixed definition. For say, if I'm going to create a container of RHEL, okay, Red Hat Enterprise Linux. So if I'm going to create a container, then I don't have to give any fixed assignment that it is going to take 5 core of CPU, it has to take 20 GB of your RAM. Okay, I'm not going to give any definition like that. If I'm creating a sushi container, again, I don't have to give any definition like 5 core of CPU, 20 GB of RAM, or 5 terabyte of disk space, or any kind of configuration I don't have to give. So how they are going to work? So team, they are going to work exactly as any application runs on your system. Okay, so how any application runs on your system? Consider I am having a Google Chrome, I have a Skype, I have a Teams, I have Outlook. How they use resources on your laptop? We have a large pool, and these resources take as much as they want in the real time. They are dynamic in nature. Alright, consider I am using Google Chrome. At now it is taking less space, less resources, but if I open multiple tabs, it is going to consume more resources. Okay, so it is dynamic in nature. Similarly, your containers are too. Okay, your containers by default take negligible resourcing to stay alive. Alright, this, my Google Chrome is running. As of now, it is taking this much of memory. It is running using this much of CPU. Alright, if I open more tabs, it is going to consume more memory. It is going to consume more CPU. If I'm going to close all the tabs, if I'm going to close your Chrome completely, it is going to release all the resources to the pool. so that other application can take care of that. Okay. Similarly, your containers do the same. Your containers take negligible resourcing just to stay alive. If your application is having a load and your traffic is increasing, they are going to take the resources from the pool dynamically. You don't have to do any reboot or anything like that. Okay, so that is one thing. Another thing is your containers are not complete operating system as compared to your virtual machines. Okay, for example, I'm running a Red Hat container. Okay, so this Red Hat container is also going to have some image, but that image is not going to have a complete operating system. It is going to have just the basic libraries or binaries of Red Hat so that you can have a similar environment for Red Hat Linux. Okay, consider this virtual machine is on Windows and I'm running a Linux container. So that Linux container is just going to have the libraries and binaries of your Red Hat, just that so that you can have the environment of Red Hat Linux. It is not going to have a complete operating system. It is going to use the OS level kernels from your server, physical server. Okay, so what advantage does it provide? First advantage, as it is not a full in nature. When we are talking about your virtual machines images, which ranges from 1 GB to 2 GB, your images in your Docker containers hardly takes few MBs. Okay, we have the lightest images with 50 to 100 MB as well. Okay, so they are quite light in nature. That is one benefit. Another benefit, as it is not a complete operating system, the reboot time has downgraded significantly. Okay, the reboot time in your virtual machine ranges from 2 minutes to 5 minutes, but in containers, your reboot time is a fraction of a second. Mark my word, fraction of seconds. Okay, not even a complete second it takes. It reboots just like that, within a second. So these are the beauty with containers. Okay, so we have the most demanded Docker container. All right, we are going to have a few labs also on that, so that you can have a good idea what basically a container is. So team, any question till now? Any question you want to ask? Gaurav, you are asking how many containers we can have in a machine. You can have n number of containers in your machine. Just consider it like as an application. You can have n number of application in your laptop, right? You can install n number of application on your laptop until and unless your physical resources are exhausted or your CPU cores or any other resources are exhausted. You can have n number of application. There is no limit like that. Thanks, Anome. Sanjay, can we run Linux kernels if we are talking about OS level virtualization? And if you have your operating system as Windows, you can have your Linux containers. And Linux containers doesn't have Linux kernels. It has Linux libraries and binaries only. Guru Nathan, don't mind if I call you Guru Nathan. All right, you have a long name, so Guru Nathan will be convenient. All right. So you're asking what is the purpose of hypervisor in the virtualization? Guru Nathan, the purpose of hypervisor is to provide you the virtualization. If you have a laptop, I cannot create a virtual machine like just like that. I cannot divide my resources on my physical laptop just like that. I need some software, and that software is hypervisor. Sanjay, yes, we can run a Linux container on a Windows machine as well. All right, because at the end of the day, nowadays your Windows laptop are also using Linux kernels at the backend. That is what happens. As containers will have partial, then to what extent or to what part of the host will be utilized, Gopal? Okay, So Gopal, yes, as you already said, it is a partial operating system, and I already told you that your partial operating system contains the libraries and binaries of your operating system. Okay, so it is going to give you a look and feel of your container. All right, so if your container is running on the Linux, it is going to give you a look and feel live or with the libraries and binaries and all the requirement of your application. Whatever your application requirements are with the libraries and binaries, your container is going to fulfill them. Otherwise, all the kernel parameters, all the hardware level resources will be taken from your full operating system at the backend. Sarath, you're asking, will you be covering Windows pods creation on a Kubernetes master? Sarath, no, we don't have your Windows containers as of now. All right, we have your containers of your Linux flavor only. All right, and these are the containers that you will be dealing in your examination as well. Okay, so everything will be done practically on your Linux environments. Adjudicator guest, you're asking, so what is different with physical? Looks like it's almost same because we have done hardware allocation and we can put application on the top of the OS. Please correct me if I'm wrong. The difference is that you can run multiple application of the similar nature. Okay, if I talk about your physical server that you are not using any virtualization or containerization, if you want to run a Tomcat application, you can run only one Tomcat application here because it is going to occupy some ports. Okay, so the port that is taken by default from the Tomcat, it is going to occupy that port. And if you want to run any similar kind of application on the same server, you cannot because that port is occupied. So for that purpose, we need virtualization. We can run multiple Tomcat application with the port availability on the virtualization. All right. Sarath, master is on Linux. Your master and your worker nodes all are going to be on the Linux flavor. Yes, Sarath, I understand that you mean creating Windows pod, but no, that is not we are going to cover in this. Okay, Windows pod or Windows container, you can assume it's same. I'll discuss more on pods and containers as well in the coming session, but not right now. Can we run Sri Rama? Can we run Linux container on Windows host without virtual machine? Okay. Okay, Sri Rama, you have mixed everything totally. Okay. If you want to run Linux container or any kind of container, you used to have your hypervisor, sorry, not hypervisor, not virtual machine, you need to have some CRA. Okay, so yes, you can do with your CRA on Windows. Kushagra is asking the difference between Alpine and normal Ubuntu images. Okay, Kushagra, there is no much difference. Just Alpine images are very light in nature. Okay, they don't have all the functionality. For example, in your Ubuntu, you have your bash prompt. In Alpine, you don't have bash, you have shell prompt only. Okay, so Alpine are light in nature, and because of that, they have limited functionalities. But Ubuntu has full-fledged functionality of your any Linux flavor. Okay. Kabil, yes, we can install your Kubernetes on Red Hat version as well. And if you want the steps for that, I'll provide you that. Okay, no worries. Ashok, you're asking containerization is a hardware. No, containerization is a software per se, where we install CRE. Containerization is a concept, okay? Ashok, containerization is a concept. Like virtualization was a concept, okay? We used to have hypervisor, your VMware VirtualBox. Similarly, in containerization is a concept. It is not a hardware. Where we are going to install your CRE. CRE is your Docker or any other software that is going to allow you to create your container that will share your OS resources. Mosomi, you are asking use case of containerd and Docker. Okay, Mosomi, both are providing you containers. For example, if I give you a very basic example, if you want to have some operating system, you have n number of not n numbers, all right. Like if you want to have a Windows laptop, you can have your Windows operating system. If you want to have a Linux flavor, you have your Linux flavor operating system, like your Red Hat, your Ubuntu, your Sushi, your CentOS. All right. So you have multiple flavors. Similarly, your Docker and Containerd are two flavors of your containerization. It is your call with which you want to proceed. Okay. It depends on the organization what containers technology they want to use. If they want to go with Docker containers, they can go with that. If they want to go with the Containerd containers, they can go with that as well. Okay. Both provide you same thing, but by the different vendors. That's all. All right. So team, I'll be asking you to hold on your questions now. All right. Let's proceed a little bit further so that we can understand all these things practically. Okay. And I guess in the previous trainer also asked you to have your GCP account ready so that you can practice here. All right. And the reason is that why we prefer GCP over AWS, because in AWS your free tier allows you to create very limited kind of resourcing. Okay, so if you want to create any EC2 instances, you're going to have 1 core of CPU, 1 GB of RAM and a free tier. If you're going to create any heavier machine, it is going to charge you. And that is why we prefer GCP, because here you can create a heavier machine as well within your credit limit. Okay, so that is what we are going to use. So let me create a machine here. I show you that how configured machine we are going to use for our labs. Okay, so for say I'm naming it as a Docker machine. Let me change the region as well. Okay, so for the practical purpose, we are going to use 2 core of virtual CPU and 4 GB of RAM. The image we are going to use will be Ubuntu. Not Sushi, Ubuntu. Okay, so when I gave my examination of CKA, they used to provide Ubuntu only. Nowadays, they are also providing Ubuntu only, but at that time it was providing Ubuntu 16. Okay, so I guess they are moved to Ubuntu 18 now. So use Ubuntu 18 machine, select. We are going to allow full access to all cloud APIs, and we are also going to allow HTTP and HTTPS traffic. That's it. This type of configured machine we are going to use for our practical purpose for all the machines, whether it is your Docker labs or your Kubernetes lab. Okay, so team, I'm going to give you a few commands so that you can have a basic understanding about containers, and then we are going to jump on the Kubernetes part then. Okay, looks like our machine is ready. We are going to connect from right here. Okay, till the time it is making connections, I want to share something with you, all of you. Onome, yes, you can use your CentOS servers also, but all the labs will be based on Ubuntu. Okay, I'll be doing everything on the Ubuntu. If you want, you can go with the CentOS also, and if you want steps for CentOS, I'm going to share that also with you. Okay. Why not Docker Swarm, then Kubernetes? Okay, I do take a guess. I'll come back to your question. Okay, as of now, we are just discussing about your containerization, your containers. Once I'll start with container orchestration, then I'll answer your question, difference between Docker Swarm and Kubernetes. All right, so team, one thing that all the content, all the things that you already have with your LMS portals are definitely with you. All right, all the course content, all the video lectures, all the prerequisites, everything you do have on your LMS portal, and it is more than enough for your practice. Okay, but I want to give you something more than that. Okay, so team, this is a GitHub repository that is going to help you with all the labs. Okay, everything that I'll be sharing, every content that I'll be doing, every lab, every project, everything is here in this repository. Okay, so this repository I'm going to share with all of you. It is an open source library in the GitHub. Okay, I am pinging this in the chat box. Okay, so team, this is the repository that I have shared with all of you, and this repository is going to have all the things that you need for your examination point of view and for your practice point of view also. All the test cases, all the YAML files, all the syntaxing, everything. And during the class also, I'm going to refer to this repository so that you can know how you're going to use this repository for your practical purposes. Okay, so I have pasted this in the chat box. I request you all to have it copied and bookmarked with you. All right, consider you want to understand more on Dockers. All right, so you do have everything in your prerequisites, but if you want, you can refer to this repository as well. So here is a folder called Docker. If you want to know how you're going to install your Docker, there is a file called install Docker manual. All right, so team, as you can see, if you want to install Docker on Ubuntu, these are the commands that you want to use. If you want to install your Docker on CentOS, these are the commands. Okay, so some of the people, Onome and some few other people were also wanted to know that how you're going to do the things on CentOS. This is the repository for you. You can use this repository and have your commands ready with you. All right, so what I'm going to do, I'm going to quickly install your Docker on this machine. Okay, nothing much it is doing. It is just doing the apt get update. If there is any Docker components previously installed on the server, it is going to remove it first. Then it is going to update your machine. Then it is going to install some transport and certificates for your Docker. Then it is going to copy your Docker image, your Docker software on your server. And then it is going to update it. And finally, it is going to install your Docker CLI, Docker, and your container DIO. Okay, this is all what it is going to do. I'm going to run the same on this machine. All right, so team, I am installing your Docker now, and looks like it is done. Okay, looks like all the commands are not executed. I have to install it one by one. So team, I'm just installing your Docker software right now. If you have any questions, you can ask. I'll be answering that. And that's the last command. Okay, so many questions. Rishabh, are we going to use VM in Google Cloud for the practical purpose or other GCP specific service as well? Because GCP is not allowing me to create account. I have got one DigitalOcean. I can get VMs here. Rishabh, yes, as per your content of the class, everything will be done on the virtual machines only. Okay, so it is not going to be an issue. But just for some extra additional knowledge, what I'm going to do, I'm going to share a few concepts that you can have on the managed cluster only. Okay, for say we have Google Kubernetes engine. Okay, it provides you some other specification as well. It is not going to help you in your examination, but it is going to help you in your real-time environment. That is why I'm going to touch some topics from there as well, just for your knowledge purpose, just to give you something extra. But yes, for your examination point of view, everything will be covered on the virtual machines only. Anil, as of now, yes, I have installed your CRA. Adjudica guest, Adjudica guest, can you try all the commands that I have just shared? Yes, probably you are not using the right operating system. Okay, please check your operating system, whether it is your Ubuntu or any other flavor, and depending on that, use my repository to install the softwares. Okay, for Ubuntu flavor, use these commands. So this is just to have your users. So I'm going to do everything with the root, so you don't have to worry about that. If you're working on Ubuntu, these commands are enough, and if you're working on CentOS flavor, these commands are enough. Yes, Anil, I'll be sharing the commands also for the CRE, whatever I am going to run. Yes, Adiruka, guess, Girish, okay, got your name. So yes, I'm going to run some commands. You can also practice that at your own, so that you'll be clear if your Docker has installed properly or not. Okay, all right. So team, these are the steps to install your Docker, and let's execute few commands. It is 7:51 IST. Okay, so I thought that we are going to assign 1 hour for the Docker, and then we are going to jump on the Kubernetes part. Okay, so we have 10 minutes more. So let's see what we can cover on Docker, because Docker is not a main topic. It is just a brief idea about the prerequisites. For that also I assign 1 hour, just so that you can have a better understanding. All right, so team, I'm going to execute few Docker commands so that you can understand what exactly Docker is. Okay, so in your virtual machine, you can also install your images from open source, but if I'll talk about your Docker, sorry, Docker has its own Docker hub. Okay, from where you can download all the images. So this is the website, hub.docker.com. You can go to this, you can create your own account. Your own account will help you to create your own images and upload that at your own repository. Okay, so you can have your account here, you can sign up. It is free of cost. If you are using any open source containers, or if you are uploading your containers, that is publicly available, you can sign up for free. There is no charges. But if you want to have private repository, then it is going to charge you. So as long as you are using public repository, it is completely free. So you can sign up and you can have your own account. For example, I want to have a Tomcat image. What Tomcat image is going to do? Tomcat image will have some operating system, partial operating system, and it is going to have a Tomcat installed also. Okay, so what it helps, it doesn't have you the challenges that you want to create a container, you want to have some image, you have to create the container, then you have to install Tomcat in it. So this part is eliminated if you use any Tomcat image. It is going to have some operating system libraries and binaries for your container, and it is also going to have Tomcat installed in it. If you want to have some plain operating system, you can have that also. If I'll search for Ubuntu, you have Ubuntu image also. So you just have to download this Ubuntu image. It is the official image, and you can create a container with Ubuntu, and then you can install Tomcat if you want to. But what is the purpose? You have already a Tomcat image. You can use that image and your Tomcat is good to go. If you want to have Nginx, you also have some Nginx images. Okay, so we have all the ready-made images here which you can use for your own purpose. So let's try to use some of them. Okay, as of now you can see there are no images or no containers. If I want to have some image downloaded, first let's see if we have any images as well. So you can see there are no images as of now. If I want to download some image, I can simply use a name. This is your Nginx. You can install any specific version as well of your image. Alright, as of now I'm going to use the latest one. For latest I don't have to mention anything. Docker pull Nginx. So now you can see it is downloading the Docker image, and it is downloading the Docker image from your Docker hub itself. Okay, your Docker image is as of now public repository, so anyone can download it. With this command you can also download your Docker Nginx image. So if I'll do Docker images, you can see there is a Docker image. Alright, but if I'll search for Docker containers, container is not created as of now. Alright, now you can see that your image is downloaded. Now you want to create the container with this image. Alright, for that you have command called docker run -d -p and your image name. The image you are using is Nginx. So now it has created your container, docker ps. Okay, so you can see this is your container ID. This image it has used. Okay, it was created 8 seconds ago and it is up from 7 seconds. So you can see 8 seconds ago it was created and 7 seconds ago it was up. So reboot time you can consider is negligible. Alright, you can see this port number as well. So your Nginx is running on this port number on this machine. Okay, your Nginx runs by default on 80 port number, but the port it has used for this this machine is this one. Alright, consider I want to create another container of same flavor. Alright, that was I need. I executed similar command again. So now you can see I have two containers running. Both are of Nginx flavor. Alright, but you can see the port number of Nginx container is 80 port number, because your containers, your Nginx run on number 80. But as we have different containers, it has taken the different port number for your machine. So it is showing 000, it means it is going to take the IP of your instance. Alright, this is my machine. I'll copy it. Let me paste it here and let me provide the port number. So now you can see I have two containers running. Both are of Nginx flavor. Alright, but you can see the port number of Nginx container is 80 port number, because your containers, your Nginx run on port number 80. But as we have different containers, it has taken the different port number for your machine. So it is showing 000, it means it is going to take the IP of your instance. Alright, this is my machine. I'll copy it. Let me paste it here and let me provide the port number. Welcome to Nginx. Okay, this is the port number of your first, and I can use the port number of your second container as well. With the same IP, I'm just going to modify the port number. So there is no difference, both are Nginx container, that is why you are seeing the same page, but now it is going to different container. Earlier it went to this container, now it went to this container. Okay, so you have created the container, it is doing its functionality, it is providing you an Nginx page. If you want to make some changes, if you want to go inside your container, we have the commands for that as well. So docker exec is the command to go inside your container. Alright, you have to provide the container ID as well. And then you have to give a prompt with what prompt you want to log into your container. I want to log into my container with a bash prompt. Okay, so team, now you can see the prompt has changed. Earlier the prompt was root@docker because Docker is the name of my machine, right? Docker is the name of my machine. And now the prompt has changed, root@, and this is your container ID. It means now I am inside my container. If you want to verify, you can verify that as well. Consider, let's see what operating system flavor it has as a container. Okay, so you want to go to this file, cat etc os release. Okay, so team, you can see this is a Debian flavor container. All right, so if I come out of this container with control PQ, all right, control PQ is used to come out of a container. All right, and if I see my operating system of my host machine, we already know that it is your Ubuntu, but just to verify, right, you can see your physical server on which I am working right now is of Ubuntu flavor 18.1. This is what we choose earlier, right? But the container that has Nginx installed in it is of Debian flavor. Okay, this is how your container varies. Okay, so team, anyone else have any question? I hope it is clear to you. Akhil, yes, your docker exec command will work. Docker exec command is working on your operating system machine, okay, where you have the full operating system. Alpine is a image that doesn't have the bash prompt. So what difference you're going to see? For example, if I'll do docker exec -it and the container ID of a Alpine image with bash prompt, you won't be able to enter. All right, you have to give a shell prompt. Here you have to mention sh, then only you're going to log into your Alpine container because there's no bash prompt. So I hope that answers your question, Akhil. Okay, anyone else? Any other question? Okay, thank you. Thank you for confirmation. Okay, so team, with Docker also you can do a lot of functionality. You can create your own images as well. You can do your container orchestration also to some extent. So what we have covered is less than 10% of your Docker container. Okay, but I have covered the part that is necessary for you. All right, this is all you need for your Kubernetes as per from your Docker part. Other than that, your Docker container is also a big topic. It also takes 4 weeks as a complete course. All right. So I just gave you a basic idea that is going to help you with this course. Now we are going to move forward and we are going to go to your Kubernetes. Okay. So what is Kubernetes? Kubernetes is not your containerization tool. Kubernetes is your container orchestration tool. So what is the difference? Okay, so at the organization level, this question is for you people, all right? So I want answers from you. In any organization, if you want to deploy your application, are you going to deploy that application on a single machine or on a single container? Is it a wise call? Is it a wise call to have your application on a single container, on a single machine? No, right? Great. All of you are answering. Superb. Absolutely correct. Yes, so the thing is, at organization level, you are not going to have a single container or a single server. You need something more than that. Okay? If I'll take a real-time example, in any organization, you don't work as a single contributor, right? If you have a team, you have a team there. You don't have a single contributor. Consider in my organization, I'm the single person. I'm also working on the incidents. I'm also working on the user stories. I'm also working on the defect. It doesn't work like that. I'm not going to do everything at my own because it is a big failover. Because of some reason, if I am on leave on some day, then all the things will be impacted. your incidents, your user stories, your defects, everything is going to impact. So what we do, we used to have a team, right? We have 10 members of team or 20 members of team, and we have designated some responsibilities to each team member, that you're going to work on the defects and you are going to work on your user stories, you're going to work on the incidents. We have a team there, right? Similarly, you have your multiple containers to be holding your application. All right, we are not going to have a single container, we are going to have multiple containers for your application, for the failover, for the load balancing, for multiple reasons and number of reasons. You're going to have multiple containers, you're not going to create a single container. All right, with that understanding, consider in your real-time scenario that I have taken an example of a layman example, that you have a team in your organization, you are not a single contributor. So to manage those group of people, consider I have a team of 10 members where everyone has some responsibilities. So are they sharing the responsibilities among themselves at their own, or they do have a manager above them? In a group of 10 people, they don't share the responsibility at their own call, right? They have a manager. Every team has a manager. And what is the responsibility of the manager? Manager has a responsibility to distribute the work among all the resources in the team so that things get done in time, okay? And there is no load. So what are the responsibilities of a manager? It is going to distribute the work, okay? It is also going to measure your performance, that how you're performing, all right? And it is also going to take the responsibility if some team member is absent because of any reason, it is going to delegate that responsibility from that member to some other member, right? So these are the responsibility of the manager. They are also going to gauge your performance, they are also going to help you with all the responsibilities, they are going to distribute the work. Everything will be done by the manager and the real work will be done by the team. Similarly, in your container world, you have multiple containers. Those containers are not going to share the responsibility among themselves at their own. They need some kind of manager as well. And that manager is your container orchestration tools. Okay? Container orchestration tools like your Docker is one of them. Sorry, Docker Swarm is one of them. All right. Your Kubernetes is another container orchestration tool. All right. So these container orchestration tools are not the containerization tool. Okay. Very important words. Kubernetes is a container orchestration tool. It is not a containerization tool. Kubernetes doesn't provide its own container. They just do the management of the container of any other flavor. Whether it is your Docker or Rocket or LXC or LXZ or Containerd, you can have any flavor of your containerization. Your Kubernetes is going to do the orchestration. It is going to orchestrate your containers. It is going to manage your containers. All the responsibilities that I told you of the manager will be taken care by your Kubernetes as a container orchestration tool. Consider you have a cluster, all right? You have a 5 nodes cluster. Because of some reason, if one node goes down, all right? So your Kubernetes is going to take the responsibility to migrate the containers support from that node to another container. As I told you that if some member is in your team is absent, his work will be assigned to some other people by the manager. Similarly, in Kubernetes also, Kubernetes is going to assign the containers of the failed node to some another node. All right. It is also going to check the performance. It is also going to check how your containers are performing. All right. It is also going to assign. It is also going to distribute the containers among the cluster. All right. All the responsibilities that I shared with you of a manager will be done by your Kubernetes or any container orchestration tool. Next question. Why we are just learning about Kubernetes? We have other tools as well. For example, Docker Swarm. Docker provides its own container. So we can use Docker Swarm also. Right? Why go with Kubernetes? First and the biggest answer for that is that your Docker provides you containerization only with the Docker containers. Okay? You cannot create any other container. Kubernetes provides you that flexibility that you can have your containers of any other flavor. So in Docker Swarm, you can create only Docker container. In Kubernetes, you can create any kind of containers, your Docker, LXC, LXG, or any flavor. So that is the biggest feature of your Kubernetes. Kubernetes doesn't limit you with any single flavor. Docker Swarm does. All right. Another difference is your Docker Swarm doesn't provide you the functionality that Kubernetes provide. For example, if I'll talk about auto scaling, this is one of the feature. Auto scaling feature in Docker Swarm is not available. Okay, you have to scale your containers in Docker Swarm manually. But if I'll talk about Kubernetes, you have auto scaling enabled. You don't have to put any manual efforts. Your Kubernetes does it automatically. So these are some of the features, and some other features are also there. The security that is provided in Kubernetes, like role-based access control. Okay, these are the features of Kubernetes which is not present in your Docker Swarm. Okay, so functionality-wise, Docker Swarm is not that advanced if I talk about in comparison with Kubernetes. That is why your Kubernetes is most in demand at these days. Your Docker Swarm is not. Okay. So Kubernetes provide you more functionality. It is more flexible. It is more complex as well to understand as compared to Docker Swarm because of the functionalities. Whosoever gives you more functionality is definitely a little complex. But in real-time organizations, we need functionalities, whether it is complex or not. Okay, so that is why your Kubernetes is most demanded container orchestration tool in the organization at this point of time. All right. Any other question? Any question till now? Yes, no, maybe? Great. All right. So team, one important tip for your examination point of view. Okay. So what I'll do, I'll keep giving you examination tips in between our sessions. Okay. So it can help you in your examination. Okay. Okay. We have few question. Why we go for containerization? Why not image management? Because is it because container is running instances? Sumit, I'm not sure if I got your question. Why we go for containerization? Why not image management? Image is your operating system image. Consider that you have a laptop, all right? And on your laptop, if you want to have your Windows operating system, how are you going to have your Windows operating system on your fresh laptop? You're going to have some bootable device. You'll have some software in your CD or any bootable device like pen drive or not. All right, you're going to connect that with your laptop, and then you're going to install your Windows operating system on your laptop. So what that pen drive is doing, your pen drive or your bootable device is your image. Okay, it is portable. With that single image, you can create multiple operating system. You can have that pen drive connected to your laptop. You can have your Windows operating system. You can connect that pen drive to some other's laptop also, and you can install your Windows operating system there as well. So that bootable device is a single image which is creating multiple operating system on multiple laptops. Similarly, if you talk about an image, your image is a device which is going to help you create multiple container of that same flavor. Okay, so image management also take place. You have to manage your images as well, but that image is just a script. You don't have the container there. You have to create a container. All right. So Sumit, I hope I answered your question. we can use auto scaling for the instances, right? At your guess, auto scaling is going to, if you talk about instance level, okay, if you're doing the instance level auto scaling, it will not be managed by Kubernetes, it will be managed by your cloud provider. Consider if you are working on AWS, you have created multiple EC2 instances, or if you are working with GCP and you have multiple VM instances, then if you want to do the load balancing between those machines, it will not be taken care by the Kubernetes, because that is the infrastructure that is provided by Google Cloud. You have to do the load balancing at the Google Cloud front. Kubernetes is not going to manage. Kubernetes is going to do the load balancing between your containers. All right. Okay, so one team I was going to give you about your examination. I don't know how much of you know this or not. If you are preparing for your CKA examination, during your examination, your examiner allows you, as of now, if you know that your Kubernetes examination is taken care by CNCF, all right? So CNCF allows you to open your official Kubernetes website during the examination, right? So during the examination, you can open your official Kubernetes website in a single tab, not multiple tabs. You cannot open multiple tabs. You cannot launch Google on any tab. You can just open a single tab apart from your examination tab, and in that tab, you can open your Kubernetes official website for syntaxing or any other help. Okay, so I'll suggest you to have a bookmark like this. Okay, you can see that I have created a bookmark, K8s. All right, in this you have multiple things, installing your kubeadm and any other topic. All right, so you can see it has commands as well. If you want to install your kubeadm, how you're going to do that, all the commands are here, so that during the examination you don't have to memorize the commands or anything. You can simply go to this link and you can have the command with you. Okay, you can choose the version as well. As of now, we'll be working on the 19th version. All right, so all the commands are here. So have this thing in your bookmark, all the links which are going to help you when during your examination. And how you're going to get these bookmarks, all right, I have created that also for you. Go to the same Git repository. All right, there's a folder called other. In other, you have an HTML file. Where it is HTML. Okay, here is your Kubernetes bookmark HTML file. Okay, you can simply Google how to have your Kubernetes. You can simply Google how you can have your bookmarks imported from HTML file. Simply, you can have the similar tab here. So during the examination, you can directly go to the field and you can open the page. So this is how it is going to help you in your examination. But just a single tab. That is also from the official website. Joy, I have already shared the GitHub repository link with you. Let me share that with you again. Joy, I have shared the link with you on one-to-one chat as well, and I'm also pasting the same link on the chat box again. Okay, have this with you. All the content you're going to find here. Jagannath, you're asking the browser tab is on a laptop machine or in the CKA lab environment. CKA lab environment, they are going to provide you some virtual machine where you have to do everything practically. CKA examination is not an optional multiple choice question. They will give you a scenario and you have to execute some commands on the terminal. They also provide you one to terminal. Okay, so you have to create your cluster, you have to create your pods or deployment, all the things we are going to cover in the classes. All right, so that is a terminal where you will be executing, and it is also going to be a browser window. Okay, so in the browser window, you can have an additional tab with the Kubernetes official website link only, not even Google. All right. Yes, CKA's exam is completely practical. You have to create the objects, you have to create the deployment, you have to create the pods, you have to troubleshoot. They will give you a scenario that this is the problem you are facing in the cluster, how you're going to troubleshoot it. Everything will be done practical. Okay. They will provide you up and running cluster. They will provide you a cluster and then they will ask you to do the things. Okay, so this is your official Kubernetes website. Apart from that, if you know that your examinations are held by CNCF nowadays, okay, Kubernetes was initially with Google earlier, all right. It has stayed with Google for created it as a open source. Now your Cloud Native Computing Foundation manages your certification, all right. So if you can go for the CKA administration, CKA, you can also go for your CKAD. Okay, that's your call. During the class, we are going to cover both the certification. By the end of this course, you will be able to complete the certification of CKA and CKAD as well. Okay, CKAD is the lengthy one because it has more topics. CKAD is your Kubernetes certified Kubernetes application developer. CKAD is that. So that has a little lesser concept than CK, and we are targeting for CKA. So if you are done with this course, if you are done with these classes, you are done with the content, you can opt for any examination, CKA and CKAD both. Okay, here are your examination details, how your examination take place, what is the deadline, what is the weightage, everything you can find, all the details are here. All right. So team, any other question before I move forward? Mon, CNCF Cloud Native Computing Foundation is a organization that is managing your Kubernetes nowadays. All right. All right, team. So now we are going to start with your Kubernetes architecture as the first topic. All right. Before starting that, shall we take a break? Yes, no? All right. So team, let's take a 15 minutes break. Okay, Gopal, you can come back in 5 minutes. Great. Okay. But still, we are going to take a 15-minute break. All right. So I'm going to put a timer here. See you in 15 minutes. Team, I'm back. Quick confirmation from all of you. Do we have all of you on board? Okay, few responses. Great. Okay, in these type of confirmation, I get all the names on the chat box. All right. So team, let's get started. All right. So this is what we have understood so far. Now we are going to understand about the Kubernetes architecture, and then we are going to do the Kubernetes installation. All right. So first thing first, this is your architecture of Kubernetes. Okay. This is already run. Let me draw it again. All right. So Kubernetes, as we are already clear, is your container orchestration tool. All right. So container orchestration tool it is, and it also distribute your resources across multiple nodes. All right. So considering that we have a multi-node architecture, in this multi-node architecture, considering this is going to be your master. Okay. Your one node is going to be a master node, and in Kubernetes, your worker nodes are simply called nodes. Okay, this is your node 1, node 2, and node 3. So this is how we are going to proceed. We are going to have one master machine, and we are going to have multiple. And in this architecture, the machines that we are going to create will have 2 core of CPU and 4 GB of RAM. Okay, this is what we are going to follow for all the machines. If you want to have higher machines, that is completely your call. But this loaded machine will be enough for our Kubernetes practice. Okay, so now we are going to mention the components of your master nodes and your worker nodes. All right. So if I'll talk about your master node components, you have 4 components here. Okay. First is your API server. Second is going to be your etcd, or first let's understand about scheduler. Next is going to be your controller manager. And the last component of your master node is etcd. Okay, so team, these are the 4 components that you have on your master node. If we'll talk about Kubernetes master architecture. Okay, what are the responsibilities of all these components? Now we are going to understand one by one. Okay, first is your API server. What your API server does. Consider that we have already seen practically how your Docker works, right? So if you can see, Control C. Okay, connection timeout, no problem. So in Docker lab, you have already seen that all the commands that I am giving starts with a Docker word. Okay, all the commands starts with a Docker keyword. Docker PS, Docker images, Docker exec, Docker run. All the commands start with a Docker keyword. So that Docker keyword is a client. Okay, that is a client that interacts with the Docker software on that particular machine. Similarly, with Kubernetes, there is also a client. Okay, and that client is called kubectl. Okay, so kubectl is a client that deal with all the Kubernetes related components in your Kubernetes installation or your Kubernetes management. All right, so all the commands that you're going to execute on Kubernetes cluster will start with a kubectl keyword. Similarly, like Docker keyword was used to do with all Docker related operations, kubectl is going to be the keyword that will start the command to interact with your Kubernetes cluster. Alright, so your kubectl directly interacts with your API server. Okay, all the commands that you are going to execute, your API server on the master component is going to be the one that will manage all the communication. Alright, so team, allow me a few minutes. After that, I'll be taking your questions. Alright, let's discuss about the master components, then I'll take your questions. So all the things that you're going to do with Kubernetes cluster, you will start with kubectl, and that kubectl will address the API server component on your master, and then it will take all the actions. Okay, if you want to do kubectl get pods, kubectl get nodes, kubectl create any resources, your pods, container, whatever, all the commands that you'll give with kubectl will interact with the API server first on your cluster. Okay, so API server is the first point of contact in your cluster. It will manage all the communication inside the cluster. API server is responsible for all the communication, whether that communication is being done with your kubectl, if the communication is happening between these components as well. Even these components cannot interact directly with each other. If etcd wants to talk to controller manager, it has to connect via API server. Any node component wants to connect with your master, it has to connect with the API server first. Okay, so that is about API server. Next is your scheduler. Alright, so scheduler does what? Scheduler is like an HR in your company. Okay, so scheduler is like an HR. What HR does? HR hire people and they assign those resources to the different teams depending on their specialty and depending on the requirement. Right? That is the responsibility of an HR in an organization. That responsibility is being fulfilled by the scheduler here. Consider I want to create a container. Okay, pod container, you can use these keywords interchangeably, but as of now, I'm using container keyword because I haven't told you about pods right now. I hope you might be knowing with the previous lectures, but I'll explain you again. So, as of now, I'll be addressing them as a container. So, if you have a container and you want to create a container, you will come to your API server with the kubectl command, definitely. Alright. Now, your scheduler is going to be the one who is going to assign the node to that particular container. Okay. Scheduler will decide, okay, this container should go on node 1. This container should go on node 2. Depending on multiple factors, we'll discuss about those factors as well in the later stages. But as of now, understood that this node has higher resourcing. Okay, this node has some specific importance with your storage. All right, so we have multiple nodes with different specifications. This is CPU highly based, this is memory based, this is storage based. Okay, so depending on your requirement, depending on the scheduler decision, your container will be assigned to a particular node. It will do the scheduling. Okay, that's about your scheduler. Next is your controller manager. So controller manager is a kind of manager and it is a combination of multiple managers. Okay, controller manager is not a single component. You have multiple controller managers, but if I talk about in general, controller manager is the one which matches your desired state equals to actual state. Okay, so we have multiple controllers like your node controller, your pods container. Okay, we have deployment, we have daemon set. We are going to discuss about all of them in detail, in depth, but as of now, they all are called controller manager. And what is the responsibility of container management? Container management makes sure that your actual state is equals to your desired state. What does that mean? Consider I have a requirement that I need 4 containers of my application running all the time. Okay, across a node, it can be across the nodes, no problem with that. Okay, my application, I have a requirement that my application container should be 4 at a time for the load balance purpose or for my application purpose. So at any given point of time, my desired state should be 4. So who is going to make sure that all time your 4 containers are running? Your controller manager is the one who is going to make sure that you have 4 containers running all the time. It means because of any reason, because of a problem or something reason, I went to this node and I deleted this container, maybe intentionally, maybe accidentally. So what will happen? My desired state was 4, but my actual state has become 3, right? I asked for 4 containers, but now only 3 containers are running. So now controller manager will come into picture. Controller manager will see that desired state is 4, but actual state is 3. So what controller manager is going to do? Controller manager is going to create that container again itself. There is no human intervention required, and this concept is called self-healing. Okay, this concept is called self-healing in Kubernetes. It means because of some reason, if this container goes down or this container goes deleted, your controller manager is going to create a container itself without any human intervention. That will be done automatically. Okay, that is one thing. That is one of your controller manager role. Consider because of some reason your node is not reachable, right? Your node went unreachable, so your container also goes down. So your controller manager is going to take the responsibility to migrate that container or create the similar container on some other available node. Okay, so that is the responsibility of your controller manager. All right, and the last component is your etcd. Okay, so what is etcd? Etcd is your database. Okay, all the information about your cluster, that how many nodes are there, how many containers are running, how many pods are running, how many deployment, daemon set, or any other object, all the information about your cluster is stored in your etcd database. Okay, and etcd database is your database with key value pair. Okay, it is not a SQL type of database. It doesn't create tables or something like that. etcd is a database with key value pair. You will have a key and you will have a value, and it will store the details like that. So that is the responsibility of your etcd. Consider that I executed a command of kubectl get nodes. It means I want to know the details about my nodes, how many nodes are there in my cluster. So how the flow is going to be? Your kubectl will give the command kubectl get nodes. It will ask your API server API server, tell me how many nodes are there in my cluster. API server will say, okay, fine, I'll do that, I'll check. So API server will ask the etcd database, because all the information are stored in your etcd. So it will ask etcd that how many nodes are there. etcd will fetch the details and give it to the API server back, and then API server will give you the results on the screen, that how many nodes are there in your cluster. Okay, so team, these are the 4 components of your master node. Now if you have any questions, now you can ask. I'll be taking questions now. Okay, a big one from Edutica guest. If we have multiple master nodes and 20 to 30 worker nodes, then when we can set up Kubernetes cluster, then token we get during installation is on all the worker nodes. Is there a best way? Any best approach to do in the real-time scenario? Okay, Edutica guest, you have a long question that if you have multiple worker nodes, say 20 or 30, and if you want to have the token with kubeadm join command. Okay, so if you want to do it on the 20 or 30 nodes, is there any better way to do that? So that can be done with some other DevOps tools, not by the Kubernetes. Say you have your Ansible. Ansible is a configuration management tool. You can have that same command, same token executed on 20 to 30 worker nodes with a single point. Okay, that can be done with other DevOps tools and your configuration management tools for, say, Ansible. Shiju, you are asking, isn't that the API server that receives instruction from the controller manager to create the container and communicate to kubelet on the worker nodes and make it happen? Yes, Shiju, that it is. But I think you are one step ahead. You are asking about the kubelet. Kubelet is a worker component that I haven't discussed as of now. Okay, I have just given the brief idea on the higher level how these four components works. Okay, API server is a single point of contact. If any worker node component wants to talk to master, it will talk to API server. If any master components want to interact with each other, say controller manager to etcd, your API server will come into picture as a mediator. So all the things happen through API server. It receives instruction from everywhere. These four components we can install on different machine. No couple, you have to install all these four components on a single machine. Okay, there are two way of installation, hardware and kubectl way. I'll tell you about both of them. All right, but you have a master and all those components must be running on the master itself. If you go kubectl way, it will do it automatically. Editor guest, no container runs in master node. Adhirika guys, I'll come back to your question later. Okay, I'll ask the same question to all of you, and then you will answer me that if container runs on the master node or not. etcd will contain all containers, ID, and other specification. Yes, Anil, all the details will be stored in the etcd. Sanjay, can you explain call flow for one container creation? Sanjay, yes, I'll do that once I'll discuss about the components of your worker nodes. After that, I'll do that. Arjun, you're asking, can we access etcd directly to view the data inside the files? Yes, Arjun, if you want to see the details of etcd, you can do that as well. But that is not required, although all the commands you do with the kubectl command. But still, if you want, you can do that. We can take the backup also of etcd. In fact, in your examination also, they do ask how you can take the backup and restore your etcd database. This kind of question comes. Okay, okay, and we'll cover that also. Siddharth, can we have multiple master node? If yes, how the etcd is syncing up? It is automatically by design. Yes, Siddharth, we can have multiple master node. Even if I'll tell you honestly, in real-time organization, it is always suggested to have at least 3 master nodes. Okay, and Kubernetes is the one who is going to manage your etcd. It will keep it in sync. Okay, no manual work required there. Sarath, what's special about CNCF project? I could see etcd as a separate CNCF project. CNCF is an organization, is a foundation that manages some software that are not owned by your organization who generated them. For example, I'll say that Kubernetes was originated in Google. Okay, after that, Kubernetes, your Google gave it up as an open source. All right, so if you want to have some certification, if you want to have some expertise in some tools where you can showcase your skills, for that purpose certification comes to picture. Now for open source tools, how you're going to have that? Because no company is there who is going to manage certification for that. So CNCF is an organization which helps you with some open source tools where you can earn certification and showcase your skills. So CNCF doesn't hold the certification only for your CKA or CKAD. It holds certification from other tools as well. Akhil, is there any command to see the etcd details? Akhil, all the details that you see with kubectl command, as I told you, kubectl get nodes and you get details that how many nodes are there. You do kubectl get pods, you get all the details how many pods are there. You do kubectl get pods -o wide. It means you are asking about all the details. So that is the way how you get the details from etcd database. How etcd differs from CSI in team storage in Kubernetes. Edurika guest. Okay, CSI, can you explain in detail? I'm not sure how you are talking about this. Is ETCL command part of CK? Yes, Jagannath, sometimes they do ask. It is not a mandate that you'll get that question, okay? But yes, ETCL command is also important for your examination point of view, and I'll tell you that also when we'll come to that part. Okay, so many questions on ETCD. Can we use ETCD outside the master node? Yes, you can use your ETCD outside, but there is no use actually. Okay, ETCD is used by the master components. ETCD is accessed by API server. If you take the backup of your ETCD somewhere else as well, it is of no use because API server is the one who uses your ETCD. Is there any link for stateful and stateless with ETCD? Akhil, I'm not sure what is your question. Stateful and stateless is a type of property of your objects. If you talk about ETCD, it is a stateful set, if I'll talk about that. Okay, container storage interface. So yes, I guess that is a different concept. Okay, we are not going in details about your container storage interface because it is about your container details only. Okay, it stores the details about your containers only. But ETCD is the one which holds the details about your complete cluster, not just about your containers, also about your services, also about your Kubernetes services, your nodes, your components, everything about that. Joydeep, I got your message. I mean, externalize ETCD out of the master node and refer to the ETCD. Okay, no, Joydeep, that doesn't work like that. You have to have your ETCD on the master node itself. Akhil, can you please explain about stateful set and stateless properties? Okay, Akhil, stateful properties are there. For example, consider that you have a database. Okay, that is a stateful. It means stateful means that with time the state of your object is changing. You have a database. You have some insert commands. You have some update commands. You insert new data. You eject some data. You delete some data. So it is dynamic in nature. Your database state is changing every second whenever a command is executed against it. Okay, so that is your stateful property. What is your stateless property? Consider you have an application. You are using that from your browser. Okay, so on browser, if you refresh it again and again, it is not going to change. It is going to be just like that. So that is a stateless property. Okay, so you can use a stateless object again and again, but its state is not going to change. Stateful properties are the objects whose state get changed whenever you do some update or deletion or increase, anything like that. Since ETCD is a key value pair kind of DB, can we put our own details in terms to, let's say, environment variables across cluster? Siddharth, you have your environment variables topic also in Kubernetes. We are going to cover that, but we don't do that directly into ETCD. Okay, you do have environment variables in Kubernetes, but we define it as a separate object. We'll see that in further classes. So basically, controller manager does the job of monitoring all the nodes and pods. Yes, I did, guys. At this point, you can understand it just like that. Okay, we are going to discuss about controller manager in depth later on, where you'll discuss all the components, all the type of controller managers. Okay, Siddharth, no, we cannot put our own details in the etcd database. Okay, if you want to create a database as a container to store your own details, you can have your database containers also. Okay, for example, you have MySQL container image. You can use that, create your own container, but etcd is specifically designed to hold the details about your Kubernetes cluster, not your own details. Do we have stateful and stateless application demo? Also, could you please provide a scenario of stateful and stateless example? Akhil, yes, like all the application containers that we are going to create, whether it is your Nginx or Tomcat, that is going to be an example of your stateless application. Okay, that is going to be an example of your stateless application. We have a stateful set, also an object in Kubernetes, and we are also going to cover that. Not right away, I guess on the 3rd or 4th week, possibly. Okay, but we do have stateful set in Kubernetes also, where we can create your database containers, and we'll cover that also. All right, anything else? Okay, so team, hold on your questions. First, discuss about the components of your worker nodes, and then once our complete architecture is complete, we'll take few more questions and then we'll do the installation. So now what are your worker nodes component? First and the most important is your kubelet. All right. Next is your CRI. Next is your proxy. Okay. So these are the 3 components of your worker nodes. Now, let's understand about them. First is your kubelet. Okay, what is the responsibility of kubelet? If I'll give an example, if I tell you, kubelet is a teacher in a school. Okay, I'll name an example. Consider we have a school, right? In that school, you have a principal. That principal is your master node. All right. And you have so many classrooms. You have classrooms from all the classes. All right. So in all the classes, you have a teacher, right? In all the classes, you have some teachers who are going to manage that particular class. And all the reporting from that class will go to the principal via teacher only. Okay. So your master node or your API server is the principal. Okay. Your kubelet is the teacher of all the classrooms. Okay, one teacher will be there in all the classes. One kubelet will be there on all the nodes. All right, and your containers, you can consider your containers as your students. Okay, in any school, if you have students, you can consider your students as containers. So in one single classroom, you can have multiple containers. You can have multiple students, but you are going to have one teacher. Similarly, in all the worker nodes, you can have n number of containers, but kubelet is going to be one who is going to manage them. Okay, so kubelet take care of all the components on your worker node, whether it is your container or anything else. It will make sure that your containers are up and running. It is take all the instruction from the API server. Consider that one pod is scheduled on your node 1. Okay, so scheduler will decide that node 1 is going to have that container. API server will instruct the kubelet. Okay, API server will instruct the kubelet that your node has been assigned to create this container. So create a container on your node itself. So kubelet is going to take the responsibility. All right, kubelet is the agent of all your worker nodes. Now, consider a request came that you have to create one container. Now, kubelet is going to create have a container runtime interface. What is your container runtime interface? It is simply your Docker software. Okay, you have to install your Docker software on all the nodes. So kubelet will instruct to Docker then. Consider your Docker is your monitor in the class. Okay, so when teacher assigns some doing some work, it will create a monitor from the students who will manage the class for that time. So Docker is a container runtime interface. It will take the instruction from kubelet to create a container or delete a container. All the container related commands will be executed by Docker itself, and it will be instructed by the Docker kubelet. If you want to have some another type of CRI, you can have it. For example, you can have your container D, LXC, LXZ. Okay, you can have any type of CRI. Next is your proxy. So what is your proxy? Proxy helps in your networking. Consider that you have one container running on node 1 and one container is running on your node 2 or node 3. Okay, inside a Kubernetes cluster, all your containers can talk to each other. In any cluster, in a complete closed environment or cluster, whether your container is residing on node 1 or node 2 or node 3, they are allowed to communicate to each other, and that happens with the help of the kube proxy. Kube proxy provide the networking so that you can have your containers talking to each other across nodes. Okay, for that purpose we install a CNI as well. Okay, so what is CNI? CNI is your container runtime interface. So you have to install CNI as well separately. Okay, so you have to have your network plugin also. So Kubernetes is doing all the things. Why it is not providing you networking functionality? Can anyone tell me why Kubernetes is not providing network plugins? Docker, if you talk about your Docker containers, if you talk about Docker Swarm, they have their own network. Okay, that is called CNM. In Docker or Docker Swarm, they provide their own networking, but Kubernetes doesn't provide any networking plugins. Why? They can do that, but why they don't? Kushagra, no, that is not the answer. Anyone else who can try? Why Kubernetes doesn't provide you network interface when it can? Shiju, you are absolutely correct. Siddharth, you are also. Nitesh, yes, orchestrator can also provide you functionality of CNI. Also me, okay, to some extent, yes. Edureka, guess by default they do, but with the help of some components, right? Anil, no, that is not the case. Ashok, yes, to the some extent you are right. No idea, guys. Open source, okay, Sanjay, alright. Okay, so team, let me give you the answer. Okay, Rishabh, okay, got it. Alright, so team, I told you that in Kubernetes you can have any CRI. You can have your Docker, you have container ID, you can have container D, you can have LXC, you have LXG, you can have Cryo, you can have Docket. Okay, so if you have Docker, you can have a proper networking. But if you have another, if you are using container D, how your Kubernetes is going to manage all the CNIs for that? You have a lot of variety with containerization tool, Docker, Cryo, LXC, LXG. How Kubernetes is going to know that which CNI is going to be there for that particular CRI? So Kubernetes say, bring your own container and bring your own network as well. Okay, because network is dependent on your container CRI. Okay, so if you are bringing your own CRI, bring your own network as well. Okay, that is the reason for that. Okay, so team, these are all components of your Kubernetes architecture. Okay, all same are mentioned here also that I have mentioned. Okay, API server listens on the default port number 6443. Okay, 6443 is the default port number for API server. Alright, key value pairs are there for your etcd. I told you controller manager manages your actual state with desired state. All these components I have already told you. Alright, CNI, the CNI supported by your Kubernetes are a lot. You have 10 to 12 CRI support, but most use are Flannel, Weave and Calico. Okay, we'll be using Weave for our own, but you can use any. It doesn't provide any difference. Okay, that is completely your call. Alright, now if you have any questions you can ask. Shiju, what is C advisor? C advisor is not a mandate component. We are talking about the mandate components. of Kubernetes. Anil, I'll come to KubeADM and services also. Okay, KubeADM is not a component. KubeADM is an installation way. I'll come to that part also. That is my next part. Arjun, can you please summarize network dependency one more time? Arjun, networking is there so that you have a complete cluster, right? You have multiple worker nodes. So it is important that your consider maybe your database pod is running on node 1 and your application pod is running on node 3. Okay, so it is very important here that your both the containers should talk to each other, but they are across nodes. All right, so it is important that these two containers should be able to talk to each other across node. For that purpose, we need networking, and kubeproxy is a component that allows that kind of communication. All right, and that networking is also not provided by default by the Kubernetes. You have to bring your own CNI. Flannel, Weave, Calico, these are the type of network plugin. You can use any. When I'll do the installation, I'll show you that practically as well. Yes, Rishabh, these are third-party CNIs. Jagannath, yes, kubelet is also required on the master component, but as I said, your master components are specific to your master component, okay? But your worker node components are also on their master. That is the difference. Akhil, yes, you can create your different CIDR block as well, okay? Although it is not required, but if you want, you can have your own CIDR block. Srirama, you are asking, can you have different CRIs across nodes? No, Srirama, you should have a single CRI across your cluster, not even across node 1 or node 2 or worker nodes, across your cluster. One cluster, one CRI. Ashok, you want me to explain CRI again? CRI is not nothing. It is just a containerization software installation. Okay. If you want to have Docker container, Docker is going to be your CRI. Container runtime interface. That's all. So whatever the containerization technology you are using, that is called CRI. If you have installed Docker, Docker is going to be your CRI. If you are having container D, then container D is going to be your CRI. If you are using Cryo, Cryo is going to be your CRI. That's all about it. Can we control kubelet with kubeadm command as flows kubeadm, kubelet API server and kubelet? Sumit. Yes, Sumit. Yes, we can do that. I'll explain that in detail later on, as kubelet is runs as a service, not as a component. I'll show you that later during the installation. Ashok, you're asking what is the roles and how it works. So role is an advanced topic of Kubernetes. As of now, we are discussing about the architecture itself. So we'll come to the roles as well, but after some time. Master can be a VM and workers can be in servers, right? If we have to deploy a bare metal. Yes, Sarath, you can definitely have that, but you have to set up your own networking across those machines. Okay. You can have any kind of infrastructure. You can have a VM, you can have EC2 instances, but proper networking has to be set up there. If you are using Docker, we no need CNI. Edureka guess no. If you are using Docker as your CRI, still you have to bring your own CNI. Okay. Docker CNI is helpful when you use Docker Swarm, but we are using Kubernetes. So you have to bring your own CNI with Docker as well. Can you explain more about CNI, how it works? Kapil, if you allow me, I will do the installation, then I'll explain you more on CNI. It will be more clear to you. As of now, I have explained you everything on the drawing, but when I'll do practically, you will understand it better. If CNI is outside Kubernetes, then what is proxy? Little more elaboration. Anil, yes, I'll do all the elaboration when I'll do the installation. I'll show you all the components thoroughly, and it will be more clear to you then. Okay, Shirama, I think I answered your questions already. Sumit, can we control kubelet and kube as a flow? Okay, Sumit, I think we have already discussed that. I'll let you know about the kubelet a little bit later. Joy, can we restrict kube proxy only between two nodes where has pod 1 and pod 2? No, Joy, that is not the case. Kube proxy is managed by your Kubernetes itself. Okay, you won't have much say with the kube proxy. You'll see that. Can we have different OS kernels across nodes? Jagannath, yes, you can have, but it is always suggested to have all your worker nodes on the same platform. You can have different platform, but it is not recommended. Sarath, CIDR is not important if you don't know about that. CIDR is a IP range, IP block, where you can have your containers created in that IP range. Okay, so that is not important as of now. You can ignore that. If CNI manages the master and cluster network, since master IP address is not coming under CIDR block, we provide. See, master components are different. If you have mentioned any CIDR block, that CIDR block will be used for your user managed containers. But if you talk about your master and worker node component, they don't strictly follow your CIDR block. CNI depends on CRI you said. Does that means flannel? Kushagra, I didn't say that CNI depends on CRI. Okay, it is not the case. CNI doesn't depend on CRI. It is just Kubernetes says that if you are bringing your own CRI, you bring your own CNI. So there is no link that Docker works with flannel only, Containerd works on Weave only. It is not the case. You can have any kind of CNI, you can have any kind of CNI. There is no link between them, but you have to bring both the things at your own. Okay, I think all the questions are covered as of now. Okay, that was a big time this time. Alright, so team, as you have understood the architecture, now we are going to do the installation part. Alright, so there are two ways of doing the installation. One is your hard way, second is your kubeADM way. Before explaining these ways, I want to ask a question to you. Maybe that was covered earlier or not, I am not sure, but I hope you can answer. Your Docker is installed on all your worker nodes. Okay, your worker nodes, you have your Docker. Do I need to install Docker on your master node as well? Question for you people. Do I need to install Docker on your master node as well? Nitesh, Edurika guest, you are not right. Kapil, wrong answer. Anil, wrong answer. Gopal, again wrong answer. Srirama, wrong answer. Govinda, Sumit, Kushagra, wrong answer. Okay, so team, I have taken the name of the people who have not given the right answer. Joydeep, again wrong answer. Alright, apart from that, who else have answered it correctly? Now I'll tell you the reason. Okay, so now there are two ways of installation. One is your hard way, second is your kubeADM way. Hard way, as the name suggests, is actually the hard way. Alright, so you have to assign some master node, you have to install your API server separately, your scheduler separately, you have to install your etcd database, you have to install your controller manager separately. Everything needs to be done manually. Okay, that is why it is called hard way. With kubeADM way, kubeADM is a utility that help you install all the components with a single go. Okay, so kubeADM way is the way which is widely used nowadays. Your examination also come on the kubeADM way. So you don't have to go hard way, and that is also not recommended, because the same thing can be done with KubeADM with very ease. Okay, so we are also going to do it with the KubeADM way. Now, the next thing is, all the components are installed automatically with KubeADM. How that is done? KubeADM creates all these components: API server, scheduler, controller manager, etcd, Docker, or Docker is already installed, proxy control. Okay, all these components runs as a container on your master node. You have these four master components: API server, scheduler, controller manager, etcd. All these four components run on your master node as a container when you do it KubeADM way. Master node also, because all the master components are also running as a container. When you need a container, you need a Docker. Okay, I hope it is clear to you. Shall we move to the installation now? Great, thank you. Okay, so for the installation steps, also you have everything on this repository I have shared with you. You have to go to the install folder. You don't have to read all these README files. You just have to go to the bottom of this page, and all the steps are mentioned here. Yes, Kushagra, you don't need Docker on the master if you are doing it hard way. Okay, you are installing all the master components at your own, so you don't need Docker on your master node until unless you want to assign some nodes, some containers on your master node itself. Otherwise, you can ignore that. Okay, so someone was asking that if you want to create your cluster on the Linux flavor or Red Hat flavor or on CentOS flavor, yes, you can do. So I have created the documentation here for you. If you want to do the installation on Ubuntu, all the steps are here: step 1, step 2, and step 3. But if you want to do it on the CentOS like flavor, I have set up all the commands here itself. Okay, so if you want to create a cluster on the CentOS flavor, you can do that also with all the steps mentioned here. But in the class, we are going to follow the Ubuntu side. Alright, now again, I am going to create the nodes for that. Alright, I have already created Kubernetes master machine. It is just a blank machine, nothing is installed there. I have just named it like that. I have created your node 1. Let me create one more machine for your Kubernetes node 2. Okay, K node 2. Zone, I'm going to keep it like this. Same. Sorry. Not Debian, Ubuntu. 18. Select. Sorry. Okay, now I'm going to connect to these machines. Yes, Kapil, if you want to do the hardware installation steps are also there in the GitHub repository. Edurek, I guess in the examination you get Ubuntu flavor. Okay, that's why we are following it on the Ubuntu. Okay, I am connected to all my machines. These are completely blank machines as of now. I'll switch to the root user. Okay, I am connected to all my machines. These are completely blank machines as of now. I'll switch to the root user. Alright, so I'm connected to all my machines. Now I'm going to do the installation. So team, all the steps that I have mentioned in the GitHub repository, these are all standard steps. These are taken up from the Kubernetes website itself. Okay, all these are official steps, nothing of my own. So you can rely on that. I have just copied it here so that you can have everything at one place. But these are the official documentation step itself. So first step is you need to step one executed on all the nodes, whether it is your master node or your worker node. These steps need to be installed on all the machines. First, you are just installing some transport and certificate responsibilities. Then I'm going to do the Docker installation. Docker installation is also required on all the machines, as we have already discussed. Then we are going to install kubelet, kubeadm, kubectl on all the nodes. Okay, so these are the steps. Let me copy paste it on all the machines. I'm simply going to copy paste all of them. Okay, it is done on my one machine. On second as well. Third as well. Sumit, that is your call. Okay, for the lab purpose, I'm doing everything from the root user. If you want to create a different user and do all the things with that, you can do it from the different user as well. Once your Docker installed, I'm going to install your Kubernetes components. I think it is not executed on this one. Alright, your Kubernetes components now. Alright team, so once your all kube related components are installed, now you have to decide which machine is going to be your master. Okay, so which machine is going to be your master? Now you have to make the decision. As of now, all the commands have been executed on all the machines. Now, when you want to decide that which machine is going to be your master and which machine is going to be your node, you have to make sure that you understand the concept of kubectl init and kubectl join. Okay, the machine that you want to make as your master, you have to initialize it with kubectl init command. Okay, kubectl init command is the initialization command, and if I'll talk about in a technical term, this is called bootstrapping your cluster. Okay. In layman language, if you want to initialize your cluster, if you want to initialize your master, it is kubeadm init. If you talk about the technical term, if you want to bootstrap your cluster, you have to decide your master with kubeadm init command. Okay, so wherever you're going to execute your kubeadm init command, it is going to become your master. So here it is, on master only you have to run this sudo kubeadm init command. If you execute this much only, it is going to be enough. Ignore pre-flight error, it is optional arguments. If you want to pass, you can. If you don't, you cannot. You don't. Alright, so it is optional. Pre-flight errors are if sometimes it gives some warnings messages and it stops your installation. Because warning messages are just warning. Without them, you can proceed with your installation. That is why this argument has been passed. If you don't want, you can ignore it. So I am going to execute this on your machine, which I want to read as a master. This is my master machine. I am going to execute kubeadm init. It is going to initialize, or simply say it is going to bootstrap your cluster. So team, installation is an important part for your examination point of view also. So we are going a little slow here. All right. We'll make sure that everything is clear to you. It is an important part. Okay, so team, it is important that you see this message that your Kubernetes control plane has been initialized. It means your master has been identified. Alright, after that, once your Kubernetes control plane is simply your master, has initialized successfully. Alright, now to start using your cluster, you need to run the following command as a regular user. Alright, so let me copy paste it somewhere else first, and then I'll explain you the significance of all the commands. Okay, so team, if I'll see kubectl -- version, or kubectl version it is, sorry, my bad. Right, so if you'll see that your Kubernetes version is installed, your client is installed, it means your kubectl is a client. Kubectl is installed. You can see the version is v1.21. Alright, team, hold on your question for a little while. I'll take your question in a little bit later. Alright, so if I'll do kubectl version -- short to have a shorter output, you can see the client version is v1.21, and then you get a message that the connection to the server localhost was refused. Okay, so you are getting some errors. If I'll do kubectl get nodes, it should get me some output, but it is also giving me some error. The connection to the server is refused. So it is giving me some issues, right? Something is not right. Why? Because as of you know, if we install Java somewhere, we have to set up your Java class path as well, right? We have to specify some paths. So where your Kubernetes config file is present, it is not accessible to your kubectl command right now. That is why it is giving you error. Alright, so if by default your Kubernetes is installed in etcd location, etc Kubernetes. Okay, this is a location where your config files are installed. Okay, this is the main file which you require for your kubectl command. Alright, this is the most important file. So you have to provide the path of this file as well to get the output. Okay, if I'll do kubectl -version -short, and if I give this path also, kubeconfig equals to this location. And your admin config file. Can you see the output now? You have the server version also. Earlier it was not visible, it was giving you error, but once you gave the kubeconfig path, it gave you the output. Again, if I'll do the similar with kubectl get pods or nodes. See, it is giving you output. As of now, you just have master. That is your control plane master. And this is running from last 3 minutes. This is your version. So now it is giving you output. So the thing is, you have to give the kubeconfig path. Now with every command, if you are giving you your kubeconfig path, it is a overload for me. I cannot remember the path every time. I don't want to give the path every time. I want to have this automated. And for the same purpose, Kubernetes has suggested you these options. Okay, it has asked you to create a .cube folder in your home location. I'll execute it. Okay, so if I'll do ls-ltra, you can see a .cube folder is created here now. Now what I am doing, I am copying the same file, admin config file, to the folder that I have just created. Alright, and I am also changing the ownership of that. Consider I am not doing this with the root user. I want to do it from some other user. So I have to change the permission of this executable file. I have done that. Now I don't have to give this kubeconfig. I just have to do the command kubectl get nodes. You get the output. You want to do kubectl version. You the kubeconfig path now. Okay, so now you're good to go. You just have to execute the command. You don't have to give the kubeconfig path. And that is why these are the steps suggested by Kubernetes itself. Okay, alternatively, you can export also, but this is what you should do. Next, you should now deploy a pod network to the cluster. Now comes a part of your CNI. I told you, you have installed the Docker, you have installed the kubelet, you have installed the kubectl, everything is installed. But Kubernetes say bring your own CNI as well. And Kubernetes help you with the suggestion as well. Okay, it gives you a link also. You have to go to this link, copy it, and open it in a browser. Okay, here you can see you have a wide variety of network plugins. You can have ASI, Enfria, Calico, Canal, Cilium, CNI Jenny, Contev, Contrail, Flannel, Knitter. A lot of variety is there. So it is up to you, whichever you want to use, you can use. As of now, I am going to go with a VNet. Here is a VNet one. You click on this one. And you just need to execute this command. Okay, copy it and execute it. The same command I have given in the steps also. You can see kubectl apply -f and the VNet line. This is exactly the same like this. So that is what I have said. I have provided you everything at a single place. Otherwise, all the steps are from the official documentation itself. This is my master, kubectl-apply. You can see some components are created. And that is why it was showing status as not ready, because your networking was not available. Okay, there was no network on your cluster, and that is the reason your master was in not ready state. Now once your networking has been created, now your master is in ready state. Here you see, earlier it was not ready because there was no networking. You have created your networking, you have installed your network plugin as suggested by the Kubernetes, and after that you have the ready state. So that is about it. Then you can join any number of worker nodes by running the following command. Now this is the token command you need to execute on the worker node so that they join your cluster. And you can see this is your kubectl join command. And this is the IP of my master node. If you want to verify, you can verify as well. My master 10.128.02. 10.128.02. And 6443, I told you this is the port number of your API server. So I'll execute this on the worker nodes, and worker nodes will connect to your API server of master node and become their worker nodes. Same command on node 2 as well. So on your worker node 1, it has been done. On worker node 2, it has been done. Come back to your master, kubectl get nodes. Okay, now you can see that your Kubernetes master was already there. Your K node 1 and K node 2 are also a part of this cluster now. Okay, both are in ready state, both are none. Okay, because these are not the master, that is why you get a none status, and they were created 32 seconds ago. Okay, so team, this is the complete installation way. All right, here it is. So all the steps are here from the official documentation. These are the commands that we executed already. This is the weavenet connection string. You can do the kubectl get nodes. On the worker nodes, you have to do kubectl join command. That is also provided here. And if you want to do it on the CentOS, you can do on CentOS. How to find a kubectl join token? Consider that later on you want to add another node onto your cluster, but you don't have the discovery token. This is a command that you can execute to have the token generated again, so that you can add any n number of worker nodes later on to your cluster as well. Okay, so all the helpful commands are provided here. Now I'll take your questions. Joy, do we need to remember all these installation steps for CKA exam? Okay, so Joy, the question is good. I hope all of you might be having this question. You don't have to remember all the commands. As I told you, all the commands I have provided you in the repository for the first time installation. Okay, what I will suggest you, first set up your cluster from this GitHub repository, and once you are confident that your cluster is up and running, go to your official documentation and have the installation done by there. Okay, go to the K8s, installing kubectl. Go to this page. All right, what are the basic commands that you want to execute are all here. And here it is. Ubuntu, Debian, Hyperdesk, whichever flavor you want to use, all the commands are here. So if you want to see significance, see, if you talk about Docker, Docker will be provided in your examination. Okay, Docker will be installed by default. You don't have to install your Docker. So on your examination cluster, these things will be done automatically. You have to take care of only these commands if they ask you to install the cluster. So the same commands are provided here as well. You go to this website, that is why I suggested you to have it a bookmark. Have these commands handy. Open the tab, simply go to your cluster, your bookmark, and click on this. Simply have these commands copy pasted on your cluster right away. So that is why it helps to have bookmarks. All the commands are available onto here. All right. After that, what's next? Use kubectl to create your cluster. Click here. This is how your installation should look like. You can see all the output that we have already seen. Okay, all the commands are provided here. To create your directories, to transfer your config file, all right, all the commands here. You want to have your plugins, any plugin you want, you can have it. All the commands are provided here as well. So I suggest you first go from the GitHub repository link. All right. Once you are confident with the installation, do try the installation once again from the official documentation as well. That is my suggestion. Couple KubeADM comes as container with 4 components needs to install master, but see KubeADM install on all the nodes. KubeADM I have installed on all the nodes. That is optional. If you don't want to install KubeADM on all the nodes, you can ignore it. Okay. I have installed kubectl also on the worker nodes, just to keep everything handy. Okay. You can see I have installed kubectl on your worker node itself, but you cannot run kubectl command on your worker nodes. Alright, it is just for a general purpose to keep the steps simpler. That is why I have installed all the components on all the worker nodes. If you want to specifically install KubeADM on master, you can do that. If you want to install kubectl on your master specifically, not on your worker nodes, that is also okay. Once installed CNI, it will use their own network range. Or is it possible to change the CID to change the CNI default value range? Couple, yes, if you want to change the CNI range, you can change also. For that, when you do kube init, you have provided an argument, ignore pre-flight errors, you are going to give another flag for your CIDR where you are going to mention your CIDR block range. So you can do that as well. Ashok, I think your question is already answered from where I copied all the commands. I have also shown you on the official website. And you can have this bookmark. All the bookmarks I have already provided you here. Simply go to other and have your bookmark downloaded from the HTML file. You'll have all the bookmarks, whatever I have filled here. Siddharth, it mentioned to run the command as normal user, but I guess you did it as root. Did I miss anything? Okay, Siddharth, that is up to you. As of now, I am doing it for the practice purpose. That is why I am doing everything from the root user. If you want to create another user and execute the command from different user, you can do that. But we are doing practice. If we'll talk about the real-time scenario, if you're working in an organization, definitely it is suggested to have a different user. But we are just learning the concept. That is why I'm doing everything from the root user. What platform we will get, Ubuntu or Red? Gaurav, that is your call. When you created the VMs, you chose which platform you want. You can have your Ubuntu, you can have Red Hat. That is up to you. Can we open the notepad during exam? Masumi, they provide you a notepad space also. Okay, during the examination, they provide you a notepad space where you can do your rough work. In exam, we have to create notes on any public cloud or any other arrangement. Sanjay, they will provide you a up and running cluster. Okay, they will give you machine terminals directly. All right, so you don't have to take care about the backend, whether it is GCP or AWS. They will provide you machine terminal. You directly work on there, so there is no need to worry about the backend, whether it is public or private cloud. Can a cluster have many nodes? Yes, Joy, we have already created 2 worker nodes for this cluster. You can have n number of nodes, 10, 20, 13. That is up to you. Kushagra, is it like CNI, like Flannel, Calico have their predefined CIDR? Yes, Kushagra, by default, they use their own predefined CIDR. You want to give your own specifically, you can do that. Otherwise, they will work it at their own choice. Please, how do I download the bookmarks from my Onam? Simply, you can Google it. Otherwise, if you want my help, I can do that also. Simply go to your bookmarks. All right. Here have import bookmark and settings. You can import here. First download this HTML file and then go to your bookmarks, import bookmarks and settings. and somewhere from here you can download your bookmarks. Just a minute. It is a simple process. You can Google it also. If it doesn't help, let me know tomorrow. I'll help you. Gaurav, I got your question during exam only. I don't know what exactly your question is. Please keep your question in a single message. Sir, a 3-start strategy for master, we'll discuss that later on. Okay. How to remove a node, how to add a node, how to change your master, everything will be done, but little bit later. Can I mix OS VM in a cluster including mix Linux flavor and Windows Linux flavor? No, Siddharth, Linux type of flavor, you have to have Linux type of flavors, not Windows flavor included inside your cluster. Ideally, your complete cluster should be of the same flavor, whether Ubuntu or Sushi or CentOS. But you can have a different in a same cluster, but it should be of Linux flavor. You can have Sushi, you can have CentOS, you can have Linux, you have Ubuntu. In the same cluster, you can have that. But it is not suggested because it's complicated things. What during exam, what platform will we get, Ubuntu or Red? Gaurav, all the examination will be done on the Ubuntu. That is why we have chosen Ubuntu for our labs. Sanjay, can we get exam syllabus topics percentage? Sanjay, on the last day of our course, I am going to show you a complete picture. I will give you so many tips and tricks for your examination as well. But still, if you want to see it right away, you can go to the CNCF website. You go to the certification, Certified Kubernetes Administrator, and here you get the weightage. Okay. Your architecture installation configuration weightage weights 25%, workload and scheduling 15%, service and networking 25%, storage 10%, troubleshooting 30%. Okay, and you get 2 hours to complete your examination. Machines in the organization don't allow internet, so can we install cluster there? Kushagra, yes, you can install your cluster there as well. Then you have to go the hard way. Ashok, examination fees, I guess it is somewhere around 21,000. I have to double check that, but I think it is somewhere 21,000 rupees in INR. Somewhere around that. Don't remember the exact cost right now. But if you want, I'll come back to you with that. Edurica guest, you are asking, is there any mock test or question bank that we can learn? Edurica guest, all the examination guide is provided on the GitHub repository that I have shared with you. Okay, you will get everything here. For example, your examination preparation documents are also here. Okay, CKA part 1, part 2, part 3, all the guides are provided here for your examination point of view. Okay. If you want to know all the details about your examination as well, you can see old version of examination has 3 hours, but nowadays you have 2 hours of examination. Questions ranges from 18 to 19 questions somewhere around you have in your latest examination way. Passing percentage has reduced to 66%. Earlier it was 74%. Now you just need to score 66%. That's all. Okay. All the details are provided here for your examination point of view also. Okay. It will help you thoroughly. Apart from that, you get 2 attempts for your CKA examination. Okay, so if you want to have a real-time scenario, real-time example, you can opt for an examination once you clear, it is very good. But because of some reason, if you couldn't make it, you get second attempt also in the same fees. So one-time fees, you get 2 chances for your examination. Shiju, Sanjay, I think you got your answer for the passing percentage now. How difficult is in the exam? Any idea on the passing percentage in the first? Okay, Arjun, I think you got your answer as well. Okay, so all the things are here in the repository. Go through this repository, play with this repository. It is going to help you a lot. Okay. So team, last thing I want to show you for today. Okay. Don't ask me much question on that. I'll explain you all the things tomorrow. I just want to show you a small thing today. kubectl get pods -n cube-system. Okay, so team, this is the command with which you can see all the components which are running where. Okay, you can see APS etcd is running on master. Kube API server is running on master. Kube controller manager is running on master. But you can see 3 kube proxy. Why 3 kube proxy? Because one proxy is running on the node, on master as well, on all worker nodes as well. Scheduler is running on master. VNet containers, VNet pods are also running on all the 3 nodes. Okay, core DNS is used for the naming convention. Okay, so this is the command with which you can see all the components which are running where. Okay, complete explanation I'll be giving you tomorrow about all this. Okay, so as of now, I think we are done for today. So how was the class? A question for you. Okay, great, good, Kushagra, good. Let me know what you want to get for the excellent. Thank you. Excellent. Okay, superb. All right. So team, one more thing. I hope your previous trainer has also told you that or not. I'm not sure. Okay. So in Edureka, it is the excellent rating which actually counts. Okay. Good is negligible. Good is equivalent to bad or something. Okay. So it is very important that you provide your written feedback as well. And if you like the content, if you like the way I deliver things, provide your feedback as excellent. If you have any complaints and if you want anything to be changed the way I teach, you can give your good, bad, average as per your choice, but do provide a written feedback as well. Written feedback also matters a lot, and if you like, provide an excellent so that it counts. All right. So team, I guess we are done for today. If you have any questions, you can ask. If anybody wants to get unmuted, you can ask. Else, we are done for today. We can have the session tomorrow again and we'll proceed further. Yes, Kushagra, there is a scale. Ashok, yes, if everything goes fine, if your feedback goes fine, if feedbacks come into my favor, then you are not going to change any trainer now onwards. I'll be completing your complete course. All right. So team, yesterday we have already discussed about some of the agenda from yesterday, like Kube architecture. We did the installation, we bootstrapped the cluster, we checked the components, we saw the directory structure folders, which I was talking about, and the API resources, container network and pods. These were the topics that we were supposed to cover yesterday, but we didn't. So we'll start right from there, and then we'll cover these topics. We'll see how your multi-container pods works. We are going to see some commands with pods. We see what kind of static pods or init pods are there. We'll see about labels, limits, environment variables, what are probes in Kubernetes, and what are the services. All right. So this is the agenda, and we'll try to cover it today. If not, we'll pass it on to the next week. But we are not going to rush into anything. Okay. So we are going to start, but still, if you want to ask any question from yesterday's class, anything which was not clear to you, which you want to share, which you want to discuss. So first we can start with that, if you have anything from the yesterday's class, and then we are going to start for today. So if you have any questions, you can ask. Okay, when we want to join to the worker node, we need to execute a token certificate. If we lost it, where can we find it? Okay, got it. I think this question is from Edric, I guess. I cannot see your name. So you're asking if you lose your token, then how you are going to have it back? That is what I have provided you in the GitHub repository links. You can go to your install folder. And this is how you're going to find your token back. Okay, this is the command that you need to execute on the master node, and this is going to provide you the token again if you want to add another worker node to your cluster. Okay, in the node or master, I have performed all the installation activity as root. When I tried to run Docker PS or Docker images as normal user, getting error. Hope we don't need to worry as K8 will take care of internally. Got permission denied while trying to connect to the Docker socket. Okay, Gopal, we are going to see few commands with Docker also, but that is not a mandate. But we'll see. Let's see. I am going to provide you further steps, and if you won't be able to do that, then we'll see further what is the issue. As we are 1 week behind, do we need to finish second week quiz because it's showing deadline for the third and fourth? Girish. Okay, Girish and everyone, it is not the case. It is okay if you delay your quizzes. You can complete your quizzes once we are complete with all the classes. You get some grace time. Once we are done with our 8 weeks content, then you get some grace period of, I guess, 8 to 10 days. And then you can also complete your all the quizzes. So no need to rush on that. Okay. All right. So team, I guess we can start for today. All right. Okay, so this is my master node. All right. And yesterday, before leaving, I showed you one command. kubectl get pods -n kube -system. I don't know if you understand about this command or not. Yes, here it is. Okay, so team, one question for you now. All right. The thing is, you can see all the master node components. All right. All the worker node components are also here. etcd, API server, controller manager, proxy is also there, scheduler is also there. Okay. You have already seen that we have installed your CRI as well separately, Docker on all the machines. Still, there is one thing missing. Can anyone tell me what is that? Ashok, I don't get your message. Screen is big, unable to see the service. I'm not sure what you're trying to say. Can you please explain more clearly? Shishu, yes, you got it. Gopal, you got it too. Venkateshwari, you can see etcd right here. Here it is. Yes, Arjun, you got it. Team, anybody else is facing any chat screen visible to all of you? Virish, these are the pods. Sanjay, networking is not right. Ganapati, database is the etcd, so database is also there. Joydeep, all pods, these are the pods right here. Okay, Ashok, I think all can see my screen properly. I am not sure if you are facing any challenge with the screen pick. Can you connect back if that is a problem with you? Rishabh, as of now, I have specifically mentioned cube system namespace. So that is why you are seeing cube system namespaces, pods. So you cannot see pods of any other namespace right now. I'll come back to that also. I haven't discussed about namespaces right now. I'm just asking, as for the architecture, which component is missing? Girish, no, network is also there. Sanjay, you got it right. Okay, guys. So the thing is, kubelet is missing. If you remember the architecture, many of you gave me the right answer. Alright. So there was one component on the worker nodes that is called kubelet, which is not there. So kubelet is not there. Why? Everything runs as a pod, I told you, in kubeADMware. But kubelet is not there. No, Shiju is not like it is inactive, it is active. That is why you get the output of kubectl get nodes. And you can guess, even all the two proxies are coming from the worker node. Sanjay, so you can see the master node components as well. Sorry, worker node component also here. Master can get details from everywhere. No, Gaurav, that is not the case. Some pods are already running on the worker nodes. If you want to see, I can show you that also. See, 2 VNet pods are running on worker node 1 and 2. 2 proxy pods are running on node 1 and 2. Siddharth, you gave the right answer. Ankur, so do you. Great team. So the thing is that kubelets run as a service. Okay, kubelet is not running as a pod. Kubelet runs as a service on the worker nodes or on all the nodes. Okay, so if you want to verify that your kubelet is working or not, you have to check it if it is running as a service. Service kubelet status. Okay, so you can see that kubelet here is running as a service. Okay, so this is, you have to remember that kubelet is not a pod, kubelet is a service. Alright, so we have already seen all the components which are working here. Ashok, still you are facing the challenge with the screen size. Okay. Ashok, there is some challenge from your end only because I cannot see any other complaint from any other candidate. So it has something to do with at your end only. If I'm going to reduce the size, it is not going to be very visible to all of you otherwise. The content I want to show. If you are connecting from your mobile, I'll suggest you to connect from a laptop so that it will be visible properly to you. So is it better now? I have reduced the size of the window. Ashok, is it better now? Ashok, I cannot reduce the size more than that because it is going to hide the content for all other people. Yes, please try login again. Okay, guys. Okay, so this is what we have seen so far. And I think if this command still working or not, let me see. Okay, let it be now. Let it be for now. All right. So, team, the next question. Now you understand the architecture completely, right? So here was the architecture. All right. So consider that I gave a request to create a pod or container, something like that. So how the flow is going to be now? Okay, so any command I'm going to give with the kubectl, I want to create some pod, I want to create some container. So how the flow is going to be? I'll give the command with kubectl. It will be heard by API server first. Okay, API server will listen to the request and it will check with the scheduler that at which node is capable enough to have that pod or container. Okay, so API server will check with scheduler and scheduler will see, depending on the details stored in etcd, that how many nodes are there, how many worker nodes are there, what are the capabilities of the worker nodes, which node has what configuration, how much RAM is there, how much storage is there. Okay, so scheduler via API server will check the details from etcd, and once it get the details that this node is properly suitable for that, scheduler will instruct API server that you should recite your container on node 2, and thus API server will connect with a kubelet of node 2 and it will instruct to create a container on that node. After kubelet gets a request, kubelet will ask Docker to create a container on the node 2. This is how your complete flow is going to be. Okay, so next thing is, what is your pod and what is your container? What is the difference between a pod and a container? Sanjay, the role of the controller is to maintain the actual state with desired state. Consider that I want 10 pods running all the time, and because of some reason, if I deleted one of my pod accidentally from the node, it is going to check that if actual state is matching the desired state, it will see that desired state was 10 pods, but actually only 9 pods are running. So controller is going to spin off one another pod automatically without your intervention. That is the role of controller. Yes. Okay. So team, the thing is that a pod and a container is nothing different but just a wrapper around your container. Okay, there is a container, and if you wrap a container with a layer of Kubernetes object called pod, then still it is going to be the same. Okay, so it is identical. A container is same as a pod in Kubernetes, only the difference is it add a additional layer called pod in Kubernetes. But why Kubernetes wrap another layer? Okay, now that is the question. If a pod is also a container, just a wrapper around it, why we are having a different terminology? The thing is, whenever you delete a container, whenever a container restart, it changes its IP and it changes its ports. Okay, thing is, whenever you delete a pod or whenever you delete a container, whenever you restart a container, when you want to create a similar container again, what happens every time the IP of the container changes and the port number also gets changed. Okay, so that is the story with Docker containers. Why Kubernetes have pods, an additional layer around the container? Because the container IP is going to be changing every time as a basic nature of Docker container. Whenever the container restarts, whenever the container is deleted and recreated, the IP of the container is going to get changed. The port number of the container is going to get changed as a basic nature of Docker container. But in Kubernetes, pod provides you that functionality which doesn't change the IP of the container. Okay, the IP inside the pod of the container will keep on changing, but the IP of the pod will remain same throughout until unless you delete the pod directly. Okay, whether your container restarts, whether your container gets deleted and recreated, if your pod is still there, the IP is going to stay consistent with pods in Kubernetes. Okay, the thing is, what is the role of kubelet in master? Sarath, as I told you that kubelet is a class teacher in your class, which take care of all the components, right? So there are some static pods as well. I'm going to tell you about that concept. For that purpose, we need kubelet on master. So I'll answer your question practically a little bit later in today's class itself. But pod deployment and replica sets are given in controller. It should instruct to API server. It should instruct to scheduler via API. Sanjay, I'll show you the flow practically. Okay, allow me some time. As of now, I am explaining you about the Docker containers and Kubernetes pod. So let's understand about that first. Yes, Girish. You're right. We have elastic IPs here. Okay. So the thing is, pod doesn't change its IP, which provides some good functionality with Kubernetes, because Kubernetes is going to address the pod every time. In Kubernetes, you don't address the container, you address the pod. And the IP of the pod is going to stay consistent, whether your pod gets restarted or not. Okay. So that is one major benefit in pods. Next thing. Consider that you have two interdependent containers. Okay, so you have an Nginx container, which is serving as your application container, and second is your Splunk container, which is getting the logs from the first container and completing your functionality. Okay, so your requirement is that you have an application container and you have a log container, which is getting all the logs from your primary container. If you talk about Docker, okay, if you talk about Docker, you can see that both the containers are dependent to each other. If your Nginx container goes down, means your application is down. What is the purpose of Splunk? It cannot get logs from anywhere, right? Similarly, if your Splunk container goes down, your application is running, but you are not able to fetch the logs. Still, my purpose is lost. Okay, so the thing is, I have two containers which are interdependent on each other. If one goes down, another one is useless for me. Right, so that is the story about Docker containers. So it is a problem for me. Now consider inside a pod, it is always suggested to have one container inside one pod. Okay, it is always suggested to have one container inside one pod, but depending on the requirements, you can have multiple containers inside a pod as well. Okay, so both the containers will have their own IP addresses, and still you will have a single IP for your pod as well. Inside your pod, you have two containers, but pod IP address is going to remain just one. Alright, because they both are serving as the same functionality. It runs as an application and it gets the logs. So both the containers are dependent on each other. That is why I am putting both the container inside a single pod. If you want to see how it works, you can see here as well. Can you see VNet pods? In VNet pods, you are seeing 2 by 2. It means inside a pod there are two containers running, and both the containers are up and ready. For all the others, you can see 1 by 1. 1 by 1 means inside one pod there is one container only. But if you see for the VNet has some functionality. That is why it has two containers inside one pod, and both the containers are up and running. If one container goes down, it will show you 1 by 2 and it will show you not ready. That is the feature of having two containers inside a pod. if my two containers are interdependent to each other, consider that my Splunk container goes down because of some reason. My pod will show not ready status or unavailable status. That is why we have two containers or more than one containers inside a pod. If they are interdependent, if one container goes down, the whole pod will not be available for the purpose. Consider your application container goes down, your Splunk container is there, still my pod will be unavailable. So this container will also won't work at all. Okay, so team, I hope containers and pod is clear to you. What is the difference between a container and what is a pod? Let me know if you have any questions. If it is clear to you, then we are going to have some practical things. Okay, Gopal, Sanjay, got your answers. Rishabh. Okay, thank you, Ankur. All right. So team, let's move forward. All right. And let's start creating your pods now. Now you understand the concept of pod. Now we can create pods. Will we do demo of creating a multiple container and pod? Yes, Anurag, that is what we are going to do real soon, today itself. Okay, I'll show you multi-container pods as well. Alright, so team, as I told you that your Kubernetes has pod as an object, not your Docker containers. Alright, so you like replica set and deployment. So if you want to know that how many objects are there, there is a command called kubectl API resources. Okay, so team, you can see all the objects that are there in Kubernetes, kubectl API resources. There are binding, component statuses, config maps, endpoints, events, limit range, namespaces, nodes are there, as we have already done kubectl get nodes, right? We have pods, we have persistent volume claims, and a lot many objects are there. We are going to learn about all the objects. That is the thing. We are going to learn about all the objects. Okay, so these are the complete name. If you want to use short names as well, you can use a short names as well. Okay, like for nodes, if you don't want to write complete NODES, you can use NO as well. Right? If you want to see kubectl get NO. See, I still got the output. So these are the short forms. If you want to use short names, you don't want to use the complete name because some names are really big. Like you can see this one, or this one, this one. You have a lot of objects with long names. So if you want to use a short name, you can use a short name as well. So this is one of the command that I wanted to show you. Now consider in Docker, if you want to create a container, you use docker run command. Okay, so you will see that so many commands in Kubernetes are very similar to your Docker commands. Okay, you're going to see that. So first of all, if I want to see if any pods are running or not, kubectl get pods is the command. Okay, as of now you can see no resources found in default namespace. Now I want to create some pod. In Docker I do docker run. In Kubernetes also I do kubectl run. Kubectl run, and let's name a pod as Shub. Then I have to give the image, which image it must be using. For say I'll use Nginx image right now. Okay, so this is the syntax: kubectl run your pod name -- image and then give the image name. You will see that a pod is created. Kubectl get pods. Okay, Now you can see a pod is running. There is one container inside it and one is also ready. So the status is running, that's why, and the age is 20 seconds. Now if I want to have a better look to it, I'll do kubectl get pods -o wide. It is going to give you a wider output or a lot of details. Okay, so you can see the name, ready, running status, restart. As of now, it has not restarted. Age is 44 seconds, and this is the IP. If you want to curl this IP, you can see a Nginx output here. See, you get the message, welcome to Nginx, when I curl the IP. Okay, it is also showing you that it is residing on K node 2. Alright, I told you that Kubernetes scheduler decide where your pod is going to be living. It decided it as node 2, and that is why you can see this pod is running on node 2. Okay, so if I'll show you something more about this, if you want to get more details about your pod, you can do kubectl describe pod and pod name. Okay, it is going to give you a lot more details about your pod. Okay, from here it started. It gives you name, namespace. You can see where it is running, where it started. All right, the IP. What is the container ID actually? Which image it is? Okay, so a lot more details. Important part is here. The events. So team, with the events, you can see the complete flow, how it actually went. First of all, when I gave the command from kubectl to API server checked with the scheduler, and scheduler decided that this pod should be assigned to node 2. Afterward, the responsibility went to kubelet of your node 2, and it pulled the image of Nginx. It successfully pulled the image in this much time, and then it created the container, and then it started the container. Okay, this is your complete flow, how it goes when you request something to Kubernetes, whenever you create any object. Is it clear to all of you? Yes, Ganapati, you can use -o wide to get a wider output. If there are more details with any command, it is going to show you that. Achirika, guess you're asking, can we force to create image to specific node? I think you want to create a pod with a specific node. Yes, we can do that, and we'll see that also. Yes, we'll see that. We can do that. Sanjay, how many pods can be created in one node? Okay, there is a lot. Okay, so it was never a situation to reach the limit. That is why I'm not sure. Still, you can see the capacity here. All right. Afterwards of 19th version, there cannot be 5,000 nodes, more than 5,000 nodes, not more than 1.5 lakh of total pods. Okay, 3 lakhs of total container, not more than 100 pods per node. So this is the limits. It's saying container means Nginx. What about pod? Okay, Grish, pod is already there. Pod is a logical wrapper around your container. So if your container is running on node 2, Kubernetes is going to identify it as a pod. Okay, so in description, it is giving you all the details. Description is a complete detail, right? So if a container is created inside a pod, it is giving you the events about that only. This container was created inside a pod. This container was started inside a pod, and that is why you are getting the output of kubectl get pods like this. We saw that this pod is running on your node 2, We can verify that as well. I'll come to your node 2. Okay, Docker is already installed here. Docker ps grep shub. Okay, here you can see this is your container ID, this is your image. This was running from last 5 minutes, and these are the details. So you get the container running on your node 2. You can verify that with Docker command as well. Okay, so now we have seen the description also. In description, you get all the details about your pod, all the details about your container, and all the event logs are also there. Alright, but in enterprise level, at enterprise level, we don't create a container or pod from the command line with like just I did, like kubectl run pod name. That is not the practice that we actually follow at industry level. We write YAML files. Okay, you have to give a complete definition into a YAML file to create a pod or any other object in Kubernetes. We never do that from the command line. This was a starting, that is why I showed you from the command line. But we use declarative syntax. Declarative syntax is called your YAML files. So whenever we are going to create any pod, any container, any object in Kubernetes, we are going to do that with a YAML file. Okay, so how the YAML formatting work? I hope all of you are pretty much aware about YAML. Is there anyone who don't know YAML? If there are people who don't know about YAML, I can give you a brief idea about it so that you can clearly understand about your manifest file, because YAML is really important to proceed with this. So if anybody has any doubts, if anybody doesn't know about YAML, you can let me know. I'll give you a brief idea. Okay, there is a very interesting question from Sarath. Okay, alright team, I'll give you a brief idea about YAML formatting also, but there is a very interesting question from Sarath. Nobody else asked about it. Okay, Sarath is asking, there is a pause image in the worker node. Right, so team, this is a very important question. Okay, you might get this question in some of the interviews if they get very detailed. Alright, so the question is, there is already one container running with the name of Shub, but still there is another container running of Docker, which is a pause container. What is that? Why there is a pause container running along with your Nginx container? The image is also different, but the name is same. Why? Anyone? No, Sanjay. Kushagra, you're right. You got the correct answer. Grish, yes, to some extent. Abhinav, you got the right answer. Mosumi, no, it is not a prop. Okay, team, one thing I told you when I explained you about your pods and container. I told you whenever a container restarts, whenever a container gets deleted and recreated again inside a pod, the IP of the pod is going to remain the same. Right? No, Anurag, that is not a command. So these pod container, whenever you create a pod with a single container, one by one container, one pod, still inside that same pod, another container is always created, which is called a pause container. And this pause container is used to retain the details about the container. Because I told you in Docker, every time the container gets recreated or restarted, it changes its IP, but pod doesn't do that. That is why there is a mechanism in pods that whenever a container is recreated, its IP will remain the same and that details will be fetched from the POS container. Okay, that is the purpose of your POS containers. So whenever you create a pod with one container, a POS container always starts with it to retain the information about the container, because of some reason if container goes down or it gets restarted, POS container will fetch all the details and give it to the container so that the IP address of the pod will remain the same. So that is about it. Now let's have some idea about your YAML formatting. Okay, so team, YAML is nothing. YAML, the full form is YAML and a markup language. Okay, YAML is not a markup language, it is a data serialization language. Okay, it is a structured format. So there is only one rule in YAML. Okay, if you want to do anything with the YAML, there is only one rule, that you have to follow the indentation. Okay, you have to give spaces wherever necessary and no tabs. Important part is this: you cannot tab anywhere in the YAML, it is going to cause indentation error. So always use space bar when you write the YAML file. Okay, in YAML also there are three features. Okay, you can have a scalar, you can have a dictionary or map, or you can have an array or list. I have given the complete examples about that also. Okay, in scalar is a very basic thing. You will have a key and you will have a value. Okay, so in YAML you follow key value pairs again. Okay, you will have one key and you will have one value. Okay, so in scalar it is the most simplest one. You will have some key and you will have some value. For example, name is Shubh. Okay, or I give a variable a, I'll give the value as 5. Okay, scalar is just a key value pair. Next is your dictionary or map. In dictionary, you will have multiple attributes about a key, and those attributes will have multiple values. There is going to be one key, but there is not going to be one value. It will have multiple attributes and it will have multiple values. For example, if I have a car as a key, okay, what are the attributes of the car? The car will have some name, the car will have some color, okay, they will have some engine specification. Okay, so in dictionary or map, dictionary means that you will have one key and it will have some attributes, and those attributes are going to have values. Okay, so this is an example. The last one is array and list. In array or list, you can say there is going to be a key and there are going to be some values. There are not going to be any attributes. Okay, for example, consider in array and list, there is a list, so list is going to have multiple values. So now I am not talking about a car, I am talking about cars. There are going to be multiple cars. Okay, so multiple cars, if I'll do this, let me remove this part and let me remove this part. Okay, so in car, if I'll talk about dictionary, you can see I am talking about multiple attributes of a single car. In array or list, there are going to be cars and there are going to be values. There are not going to be any attributes. Cars, multiple names: BMW, Audi, Tesla, or many more. Okay, so these are the three definitions in your YAML formatting: scalar, dictionary, and array. And the beauty is this, that you can use each of them inside other one. You can have an array inside a dictionary, you can have a dictionary inside an array. So that is also possible, and that is why I just removed it. So now you can see cars have some array. Array are BMW, Audi, or Tesla. Now what I have done, inside an array, I have defined a dictionary, if you can see. Right? So you can see this is just similar like this. I'll have a car, I have a name, I have a color, I have an engine, and this is similar to this. BMW is a name. Inside that I have defined name as BMW, color as red. So what is happening? I have defined a dictionary inside an array. Again, I have done that. For audio also, there is a name called Audi. There is a color called green. Okay, so I have defined a dictionary inside an array. So the important part you have to follow is about the indentation. Okay, so if you're using your Notepad++, if you'll go to languages, you can see there is a YAML formatting. So you have this look, this kind of look. You can see a key started, and then I gave 2 spaces. Okay, for the definition of an attribute. If I misplace any spaces, it is going to create an error. You can see this key starts from here and ends here because the indentation is exactly the same. If I change the indentation, see, I gave 2 more spaces. So what happened? This attribute 2 becomes a part of attribute 1, not a part of the key. You can see here, your attribute 2 is a part of attribute 1 now because of the indentation. It has changed. So it is very important that you follow the indentation very properly. It should get aligned. It should have proper indentation. If I remove the spaces, you can see that your key started from here and attribute ends here. Okay. After that, another attribute started because the space has been changed. So this key has just completed with attribute 1. Now you have attribute 2, and attribute 2 have a part called attribute 3. So it is very important that you pay attention to the indentation and spaces in YAML. So this is about your scalar, dictionary and array. I hope it is clear to all of you. No, Gopal, you can give as many spaces as you want. It is just a practice that we follow to have 2 spaces. If you want to have more spaces, you can have more spaces as well. See, now I am giving 4 spaces. Still, you can see the indentation is correct. Your key starts here and ends here. So it is general idea that you give 2 spaces, that is more than optimum, so that it is clearly visible as well and it is not wasting more spaces. So that is why we give 2 spaces. You can give 3, 4, 5 as per your requirement. Okay, so team, now when your indentation or YAML is clear to you, now I am going to show you some of the YAML files with which we are going to create your pods. Okay, there is a folder called pods, and I'm going to pick one pod example from here. Okay, there is a pod.yaml here. Okay, so team, this is how you are going to have a definition of a pod. Okay, this is how you are going to create a pod in YAML. Now the question is, what is this API version here? What is any object in Kubernetes, whether it is a pod or deployment or service or whatsoever, whatever you are going to create with YAML inside Kubernetes, there has to be 4 fields mandatorily. Okay, 4 fields are mandatory. And what are those 4 fields? You always have to mention the API version, you always have to mention the kind, you always have to mention metadata, and you always have to mention the specs as well. So whenever you create any object in Kubernetes, you have to mention these 4 always, without fail. Otherwise, your object is not going to get created. So Kubernetes has defined these 4 parameters as mandatory. So from where we are going to fetch these information? I'll show you that here. So with kubectl API resources, you get all the details about all the components, right? What are all objects you can create? Pod is also one of them. Now you can see this is a full name and this is a short name. This is the API version here, V1. It is visible you here. Alright. You can see I have mentioned V1 API version. So you can see the API version here, V1. For all the objects you can verify. Okay, it can be namespace or not. I'll tell you about that when we talk about namespaces, and this is the kind. Okay, so if you want to create a pod, you have to mention the API version from this table and you have to pick the name as kind. Okay, here you cannot use short name. So if you want to give here as just a PO, like it is mentioned here, short name from for a pod, you cannot use that. You can see PODS, pods. But what is the kind? Kind is pod. You have to mention the kind here. Alright, so you can see that I have mentioned the kind as pod. Or if you want to get more details, you can use explain command, kubectl explain pods. kubectl explain pod. Here you can see what is the kind? Pod. You have to mention this kind here. Next is version v1. You have to mention that here, API version :v1. Okay. Then you get other details as well, that what are the description, what is a pod. Pod is a collection of container that can run on a host. This resource is created by client and scheduled onto host. Okay. You get some one-liner description with of all the objects here as well. You can use explain command with any object. Okay. And what are the fields? It is mandatory. You can see here. In fields, you have to mention API version, you have to mention kind, you have to mention metadata, and you have to mention the specs. The status is optional. If you want to mention, you can. If you don't, you don't. But these are the 4 mandatory fields you have to mention in a YAML file. Now let's see about this definition. I have mentioned the API server version, API version. I have mentioned the kind. Then metadata. What is the metadata? Metadata is the details about your pods or container. Okay, what's the name it is going to have? Your pod will be named as pod 1. Okay, labels, I will come back to labels later. As of now, you can ignore it. Okay, metadata is pod 1. What are the specification? You have mentioned the name in metadata, but what are the specification? Your pod name is going to be there, but what kind of container I am going to create, how many containers I am going to create, which image I am going to pick for the container, that all you are going to mention under specification. Okay, so now you can see that specs have containers, and what is it? It is a array. Sorry, just a minute. So you can see it is an array now. Specs, containers. And then under containers, you can see container have some attributes. Container name is going to be Tomcat. Image is going to be Tomcat. And if I'm running a Tomcat, I can give the port number as well if you want. If you don't want, you can skip this part. So ports, container port, Tomcat will be running at port number 8080. Okay, so this is one example. I have multiple example of single container pod as well. Okay, this is another definition. This is another definition if you want to use this one. Okay, so that is up to you. You can use anyone. As of now, I am going to pick this one. vi pod.yaml. Okay, so you are going to write a vi editing file. I'll paste the content here and I close it. Okay, now if you want to create any object from a file or YAML file, the command is kubectl create -f if you are giving a file name and then the file name. Okay, so you can see pod 1 is created with the YAML file kubectl get pods. Okay, as of now you can see the status as container is getting created. That is why it is showing you 0/1. Tomcat is a heavy container, that is why it takes some time. Until the status is creating container, it is showing you 0/1. It means it is not ready. Still taking some time. Why container port is an array? Mosumi, that is how its formatting it is in YAML. That is understandable by Kubernetes. Do we need to remember these YAML formats for exam? During a guess, you have to understand about the basic concept, what are the mandatory field. But if you don't want to remember, I'll show you that also. How you can avoid remembering all that. But still, 4 fields you have to remember that you have to give 4 fields. Okay, so team, now you can see that pod 1 is created and it is also running. Alright. Let's see where it is running, shall we? So you can see the pod 1 this time is running on node 1. So it is always changing the node, okay? Because both the nodes have similar configuration, that is why it is going in round robin. First it's created on node 2, then it created on node 1. Can we use more than one kind in a single YAML file? Ganapati, yes, you can use, but the thing is you have to use for all the objects. Okay. Let me show you that. Just give me some time. So team, if you want to delete all the pods at a single go, you can do that also. kubectl delete pod. Okay, if you want to delete a specific pod, you give kubectl delete pod and pod name. If you want to delete all the pods, you are going to give a flag call -" all. Okay, with this command you can see that pod 1 and pod shub are getting deleted. So both are deleted. I'm removing the pod file also. So if you want to give more than one kind, then you have to give a separate definition as well. Okay, so you can see I have differentiated with 3 hyphens. If you want to create 2 pods at a single time, you can create 2 pods as well. vi pod.yaml. Okay, give as many definition as you want. I have given twice the kind now, right? You can see kind here and kind here. But with that, I have given different API version again. So whenever you are giving multiple kinds, you have to give all the fields again because you are creating multiple objects this time. Okay, so now I am going to create pod 1 and pod 2 as well. For that, I have to give 2 separate definitions that I can give in a single file. kubectl create -f pods.yaml. See, now 2 pods are created. You can create multiple objects in a single YAML file as well. See, both the pods are running from a single file. That you can do. Can we install a pod on specific node? Yes, Himanshu, we can do that and we'll see that further. Yes, Akhil, I'll show you that just in some time. Thank you, Ganapati. Siddharth, you're asking, coming back to pods container, is it created per container? If yes, then the total number of containers running on the node would be total 2. Is that fair understanding? Yes, Siddharth, you're absolutely correct. Your understanding is completely right. How both pods are created in less than this time. Govinda, the thing is, this time your image was already downloaded. Right? You understand that Nginx is a light one, so it gets downloaded easily. But Tomcat is also getting created very soon this time because it was already created earlier. That is why your image was there on the node and it picked the same image. But if image is not there, it has to download the image also. So that is why it takes some time at the first go. Sanjay, how 2 pods are created? Because this time I gave 2 definition in my pods file. You can see in this YAML, I have given 2 definition, one for pod 1 and one for pod 2. That is why 2 pods are created. In Docker Swarm, we used to run docker prune-a to clear all the unused images or container. How about in okay, Satish, if you want to delete the unused images, then you have to do it manually. Okay, because Kubernetes doesn't take care about the images. That is why we install Docker on every machine, right? You understand that we install Docker on all the machine. What is the purpose of installing Docker on all the machines? Because Kubernetes is not going to take care about the images. Kubernetes is going to delete is going to delete the pods only. It is going to delete the containers. It will play with the containers and pods only. It is not going to take care about the images. So if you have to delete the unused images, you have to go to the nodes and use your Docker command only. Sanjay, why it should be one? I have given two definition. If I'll remove one definition, it will create one pod. If I have given two definition, it will create two pod. If I'll give three definition, three pods here. Any restriction when we create pods apart from 4 mandatory component in the YAML file? No, Arjun, it is not a restriction. You can give as many fields as you want. Going forward, you will see how many components are actually there and how much detailed definition you can give. We'll see that as well. Sarat, the image is going to get downloaded where the pod is assigned. If your pod is assigned on node 1, your image will be downloaded there on node 1. If your pod is assigned on node 2, image will be downloaded at your node 2. Because you have to understand the basic flow. The node has been assigned for the pod. If node 2 is assigned, then the Docker living on node 1 will take care about creating the container and downloading the image. So is it fair to say that the total limit provided by Kubernetes is actually half? Let's say 10K in the total limit. So actually containers, it is supported 50K. Okay, Siddharth. It actually never happened that you reach this limit. It is also not suggested because if you have this much load, you will create multiple clusters and multiple nodes. Okay, this is the maximum limit it has defined, but we never go as per the maximum limits. If you have this much load, you will have to create multiple nodes and multiple clusters. How can we create two pods? Himanshu, you are asking how to create two containers inside a pod. Team, a humble request to all of you. Okay, a humble request to all of you. We'll cover everything, how to work with multi-container pods. I have already told you many times. Just bear with me. Please ask the question from the content that I have just delivered. Okay, when I'm asking you to ask a question from the content I have just delivered. Once it is clear to all of you, then I'm going to move to the next part. So first, I'm trying to make you understand how one container works inside a pod. If all of you understand that properly, then I'm going to move to the next part. So definitely we are going to see everything, how multi-container pods works as well, but one step at a time. Fields in metadata are compulsory. Sanjay, that is up to you. If you have given the field called metadata, under metadata, it is dependent on you. Under metadata, name is mandatory, labels are not. So that is up to you. Under metadata, name has to be always there. Other things are optional. If you want, you can give. If you don't, you don't give. Govinda, so right now in which nodes these pods are created? Okay, we can see that. kubectl get pods. Okay, -white. Okay, you can see pod 2 is running on node 2 and pod 1 is running on node 1. Sanjay, yes, pod will not get created if metadata field is empty. You have to give the name. Even if we create two pods from one YAML file, it will spread across multiple worker nodes as per the scheduler activity. Is it current understanding? Yes, Joydeep, you have also seen that now. Okay, Ashok, you're asking about the pods container again. Okay, Ashok, I'll tell you that. So Ashok, the thing is, I told you what is the difference between pod and a container. Okay, container whenever gets restarted, its IP or its port number is going to get changed. But whenever a pod dies or gets recreated or gets restarted inside a pod, its IP remains the same. How its IP is sustaining, whether the pod, even when the container was deleted, how the IP sustained, because pod always create a POS container inside itself to hold the details about the container. Whenever a container is created, it is going to store the networking details about the pod's IP and port number. All the details will be stored in a POS container. POS container purpose is to store the details. So even if your container gets deleted or gets restarted, it will get the same details every time it's getting created with the help of POS container details. So I hope it is clear to you now. Akhil, you have the GitHub repository link, right? So all the structure are there. I'm giving you all the examples right from there. Yes, Govinda, scheduling is done by the scheduler. Prempal, you are asking about the algorithm that scheduler takes. Scheduler takes a lot of consideration. If you want to see, I'll show you kubectl get nodes. So there's a question from Prempal that on what basis your nodes are decided for the pod assignment. kubectl describe. So now these commands must be handy with you, that what describe does, right? kubectl describe node 1. Let's describe it. Okay, so Prempal, the thing is, it takes the information and it checks for certain tick marks that if it is proper, healthy or not. Okay, it will check that network available is not available or not. Network unavailable, it is false. Is there any memory pressure on that particular node? False. Disk pressure is false. It means there is plenty of disk space. PID pressure, process ID pressure is also not there. The status of the node is ready or not. So these are the certain checks that your controller does on all the nodes, and depending on that, it assigns the pod to your nodes. Okay, so it gets all the details and then it is going to check for that. It is also going to check that your kubelet is available or not, or your node is available or not. If node is available, is there any memory pressure, is there any network unavailability? All the multiple checks are done, and then your scheduler decide that this node will be suitable for your container or pod. I hope it answers it. Kapil, nominated node is the node where the pod is assigned. Ganapati, you're asking if one node is down for some reason, will K8 take care of the running those node in worker machine automatically? Ganapati, if one of your node goes down and there are certain pods running, if node goes down, controller manager will take care to migrate those containers to another node. For example, there is one pod running on your node 2 and the details are stored in etcd. So controller manager is going to see that your node 2 is not reachable. It is failing with kubelet connection. So what it will do, it will delete the details about that pod on node 2 in etcd and it will migrate that container or pod on node 1. Okay, that was a long question answer session. I hope it is clear to all of you now. Now, so many things practically. Okay, now I am going to bore you a little bit with theory part. Okay, because this part is important for your examination point of view only if you are opting for CKAD. If you are opting for application developer part, then it is important for you theoretically. Otherwise, if you are opting for CKA, it is not that important. Now I am going to move to multi-container pod now. Okay. So with the definition, there are three type of multi-container pods as per the definition. Okay. So team, again telling you, this is just for the import. It is important for CKAD examination point of view. They might ask this question theoretically. Otherwise, this question is not going to come for your CK examination. And honestly speaking, this is also not helpful for your practical work life also. If you are working in an industry, it is not going to help you at all. Okay, I have rarely seen the use of this. So this is just a definition how your multi-container pods are. There are three types of multi-container pod. One is your sidecar, second is your ambassador, and third is your adapter. So these are the three definitions for your sidecar containers. There are three type of sidecar multi-container pods. Okay, so what are they? We are going to see about that. A little bit of theory. So first is sidecar container. Sidecar derive their names from the motorcycle sidecar. Okay, so the thing is, inside a container there are going to be two pods. Now, two containers. We are studying about multi-container pod. So definitely there are going to be two containers inside a single pod. First type is sidecar container. In sidecar containers, you will have two containers and one container will be called sidecar. That is extra seat. So in Kubernetes, what it does, your container works perfectly well without the sidecar container, but with it, it can perform some extra functionality. Okay, so the thing is, a sidecar container enhances the main container in some way, adding functionality to it. Consider that you have two containers. One container is going to be there as a main container. Okay, one is going to be your application container, and your sidecar container is going to give some details to it. If I'll talk about a layman example, okay, let me take a layman example. Consider you are watching news. Okay, on news channel you are watching news. There is an anchor on the screen. Okay, so the anchor is reading news for you. What happens? There is going to be a helper at the backend who is going to provide the details to the anchor. Okay, it is going to pass on some chits. It is going to pass on some paper to the with the news to the anchor, and then the anchor is going to read the news for you. So the anchor is your main container, and the helper who is passing on all the details is your sidecar container. It is injecting the details, it is injecting the information to the primary container. So this is about your sidecar container. Okay, second is your ambassador. What happens in ambassador, your second container is used for traffic routing. Okay, so there is going to be one primary container, your application container, and there is going to be second container called ambassador container. It is used for traffic routing. Okay, for example, you can see an HA proxy ambassador container receives network traffic and forward it to main container. So now your second container is not passing on some details or functionality to your primary container. It is just routing the traffic so that from the outside world, no one can reach to your primary container directly. It has to go through the secondary container. So HA proxy, like you can say as a load balancer. Your second container will work as a load balancer. The purpose is we don't want to give the access to the primary container directly to the outside world. So that's why where we use ambassador. Okay, so you can read all the details, all the definitions here. I'm giving you on the higher level. Okay, so layman example for ambassador. Okay, let me think of something. Okay, consider that you are going to meet some celebrity, or you are going to meet some minister or some politician, somewhere, anyone just like that. Okay, you want to go to meet a politician. So your politician is sitting inside a room. Okay, you cannot directly go or barge inside his room. There is going to be a PA, there is going to be an assistant. All right, you have to talk to the assistant first, and then that assistant is going to have your appointment, and then you can go inside the room to the politician with the PA. PA is going to guide you when you can go inside and when you are going to meet the person. Okay, that is a layman example for ambassador. So team, I'm giving layman example so that you can connect better. Alright, the third one is adapter. So the thing is with the third type, it is about the data reading, you can say. Okay, as of now you can see in sidecar, your sidecar container pass on some injecting data to the primary container. In ambassador, it gives you the routing. Second container is used for the routing purpose. Third type is where you get the details from the primary container to the secondary container, and that is called your adapter container. Consider that you want some logging. This is the example which I gave you here. Okay, this is the example which I gave you here. There is an application container and those application logs are getting written to your secondary container. You are also running a Splunk container so that your Splunk container will get the logs from your application container. So this is a good example of your adapter container. Adapter container doesn't give any details or routing to the primary container, but it get the details from the primary container and write down some logs. Consider you have an application and you want to have the logs written properly inside a container. So alright, so team, these are the three theoretical types of multi-container pods. I hope it is clear to all of you. Let me know if you have any doubts. Kushago, you are asking what is the purpose of HA proxy load balancing inside a pod. Consider you have three containers running inside a pod. Multi-container pod can have 2 or 3 or 4. There is no rule that inside a pod you can have only 2 containers. You can have 3 containers also. Consider you are having 2 application container and 1 HA proxy so that you can do the load balancing between 2 containers. So there you are going to use a HA proxy. Rahul sir, how to share IPC memory or POSIX queuing with multi-container pod? Rahul, I'm not sure about this one. If you can give more details about IPC share memory and POSIX, because honestly I don't know much on POSIX here. Edureka guest, you are asking to repeat on adapter. Okay. So Edureka guest, adapter is a completely different type from the other two. On the other two, you have seen sidecar containers. Your primary container get the details from the sidecar container. In adapter, in ambassador, your primary containers take the routing from their secondary container. In these two, your primary container is taking details from other one. But in adapter, it works as a vice versa. It is an opposite situation. In adapter, your primary container gives the details to the secondary container. Okay, like your application is being accessed, how many times your application is being accessed, you have to write down some logs about that. Okay, so you are using a Splunk container, or maybe you are using a database container as well. Okay, your application is having some front end. From that, your data is getting stored onto the secondary container, and that is your database container. So here your database container will act as an adapter container because it is taking details from the primary container. It is not giving the details to the primary container. Okay, so you can see the flow where it goes. In adapter takes the details from the primary container. Prempal, can we see Kubernetes cluster using CLI? Details having all nodes joined. Prempal, that we have already seen, right? This is your command line, right? kubectl get nodes. You can describe all the nodes and the installation we have done yesterday. So I'm not sure if you were there in yesterday's class or not. So you can have the recording. Your recording must be uploaded on the portal. You can watch yesterday's recording. Yesterday we connected everything from the CLI. We bootstrapped our cluster and we added all the nodes to the master from the command line itself. Shiju, where do we specify the type of multi-container pod in the definition? Shiju, if you are talking about the YAML files, there we don't define the type, whether it is a sidecar, it is the basic understanding. As I told you, this is a theoretical part only. You are not going to use it anywhere in the practical YAML files. We don't mention anywhere sidecar or ambassador, it is just a concept. So that is why I said don't pay much attention to it if you are opting for CKA or if you are targeting for interviews or some real life work. It is not going to help you. It is just a theoretical concept. Does STO use as a sidecar container? Yes, Abhishek, you are absolutely correct. STO is used as a sidecar container. So Prempal, if you were there yesterday, so adding your notes and everything. Yes, Shiju, it is based on the containers we have inside a pod. It is just about your understanding. Okay, so team, I hope it is clear to you. Shall we have an example with this? With example, it will be more clear to you. kubectl get pods, kubectl delete pods -- all. Okay, so team, let me show you a practical example about all of these. Okay, so for your better understanding, ambassador is there, a sidecar container. There are a lot of details, volumes are also there. That concept I haven't shared as of now. But inside containers, you can see this is your first container, Nginx. Okay, and second is your Debian. What is happening in this one? You can see there are some data being written in the HTML file here in the sidecar container. This is your second sidecar container. You can see I haven't mentioned anywhere that it is a sidecar. It is just a concept. So what is happening? It is writing some data into some HTML file. Okay, still volumes concept is there. So you don't know that, but you can understand that what I am doing while true, it is passing the date into an HTML file and it is going to sleep for a second and it is going to do the loop. Okay, so this HTML file will be passed to your Nginx once your Nginx container is running. Okay, so this is a location it is going to be there. So what is happening? Some HTML file is being written and it will be passed to the Nginx container. So it is a classic example of your sidecar container. It is passing on some details from the second container to the first container. Okay, that's about it. And then ambassador, legacy fruit service. Okay, this is a open source GitHub Docker repository. You can use this image also. All right. So second container I am giving of a HA proxy. Okay, so that it is going to do the load balancing with your pod. It is just for traffic routing. HA proxy is being used for the traffic routing. And the last one is your adapter. So here are your containers. First is your application container, Alpine. It is doing something, right? It is writing date in the top file and then it is going to sleep for 5 seconds. Second is your adapter container here. Okay, this is we are picking from Alpine. We are going to run some command. Now what it is doing, it is doing the cat on the top file which is being written on the primary container. So whatever work is done on the primary container will be stored in your secondary container. That is what we are doing here. Okay, so this is the theoretical concept. I am going to pick this example for the practical one, multi-container pod. Okay, so what we are doing, we have given API version, we have given kind, we have given metadata, and now we are going to give the specification. Under metadata, name is multi-container pod. Okay, here what I'm going to do, I'm going to run two containers. Okay, one is going to be your Nginx one, and second is going to be your Alpine one. Okay, so this example I'm going to show you practically. We are multiple dot YAML, escape I insert. So team, what is going to happen in this one? First is your Nginx container. Nginx container does have an application page in with it. Alright, so it is going to run. But second container I am taking as Alpine, and Alpine is a OS based image, so it is going to be live for 60 seconds only. After 60 seconds, your container is going to die out. Okay, so that is what I told you. If a container dies inside a pod, in a multi-container pod, your pod is not going to be available for that time, right? So let's see what happens here. kubectl create -f. Okay, kubectl get pods. If you want to see the continuous output of this one, you are going to put a watch, WATCH, and then the command kubectl get pods. Okay, it is going to give you the output for every 2-second refresh rate. You can see 17, 19, 21. Okay, so you can see two containers are running inside a pod. A container contains, a pod contains two containers, and both are up. But your one Alpine container is going to die out after 1 minute. Okay, let's see what happens then. Two by two running status, restarts are 0, and it is almost 60 seconds now. You can see 1 by 2 and not ready status. Okay, it means what happened, your Alpine container died out, and once your Alpine container was died, your Kubernetes, or you can say your controller manager, took care of it because the status was not ready. It restarted your pod. Your pod got restarted. It means your container which died out of Alpine, it was restarted, and that is why you can see the status as restart 1. Okay, again your Alpine container is going to die out after 1 minute 60 seconds, and again it is going to restart your pod, but the IP is going to stay the same. Now you can see 2 minutes are there. Again it is going to get restarted. Status will be not ready for a while. Not ready, 1 by 2. Now it will restart it. Okay, now it is in flashback loop and second restart. Now you can see it is restarted twice. Okay, so team, this is how I wanted to show you the concept of multi-container pod. Even if one pod has two containers and one container dies out because of any reason, your pod is not going to be available and it is going to restart itself again and again every time. Shiju, you're asking this example doesn't fit into any other type we discussed. Yes, Shiju, as I told you, the 3 types I told you is for the theoretical part only. You might be using that in practically somewhere, but the concept I wanted to show you of a multi-container pod, that how one container dies out and pod gets unavailable. So yes, the example I showed you practically is not a part of any of those 3. You can have that ready with you. All the YAMLs are there. You can simply have a YAML file here and kubectl create it.
Yes, team. So somebody asked me earlier that can I define a particular pod to a particular node, if I can do that or not. So yes, we can do that. kubectl get pods. First, let me delete all the pods from here. Okay, we have already deleted all the pods. So as of now, no pods are running. Okay. So team, the thing is, if I want to have a pod on a specific node, we can do that, and those kind of pods are called static pods. Okay, so what I'm going to do, I'm going to pick a definition of a single pod. This is my pod and this is my pod.yaml. I'm going to pick a basic Tomcat image and going to create a pod. And how I'm going to create that? I have to go to a specific location on a specific node. Okay, consider I want to assign that pod on node 2. So I have to go to node 2 directly. Okay, so first there is a file called just a minute. Sorry. So team, as I told you, on all the worker nodes you have a kubelet, okay, and kubelet runs as a service. So for the kubelet service, all the definitions are placed at this location, where lib kubelet, on every node. Okay, whenever your kubelet service is running, it will be located at this location, where library and kubelet. So team, here is a file called config.yaml. Okay, we are going to see this file vi config.yaml, and there is something called static path, pod path. Okay, so team, here is a key value pair called static pod path etc Kubernetes manifest. So I'm going to pick this location and I'm going to go to this location. As of now, this location is empty on your worker node, right? So what I'm going to do, I'm going to place a YAML here, pod.yaml, any name you can give. This definition I'm going to place here, and I'm going to save it. Okay, so this definition I have saved directly on my node 2. Now I'll go to my master node. I just executed kubectl get pods. It showed me nothing. Can you see the difference now? Kubectl get pod is going to show me some output now. A pod 1 is getting created. Its name is also a slightly different. Earlier the name was pod 1. Now you can see K-node 2 also written in the naming convention. kubectl get pods -o white. The definition I have placed at node 2, and that is why this pod is getting created on node 2. So if you want to create a pod on a specific node, so what you're going to do, you're going to go log into that particular node, come to this location, etc Kubernetes manifest, and place a YAML file here. It is going to create the pod on directly on that node. Okay. One more difference I am going to show you. Now it is up and running. It is running on node 2. kubectl describe pod and this pod name. Team, tell me a difference here. With all the definition we have seen so far, what is the difference this time here? Is there something missing, or is there something addition, something plus or something minus? Tell me the difference. Gopal, Shiju, Jagannath, Abhinav. Ganapati, kubelet is here. Kubelet is here. Kubelet is not missing. Rishabh, Kushagra, Nitesh, that is done, but something is missing, Nitesh. What is that? Mosomi, no, that is not the case. Girish, right? Ankur, Kapil, Gaurav, Edurika guest, right? Yes, Siddharth, correct. So team, what happened here? The thing is, as a general rule, if you do anything from the kubectl command, okay, this thing should have your better understanding with the architecture. Okay, so what happens whenever you do anything from the kubectl command, it goes to the API server and then scheduler decide which node will be chosen. Okay, and once scheduler has chosen, then kubelet is going to take care of all the further work. Now what we did, we skipped this complete portion. Okay, we didn't give anything from the kubectl, we didn't went to API server, we didn't ask the scheduler, we scheduled it directly, and then we instructed the kubelet. So all the previous steps we have skipped and we have instructed the kubelet directly to create the container. Okay, that is why scheduling is not done by the scheduler. You have scheduled and you have went directly to the node and ask the kubelet of that particular node to create the pod. So kubelet can be instructed by the API server, that is also the case, but you can instruct the kubelet directly also. Okay, so that is one case. Now tell me one thing, can I delete this pod with kubectl delete command? If I delete this pod from here, kubectl delete pods and this pod name. If I do this, what will happen? I didn't create this pod with kubectl command, but if I delete this, what will happen? Kushagra, absolutely correct. Shija, you're also right. Kapil. Okay, so many answers. Shiju, Kapil, you're right. Moswami, right. Rishabh, you're not. Partially. Gopal, absolutely correct. Edurika guessed, okay. Girish, Anil, Jagannath, okay. Okay team, great answers. Some of you have given the right answers, some of you haven't. Okay, so let's see what happens. Let me try to delete this. See, I was able to delete it from the master itself. I was able to delete. kubectl get pods, but it got created again 12 seconds ago. It got created again. So if you delete a static pod, okay, so team, these are the pods which are called static. Why these are called static? Because you have defined the definition directly on the node. You have directly inserted to the kubelet of that node. So that is why these pods are called static pod. If you provide a definition at the manifest location, these are called static pod. So what I'm going to do, I cannot delete this pod from the kubectl command because this pod is being managed directly by the kubelet. Okay, so what I have to do, I have to delete the YAML from here. Then only you will be able to delete this pod. Otherwise, your kubectl delete command will not help you at all. See, your pod is gone. Now, I am going to show you something very interesting. Okay, so pay attention and see it. I am going to execute an old command -n kube-system. Gaurav, what if node goes down? Will the controller take control of it? No, Gaurav, if your node is gone down, then that pod will be gone also. Static pods remains with the node no matter what. If your node goes down, your static pod will be gone as well. So team, this is the old command which I showed you earlier, kubectl get pods -n kube system. Can you see something here? When I created a static pod, the naming convention is like that. Your pod name hyphen node name. So this is your static pod. Can you identify the static pods here for your master node? Can you identify the static pod? Jagannath, no, Weavnot is not the one. Sorry, Jagannath, you said etcd. Yes, it is. Shiju, no, Weavnet is not. Kushagra, you're right. Arjun, yes, I'm asking about which are of these are static pods. Maswami, Rishabh, Ganapati, Kapil, Gaurav, Rishabh, yes, all of you gave the right answer. Okay, so team, all the components which are of master are static pods. Kubectl get pods -n kube system -o wide. So all the components which are running on master are running as a static pod. Okay, all of them are running as a static pod. So what can we do? Can we delete this? kubectl delete pods, the scheduler one -n. Let's try to delete it. Team, I have deleted the scheduler itself. I deleted the scheduler and the scheduler came back online 7 seconds ago. Okay, so this is the basic nature of static pods. If you delete it with the kubectl command, it will not be deleted or it will be recreated again. Alright, so that is why all your master components runs as a static pod. And you know the location, etcd Kubernetes manifest. Okay, this is the location for all your static pods. You can see controller manager, API server, scheduler, etcd. These 4 components are running as your static pods. So is it clear to all of you? Any doubts with the static pods? Any question on static pods? No questions. Great. Why core DNS is not a static pod? Okay. Okay. So team, as of now, don't question me on other pods. Okay, core DNS is there and kube proxy is there, Weavnet is there. These are different type. As of now, I have explained you about the static pods. That is why I have shown you the static pods. There are some daemon set as well. There are some deployments as well. When I'll cover the deployment and daemon set part, then I'll show you about these naming convention, how these pods are running. Okay, so that is a topic about later. Anil, real world, why do we need static pod? Anil, I gave you a complete big picture of the real world. Why do we use static pods? Because your master components should be running on master only, right? These are also pods. Your master component should be running on master only. Your kube API server or controller cannot live on node 2 or node 1. you have to make sure that they are running on node 1 itself. That is why they are static pods. So that is a real-time scenario for this. Your master components are static pods, and that is a real case here. Yes, Gaurav, during the exam, you will have the access to all the cluster machines. Kapil, no, you cannot make the entry in the etcd. It is completely managed by the Kubernetes. You cannot modify the entry in etcd database. Arjun, I think I answered your question as well. What is a real-time scenario for your static pod? These are the real-time scenario. Your master components are running on the master node itself. They are supposed to be living there only. Your API server cannot reside on node 2 or node 3. That is why they are created as a static pod. Otherwise, Kubernetes would also have created your API server controller manager as a normal pod. It could have done that. But they have created them as a static pod because they are supposed to be running on master node only. Similarly, if you want to have some logs connection, okay, you want to collect log from all the nodes. So what you're going to do, there should be a pod running on all the nodes. So you can create a static pod that this pod will pick all the logs from this particular node itself, not from any other node. So there you can also use static pod. Okay, so team, next topic now. Chandrasekhar, yes, Kubernetes do have a GUI console as well. Okay, we are going to see that as well. But I think that is going to be in the 6th class, I guess. Probably we are going to have the GUI console of Kubernetes on the 6th class. Okay, so team, now another situation. Consider you have a pod. Okay, this is my pod, and I'm going to create 2 containers inside this pod. Okay, or let me give you a layman example now. Okay, first I'll give you a layman example, then I will give you a practical example. Consider you went to a restaurant. Okay, so think you went to a restaurant and you ask for a order. You place an order. Okay, your waiter came to your table. He asked for your order. You gave the order. All right, and after that, your manager came of that hotel. Okay, or that restaurant. Manager came to you. He said that wait for some time, sir. You have to wait for some time because the chef is not ready. The chef has not arrived. The chef is on his way. Once chef will be there in the kitchen, he will cook your food and then will be able to serve you food. Right? So as a customer, what you're going to say? As a customer, you're going to say that if the food is not ready, if the chef is not here, so why have you opened the restaurant till now? You should not open the restaurant till your chef is ready in the kitchen to cook meals. Right? So that is going to happen. So you went to a restaurant, the chef is not there, chef is on the way. So you are going to complain that why your restaurant is open if your chef is not ready. First your chef should be there and then only you should open your restaurant. Alright. Now, taking the same example in your real-time situation. Consider you are working in a multi-container pod. Okay. This is your pod and you have 2 containers. And assuming this is a sidecar container. Okay, this is a sidecar container. What happens in a sidecar container? Your sidecar container is going to cook something and then it is going to provide to the main container. Right? Your sidecar container is going to cook some scripts and those scripts will be passed on to the primary container. Alright. So whenever you create a normal multi-container pod, both the containers comes online at the same time. So what will happen? Your primary container will have no data until your secondary container is going to cook something for it. Okay, consider you have nginx container and your HTML file is getting ready. Index.html is getting ready by secondary container, and then it will be passed on to the primary container. But you started a normal multi-container pod. Both the containers came online on the same time, but your primary container has nothing to display because your sidecar container is still working. Your sidecar container is still cooking. So in that scenario, your container will be up, your pod will be up because both the containers are online. Your pod is also online. So, but it is not serving the request. So you have created the application, you have the application container, you have the sidecar container, you have the pod, everything is online, but still you are not getting your application result on the front page because your sidecar container is still cooking. So this is not a situation that we want to encounter. This is not a situation that we want to encounter. In those scenarios, we use init container. In place of keeping it as a sidecar container, what I'm going to do, I'm going to put it as an init container. How a init container is different? Now, once your init container has cooked the meal, then only your restaurant will be open. Okay, only when the chef is ready in the kitchen, then only your restaurant is going to open. So what happens? First, if you have defined a init container, your init container will complete its job. Until and unless your init container completes its job, your pod will not be available. Okay, your pod will not be available until your init container has completed its work and died out. It will cook some meal, it will pass it on to the primary container, and then your pod will be available. So your init container will do its job, your pod is unavailable till your init container is working, and once your init container has completed its work, then your container, primary container will be available, then your pod will be available, and it can die out. So init container has a basic nature to do its work and then die out. Its liveliness doesn't depend on pod availability. Okay, let's see this practically and then it will be more clear to you. Okay, where is init? Here is an example for this one. Okay, so team API version you have defined, kind you have defined, metadata you have defined, specification you have one container that is of your nginx. We are defining volumes as well. Now init container you define separately. Okay, inside containers you don't define init container, you define init container separately. Okay, so init container I am defining as alpine. I am taking the image alpine. Some commands will be executed. Init container demo works will be written to the index.html. Then it is going to sleep for 30 seconds. Okay, so your init container is going to be live for 30 seconds. In the meantime, your pod will be unavailable. Okay, and we have also defined the volume to pass on this HTML file to your primary container. Okay, so I am going to use this one. Now another thing, so team, every time I don't want to create a YAML file on my node, what I can do, I can simply use raw formatting from here. Click raw, have the URL and create your pods directly. kubectl create -f and give the path directly. kubectl get pods. So team, now you can see it is 0/1 because your init container is working right now. Watch kubectl get pods. Okay, it is 16 seconds because it was supposed to live for 30 seconds. So for 30 seconds your init container is working and your ready status of the pod is 0/1. So your primary container will not be online till your init container is working. Okay, so now you can see your init container has already completed its work, and then your init container died and your primary container is running as 1/1. Okay, so what was happening here? Some text was there, init container demo works. I wanted to write this content into an index file and then this index.html I pass on to the Nginx. Okay, so by default Nginx shows you welcome to Nginx, but I don't want to see welcome to Nginx. I want to see init demo works. That is why I created the file in a different init container. Pass on that cooked meal to your primary container. If I'm going to curl this pod now, this was our init container. Sorry, this was our Nginx pod. It should have shown me welcome to Nginx, but I have modified that as index.html, so I should get a different output. See, now if I curl, it shows me a different message. Init container demo works. Alright, so team, this is the concept of your init container. Init containers are used to do some predefined work first and then pass it on to the secondary container, which is your primary container, and then that primary container will be live to keep the pod online. Your init container can die out after that. Let me know if init container concept is clear to all of you. Yes, no, anything, clear, not clear, doubts, anything? Rahul, no, it is not mandatory to give the sleep time. See, this work, init container and creating a HTML file takes fraction of second. I wanted to show you how init container works. That is why I asked for sleep for 30 seconds. Otherwise, you won't have seen that practically. So I gave 30 seconds sleep time just so that you can watch it, how your init containers actually work. So it is not mandatory. Joydeep, we pass the information using volumes. Okay, you can see I have created volume here, volume mounts and volume. So volumes is an advanced topic. I know it is creating a little gap. I understand that, but volume concept is big. I want to have it for a dedicated day. So I will take that, but we are transferring this with a volume, and volumes also we are going to cover a little bit later. Akhil, yes, I want to explain all the commands, but all the things won't be clear because as I can, you guys shown you that volumes are also there, and it's a concept which I haven't explained you as of now. But still, in Alpine container, what I'm doing, I am having the shell prompt, okay. Then I'm providing command, sh for shell and -c is for command. I'm passing some commands. What commands? First, it is going to create a directory. Then it is going to create a blank HTML file with touch, and then it is going to pass init container demo works content into that empty file, and then it is going to wait for 30 seconds. So this is what the commands are doing. Is the init container runs along with the main container, or it has to complete before the main container start? Gopal, first your init container will work, and after that your main container is going to be live. Okay, they both run, they don't run along. Okay, first your init container will work, then your main container will be online, and then your pod will be online. Kapil, you want me to explain once again? Okay, let me know where I am falling. I will explain you again. Let me know what is not clear to you. Init containers are the containers which are initialization container. Init containers full form is initialization container. It means first your initialization container will work, your main container will not be live till then, your pod will not be live until then. Once your initialization container has done some initialization, has done its work, then it will pass on that information to the main container, and then your main container will be alive once your init container has completed its works, and then your pod will be online. Is it necessary for init container to pass something to the other container? Rishabh, that depends. You have to give some work to the init container, and once that work is completed, then only your other container will be live and pod will be live. So it is not necessary, but it is the functionality of init container. Otherwise, if you are not passing anything to the primary container, then what is the use of init container? It is not necessary, it is a use case actually. Will init container always die out of after work, or will it retain? Yes, Edurek, I guess your init container will always die out. Okay, it will not retain. Your init container is destined to die. So init container is physically not created as we have seen 1/1. Yes, Anil, as I said, init container has to do some prerequisite, that's all. And once it is done, your init container will die out or your primary container is going to be live. Because you can see here, in containers definition, I have given only one container. Init container is given in a different definition. So your pod will consider its container only whatever has mentioned inside the container. Pod will not consider init container as containers. Chandrasekhar, you are asking real-time example of init container. I have given you real-time example. You have an Nginx image, but why you don't want to have an Nginx container right away? If you want to create your own application and you are using your Nginx image, are you going to have the Nginx page welcome to Nginx every time? Nginx is just a web server. You want to use it. You want to pass on your own HTML files. If you are taking the default HTML file, then it will show you welcome to Nginx. You don't want that. So this is a real-time scenario. What you are going to do, you are going to cook some HTML pages into init container, and those HTML page will be passed on to the Nginx pod so that you can have your own Nginx web page, web-based application. If you want to have your own, you have to pass on your own HTML file, and those are created into init containers. Unable to curl pod IP during an initial cluster build, we pass on kubeinit --pod CIDR block. Jagannath, then what is the output of kubectl get pods -o wide? You have to pick that IP and curl it there. Sumit, how to check init has issue while initialization in, is there any logs? Sumit, okay. Sumit, your init container also have logs, but as you can say that your logs are gone when your container dies out. Okay, so what you can see, I have created some HTML file. I can have those log also onto the volume mounts. Okay, so Sumit, it is a basic concept as we also understand with the containers. If your containers dies out, you cannot see the log. So that is the basic nature of containers. In that situation, whether if you're talking about Docker or Docker Swarm or Kubernetes, anywhere, if you want to retain the logs of a container, you have to use volume. Even in Docker, you use volumes to retain the logs of a died out container. Similarly, with init containers, with pods, with anything, if you want to retain the logs, you have to use volumes. Rishabh, is it necessary for init container to pass something to the main container? Rishabh, no, it is not necessary, but the functionality is for that purpose only. Okay, Siddharth, this is a big volume concept that you're asking right now. Yes, it asks for user share Nginx HTML location is the default path. I understand that, but it is a volume concept in Kubernetes. If you want to know what I did, I created a volume here. Okay, I created a volume of my volume name. Okay, and then the my volume path was /init container. So I created that path in the init container. All right, and pass on that volume to my volume, my wall. Then what I did, I mounted the my wall inside my Nginx container at this location, user share Nginx HTML. Okay, so whatever the work was done in the secondary container or init container, I pass on that value into user share Nginx HTML in Nginx container with the help of volume. init container concept, and we need to use image init container, and we cannot pass command directly into the init container. Kapil, I passed on all the commands into your init container itself. You can see all the commands that I'm executing here, mkdir, touch, echo, everything is taking place inside your init container. Himanshu, no, we can create only one init container. Okay, init containers are supposed to be only one inside a pod. If we use the exact method and go to the Nginx container more on board, will we see the init container part details? Akhil, that is a volume concept. I will request you to leave it as of now. Okay, you will be able to understand the volume concept when I explain you volumes. That is a big concept. Okay, I cannot tell you on the fly, but inside your inside your main container of Nginx, I have given the content to value a user share Nginx HTML itself. Kushak, that is the formatting that Kubernetes YAML formatting has suggested us. Web server in container and in container as are different here. Generally should be the same. Anil, no, that is up to you. You can have the main container and int container of completely different flavor. There is nothing, generally it should be same or not. That is your call. You want to cook something, you can cook anywhere. You want to cook in your kitchen, you want to cook in the restaurant, that is up to you. I want to cook in Alpine image, that is my call. Is there any specific reason why we are not mentioning in log in object command and append that for the every restart? Why we are not mentioning in log in object command? Sumit, you can do that. Okay, it is just an example. It is not a standard. It is just an example. You want to use logs to do all this, that is your call. Okay, it is just an example. I have multiple examples here. Thing is, I just want to explain you the functionality. If you want to do with the logs, if you want to do with the sleep command, if you want to do it with the volumes, that is completely up to you. See, this is another example. Many of you are asking that, is your init container always supposed to pass on some information to the main container? No, it's not. But that is the reason why we use init container. In this, what I'm doing, I'm using a busybox image. It is going to sleep for 60 seconds. And after that, your main container will come online. Okay. So team, I want you to practice this example at your own. Okay. You are going to do this. Your init container will be live for 60 seconds. It is not going to pass anything, but in the meantime, your main container will not be live. Once your 60 seconds has passed, then your main container will come online and then your pod will be available. So it is not mandatory to pass on the information from your init container to main container, but that is the reason why we use it. But you mentioned image name, so it will use Alpine images. So instead of using image, we can directly start command like ch. No, Kapil, you have to give something at least. Okay, you cannot write some commands. You have to use the command somewhere, right? Init container is going to cook something, then only it is going to pass on something to main container. You need some space at least, right? If you have opened a restaurant, you need a kitchen, you need a space for that. You cannot cook anywhere. You cannot cook on your customer's table, right? So you need a space. That is why we are using init container. We cannot write the commands just like that anywhere. Alright, so team, any other question till now? We are done with the init containers and static pods. Fanny, you're asking if I can explain you on props once. Okay. Okay team, so one thing is here for you. Actually, this is the agenda that I follow for all the days. Okay, but I took this batch from the middle, so that is why I am not able to strictly follow it, but I am going in the same flow, if you can see. Okay, the day one I take only for Docker. Okay, so this is how I go. For the first day, I cover only Docker commands, everything with the Docker. Second day, we start with Kubernetes architecture, installation, bootstrap, component, folders, API resources, and pods. Okay, so as I took it from the middle, that is why we had a little overview of Docker, and we also did the same of day two on our first day. Okay. Afterwards, we discussed that how we are going to work with YAML. We studied about multipods. We studied about static and init pods. Okay. This is what was supposed to be on day third, but we have discussed some of them on last class as well. Okay. So currently we are at this stage. And how we are going to move forward. Further, we are going to discuss about namespace, labels, limits, variables. Okay. This is about it. Then we are going to discuss about your controllers, your rolling updates, and your services. And today only we are going to discuss about props as well. Okay, I think it is not mentioned here. Props. Okay. So next we are going to discuss about your controllers. How many type of controllers are there? And then we are going to see rolling updates, rollbacks. We are going to discuss about services. We have multiple services. We have node port service. We have cluster IP that we are going to discuss. Next day, we are going to discuss about storages. How many types of storages are there? PB, PVCs. Okay, all of them we are going to discuss. Then we are going to discuss about your ConfigMap secrets. We are going to discuss about your cloud disk and service load balancer. Cloud disk and service load balancer is not important for your examination point of view, but I'm going to cover so that you will have some idea, because these two concepts come under your cloud managed Kubernetes cluster. Okay, so this is not for your examination, but it is an important point. I want to give you some overview on this. Next day, we are supposed to cover our scheduler, how we are going to schedule our pods on different nodes with your taints and tolerance, your empty volume and everything. We are going to see about your namespace limits. We are going to see your etcd backup, how we can do that. We are going to see something on monitoring as well. On next day, we are going to discuss about your networking, your securities, how you use your context, how you use your config file. All right. And on the last day, we are going to do some troubleshooting. Okay. Once all the concepts are clear to you, then we are going to discuss about how your troubleshooting actually works. Because all the things that we will have covered by day 7 will be important for your examination point of view. And on day 8, so that we are going to do the troubleshooting, so that you can have some idea how your examination happens. After that, we have your Ingress, we have StatefulSets, we have headless services, we have Helm as well. These things are not important for examination point of view, but I'll give you some idea how you are going to use it. Also, we are going to see about your HPA as well, your horizontal pod auto scaling. And then we are going to discuss something on examination. So this is how I carry my batches with all the topics. This is how we are going to move forward with it. As of now, we have discussed till init pods. Now we are going to discuss about your namespaces, labels, limits, variables, props, controllers, rolling updates, rollbacks, and services. So this is our agenda for today. All right. Any other question before we start for today? Okay, I guess not. So we are going to move forward, and today we are going to start with your topic called namespaces. Okay team, so So as you all know that I start with a very basic example for the basic understanding in a layman language. Alright. Consider this is a house. Okay. This is a big house. Inside this big house, we have multiple rooms. Alright. This is your room 1. This is your room 2. Your room 3 and room 4. Okay, so this is the house and we have multiple rooms here. We have 4 rooms. Now every room has some resources. Right? Consider that on room 1 you have a bed, you have a television, right? You have fan. Okay. Similarly, all the resources, all the rooms have some resources just like this. You have some bed, you have some TV, you have some fan. Okay, so you do have in every room, and you have some common area as well. Okay, for say you have a drawing room, you have a hall. Okay, where you place the fridge. Okay, so some of the things which are placed in common area. Okay, so that it will be accessible to all the rooms. This is how it happens in a house, right? So, one question. Can you control the television of room 1 from room 3? A person who is sitting in room 3, can he control the television which is placed in room 1? Okay, provided there is no smart gadgets allowed. Okay, so team, the thing is, you cannot have any smart gadgets. No, right? So if you are sitting in room 1, the owner of room 1 cannot have access to any resources of room 2 or 3 or 4. Similarly, it happens with all the rooms. But there are some common resources. There is a common hall, there is a common fridge. All the people from all the rooms can have access to that fridge because that is a common resource. Okay. Similarly, now in Kubernetes, these different rooms are divisions, right? In a house, rooms provides isolation. They provide division. Similarly, in Kubernetes cluster, these rooms behave as a namespace. Alright, so in Kubernetes cluster, you are going to have a single cluster, but still you want to provide some level of isolation. You want to have some projects which will not interfere with the resources of different project. Okay, consider this is your project 1, this is your project 2, project 3, project 4 in your Kubernetes cluster. You have the same cluster. You don't want to create multiple clusters. So you have just one cluster and you want to have some kind of isolation between these projects so that they don't interfere with each other. I want the person who is managing, who is working on project 2 should work on project 2 only. He should not interfere whatever is happening in project 3. So we provide that kind of isolation in Kubernetes with the help of namespaces. This is what we call namespace. You're going to have a single cluster. It is going to be a single cluster, but in that single cluster, we isolate the space in namespaces so that they don't interfere with each other. Alright, we are going to see that practically as well. Let's connect with the machines. Alright, so here I am on my master machine. Okay, so team, I have connected to my master machine and as of now you can see there is one pod running. Alright, so the thing is, whenever I do any command, it shows me an output that one pod is running, Alright, but as you already know that we have some pods of API resources, your API server, your master components, your etcd pods, those are also our pods, but we cannot see that here. We cannot see that. But if we want to see that, we have to give some flag. That is -n cube-system. Then only you see all those pods. If you don't give this flag, you don't get the output. Right? So the thing is, this cube system is also a namespace. Okay? If we talk in the layman example, this is the powerhouse. Okay, consider out of all these rooms, you have created one room as a powerhouse, which provide for household resources. Like it is a storeroom. You place everything here. All right. So all the basic components, all the system level components resides in your cube system namespace. For example, if we'll see kubectl get ns. Earlier I did kubectl get pods. Now if I do kubectl get ns, ns is a short form of namespaces. Okay, so you can see we have 4 different namespaces. First is default, second is kube node leases and kube public. Another one is kube system. So you can see these kube system resources are your system level resources. That is why they are placed in a separate namespace so that nobody interfere with that. And whenever I do not give any flag, if I do kubectl get pods, if I don't give any flag, it goes to the default namespace. For example, if I do this kubectl delete pod and this pod name, it is related kubectl get pods. So now you can see no resources found in default namespace. So if you don't give any flag, it goes to the default namespace. Alright, so this is how you're going to deal with it. Namespaces provide you isolation. We are going to see some practicals as well. I'm going to show you, okay? Then I'm going to take your questions. So if you want to provide some isolation, you create namespaces. Alright, no problem. We can create some namespace as well. Kubernetes give a functionality of that as well. So let's create a namespace first. kubectl create ns, okay? This is the simplest command you can use to create a namespace. kubectl create ns and then the namespace name. For example, I'm using the development one. Okay, now you can see namespace dev is created. kubectl get ns. Okay, now you can see a new name is here, your development. Now, if I want to create some resources in this particular namespace, I have to give the flag of -n. And before that, let me show you this first. Then I'm going to show you something else. Okay. I'm going to create one pod, kubectl run dev pod -image. I'm using nginx 1. If I run this command only, kubectl run dev pod -image nginx. If I'm going to execute this command only, your pod will be created in the default namespace. But I don't want to create in default namespace. So what I'm going to do, I'm going to give a flag -n stand for namespace and then dev. Okay. Now you can see a pod is created. If I do kubectl get pods, you won't get the output, because this pod is created in the dev namespace. So I have to give -n dev as well. Only then I will be able to see this. Now this pod is created in dev namespace. Now, how you are going to identify what resources can be created inside a namespace and which resources cannot get created inside a namespace? Because I already told you, because some of the resources, for example television, it is a room level resource, okay, but fridge is a house level resource. Similarly, you have some namespace level resources and you have some of the resources as cluster level resources. Cluster level resources are accessible to all of them, but namespace level resources can be created inside a namespace. For example, if you see this pod is running here, if I'll do -o white, you can see this was placed on K node 1. So even if you can see the pod is logically inside a namespace, but still it is using the same nodes. It means nodes are not your namespace level resource. Nodes cannot be namespaced. Nodes are cluster level resource, but your pods can be a namespace level resource. So earlier also I showed you one command, kubectl API-resources. Okay, this command we have already used earlier. So all the components names are here and it shows you which can be namespaced. Okay, so if you'll see pod, you can see that pods are namespaced equal to true. It means you can place your pod inside a namespace. But as I told you, nodes are not. Where are nodes? Can anyone see nodes? Yeah, nodes are here. So you can see that nodes cannot be namespace because nodes are cluster level resource. They are not node your namespace level resource. Alright, kubectl get ns. Now if I'm going to destroy this room, okay, if I'm going to delete this room completely, so all the resources will also be gone. Okay, I don't have to remove everything particularly one by one, but if I destroy this room, everything along with it will be gone. Kubectl get ns. Kubectl delete ns dev. So if I'm going to delete this namespace, all the objects which were created inside this namespace will be gone as well. So you don't have to remove everything one by one. If you want to delete the complete namespace, you can delete it on the go. So team, now if you have any question, now you can ask. Sarath, what about C groups? I'm not sure what about you're asking about. What you're asking about? Okay, Gaurav, I think I already answered your question. How does this separation take place in cluster? Can we have pods with different namespace on same nodes? Yes, we can, and I think you were able to see that practically as well. Fenny, we haven't discussed anything about replicas till now. Okay, we are going to discuss about replicas, but we have to hold on for this. Okay, so please ask the question whatever we have covered so far. If you have any doubt in that, then do ask. Otherwise, those topics will also be covered. Gopal, you're asking how to make dev namespace as default namespace. Gopal, we can do that. The thing is, it will be done in the security part. Okay, if you want to make any other namespace as a default namespace, that topics come under context. Okay, so it comes under context and security. Once we will discuss that topic, at that time I'm going to show you how it actually works, how you can make any other namespace as a default one. That is an advanced topic. That is why I cannot give it to you right away. If the pod is deleted, it should be deleted. Okay, already covered that. Can we limit resources at namespace level? Kushagra, yes, we can. We can do that. We can have the limitation on your namespace level as well. Okay, you can see that also here. We have that in our agenda. Where it is? Yeah, on day 6. On day 6, you can see namespace limits. We can put both kind of limits. If you want to do resource level limitation, that this much of CPU it should consume, this much of RAM it should consume, or how many number of pods it should get created. It means object level resourcing and your hardware level resourcing. You can put limits on both. Ganapati, no, we cannot create nested namespace. Okay, no nested namespaces. Yes, Akhil, it is about different projects as well. If you want to divide it as per dev, QA, prod, you can do that. If you want to have different kind of project, different application, you can have one application on one namespace, different application on different namespace. So it is a logical division. You can use it as the way you want. Anurag, namespace is a logical division. If you don't want any interference, by default, there is no interference between resources of namespace A and namespace B. But still, if you want to have networking capabilities between different namespaces, that a namespace A resources should be able to talk to namespace B resource, we can do that. We can see that in the networking concept. On day 7, we are going to discuss about networks. There you will see, by default, it is not allowed, but if you want, you can allow that as well. Amar, you are asking, can have 2 namespaces and different pod inside a node? Yes, Amar, you can. Namespace is a logical division. Okay, we have 3 worker nodes with master. Okay, so namespace A will also create all the pods on K node 1, K node 2. Alright, and if you have created a namespace 2, they are also going to create the resources on node A and node 2 only. Because we do have that nodes, we have created multiple namespaces, we are not adding multiple nodes. So ultimately the same nodes are going to be consumed. So nodes are your hardware level division. That is a different part. But namespace is a logical division. Primpal, what is the use of default namespace? Okay, if it does not have much isolation security as compared to other namespaces. Okay, Primpal, every tool provide you something by default, right? So if you're going to execute some command, for example, kubectl get pods. If you execute this command or if you execute -n default, both are going to work as same. Okay, just for the handiness, they have provided one namespace as a default one. They don't want you to give every time the flag as -n default. They don't want to execute longer commands. Okay, that is why they say if you don't provide any flag, we are going to use a default one, and you can change that as well. So to have your commands handy, that is why we are using like this. That is why they are providing a default namespace. Whenever you create some source, they should get created inside some namespace, right? Why are we using namespaces? What is the role here? Saurav, I told you that in the beginning itself, right? If you want to have different projects, for example, you have a same cluster and you are having different application. You have 3 different application and you want that 3 applications should have completely isolated environment. So you are not going to create 3 different cluster of Kubernetes. You are going to use a single cluster of your Kubernetes, but you are going to namespace them so that there should not be any interference. Your node, your project A, your application A will not be interfere with the resources which are residing in your namespace B and namespace C. So to provide your logical isolation. That is why we use namespaces. I mean kernel concepts, how namespace originated. Sarath, if you are going to how it is originated, you have to go to Google. And they have created complete Kubernetes on Golang. Alright. So they have complete code how all the resources are originated. We are discussing about the functionality. What is Kubernetes and what functionality does it provide? How it originated, that is a completely different topic here. Himanshu, if database pods are on another namespace, can it be accessible by a pod application which is sitting on another namespace? Yes, Himanshu, if you want to do that, you can do that. Okay. By default, the networking doesn't allow you with cross namespace resource utilization. But if you want to do that with the networking concept, you can do that as well. You can allow communication between two namespaces as well. Fanny, no, there is no as such limitation like that. Okay, you can create as many namespaces as you want. Prempal, you are asking, can we create pod on a specific node? If you were present in my previous class, you must have known that. Okay, we have discussed how we are going to create your specific pod on specific nodes. If you were not in my previous class, I'll request you to have the recording of my last class. I have already shown a complete practical on that. Static pods are there for this. Sanjay, you are asking, can you show processes running in any namespace? Sanjay, by default, Kubernetes doesn't allow you to show real-time processes, how much your resource utilization are there. We have to install Matrix server for that. Okay, Matrix server is also a kind of deployment that you can have so that you can see the resource utilization. As of now, we have not covered that part. We are going to see that, but not right away. Team, allow me a minute, please. Hi, sorry for the delay. I had to do something in a rush. Ashok, no, if you have created a namespace 1, you cannot rename it. Okay, you just have to delete it and recreate it. Chandrasekhar, the namespace name kube node leash and kube public are not used anywhere else. Okay, this is used for the internal processes of Kubernetes. So anywhere in your practical experience, anywhere in the examination, there is no question and nothing related to kube node lease and kube public. You will always be dealing with default namespace and kube system. That is all. So you can ignore kube lease and kube public as well. Sumit, if I'm using same resources in two different namespace, how the memory and CPU utilization happens for both of them? Is it separate or both consume the same resource? Okay, Sumit, the thing is you have to understand a part that if you have a same, you cannot have a same television in different rooms, right? There is a television in room 1 and there is a television in room 2 as well. They might be similar, they might be identical, there might not be any difference with the configuration of the television, the number of channel, cable connection, remote can be similar, everything can be similar, but these two televisions are completely different. They are individual, they are unique to the rooms. So anything which you have in namespace 1 and you have the similar object in namespace 2, they will be two different unique items. So they will consume the resource as per their load. Consider you have an Nginx pod running on namespace 1 and you have another Nginx pod running on node 2. So if any application comes on your first Nginx pod, the resource consumption will be there. And whenever your application target will hit your second Nginx server, so it will be consumed from node 2. So they might be identical, but still they are unique in their own way. Maswami, in component status, my scheduler and controller manager is showing unhealthy. Why? Because of network. Okay, Masami, we have to see that, we have to troubleshoot that. You have to see that if you have installed any third-party CNI as well. If CNI is not available, it might show you unhealthy. Okay, so please check that your CNI is in place or not. And still, if it is unhealthy, we have to troubleshoot. We have to do the kubectl describe command, and with describe command, we are going to see how the things are happening at the backend, if there are any issue or not. All right. Any other question, team? All right, let's move to another concept now. Now the part is, consider on in a cluster. Okay, we have a cluster. Inside that cluster, I'm going to create multiple pods. Okay, your namespace is gone. Okay, so we can ignore that now. Consider inside a cluster, inside any particular namespace, I am creating multiple pods. Okay, so team, on the higher level, I want some kind of identification. Okay, definitely these all pods might be of different flavor, right? One may be your Nginx, second may be your HTTPD, third may be your Redis. Okay, that is based on the functionality, but I want to have some kind of differentiation as well. Okay, like this is my production pod, this is my dev pod, this is my QA pod. Okay, so if you have same application and your same application running in all the environments, so all the images will be same, all the pods will be same, but I want to have some kind of identification. All right, so for that purpose we use some kind of labels. Okay, now again I always try to give examples as a layman examples. All right, so a layman example for this, consider you are inside your kitchen. All right, inside your kitchen you have multiple jars, right? In some jars you place sugar, in some jars you place salt, right? In some jars you have something else. Okay, so how do you identify on which particular jar what is actually inside? If you are no man, then how you are going to identify that which is sugar and which is salt? You cannot identify that, right? So what we do, over the jar we place some kind of label, we place some kind of sticker. Okay, and with that we can identify, okay, this jar contains some sugar, this jar contains some salt. Okay, so what we do, we place some kind of sticker, or simply you can say we put some kind of labels over the jar so that we can identify that this jar contains sugar, this jar contains salt, right? Similarly in Kubernetes as well, we place some kind of a label on our pod so that we can do the identification. Okay, so how it goes, let's see that practically. This is my master machine. Okay, so if you want to give labels, it is very easy if you do it from the command line with the imperative commands. kubectl run pod1 -- image nginx. All right, now if you want to give labels, you can simply give it by providing 2 slashes and label as a keyword. Okay, -- labels equals to, in single quotes I am going to give all the environment, all the labels. So the thing is, I am saying that this pod belongs to the environment which is of production. Okay, so that is I have given. All right, so I have given only one label as of now. Let's create multiple pods with multiple labels. 2. Okay, the environment for this pod is going to be dev. Okay, everything is same, name is different, image is same. Now I want to identify this pod as a dev pod. I can give multiple labels as well. Okay, I'll say that owner of this pod is Shubh. Okay, I can give that. This pod is also created. Let's create another pod. This is my pod 3. All right, and this pod belongs to, say, production environment. Okay, and this time I am not giving as owner, I am giving another one. Type, what kind of pod it is, what type of pod it is. I'll say this is the database pod. Okay, so you can see I have created 3 pods. kubectl get pods. You can see 3 pods are running here. Pod 1, pod 2, pod 3. Now you may ask that what is the use case of labels? Okay, what is the use case? We have understood the functionality, how they provide the differentiation, but what is the use case? Consider inside your cluster 100 pods are running. Okay, consider inside your cluster 100 pods are running. Out of them there are some database pods as well, there are some application pod as well, there are some middleware pods as well. Okay, so how you, if you want to see only pods which are database pods, how you are going to see that? You have 100 of pods, you are not going to filter it one by one, you need some kind of filtration. Okay, so what I'm going to do, I want to see just database pods outside. Out of those 100 pods, I want to get the output only for the database pods. So listing command is same, kubectl get pods, this is going to be same. -l I can give, and then I can give the type equals to database. So whenever you give -l flag and you provide the pod definition or pod label, then you are going to see the output for that only. Okay. Now what I need to list the pods which are owned by Shubh only. I don't want to see any other pod. I just want the list of pods which are owned by Shubh. Okay, do that. You can see only pod 2. You want to see only production pods. You don't want to see any development pod. You don't want to see any QA pods. No problem, you can do that. env equals to prod. Now you can see only 2 pods, pod 1 and pod 3, because these 2 pods were defined as environment equals to production. Okay, team. So this is how you're going to give your labels to your pods. Okay. So where does this label occurs? Label occurs on the pod level. So any doubts with the pod now? Krish, you're asking label should be unique in same cluster, right? If we give same name. Krish, they don't have to be unique. You can see I gave environment equals to production to 2 pods. Okay. So it is an identification. In a layman example, you can have sugar in 2 jars. You can have salt in 3 jars. So you are going to place the same sticker on all 3 of them that this is salt. So your labels does not need to be unique. For creating pod instead of run, we can use create. Yes, Sanjay, if you want to use your YAML formatting, you want to have your manifest file, then you can have labels inside your manifest file as well. With manifest file only you use create command. Okay, I'll show you that how we are going to use your this. Just a minute. Yeah, so I'm going to show you how you are going to use your labels inside your manifest file as well. I'll show you that. Jagannath, how do we use and or condition while selecting labels? Jagannath, it's not about and or. If you want to give 2 variables, you can give 2 variables. That you can do. Owner equals to Shubh. Okay, no. Even I haven't tried that any time before. So no, if you are using your labels for listing, you can use only one label at a time. Maybe with a comma. So this is a different question. I have never encountered this. No, it doesn't work. Alright, any other question till now? Oh, Shiju, it is working for you? Why not for us? No? Govinda, you are asking how can labels be assigned to the existing pods. Govind, whenever you create a pod, a label is created by default. Okay, environment is dev, I have already given. Okay, was I doing any spelling mistake? Okay, so yeah, it is an AND condition. All right, it is not an OR condition, it is an AND condition. So both the condition, if both the conditions satisfy, then your -L is going to give you the output. All right. So somebody was asking if I do create a pod without a without a label, and if I want to label it. So the thing is, by default, whenever you create a pod, a label is defined there. All right. So let me show you. kubectl run hyphen image nginx. Okay. I have to give the pod name as well. Pod 4. Alright, so if you're going to execute this much command, you haven't given any label. Still by default, some labels are placed at the backend. If we want to see that, we can see that with the dry run command. You all know that, right? Dry run command we have already executed. -o YAML. Okay, so team, here you can see whenever I create any resource, a by default label is already placed. Okay, so run pod 4. We haven't given this label, but it is created by default. So labels are always there, whether you give it or not. If you give, it will use that label. If you won't give, it will have some label by default at its own end. Okay, so if you want to see that as also, let me show you for something else. Okay, let's do the dry run for this command. Alright, so team, here you can see, here it didn't took the default one, right? Whenever you define the labels explicitly, the labels are going to be just like that. Labels, environment equals to prod, type equals to dv. Alright, so if you don't give labels, some by default label will be there. If you will define the label, default label will be gone and the labels that you have defined will be there. Okay, so if you want to create it from the YAML manifest, you have to give the labels under metadata. That is how it is going to be. Okay, any doubt with labels now? Any other question? What is the other possible use case of labels other than justifying filtering and identification of pods? Prempal, we use labels very handy. Okay. Then how we are going to proceed, you will see how much we are going to use your labels. Labels are used with your node selection as well. Okay. If you are going to use your props, we are going to use that here. In props, I'm not sure. But yes, labels do provide a vital role. Okay, as we are going to proceed, I'll tell you where labels are being used. But as of now, you just understand that labels are used for the identification purpose. Wherever we use labels, I'll show you that later. Any other question from labels? Clear to all of you? Okay, looks like not. Alright, so team, next concept we are going to cover is your environment variables. Okay, now we are going to discuss about your environment variables. Environment variable, as a name suggests, right? We have some kind of environment variables in any machine. Okay, so whenever we create some pods, we might need some of the environment variables inside our container as well. Okay, we have discussed about namespaces, labels, environments variable we are on. Okay, so we want to provide some kind of variable inside our container as well. How we are going to have that environment variable? We are going to use the same way as we used your labels. kubectl delete pods -- all. Okay, so now first I'm going to show you the dry run, then I'm going to create the label, environment variable. So to run any container or pod, you use kubectl run command. Okay, again I'm defining pod 1, image, nginx. Earlier I gave labels, now I am giving env. Env is your environment variable keyword. Okay, single quote start. For say I am giving as training equals to CKA. Alright, quotes close. If I'm going to execute this much, a pod will be created with a container as a environment variable with training equals to CKA. Alright, but see, let's see the dry run first. Dry run equals to client. Okay, and then -o YAML. Okay, so team, where does your environment variable reside? You can see that. Okay, labels comes under metadata. So label is a property of a pod. That is why it is coming under metadata. But where is your environment variable? Environment variables comes under your container specification. Okay, so all the environment variables are your container level resource. So any environment variable you define will be inside your container specification. You can see specs, container, environment, name is training and value is CKA. Means training is equals to CKA. Now I am going to create this container as well. Okay, let's remove the dry run. Okay, your pod is created. If I want to log into my pod, how do I do that? kubectl exec command, we have seen that, nothing new. And then I'm going to give the pod name, pod 1, and then some bash prompt. Now you can see I am inside my pod. Okay, so if you want to see environment variable, what is the command? Print env. Okay, so you can see that whenever a pod is created, whenever a machine is created, we have some variables, environment variables created by default. Okay, some environment variables are your image based. Okay, you have nginx image, so some environment variables coming from that. You are using it as a Kubernetes pod. That is why you have some Kubernetes level environment variable as well. But you have the environment variable that you have defined as well. Okay, so it will have the environment variable that you have created. If I'll come outside, Control PQ. Alright. Let's have an example from the repo as well, shall we? Oh, where are pods? Here it is. Do we have any environment variable pods? So yeah, here it is. I'm going to pick this one. So team, what is happening here? I'm going to create a pod. This is the name of the pod. I have given a label as well. Alright, these are the specification. Container is this. If you want to have the image from a private repo or not from the Git repo, not from the Docker Hub right away, you can have GCR repo as well. This is your Google Cloud repo. Okay, I'm giving the environment variable as welcome equals to hello from the environment, and CK exam equals to CK exam version 1.18. Okay, so this YAML I'm going to take kubectl create -f. Okay, your pod is created. Kubectl get pods. Still creating. It is a heavy image, so it is taking some time. Yeah, now it is ready. Alright, so your environment variable pod is created. If you want to see the environment variable, you can again see that in this one also. Kubectl. Just a minute. Yeah, kubectl exec -it. Alright, pod name --. If I'll give bash, I will be logged inside to my pod or container with a bash prompt. If you want to provide some command right away, you can do that as well. What I want to do, I want to go inside my container and have the print env. So I don't have to go inside my container. I can simply give the command right here itself. Okay, so I did --, print env, and I give the environment variables right here. You can see welcome, hello from the environment, and CKA exam version 1.8. So if you want to provide any environment variables like this, you can provide with environment variables. env is a keyword, and how if you want to give it inside a definition, a YAML file, we have seen that as well. Okay, any question with environment variables? Sir, will it be used across cluster, or we have to set it per cluster environment variables? Rahul, it is not a cluster level resource at all. If you have multiple Kubernetes cluster, that is a completely different thing. Okay, we are using it inside a cluster, and even if you have to give the environment variables are at the container level, not even at the pod level. So even if you're creating two containers and you want to pass on the environment variable to different containers, you have to mention it specifically. Okay, so it is not even at the cluster level, it is at the container level. Jagannath, you're asking if we have multiple containers inside a pod, is it the environment variable available to both the container? Jagannath, you can see the definition here. Okay, this is one container definition. Inside that container definition, you are giving variable. If you want to have another container, you're going to have this complete definition below, and you give another environment variables. So if you want to have two containers inside a pod, you have to define environment variable twice. Okay, because it is container specific. Okay, now we can see pretty much responses, so we can start now. Alright, so team, we have covered environment variables, we have covered limits. Next thing that we are going to cover are probes. Okay, so team, there are two type of probes. First is your liveliness. Okay, and second is your readiness. Okay, so you have two types of probes. First is your liveliness probes and second is your readiness probe. But what actually probes are there? Okay, before understanding about type of probes, what are probes actually? So team, now you can see that one of your pod is running, right? Pod 1 is actually running. But how do you find out that your container inside this pod is healthy? Your pod is running, everything is fine. But how do you know that your container is working fine? Your container is healthy, or say your container is serving the purpose that for what it is created. Consider you have created a container. Okay, you have created an Nginx container. It should by default listens to port number 80. Okay, but because of some reason it is not listening to port number 80, it is listening to port number 800. Okay, and you are checking your application on port number 80, so your application won't be available at you at port number 80. All right, it means your functionality is not being served, but your container is running, your pod is running, right? So in these scenarios, your probes comes into picture. Okay, probes are nothing but probes do the health check. All right, Arjun, you are talking about our Docker commands. We don't want to do anything with the Docker. We are going to do everything with the probes, right? So the thing is, I want to do some kind of health checks or condition checks from Kubernetes itself. I don't want to go to any other tool. Alright. So for that purpose, Kubernetes provide you probes. Okay, and there are two type of probes as I told you. First is your liveliness and second is your readiness. I'll show you this right away practically so that it will be more clear to you. Alright, here it is probes and this is your liveliness probe. Let's see what it is actually. Okay, first is your API server version. All of this is clear to you. Metadata, names, label, this is all clear to you. Alright, the specs, termination grace period, you can ignore it for now. Alright, you have container, your container name, your container image, and your port number is 80. Alright, Nginx container will be running on port number 80. And I have put a liveliness probe check here. Okay, I have defined a liveliness probe. It means it is going to do some kind of check. Alright, these are comment out. Alright, I have just written here so that you understand that what you can do. Consider your application has some application URL, right? You can provide that at the HTTP GET. Provide the URL here. If that URL is working, then your container is fine. If not, it means your liveliness probe is failing. Alright, you can check for some path also, right? That a particular path is created or not. If that particular path is not created, it means your container won't be serving that purpose because we want that path to be there. So you can do the path check as well. You can do the port check as well for your application URL. Consider you have a database pod. In database pod, you work on the TCP ports. So you can see that if your TCP port is working or not, right? So these are the checks. Let's take this file and create your pod and then see how it goes. Okay, so what is initial delay second? It means it will wait for 5 seconds. After that, it will check for your liveliness probe. It is not that if your pod is created, it will do the check initially right away. It will have the initial delay of 5 seconds. After 5 seconds, it will check, and it will check after every 5 seconds. Liveliness probe will be checked after every 5 seconds. That it is val.yaml. Okay, so I have placed this YAML file here. Alright, so as of now you can see I am checking port number 800. So it should fail because your container port which is available is port number 80. So I have given a wrong port number. So your probe should fail. So let's see how it goes. Create -f l.yaml. Okay, so your Nginx demo pod is created. kubectl get pods. Okay, I should have removed that. kubectl delete pods. I'm just removing the previous pod, which are of no use for us now. Okay, team, can you see your Nginx pod has restarted twice? Right? Earlier it was 0 restart. Now it has restarted twice. Why is that so? Now see, it has restarted twice, 3-time restarts. So why it is restarting again and again? Because you have placed a probe check. Liveness probe is as per its own name. Okay, so team, for the basic definition, you can understand what is the difference between liveness probe and readiness probe. I will give you the readiness probe as well, but it is right away from the name. Liveness probe, it means your container will not be live if the probe is failing. If the probe is failing, it will delete the pod and it will restart the pod again and again, until and unless your pod is listening to it correctly. Okay, now you can see it has restarted 4 times. Now it has a crash loop app. It means it is again deleting and creating again and again. Let's try to explain it also. kubectl describe pod name. Team, what error you can see here? Unhealthy. Where? Liveness probe failed. It tried to do the TCP, and this is your this IP is of your pod. Okay, so if you want to see kubectl get pods -o wide. Okay, 104402 104402 is the IP of your pod, and the port number it is trying to listen is port number 800, and its connection is refused. That is why it is keep on restarting this pod. Now you can see it has been restarted 5 times. Okay, so it will keep doing that until unless your probe is passed. Alright, so if I delete it, kubectl delete pod name. Okay, your pod is deleted. Let's modify it. Okay, this time I'm going to check for your liveness port in number 80. Alright, let's try it this time. kubectl create -f al.yaml. Okay, there's some error with the formatting. I hope it should work now. Line number 17. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see it on the GitHub repository itself. Yeah, here it is on the same line. time I had to uncomment the HTTP get as well. Okay, because earlier we were checking for TCP port, TCP socket. Now we are checking for HTTP port. Okay, so now your pod is created. kubectl, just a minute. kubectl get pods. Okay, now it is running. It is not going to restart. If we want to verify, we can describe it. kubectl describe pod name. Okay, now this time you can see there are no failures. Your probe is passed successfully. There is no problem with that. Alright, everything is normal here. So this is how your liveliness probe work. If your probe is failing, it will keep on restarting your pod until unless your check is passed. This is the story of your liveliness probe. Okay, I hope it is clear to all of you. Any question with liveliness probe? Okay, some of you answered as well. Okay, thanks Anil, Gopal, Gaurav. Alright, Arjun, under liveliness probe we have TCP socket and other definition. Is there a man page like in Linux for us to know that available condition and parameters available in Kubernetes? Alright, so Arjun, yes, there might be on the official documentation. It must be there. Alright. Probably on this. Okay, let's go to the home page. Okay, so this is the official documentation. Whatever the probes you can use will be provided here. Okay, all types of probes, what are the condition, everything will be placed here. And I have also placed the examples here. Alright, so you can try the examples that I have placed here. Okay, I open the same page. Your pods, and under pods you have probes. Okay, so I have placed multiple conditions here. So whatever the application you have, if you have database pod, there are two type of pods itself. Okay, first is your database pod. On database pods you can do the health check on the TCP port. So that is one story. If you have application port, how you can test about your application? There might be a URL, there might be a port number. So only these kind of checks are there if you want to do it on the condition in probes. So first is your liveliness probe that we have already discussed, and now I'm going to discuss about your readiness probe. Before that, if you have any questions, you can ask. I might have missed some questions as of now. Can we generate some alert? Yes, Ganapati, again, if you want some alerting system, that is a part of monitoring. I have repeated it today many times. Okay, if you want to get some alerts, if you want to get some notification, that is a part of your notifications, monitoring. So yes, these things can be done. You can get the output all the time, but with the help of monitoring. So that is the part we are going to discuss later on. Any other question with the liveliness probe till now? Alright, so let me show you another example for your readiness probe now. It will be used for only port, or we can use other couple I have shown you here. I request you to pay attention. I have already shown you and discussed multiple times. It is not just port, you can give the path as well, you can give your application URL as well. You have multiple things. So it is not only with port, it is with the path as well, it is with your application URL as well. I have shown you that. Okay, so let me show you another example of readiness prop this time. Alright, so now you can see all the definitions are exactly same. Your kind, metadata, name, labels, alright, container name, image, everything is same, container port number. Alright, readiness prop. Okay, this time I have given the definition as readiness prop. In the previous definition, it was liveliness prop here. That is the only difference. Apart from that, I'm doing the health check for your HTTP GET itself. Okay, port number again I'm checking for 800. Okay, this is not the correct value. You can understand that because your Nginx is listening at port number 80. Again, I have given the wrong port number so that we can see what actually it does. I'll have the YAML kubectl create -f. Your pod is created. kubectl get pods. Okay, so team, now you can see it is running. Can you see any difference with the liveliness prop? It is running and it is not getting restarted. Any difference you can see in the output? Gopal, Shiju, Anil, you are right. Kapil, pay attention. Still not the right answer. Arjun, Kadapati, yes Kapil, now you saw it, right? Feni, yes. Mosami, yes. Chandrasekhar, still you have to get it. Yes, Rahul. Yes, Saurav, yes, I haven't given the right port number. Okay, so it is a problematic situation right now. But what is the difference? I haven't given the right port number. I'm asking about the readiness prop. You have to see the lower one, lower pod, RP Nginx demo. Yes, Aditya, port is not getting restarted. We have seen that. But what is the difference? Team, can you see the ready status as 0/1? Right? So readiness prop is not making it ready to serve the application. Okay? Your pod is running. Your pod is not getting restarted, but it is not allowed to serve the request. Okay? Your hotel is open, your restaurant is open, but your kitchen is not ready. So it is not serving any customers right now. Right? That is why it is showing 0/1. It means you have 0 container running inside the pod right now. Why is that? Because you have a prop condition and that is failing. If you want to see, you have to do kubectl describe pod and pod name. Okay. Now you can see warning unhealthy. Okay. Readiness prop failed at HTTP GET port number 800. It is failing at your port number 800. Connection refused. Okay. kubectl get pods. You can see it is still not restarted, but it is 0/1. So what is the difference between readiness prop and liveliness prop? The name explains itself. Okay. Liveliness prop, it means your container will not be live. Okay, in liveliness prop, your container will not be live. In readiness prop, your container will not be ready. That is the difference. In liveliness prop, your container will not be live. It means your container will be killed and it will keep on restarting. It will keep on recreating again and again until unless your prop is passed. In liveliness. In readiness prop, it won't make it ready. It means if your check is failing, it means your container is not ready to serve the purpose. Okay, it will keep on waiting. It will not make it ready until and unless your check is passed. Even now, if you check, it will show you 0/1. Even after 3 minutes, it is not restarting. It is just not making it ready in readiness probe. Okay, so let's try to edit it. kubectl edit pod name. I'm not 100% sure if your props can be modified in the real time. Okay, so the thing is, it is not always that you can modify everything with the running pods. There are some fields that you can modify. There are some fields that you cannot modify. Okay, edit, cancel, no valid changes. Okay, so this value cannot be changed. kubectl delete pod -- all. Okay, I'll take this definition. vir.yaml. Okay, I'm just modifying the port number. I'm giving the right one. Port number 80. kubectl create -f r.yaml. kubectl get pods. See, now your prop has passed, and that is why it is showing you 1/1. When you gave the right port number, it allowed it to be ready. Your readiness prop passed, so it made it ready. kubectl describe pod rppod. Okay, so you can see there are no problems this time. Everything is running perfectly fine. Okay, so readiness prop won't make it ready, and liveness prop won't let it live until unless your prop is passed. These are the two props which is available in Kubernetes. We have discussed both. Let me know if you have any problem with any of that. Any question with liveness prop and readiness prop. Yes, Joydeep, you are right. But if the container itself is not ready, then will it be able to ping URL? Anil, no, that is not the case. It means your container is created. Your container is created and it is available. But the prop is not passed. It means there is something going on inside the pod. Okay, the example I gave you earlier in the earlier classes for init pod, init container, it means that your restaurant is open, but your kitchen is not ready to serve. It means you place the readiness prop where there is some cooking required. Okay, it is not that once your container is created right away and it will start serving the request. Your purpose is once your container is created, it has to cook something, it has to create some HTML pages for your Nginx web server, or it has to do some work. After that, it is going to serve the request. So for that purpose, either you can use init container or either you can use readiness prop. So you will place a readiness prop for 5 seconds or 10 seconds or 1 minute as per your requirement. After that, it will make your container available. Your container is created, it is waiting to make it available. Okay, I hope it is clear to you, Anil. Can we have dependent pod to be created, deleted based on the other pod prop success? Ganapati, no, that is not the case. If your one prop is failed, props are basically on a particular container itself. Okay, you cannot define a condition for another container or pod based on the props defined on one container. Okay, for that purpose, you have init containers. But props is done on the specific container itself. Suppose my container is taking seconds for starting and liveness initial delay is 5 seconds. In that case, my pod will continue to restart forever. Yes, Kushagar, that is going to be the case. So you have to place your props very intelligently. if you know that your container comes up online after 7 seconds, so at least you should have an initial delay of 9 seconds or 10 seconds at least. In production, should we always use readiness prop? Is it a good practice? Yes, Adurika, guess it is a good practice. That is why readiness and liveness props are there for do the health checks. Okay. Also, if you want, you can use both the props itself. Okay, there is no hard and fast rule. You can use only one prop. You can use both the props. And here is also another example for that. Okay, in myapp.yaml. Okay, so you are going to practice this one at your own, right? You can use your own image. I have used my own image. Okay, so it is up to you. I have also used the readiness prop here, and I have also used the liveliness prop here. Okay, so in HTTP GET, you can see I have provided the path as well. It means I will provide the IP address, port number / pet clinic, and then you are going to do the complete check. Okay, if you want to execute some command as well, okay, you don't want to do this check on the URL, you can use the command as well. It means curl localhost :8080 / pet clinic. Okay, so if you want to execute some command as well, you can do that also. All right, so team, if props are clear to all of you, we can move to the next topic, can we? Kushagra, how to decide which prop to use? Use cases, please. Kushagra, use cases I have explained to some extent. Okay, readiness props are mostly used when we have some containers that has to cook something. So there is some time after that they will be available. Okay, so it is not on the go. So once your container is created, once your pod is created, it is not going to serve the request right away. It has to wait some time. After that, it is going to serve the request. In that case, we use readiness prop. Okay, and I told you that you can use both the props itself. So they are for the condition check. It is up to you which check you want to use. Liveliness prop is, consider you have some application with which you don't want to have some wait, because you know once your container is live, it will start serving the request right away. Okay, so there is no purpose of waiting for some initial delay second or for being it ready. There you use liveness prop. It means your container is live, it should start serving the request right away. If it is not serving the request, it means there is some problem with the container and it should be deleted and recreated again. So in that case, you are going to use your liveness prop. All right, could you please explain the difference between initial delay second, period seconds, and timeout seconds? Okay, there are so many variety. Okay, first is your initial delay second. It means this check will not take place when your container is created, your pod is created for 5 more seconds. Okay, consider my container and pod is created right now. So it will wait for 5 seconds before doing the readiness prop check. Okay, that is your initial delay second. It will wait for 5 seconds after creation of your pod and container. Then it is going to do the readiness check. Then you have period second. It means it will keep on checking after every 5 seconds. Consider your application is currently available. Okay, your application is available, your application URL is working, and after some time what happened, your application load increase, which your container was not able to handle, and that is why your application has stopped responding on that particular port number. Your application is not responding anymore. So then how you are going to check that your prop is being passed and failed? It means it is a period second that it will check after every 5 seconds. Even if your prop is passed, even if your prop is passed once, it will keep on checking after every 5 seconds. Consider after 10 minutes your prop has failed. So again, it will make your container as not available. or it will delete your container. Based on the readiness prob and liveness prob, it will take action, but it will keep on checking after every 5 seconds. That is your period seconds. And timeout second. Timeout second is once your prob has failed. Okay, if your prob is getting passed, it will check after every 5 seconds, but your prob has failed, then there comes your timeout second. Once your prob is failed, it will check after every 3 seconds this time. Okay, that is your timeout seconds. So this is the definition of all three. Sumit, I hope it is clear to you. You will be covering how to use local images in K8s. Sarath, what do you mean by local images? The images which are downloaded on the machines. So that is all okay, I guess. So even if you have local images, if you have a remote images, it doesn't matter because the image downloading is done by your Docker. Kubernetes is not downloading any images. Okay, Sarath, if you remember, I have shown you today itself how to use local registries. Okay, I have also shown you how you can use Google registry as well. An example I took just today was from Google registry. Here you can see I am also taking the image from a privately owned registry as well. Okay, so both the example I have shown you. Okay. What is the maximum period second we can set, and it should be minimum suggested. Sort of that is all dependent on your business requirement. Okay, it is all based on your business requirement, that how much minimum downtime you have signed with the client, what is your service level agreement, that your application will be available 99.9% of time. Okay, so it is all dependent on that how much maximum period seconds you are going to define, what should be the minimum value. So it is based on your business requirement. You can give any, you can give 2 seconds, you can give 5 seconds, you can give 10 seconds, and it is also dependent on your image. Okay, that how heavy your image is, how much time it is going to get downloaded, how much time it is going to have something cooked. If your container is cooking something, then how much processing it is going to do, how much scripts it is going to execute. So it is all dependent on that how much processing needs to be done and what time it takes to do the processing. Consider you are executing some script before your readiness prob. Okay, so your script execution take 5 seconds, then give the initial delay second of 7 seconds. If your script's execution take 20 seconds, you have to give the initial delay second of 25 seconds then. So it is all dependent that how your business is defined, how your processing is being done at the back end. All right. Okay, so team, next topic. All right, props are covered. Then we had services, but services are on this agenda as well. Okay, so what we are going to do, we are going to cover services at once only. Okay, first we are going to discuss about your controllers. All right, so it is an interesting topic. All right, so do pay attention. I hope you'll like it. All right, so first is your RC. First controller we are going to discuss is RC, which is called replication controller. Okay, so team, let's discuss about your controllers. How many type of controllers are there? So when we discuss about the architecture, if you remember, I told you there is a controller manager, right? In the architecture, you know there are controller manager, and I told you there are multiple controller manager. It is not just a single component. You have your node manager, you have your pod manager, okay? So we have multiple controllers. Control manager contains multiple controllers. So we are going to discuss about those controllers now. Alright. So first thing first, as we have already understood that it is never suggested to have a single container for your single application, right? Because there is no load balancing being taken place, no auto scaling is there, no load balancing, no distribution of traffic. Okay, there is nothing. So if there is only one pod, it might get failed, it might get restarted, and during that time your application will be not available. So what we always need, we have some multiple replicas. We need to have multiple replicas so that even if a container goes down, your customer will be able to use your another container to have the application availability. Okay, so for high availability, we always create multiple replicas of your single application pod. For that purpose, one of the controller is called replication controller. Okay, so team, the thing is, I have to tell you, replication controller is kind of obsolete now. It is depreciated. All right, but I'm going to give you some idea about this. Okay, first is your replication controller it is. All right, kubectl API resources. Where is replication controller? It has to be somewhere. Here it is. Okay, so team, this object is called a replication controller. All right, and the short name is RC. So if you want to define the replication controller, you can give RC as well. All right, but the kind you have to mention is replication controller. So what is replication controller? I'm going to create 3 replicas of my same container. All right, let's take an example directly so that it will be more clear to you. You have to go to the controllers. Replica controller. Alright, so team, let's try to understand it, what replication controller actually does. Okay, first is your API server. Alright, kind is replication controller this time. What is the name of replication controller is Tomcat RC. Alright, under specification I have defined 3 replicas. It means I am not going to create a single container, I am going to create 3 containers of the same type so that load balancing can take place. Okay, for high availability. Selector field is application Tomcat. It is for your labels. Okay, template. So now under template, you are going to give the definition of your pod. Okay, this is your application controller. This is the name of your application controller, and under specification template, you are going to give your Tomcat pod definition. Okay, what is the metadata? Tomcat is going to be the name of your Tomcat pod. Okay, Tomcat RC, and this is going to be your label. I am defining label as well. So Tomcat is the name of your pod here. I am going to put some label also. Pod is equals to Tomcat RC. App equals to Tomcat. I am giving some labels. And what is the specification of that pod? Containers. I am going to use the container name as Tomcat, and this is the image I am going to use. Learn DevOps Tomcat. This is from the private registry. Okay, so let's have this example. Let's have the raw format. I'll copy it. kubectl get pods. kubectl delete pods -- all. kubectl create -f. So team, I'm going to create a replication controller. I'm going to create a RC. Alright. So let's see kubectl get RC. So you can see the desired count is 3. How much current state is 3? It means I must be having 3 pods. What I desired was 3 pod, and how much I am actually having 3 pods. As of now, none of them is ready. Okay, now you can see desired was 3. I asked for 3 pods. Current state, there are currently 3 pods running and 3 pods are ready as well. kubectl get pods. Okay, so the naming convention you can understand. This is the name of your replication controller. Okay, first the name of your application controller, then some random alphanumeric string is going to be there. And you can see the 3 pods created at the same time by the replication controller. So whenever you want to have multiple replicas, you are not going to create them one by one. You are going to use replication controller. Alright. So I told you this is a controller. What was the responsibility of controller manager? Controller manager responsibility was I have some actual state and I have a desired state. It has to manage them. Because of some reason, if one pod goes down, it should get created automatically. Right? That was our expectation. Let's try to delete one of the pod. kubectl delete pod name. Okay, once our pod is deleted, still you can see current is 3, ready is 3. Why? You can see when I deleted a pod, another pod came online 16 seconds ago right away. So what your replication controller did, even if one of your container goes down, even one of your pod is deleted manually, your replication controller is going to manage the state no matter what. Okay, so it will still be there. You can delete all, it will create them all. kubectl delete pods -- all. I'm deleting all the pods. Still you can see the RC, it is 333 again. Why? Because all the pods are created again with the help of your replication controller. Okay, so if you have to delete the pods, you have to delete the RC. kubectl delete RC name, and once your application controller is gone, your pods will get terminated. All the pods are gone. Okay, so team, this is the story of your replication controller. Yes, Sanjay, self-filling it is. So team, any doubts, any question with your replication controller? Because if the pod goes down, then application controller will handle and create new pods. Yes, Saurabh, you're right. Team, any question with replication controller? Clear to all of you? Sumit, you are asking, can we edit any specific pod within RC? No, Sumit, you cannot do that. The reason is your replication controller is managing them, and the purpose of replication controller is load balancing. So load balancing will be done with similar pods. If you have different kind of pod, then there is no load balancing between them. Okay, so all the 3 pods, all the replicas that you have defined should be exactly the same. Sumit, or it has to be unique under RC. Okay, I already answered that. Kushagra, does it create a static manifest like kubelet do for the static pods? No, Kushagra, there is no static manifest right here. Okay, replication controller manages it at its own at the backend. There is no manifest with like your static pods or something. Okay, replication controller manages it at the backend. Yes, Himanshu, we can modify the replicas in the real time as well. Okay, that is my next part to which I am coming. Okay, so team, if it is clear, let me have next thing. How to create new replicas based on traffic. Ganapati, I am coming to that only. Okay, I am coming to that only. Okay, so team, as I already told you that your replication controller is obsolete now. Okay, it is depreciated. Why it is depreciated? Because it is being replaced by another object called replica set. Okay, your replication controller has been replaced by RS, that is your replica set. So why is that? Because your replica controller had some shortfalling. That is why your replica set removed those shortcoming and replace it with the replica set. So what were the challenges with the replica controller and what are the additional features we get in replica set? We are going to see about that. First thing first. Again, I am going to take a layman example this time. Yes, Kushagra, you are right. Okay, so team, let's take a layman example. All right, consider you're working in an organization. All right, you're working in an organization, and a new project came, and that new project asks for that you want to have at least 5 people with Kubernetes expertise. Okay, as of now, there is a manager in your team. Okay, there is a manager in your team, and these are your resources. Okay, I'm not deleting these images. Consider these are also human resources. So what is the manager doing? Manager has a person in his team who is of Linux expertise. Okay, your manager has another person with database expertise. Your manager has already a person in a team with Kubernetes expertise. Okay, then a new project came, and that new project asks for 4 people with Kubernetes expertise skill set. Okay, a new project came to your manager and it asked for 4 people with Kubernetes expertise. All right, so what happened? Your manager went to another person in human resourcing. Okay, your manager went to HR and he said there is a new project. I need 4 people with Kubernetes expertise. Okay, you have to hire 4 people that have the skill set of Kubernetes. Okay, so what happened? There is already a person with Kubernetes expertise already there in his team. Okay, so now how many people does it require for the same skill set? How many people we have to hire this time? Do we have to hire 4 people or do we have to hire 3 people? Yes, Rishabh, you're right. Team, so the new project came, it asked for 4 people with Kubernetes expertise. All right, but inside our team we already have 1 person with Kubernetes expertise. Then how many people we have to hire this time? Right, Himanshu, Sanjay, Adhirika, guess you're right. Kapil, you are not. Okay, team, try to understand this. I already have 1 person in my team with Kubernetes expertise. Okay, the project requires 4 people. So I already have 1 people. Why do I have to hire 4 more people? I'll have 5 Kubernetes experts in my team. If I hire 4, I already have 1. Why cannot I consume this person in the new project also? Right? So I have to hire only 3 more people because I already have one person in my team with Kubernetes expertise. I can consume him also in the project. He can also contribute and I can have 3 more people. So this much of smartness was not present in replication controller. Okay, this smartness was not there with replication controller. If you have created a replication controller, if you have mentioned 4 number, it is going to create 4 replication controller. It is going to create 4 replicas no matter what. If the similar pod is already running, okay, if the similar pod is already running, it is not going to count it in. It is going to create 4 pods no matter what. It is not going to take care that if already a pod is running with the same functionality or not. It is not going to worry about that. It is going to create 4 pods right away. Replica set came with some smartness. Okay, replica set came with some smartness. It said, okay, if I already have a pod with the same functionality and you are asking for 4 replicas, I am going to create only 3 replicas. I am not going to create 4 replicas. Okay, so I already have one. I am going to count it in. Right? So that is why your replica set is a smarter one. It is also going to look into the cluster first, that if a similar pod is running or not, and if it is there, it is not going to create another one. If it is asking for 4, it will create 3 because one is already there. Alright. Now I am going to take an example for that. Alright. So team, now you can see the kind is changed. Now I'm using replica set. The name of replica set is test and I'm asking for 3 replicas. Here comes something in picture which is called selector field. Okay, selector field was not there in your replication controller, but selector field is here in your replica set. It is going to match the label here. Okay, it is going to match the label. Now under template, again under template you have to give the definition of your pod. Okay, metadata, labels. The pod label is going to be tier front end, and specification I am going to use a container, and the name of the container is LB, and this is going to be your image name. Okay, so I gave you an example that a person is already there with the same expertise. So what I am going to do, I am going to create this container with the same label first. kubectl run pod1 -- image. You can give any image. Okay, httpd. All right, now I'm giving labels. Equals to, I'm going to give the same label, tier equals to front end. It is important the spelling is exactly the same. kubectl get pods. Okay, so now a pod is already there. All right, now I'm going to use this definition. Let's see if it is going to create 3 or it is going to create 2. Okay, your replica set is created. The short name for replica set is RS. kubectl get RS. Okay, the name of your replica set is test. Desired is 3, current is 3, ready is 1 as of now. Okay, now all 3 are ready as well. kubectl get pods. So team, can you see it only created 2 pods? It didn't create 3 pods. Why it didn't create 3 pods? Because one pod with a similar label was already there. So replica set do the identification based on your labels. Okay, that is why in replica set, selector is an important field. How it is going to check that similar pod is running or not? How are you going to define inside your kitchen? Consider you are inside your kitchen. How you are going to see that how many jars are there of sugar? You have to check the label for that, right? Inside your kitchen, you are going to check all the jars and you are going to see the sticker or label on the jar that how many jars are there of sugar, right? Similarly, your replica set checks for your selector field. It has to match the labels. If any pod is running with a similar label, it is going to count it in. Okay, so if I'm going to delete this pod this time, if you remember, I created this pod manually, but now it is a part of replica set. When I created it independently, it was alone. It was not a part of replica set. But once I created the replica set, it became a part of replica set. If I'm going to delete it now, it will get recreated. See, another pod was created 13 seconds ago. Why? Because I already had a person. Maybe this person resigned. If this person resigned, then now I need at least 4 people. Alright, earlier I was asking for 3 people because I already had one person, but that person also resigned. So I have to have 4 people now. That is why another pod came online. Alright, so team, this is the additional functionality that you get with your replication set. Now coming back to the previous question, if you can scale it again or not. Alright, now the use case. Consider you started your new application. Okay, you started a new application of your own. Now what is the situation? Consider, just a minute team. Here it is. Okay, so team, this object is called a replication controller. Alright, and the short name is RC. So if you want to define replication controller, you can give RC as well. Alright, but the kind you have to mention is replication controller. So what is replication controller? I'm going to create 3 replicas of my same container. Alright, let's take an example directly so that it will be more clear to you. You have to go to the controllers. Replica controller. Alright, so team, let's try to understand it, what replication controller actually does. Okay, first is your API server. Alright, kind is replication controller this time. What is the name of replication controller is Tomcat RC. Alright, under specification I have defined 3 replicas. It means I am not going to create a single container, I am going to create 3 containers of the same type so that load balancing can take place, okay, for high availability. Selector field is application Tomcat, it is for your labels, okay. Template. So now under template you are going to give the definition of your pod. Okay, this is your replication controller, this is the name of your replication controller, and under specification template you are going to give your Tomcat pod definition. Okay, what is the metadata? Tomcat is going to be the name of your Tomcat pod. Okay, Tomcat RC, and this is going to be your label. I am defining label as well. So Tomcat is the name of your pod here. I am going to put some label also. Pod is equals to Tomcat RC. App equals to Tomcat. I am giving some labels. And what is the specification of that pod? Containers. I am going to use the container name as Tomcat, and this is the image I am going to use. Learn DevOps Tomcat. This is from the private registry. Okay. So let's have this example. Let's have the raw format. I'll copy it. kubectl get pods. kubectl delete pods -all. kubectl create -f. So team, I am going to create a replication controller. I am going to create a RC. Alright. So let's see kubectl get RC. So you can see the desired count is 3. How much current state is 3? It means I must be having 3 pods. What I desired was 3 pod, and how much I am actually having? 3 pods. As of now, none of them is ready. Okay, now you can see desired was 3. I asked for 3 pods. Current state, there are currently 3 pods running, and 3 pods are ready as well. kubectl get pods. Okay, so the naming convention you can understand. This is the name of your replication controller. Okay, first the name of your application controller, then some random alphanumeric string is going to be there. And you can see the 3 pods created at the same time by the replication controller. So whenever you want to have multiple replicas, you are not going to create them one by one. You are going to use replication controller. Alright. So I told you this is a controller. What was the responsibility of controller manager? Controller manager responsibility was I have some actual state and I have a desired state. It has to manage them. Because of some reason, if one pod goes down, it should get created automatically. Right? That was our expectation. Let's try to delete one of the pod. kubectl delete pod name. Okay. Once our pod is deleted, still you can see current is 3, ready is 3. Why? You can see when I deleted a pod, another pod came online 16 seconds ago right away. So what your replication controller did, even if one of your container goes down, even one of your pod is deleted manually, your replication controller is going to manage the state no matter what. Okay, so it will still be there. You can delete all, it will create them all. kubectl delete pods -- all. I'm deleting all the pods. Still you can see the RC. It is 333 again. Why? Because all the pods are created again with the help of your replication controller. Okay. So if you have to delete the pods, you have to delete the RC. kubectl delete RC name, and once your application controller is gone, your pods will get terminated. All the pods are gone. Okay, so team, this is the story of your replication controller. Yes, Sanjay, self-filling it is. So team, any doubts, any question with your replication controller? Because if the pod goes down, then application controller will handle and create new pods. Yes, Saurabh, you're right. Team, any question with replication controller? Clear to all of you? Sumit, you are asking, can we edit any specific pod within RC? No, Sumit, you cannot do that. The reason is your replication controller is managing them, and the purpose of replication controller is load balancing. So load balancing will be done with similar pods. If you have different kind of pod, then there is no load balancing between them. Okay, so all the 3 pods, all the replicas that you have defined should be exactly the same. Sumit, or it has to be unique under RC. Okay, I already answered that. Kushagra, does it create a static manifest like kubelet do for the static pause? No, Kushagra, there is no static manifest right here. Okay, replication controller manages it at its own at the backend. There is no manifest with like your static pods or something. Okay, replication controller manages it at the backend. Yes, Himanshu, we can modify the replicas in the real time as well. Okay, that is my next part to which I am coming. Okay, so team, if it is clear, let me have next thing. How to create new replicas based on traffic. Ganapati, I am coming to that only. Okay, I am coming to that only. Okay, so team, as I already told you that your replication controller is obsolete now. Okay, it is depreciated. Why it is depreciated? Because it is being replaced by another object called replica set. Okay, your replication controller has been replaced by RS, that is your replica set. So why is that? Because your replica controller had some shortfalling. That is why your replica set removed those shortcoming and replace it with the replica set. So what were the challenges with the replica controller and what are the additional features we get in replica set? We are going to see about that. First thing first, again I am going to take a layman example this time. Yes, Kushagra, you are right. Okay, so team, let's take a layman example. All right, consider you're working in an organization. All right, you're working in an organization and a new project came, and that new project asks for that you want to have at least 5 people with Kubernetes expertise. Okay, as of now there is a manager in your team. Okay, there is a manager in your team and these are your resources. Okay, I'm not deleting these images. Consider these are also human resources. So what is the manager doing? Manager has a person in his team who is of Linux expertise. Okay, your manager has another person with database expertise. Your manager has already a person in a team with Kubernetes expertise. Okay, then a new project came and that new project asks for 4 people with Kubernetes expertise skill set. Okay, a new project came to your manager and it asked for 4 people with Kubernetes expertise. All right, so what happened? Your manager went to another person in human resourcing. Okay, your manager went to HR and he said there is a new project. I need 4 people with Kubernetes expertise. Okay, you have to hire 4 people that have the skill set of Kubernetes. Okay, so what happened? There is already a person with Kubernetes expertise already there in his team. Okay, so now how many people does it require for the same skill set? How many people we have to hire this time? Do we have to hire 4 people or do we have to hire 3 people? Yes, Rishabh, you're right. Team, so the new project came, it asked for 4 people with Kubernetes expertise. All right, but inside our team we already have 1 person with Kubernetes expertise. Then how many people we have to hire this time? Right, Himanshu, Sanjay, Adhirika, I guess you're right. Kapil, you are not. Okay, team, try to understand this. I already have 1 person in my team with Kubernetes expertise. Okay, the project requires 4 people. So I already have 1 people. Why do I have to hire 4 more people? I have 5 Kubernetes experts in my team. If I hire 4, I already have 1. why cannot I consume this person in the new project also? Right? So I have to hire only 3 more people because I already have one person in my team with Kubernetes expertise. I can consume him also in the project. He can also contribute and I can have 3 more people. So this much of smartness was not present in replication controller. Okay, this smartness was not there with replication controller. If you have created a replication controller, if you have mentioned 4 number, it is going to create 4 replication controller. It is going to create 4 replicas no matter what. If the similar pod is already running, okay, if the similar pod is already running, it is not going to count it in. It is going to create 4 pods no matter what. It is not going to take care that if already a pod is running with the same functionality or not. It is not going to worry about that. It is going to create 4 pods right away. Replica set came with some smartness. Okay, replica set came with some smartness. It said, okay, if I already have a pod with the same functionality and you are asking for 4 replicas, I am going to create only 3 replicas. I am not going to create 4 replicas. Okay, so I already have one. I am going to count it in. Right? So that is why your replica set is a smarter one. It is also going to look into the cluster first, that if a similar pod is running or not, and if it is there, it is not going to create another one. If it is asking for 4, it will create 3 because one is already there. Alright. Now I am going to take an example for that. Alright. So team, now you can see the kind is changed. Now I am using replica set. The name of the replica set is test and I am asking for 3 replicas. Here comes something in picture which is called selector field. Okay, selector field was not there in your replication controller, but selector field is here in your replica set. It is going to match the label here. Okay, it is going to match the label. Now under template, again under template you have to give the definition of your pod. Okay, metadata, labels. The pod label is going to be tier front end, and specification I am going to use a container, and the name of the container is LB, and this is going to be your image name. Okay, so I gave you an example that a person is already there with the same expertise. So what I am going to do, I am going to create this container with the same label first. kubectl run pod1 -- image. You can give any image. Okay, httpd. All right, now I am giving labels. Equals to, I am going to give the same label, tier equals to front end. It is important the spelling is exactly the same. kubectl get pods. Okay, so now a pod is already there. All right, now I am going to use this definition. Let's see if it is going to create 3 or it is going to create 2. Okay, your replica set is created. The short name for replica set is RS. kubectl get RS. Okay, the name of your replica set is test. Desired is 3, current is 3, ready is 1 as of now. Okay, now all 3 are ready as well. kubectl get pods. So team, can you see it only created 2 pods? It didn't create 3 pods. Why it didn't create 3 pods? Because one pod with a similar label was already there. So replica set do the identification based on your labels. Okay, That is why in replica set, selector is an important field. How it is going to check that similar pod is running or not. How are you going to define inside your kitchen? Consider you are inside your kitchen. How you are going to see that how many jars are there of sugar? You have to check the label for that, right? Inside your kitchen, you are going to check all the jars and you are going to see the sticker or label on the jar that how many jars are there of sugar, right? Similarly, your replica set checks for your selector field. It has to match the labels. If any pod is running with a similar label, it is going to count it in. Okay, so if I'm going to delete this pod this time, if you remember, I created this pod manually, but now it is a part of replica set. When I created it independently, it was alone. It was not a part of replica set. But once I created the replica set, it became a part of replica set. If I'm going to delete it now, it will get recreated. See, another pod was created 13 seconds ago. Why? Because I already had a person. Maybe this person resigned. If this person resigned, then now I need at least 4 people. Alright, earlier I was asking for 3 people because I already had 1 person, but that person also resigned. So I have to have 4 people now. That is why another pod came online. Alright, so team, this is the additional functionality that you get with your replication set. Now coming back to the previous question, if you can scale it again or not. Alright, now the use case. Consider you started your new application. Okay, you started a new application of your own. Now what is the situation? Consider, just a minute team, just a minute please. Yeah team, sorry. So what I was telling you, that in consider you have created your application in a single pod. Okay, but now your application is getting viral. Now a single pod is not able to handle that much requests. How you are going to multiply it? How you are going to create multiple pods so that load balancing can take place? Okay, earlier your application was so small that you created a single pod. Now your application is getting viral, it is getting all the loads. So now you want to have some load balancing, and you can also not delete your previous pod. Okay, so in that case, your application was created with a single pod initially. Now your application is getting viral, you want load balancing, so you create replica set. So earlier your single pod was serving the request, now your all the pods will serve the request. So even if one pod goes down, your another pod will be available. As of now you have asked for 3. Consider you want to have more replicas now because your application is getting more viral. No problem, you know the command kubectl edit rs test. Okay, you have defined replica 3, you modify it, ask for 5 this time. Okay, you can see your replica set has been edited. kubectl get rs. Now you can see 5 kubectl get pods. You can see 2 more pods was created just away 12 seconds ago. Okay, so in the runtime you can have multiple replicas with replica set as well. Consider your application load has decreased. Reduce the number, no problem with that also. Okay, as of now there are 5, I am giving 2 now. The load is not that much. Again edit it, kubectl get rs, kubectl get pods. Okay, you can see other pods are getting terminated. Only 2 pods will be live then. because you have asked for 2. All the other pods will be gone. So you can modify your replica set in real time as well. Okay. Let me know if you have any question with replication controller and replication set now. Yes, Anil, images were different. Okay. That example I have just taken, but in the enterprise level, you don't use different images. You don't use different pods. Okay. Your Kubernetes is not going to identify on the image level. Okay. Your Kubernetes identify on the label itself. So if you have different image, if you have different application, it is not going to identify that. It is going to check for the label. So it is your intelligence as a Kubernetes administrator that you give labels on the pod based on the similar image or similar functionality. Okay, this is the smartness that you have to do as a Kubernetes administrator, that you don't use different application for the replica set on the based on your labels. You have to have same labels for similar application pods. Fanny, yes, load balancing scaling can be done. I think I have shown you that. Jagannath, if we have more than the desired pod and replica set, will it scale down automatically? Jagannath, no, it won't be done automatically. Okay, if you want to do it automatically, we have to use HPA. Okay, but if we talk about replica set itself, you have to scale it down. You have to scale it up manually. It doesn't do it automatically. What are the other criteria apart from match label in the object selector? Sumit, that is the only case. Okay. So Sumit, the thing is, your replica set works on labels only. You cannot do the load balancing. You cannot create replica set on any other term or any other object. It has to take with labels only. So that is also a use case. Somebody asked me earlier that what are the different use cases of labels. This is another use case of labels. Labels helps in load balancing in replica set and deployment also, that we are going to cover later. Deployment is the next topic per se. So if you have more than the desired pod and replica set, okay, I already answered this one. How and which pods are getting terminated for FIFO and LIFO? Chandrasekhar, that is not the case. Okay, so if you know about the application pods are stateless. Okay, application pods are stateless. It doesn't matter which pod is serving the request. All the pods are completely identical because they are application. They are stateless. Okay, so any pod can get deleted randomly. Any pod will be created randomly. Load balancing will be done randomly among them. Okay, so there is nothing like FIFO or LIFO. Any pod can be terminated if you are scaling down. Okay, Satish, I think your question is also answered. If the pod in the artist is still serving some requests and we scale down, how it will make sure that the pod is deleting and is idle and not processing anything? Okay, so Rishabh, again, as I said, it is a stateless server. Okay, your pod is deleted. You will have a slight glitch. Okay, because consider the pod which is getting terminated is still serving some request. First of all, that pod will be not terminated. First priority will be if we have 4 replica set and we want to scale it down to 2. So it will always try to terminate the pod which are not serving any request. But even if consider that you are scaling down to 2 and still 3 pods are serving requests. So 1 pod will be terminated which is serving the request. So there is going to be a slight glitch for the user. It has to refresh the tab. Once the tab is refreshed, your request will again go to the pod which is available out of the remaining 2. So a slight refresh is going to be there. That's all. Based on CPU and RAM limit, we need to set replica set. Kapil, replica set is an independent entity. It is not related to CPU and RAM. Okay, CPU and RAM limit you have to set at the container level, and replica set deals with the replicas of your pod. So there is no connection between them. If you have to set the limits for CPU and RAM, you have to define them under containers definition, and replica set is itself a bigger definition of your pods. What is the other advantage of replica set over replication controller? So Prempal, the benefit is that you can scale it in the real time. Also, you can have already running pods inside your replica set, but your replication controller doesn't do that. So that is the only difference between replication set and replica controller. Himanshu, that will be done on the round robin. How user request will be handled by the replica pod. If you know about the load balancing, it is done automatically. Maybe your first request goes to pod 1, your second request will go to pod 2, your third request will go to pod 3. Again, your fourth request will go to pod 1 again. Okay, a big question from Arjun. If one pod is created manually for a specific ask, and then the replica set will have 3 pods, so it will create 2 pods. If we delete replica set, will it delete the first pod which was created manually? Yes, Arjun, you are correct. Consider one pod was created independently, and after that it became a part of replica set. Now, if you are going to delete the replica set, that pod will be gone as well, because that pod doesn't have any identity as an individual now. That pod has an identity as a part of a replica set. So if replica set goes, that pod will be gone also. Himanshu, it will be done automatically. What will be done automatically? Rishabh, okay. Replica set is used only for stateless object, okay. But if you want to use stateful set, there is an object itself present in Kubernetes called stateful sets, okay. So replica set replication controller is used for stateless objects, and if you want to use stateful objects, we have stateful set. We are going to discuss that at the end of the class, or course I mean to say. Okay, you can see on day 8 there is a topic called stateful set. Kushagra, you are asking, can replica set pick up static pod with same label? No, Kushagra, it cannot. Okay, it is actually a good question. I haven't tried that anytime. Okay, so try it out, find it out at your own. To be honest, I haven't tried that, so I cannot give you an answer with certainty. But you can try that. Create a static pod with the same label and create a replica set. As per my understanding, as per the architecture, I don't think it will be controlled by the master, so it won't count it as a replica set, as per my understanding. But honestly, I haven't tried that. You can go on and try that. Kushagra. Yes, Himanshu, your request will be handled automatically using the load balancing. Akhil, you're asking what is the difference between stateful and stateless. Okay, Akhil, consider your application Nginx page. Okay, you have an Nginx page that is a stateless. It means its state is not changed over the time. Your Nginx has some HTML file, it will keep on displaying that. As many times as you want to refresh it, it is going to show you the same request. So it is stateless. You cannot change the state of that. But if you talk about a database pod or a database container, it means there are going to be some entry in your database. Your database is going to have some updates. Your database is going to delete something. Your rows will be updated. Your data will be updated, deleted. So that is stateful. It means its state is changing every time. If you do some update, the state of your database pod is changed. If you delete some rows, if you enter some rows, insert some rows, update some rows, the state of that pod is changing. So that is a stateful set. So I hope it answers you, Akhil. what is variables mentioned? Okay, Shiju, that is your environment variables that we have discussed today. Okay, those are the variables. Akhil, that is a question of advanced topics. Okay, so I won't be able to answer it right away. Any relation between volumes of stateful set and stateful sets, stateless set. Okay, so that is an advanced topic. Once we'll cover that part, once we cover the volumes, once we go to the stateful set, then I will be able to answer that. Okay, so it is an advanced topic right now. Any question? All right. So team, yesterday we have discussed a lot, right? And as per our agenda that we have here, yesterday we were able to discuss only RC and RS. Okay, RC was replication controller and RS was replica set. And we saw that why RC got depreciated, why RC is no longer much in use, and what advantages that RS provided us over RC, because of which that we prefer RS in place of RC. All right. So anybody has any doubt till now? Whatever we have discussed till yesterday? Any question, any problem from yesterday class? Any doubt? Okay, so everything is clear till yesterday? All right, that's great. Okay, I'm just connecting to my machines first. Okay team, so now we are going to proceed further. All right, yesterday we discussed about your controllers. We started about our controllers, and RS and RC were the controllers that we discussed yesterday, and we are going to move forward and discuss about your deployments. That what is deployment in a Kubernetes? All right, first thing first, deployment is simply an extension to your replica set. All right, RC was depreciated, the RS came into picture, and what is your deployment? Deployment is simply an extension to your replica set. What do I mean by that? Deployment is exactly similar to your replica set. In fact, whenever you create a deployment, a replica set is created at the backend by default. Okay, just like you understand that whenever you create a pod, a container is created at the backend, right? Just to make you understand, I am explaining you with this example. Whenever you create a pod is created. Yes, that is true, but at the backend, a container is also created. Similarly, whenever you create a deployment, a replica set is created at the backend automatically. Team, am I audible to all of you, right? I got a ping that I am not audible to someone. Please confirm if you can hear me. Alright, thank you. I got your responses. Needed. Alright. Alright. So, the thing is that deployment isn't simply an extension to your replica set. But why deployment came into picture and why replica set was not enough, we are going to understand about that. Alright. So team, consider that we have a situation in an organization. Alright. I hope this example was clear to you, so we can clean it up and have a different drawing. Alright. So this is your Kubernetes cluster. Alright. And what you have for say 3 replicas of your application. Okay, team, before explaining this to you, I want to ask you that how many of you actually knows about blue-green deployment? Asking generally, not in the same context. You don't have to know about Kubernetes. I'm simply asking what is a blue-green deployment? How many of you knows? Alright, some of you do and some of you don't. Alright, so no problem, I'm going to explain you from the scratch. Alright, in a general scenario, I'm talking, if you are going to do a blue-green deployment, if you generally want to do a blue-green deployment, what you do, you have a version 1 of your application. Okay, consider this is your version 1 of your application. In this you have 3 pods or 3 replicas. Okay, so your application is currently running on version 1. Alright, that is called your blue deployment. Now what you do, you create a exact replica with the latest version. Okay, you create the exact replica with the updated version. Currently my application is running on version 1. Now I have created a similar deployment of version 2 and I'm going to call it as a green deployment. Now simply what I'm going to do, if somebody is using my application, okay, someone is using my application and currently it is pointing to your blue deployment, that is currently your version 1. I'm simply going to change the pointing of my application to version 2. It means I'm going to have a negligible downtime. Currently my version 1 is also running, version 2 is also running. And as of now my client are using version 1. I'm simply going to change the routing. Okay, I'm just going to change the routing, like if I'm having route 53 entry or something like that. Simply I'm going to change the routing and I will now route all the traffic to version 2, which was already in place before. So both the versions are running at the same time, you simply change the pointing. That is your blue-green deployment. Generally speaking, not in the context of Kubernetes. In Kubernetes also, we do the same just like that. So I told you that it is exactly the same as a replica set, but deployment comes with some additional features or some additional functionality. All the features that replica set have, deployment also have, but deployment provide you some additional feature which is not present with replica set. For example, the thing we already have in agenda is rolling updates and rollback. This feature is not available with replica set, but it is present in your deployment. But what is that? Let's try to understand that. Consider I do have an application and I want zero downtime. Even if I do have a blue-green deployment setup where I'm simply going to change the pointing, still it is going to have a little bit of downtime at least. Okay, a little bit of downtime is going to be there for sure. Just for a fraction of a second even, but it is going to be there because it is going to shift from version 1 to version 2. But I don't want to have a downtime at all and I still want to update my application. How I'm going to do that? I still want to update my application, but I don't want to have a downtime at all. I want my application to be up and running all the time. In that scenario, what happens? Okay, let me remove it from here and let me write it here. It will be a better place to understand. Alright, in this scenario, what I'm going to do, if I do have a deployment in Kubernetes, so what will happen? I will replace one pod at a time. Okay, first of all, what I'll do, I will take my version 1 down and I will replace it with version 2. Okay, don't think that I am having all the pods at the same time as a blue-green deployment. Okay, in my cluster at a time, I have only 3 pods. Alright, so what I do, I will replace one pod at a time. I first replace my first pod, which is now version 2, and other 2 pods are still running at version 1. Alright, so what's going to happen? Some of the users might experience version 2. Most of the users are going to experience version 1. But my application is not going down. Version 2 is also there, version 1 is also there. Next, once it is working fine, once it is stable, I'm going to bring my pod 2 of the same version and remove my version 1 pod. One pod at a time, not replacing all of them, not creating multiple pods at the same time. I'm just replacing it one at a time. After that, once 2 pods are working fine, finally I'm going to bring down my last pod of version 1 and I will replace it with version 2 pod. Okay, so you can see what is happening here. I am replacing one pod at a time. It is called rolling updates. Okay, this is called rolling updates. It is not a blue-green deployment. It is not replacing all the pods at the same time, but one pod at a time. Similarly, if you talk about rollbacks, rollbacks also happen in a similar manner. If I want to roll back to the previous version, like the client started pointing out that I do have some bug, there is some problem in the application. Okay, what I'm going to do, I'm going to roll back. In that scenario, what I'm going to do, again I'm going to do it one at a time. First, I will take down my first pod and replace it with the previous version. Once it is working fine, I will bring my version 1 pod and I will bring my version 2 pod down, one pod at a time. Similarly, bring down version 2 last pod and replace it with the version 1 of the last pod. So this is called your rolling updates and rollbacks. This feature was not available with replica set, but this feature is available with deployment. So team, this is the concept of deployment. Let me know if you have any doubt, if you have any problem. We are going to do the lab on deployments, but before that I am going to touch base on the concept called services. Okay, to understand the deployment practically, it is important that you understand about service as well. So before doing the practical on deployment, we'll understand about services. But conceptually, let me know if you understand this or not. No doubts, very good. In only two situations, you don't get any doubts. Either you understand everything or you don't understand anything. Okay, alright team. So team, next concept I'm going to start is of services. Okay, and I'm telling you beforehand, it is a tricky concept. Okay, so I need your complete attention here. I will try to make you understand with ease. Okay, but services is a typical concept. Okay, it is not that easy at all. Okay, but still I'll try to make you understand, but I need your complete attention here as well. Okay, if you will miss anything, you will miss everything, I'm telling you. Just let me clean my environment. Okay, my bad. kubectl delete. Okay, so team, I have just created a Nginx pod right here. Okay, I have just created a Nginx pod. -o wide. Okay, I simply created a pod which is a Nginx pod. It is residing on node 1 and this is the IP of the pod. Okay, so team, if I want to access this pod from outside world, can I do that with this IP? I want to use my Nginx web page. Okay, if I do curl operation with this IP internally, I can see the page. Alright, you can see welcome to Nginx. It is visible to me. But if I want to have this access out to the outside world, okay, I am simply using creating my application for the outside world, definitely for the client. Alright, so they want to have access to this to the outside world as well. So can I use this pod IP for external uses? Can I? No, of course, right? Definitely not. So if I'm going to use this on the browser, it is not going to give me any response. This IP is provided to the pod by VBNet, the CNI that we use, and that is used for internal purposes only. if I want to have access to this container from the outside world, I need something else. Alright, I need something else. Consider this is your cluster. Okay, this is your cluster. Inside your cluster, you have a pod. Okay, team, I'm going to show you all the layers here right now. Okay, because your container is covered in this much layers. Alright, so this is your cluster. Inside your cluster, you have a pod, and inside your pod, you have a container. And here your Nginx is running. Alright, and the Nginx container is having this as a pod IP. Alright, and this is your pod IP. Now, if you want to access your Nginx pod from the outside world, you cannot use it directly. This IP is not going to work. For that purpose, we need something which is going to route our traffic to this internal IP. Alright, we need something that is going to route the traffic to this container inside, to this IP, internal IP. For that purpose, we use services in Kubernetes. This routing is achieved by using services. We need something, some object. It is an object of Kubernetes like pod, nodes. Similarly, services is also a object in Kubernetes which helps routing our traffic from outside world to your particular container. Alright, and how does it actually work? For that, you create a service type. Alright, first we are going to discuss about node port, and then we are going to understand about the another one. Okay, you create a service, and that service is first type is your node port. Node port provide you some kind of port number. Okay, it provides you some kind of port number for say 30,000. Okay, 30,000 is the port number. So what you have to do, you have to use the IP of your cluster machine. Okay, IP of any working machine, worker node. Alright, you are going to use the IP address of any of the worker node along with the port number, and then it is going to route your traffic to the node port, and then finally you will be able to access your pod. Okay, I'm going to show you this practically. Alright, just give me a minute please. Alright, so let's try to create a service from the command line first using imperative way. Alright, so command is pretty different here. Here we don't use kubectl create or kubectl run, alright, or apply something. We simply use kubectl expose. Okay, to create a service, this is the keyword you are going to use. So what I did, kubectl expose. We are going to expose our pod right now. Okay, as of now we have a pod, we are going to expose it. Then pod name. I hope this is the name of the pod. Yes, it is. Alright, and now I am going to name that service as well. Okay, Every object does to have a name. We created a pod and we named it as Shub. Alright. Now I'm going to create a service. I'm going to name a service as well. Shub SVC. This service I'm going to create. Alright. Now you have to give the port number. Nginx by default runs at port number 80. We all know that. Alright. I'm also going to give a target port. I will explain you later why I am giving port again and again. Again 80. And then I am going to give the type. Okay. What kind of service I am going to create? I am going to create a node port service. Alright. That's all. This is the command. You can see service shub svc exposed. Alright. So simply you can do kubectl get services. Okay. Or simply put, you can use svc. Services short name is svc. Alright. So now you can see shub svc is created. Type is node port. This is the IP of your service. Okay. So team, don't get confused. This is the IP of your service. This is not the IP of your node. This is not the IP of your pod. This is the IP of the service that you have created. Alright. And the port routing is from 80 port number to 30,851. Alright. So team, the thing is, the node port has a port range. Alright. Whenever you're going to create your node port service, it has the port range and it ranges from 30,000 to 32,766. Okay. Whenever you are going to create a node port service, it will range under this only. If you want to give your own port number, you have to give the port number within this range. If you don't do that, you are going to have the randomly generated number from this range only. Alright. So what I told you, if I want to access my application now, I am going to use this port number along with the IP of any of the worker node. For say, I am going to use one of my machine IP VM instances. Let me take the IP of node 1. Node 1 IP. I will place it here. I will place it again here on the diagram as well for your understanding. I'll give a colon and then I'm going to give the port number. What is my port number? 30851, and I'm going to use it like this: IP colon port number. Team, your application is now exposed to the open world. Now you can access it from the browser. Earlier you were not able to do that. Now your application is available to the open internet. Okay, so this is the main type of service which is required to expose your application to the outer world. The thing is, whenever you define type as node port, whenever you define the type as node port, Kubernetes understand that, okay, if you're defining node port, it means you want to expose your application to the outer world. Alright, hence you're able to access it from the open internet. And it is completely up to you. You can use any IP. You can use your master IP as well. You can use your worker node IP as well. All of them will work properly without any problem. If you want to, you can verify it as well. Now I have used my master IP along with the port number. Still, you can refresh it as many times as you want. You are going to see the same page. Alright. So what do you understand by this? Your services is a cluster level resource. Services are cluster level resource. What does it mean? That your service expands across your cluster. You can use your master IP, you can use your worker node 1 IP, you can use your worker node 2 IP. There is no problem with that. All the IPs will work because service is residing on every particular node once you have created a service. Alright, I have provided you the range of the node port IP. Now I am going to explain you the flow, how it actually goes. Okay, is it going to expand or not? Alright, it doesn't expand. I was just trying to make it a little fat. Okay, no problem. So you can see your node port service also gets an IP address. Okay, what is the purpose of this IP address? We are going to see that. Alright, now you can see I have written all the IPs here practically so that you can connect better. Alright, to understand it better, let's try to describe your node port service. kubectl describe SVC shub SVC. Okay, we can describe anything and hence we are explaining it again. Alright, so team, what you can see here, let's see about the description. This is the namespace, default namespace, labels. Alright, it has some label called run equals to shub. Selector is also run equals to shub. Type is node port. Alright, so team, you can see a selector field here as well. This selector field is coming from where? kubectl get pods, kubectl describe pod and shub. Alright, so you can see there is a selector field as well, and this selector field is picked by the command that we provided earlier, and it came from your definition of pod. Okay, you can see the definition of pod, there is also a label called run equals to shub, so it picked that only. Alright, and based on that label, it picked the endpoint. What is your endpoint? Endpoint is the IP of your pod. Okay, you can see 1044.01. Endpoint is 1044.01. Okay, the command we used selected all the pods which are running with the same selector field that you have defined. Okay, we defined the pod name, we expose the pod with pod name. Okay, it does not understand anything with the pod name. What it do, if you have given a pod name, it will check the label on that pod, it will make that as a selector field, and if any pod is running inside your cluster with the same label, it is going to have the endpoints of that only. Okay, I'm going to show you that with another example. Okay, as of now you can understand it divert the traffic based on your selector field. Alright, and this is your endpoint. Endpoint means ultimately this is going to be your final destination of the complete routing. This is the IP of your service. So what happened? Once you have defined anything, you have a master IP or a worker node IP. Alright, you are going to use the node port. Once you use that node port understand, okay, I am going to divert this traffic to this particular IP. This is your service IP. Alright, you use the IP, use any IP of your worker node or master node, you use a port number along with that. Once you use that port number, that node port number divert your traffic to the service IP. once you use this port number, it is going to divert the traffic to this IP. Okay, and this IP have some endpoints. What are the endpoints? Your pod number, and then it is going to divert the traffic finally to your pod, and that is how we are able to see your Nginx page right here. Okay, so to use a pod, an application outside your cluster, you have to use a service called node port. Okay, so team, this is the complete flow. I understand that was a little typical, but this is a tough topic. I try to make you understand with the drawings as with the best possible ease. Let me know if you do understand this or not. Okay, as of now, I have shown you example with a single pod. I am going to show you the same with a different example as well, where I'm going to have multiple replicas. Okay, but still, if you understand this, this was the most basic example I could have taken. Let me know if you have any doubt or it is clear to you. Feni, there is no concept like firewall here right now. Alright, firewall was, I just gave an idea yesterday because somebody was having issues. Firewall doesn't apply here. Alright, we are talking about services. Services are used to expose your internal application to the outside world, and the service which exposed your application from internal to external is called your node port service. Okay, let me know if you have any doubts. Sumit, what if I have same two labels with two different endpoints? How to pick one on the node port, since we are assigning service over name as match label? Do we have any provision of picking respective endpoints among both? No, Sumit, you don't have the provision to pick the specific endpoint. Endpoints are always chosen based on your selector field. Okay, based on your selector field, based on your labels, your endpoints are selected. If you want to choose the endpoints everything manually, then what is the use of automation? Okay, you want to automate things, you don't want to create it more manually. If you want to do it manually with the endpoints, simply it is a overhead, and we are moving towards automation, and that is the use of labels here. Another use case of labels, why we use labels, because we want to automate the exposing of services. We don't want to do it manually. Alright, so this is the importance of label. That is why you choose your labels very carefully. Gaurav, what is the role of port and target port? What happens, what will be the flow in case of multiple pod container? Okay, Gaurav, the first point is your port. Alright, so you know that you have a pod and you have a container. Alright, and you also know that your container also has some IP. Okay, and your pod has some also have some IP. Okay, so the port number you are using, is for your pod. Okay, but you know that your application is running inside a container, and the container also have some port number. Your application is also running on a port number inside your container. So internally also you have two different ports. Understood? So the endpoint that you are giving, okay, you saw that I gave the endpoint as target port 80 and port number 80. This port number 80 I am giving for your pod. That is why you can see the endpoint as the pod IP and the port number. This is about this. But still inside your pod you have a container which is with a different IP, with a different target port. It is possible it can have a different target port. So you give the target port here as well, that at what port number your application is running inside the container. For the sake of simplicity, we keep it as same. Alright? Not to confuse anybody, it is a normal practice that we use target port and port number same. But target port is the port number inside your container, and the port is of your pod. Alright, and yes, you can have a multi-container pod as well. Okay, you asked about the flow in multi-container pod. If you understand it properly, when I explained you multi-container pod also serves with one container only. Even if you have 2 containers or 3 containers, only one pod is going to be there which is going to serve for your application. So routing will be done to that particular container as well. In multi-container pod, you understand there is a sidecar container where some site container pass on some details to the main container. There is an ambassador which is helping to route the traffic. Your first container will not be accessible to open world. Your second container is going to divert the traffic. So all in all, whenever you use multi-container pod as well, traffic will be routed to one container only. What about multi-port container? Okay, Akhil, you are asking about multi-port container pod. Okay, you can have a multiple port, but still your application will be running on one port only. Even if you're using your application without the concept of Kubernetes or services or anything like that, whenever you use a Nginx container, simply put, you use a port number with it. All right. So if your application is running on different port, you have to create a different service to expose that different port number. All right. So if your application have multiple port and having different services at different port, you have to create different services. What do you mean by a service is a cluster level resource? Can you explain that one again? And Eureka guest. Okay. So you're asking why I said the service is a cluster level IP resource. Sorry, because whenever you're using the IP of the machine, I told you you can use the IP of any machine. You can use the master IP machine. You can use your node 1 IP. You can use your node 2 IP. It means your service is residing with all the IPs. All right. You can use any IP. So you can use the IP of any machine inside your cluster. If your cluster contains 10 machines, 20 machines, you can use the IP of any machine. What does it explain to you? That you can use any node's machine, so it will be accessible from everywhere. It will divert the traffic to anywhere. You're using your worker node 1 IP, but your pod is running on node 2. So how it is going to access? It doesn't matter because your service reside on all the machines. Okay, it can divert the traffic from anywhere. That is why it is called your service is your cluster level resource. It means simply it cannot be namespace. You can say in simple words. Okay, I told you there are 2 types of resources. One can be namespace, one cannot be. And this objects which cannot be namespace are called your cluster level resource. So your services are also a cluster level resource. Rahul, could you please also explain how I connect to a service from container to outside world database? Rahul, I am not able to understand your question. Okay, you want to have a connection between a database pod from outside world. Okay, I'll come back to that one. Okay, that is a different type of service called cluster IP. Once we understand about node port, then I'll come to cluster IP service, and then I will answer your question. Okay, that is my next part. What is the target port mentioned in the command? Is that the port pod port? Satish, I think I already answered that. I'm going questions one by one. Can I access this port via cluster IP instead of node or a master machine? Prempal, if you want to access it from the outside world, you cannot use cluster IP. Okay, you cannot use the cluster IP anywhere. Cluster IP is also an internal component. It is not an external component. Only the node port, the port number is the external component. What is the target, Joydeep? I think I answered that as well. I guess HTTPS for the service will be a different topic. Anil, that will be a part of security. Okay. We'll talk about certificates as well. Is there any way we can specify the node port manually? Yes, Akhil, I have given it from the command line. If you want to do, you can give it with the manifest file as well. Okay, the YAML files. There you can define your port number manually. Still, if you want to see, I can show you right away. Okay. So you're asking, can I use my port number manually at my own? Definitely you can do that. And for that, what you are going to do, kubectl get svc. Alright, if you're going to define it from the manifest file, simply you can do that, or you know how to do it, kubectl edit command, right? All of you are aware of it. Kubectl edit svc, shub svc. Alright, here you can see there is a node port component. Alright, you want to modify it, do it, 32000. Okay, I am modifying it. Okay, your service is edited. Now you can see the traffic is going to be routed from 32,000 port number. Alright. Now if I'm going to refresh it, it is going to fail because this port number is no longer in operation. I have to modify it. See, now it is working on 32,000 port number. So if you want to modify, if you want to have your own port number, you can do it with the declarative syntax. Sumit, yes, I am going to explain you the scenario where there are same labels inside a cluster. Okay, I'll show you the same thing with your node port service so that you can understand it better. Then if I use one port number for one port, it can be used for another port. No, Rahul, you have to use a different port number. Try to understand that if you are talking about the port and target port, that can be same for different port. Okay, consider I am having two different port to serve for two different services and they both are running on port number 80. Then that is okay. Alright, then that is okay. Your application 1 is running on one port A. Your application 2 is running on port B. Both are serving at the port number 80. So both the ports are running at port number 80. Both the container are running at port number 80. That is their internal setup. Now you are going to create two services. First service will be created for application A and second service will be created for your application B. Now both the service will have some different port number, node port. Okay, your first service is going to have some node port of 31,000 and your second node port service is going to have a port number of 32,000. So the routing will be done based on the labels now. Alright, definitely your endpoint will have the port number as 80 because both the applications are running on port number 80, but your node port is going to be different. Alright, how can we predefine our node port? I think I answered that also, Gaurav. Alright, how to modify the port number. Pod and container is having the same IP. Sanjay, no, that is not for sure because Kubernetes doesn't understand any of your container IP. Okay, but it does know that there is a container running and some application is responding at this particular port number. Alright. When I run kubectl API resources, it shows me a service is namespace equals to 2. Yes, Adurika, guess you can have a namespace, you can create a service inside the namespace, that is all okay, but it spans across your cluster. I said it is a cluster level resource because it spans across your cluster. You can use any cluster machine IP. Alright. Okay, still some people are getting confused with your port and target port. Okay, some of you are getting confused with the port and target port. Let me try to explain you with a layman example, okay, as I always do. All right, consider you live in a society. All right, consider you live in a society. All right, now somebody wants to come to your house. Somebody wants to come to your house. So that person is asking for the guidance. He's asking that how should I come? What should be the route? How should I reach to your place? All right. So what you are going to do? First of all, you are going to tell that person that you have to come thus to the society. Okay. And at that society, there is going to be a gate number 80. Okay. First, you come to my society, and my society don't come from any gate number. There are multiple gates. Okay, there are 4 gates, but don't come from any gate. You enter from the gate number 80 into my society. All right. Once you have entered into my society, okay, once you have entered into my society, my flat number is also 80. Okay. So how you are going to reach to my place? First, you have to come to my society. In my society, you have to enter from gate number 80. And once you have entered my society, my flat number is also 80. Okay. So this is how you are going to reach me. So the society gate number you are describing, the society gate number you are describing is called your port. And your flat number, your absolute address is your target port. Okay. Your flat number is your absolute target port number. So I hope with this example, port and target port is clear to you. Gaurav, I haven't tried that actually. Okay. So I'll suggest try at your own. Gaurav is asking if I can have same node port under 2 different namespaces. Okay. Give it a try at your own. Honestly, I haven't tried that. Okay. So team, conceptually, is it clear to you? Okay. It is a big topic. It is a little typical. Is node port clear to all of you? I'm going to take another example of node port, but till now, if it is clear to you, then I'm going to move forward. Alright, so now we have seen how it works with a single pod. Sorry. Now let's see how it works with a multiple pod. Okay, I'm going to take an example of your replica set. Okay, we understand about the replica set now. Let's take the second example. Okay, so team, I have shown you how you are going to work with a single container and a single endpoint. Now we are going to see how we are going to deal with the replica set. This is the definition of your replica set. Okay, sampler is going to be the name of your replica set, RS. Okay, your labels are going to be, I'm defining the labels as well. Okay, app equals to sample app, tier equals to front end. This is the labels I'm defining at the replica set label. So what is going to happen? Okay, this label is going to stay with your replica set, not with your pods. Okay, I'm defining the labels at the replica set label. Now, how much replicas I want? I want 3 replicas. What is the selector field? Now I am defining the selector field. All the pods which have the label front end equals to tier equals to front end will be a part of this replica set. Okay, I'm giving the same label on your replica set as well, and I'm giving the same label as a selector for my pods. If any pod is running with a tier called front end, that will be a part of this replica set. Metadata is the definition of your pod. Alright, container, I'm using a private image here. Alright, sample app2. Name of the container is going to be test, and the port number where this container is running is your 3000. So as per the drawing, this 880 is going to be 3000 this time. Okay, the absolute target port. Alright, so I have created a replica set with this definition. I am creating a service in the declarative syntax as well. Okay, I have shown you how to create a service from command line. Now I am telling you how to create a service from YAML. API version v1 kind equals to service. This is the name of your service. Alright, sample SVC is going to be name. Labels, I am calling app equals to front end. Alright, specs, under specs I am defining type. Type is going to be my node port. Okay, I am defining port as port number 80. Alright, so as I told you, for the sake of simplicity, what I am doing, I am keeping your pod port number as same. Okay, for the sake of simplicity only. Alright, protocol is equals to TCP you can give. Now selector field. So I am defining this service should expose all the pods, all the objects with the label called front end tier. Alright, I am going to take the raw format and create both the objects in a single go. kubectl create -f. Okay, you can see your replica set is also created. You can see your service is also created. Okay, to see all the objects you have a simpler command, kubectl get all. Okay, you do kubectl get all, everything from the particular namespace will be visible to you. And let me do it O wide also. Alright, so team, let's try to understand about this now. Alright, first of all, I created a replica set. In replica set, I have 3 replicas. Alright, you can see selector field as well here. Now you can see 3 pods are created. Okay, one is running on node 1, 2 are running on node 2. Alright, and I created a sample SVC service also. Type is node port, and it has a port number this. Alright, now let me explain you this with a diagram again. Alright, consider this is your cluster. Okay, this is your cluster. This is your master machine. This is your K node 1. This is your K node 2. Okay. Now, in between you have your service. Okay, and as I told you, your service expand across your cluster. Okay, it is connected with all the nodes. Okay, so if you give your master IP, if you give your K node 1 IP, if you give the IP of K node 2, all will work. Alright, so with the IP of your master IP, you give the node port. Alright, it will divert the traffic to your service. Okay, what is your service IP? This is your service IP. Alright, now if I'm going to explain this service, kubectl describe SVC, sample SVC. Okay, now you can see when I have a selector field, it will pick all the endpoints. Okay, you can see 1036, 01, 02 and the old one as well. Okay, 1036.02, 1036.01 and 1044.02. It have the endpoints of all the pods, all the replicas of this replica set. Alright, it has the endpoint. So you can see you have 3 pods here. Okay, so team, this is the complete diagram for your understanding. You can use your master IP, you can use your node port IP or node IP. Alright, along with the node port, it is going to divert the traffic to your service IP. Alright, this is going to be your service IP, and that service IP is going to do the load balancing across these containers. Alright, to show you that, let me have it here. Okay, I do have already the IP of one of my machine. Alright, let me have the port number. What is the port number of your service? It is 31205. Okay, so team, why I took my own image? Because I wanted to show you this. Okay, first of all, you can see the container ID is 6HH6G2. Okay, first of all, my traffic is going to my first pod. If I keep on refreshing it, you can see the ID is getting changed, MLK94. Now my traffic is going to the third pod. Okay, I'll keep on refreshing it. Okay, now again it went to 6HS62. Now it went to first one. Okay, so it is doing the load balancing now. Okay, first it is going to send the traffic to pod 1, then it is going to send the traffic to pod 2, then it is going to send the traffic to pod 3. Okay, so for load balancing also it is helpful. If you have multiple pods, it is going to do the load balancing itself. Service is going to do the load balancing. Alright, you can refresh it as many times as you want. HP, MLK. Alright, every time you are going to see a different output because your request is getting served by a different pod every time whenever you do the refresh. It is doing the load balancing as well depending on the endpoint of your service. Alright, so team, now here I am going to conclude the topic of node port. Alright, we spent a good time on this. This was a confusing topic, I do understand. Alright, let me know if it is clear to you or if you have any doubt. Okay, don't hesitate. If you don't understand anything, let me know. I am going to explain all of that all over again, but it is an important topic. You should understand this. Let me know if you have any question. If not, I am going to move to the second type, that is cluster IP. Prempal, you're saying when we have created service, it is behaving like a cluster as showing service IP under cluster IP. It seems the service act like a cluster. Okay, Prempal, if you're talking about this cluster IP, this is the naming convention that Kubernetes has done. Okay, I know it is a little confusing because you have another type of service also called cluster IP. And in this table, they have also set it as a cluster IP. So ignore for it. You can understand that this cluster IP is your service IP only. Okay, we are talking about this service IP. Joydeep, can you show which external IP to access for node port? Joydeep, I told you you can use the external IP of any of the worker node. As of now, you can see I am using 34.123.96.211. All right, and this machine, this IP is of my master. All right, 34.123.96.221. I can use the IP of any of the external machine. I can use of master, I can use of worker node 1, worker node 2. Any external IP will work along with the node port. Prempal, and do the load balancing among the nodes. Prempal, if you want to do the load balancing among the nodes, you have to do it from the GCP, okay? Because your nodes are managed by your GCP. If your node goes down, Kubernetes is not going to manage it. Okay, if pod goes down, Kubernetes will manage, but if node goes down, Kubernetes is not going to manage. You have to manage it from the GCP. Okay, so actually, to be honest, there is a provision. You can get confused that which IP should I use? Should I use the master IP? Should I use the node 1 IP? Should I use the node 2 IP? Consider if your node 2 goes down, your service is still available, but your node 2 is gone. How your node 2 IP is going to respond? Definitely, that is a good question. For that purpose, we use a load balancer. We create a load balancer, okay, on GCP. On GCP, we are going to create a load balancer, and that is also a part of Kubernetes as well. When we use CKA, if we use managed service, we can create a third type of service as well called load balancer. Okay, then we are going to give the IP of load balancer. Okay, we are going to give the IP of the load balancer and the port number. Then it is going to divert the traffic to any of the nodes. All the nodes will divert the traffic to your service IP, and then service IP will divert the traffic to your pods. I know it is a big thing, okay? So we'll take one thing at a time, all right? So first we are going to understand about node port, then we'll discuss about different type of services. Can we change the pod IP from 300 to something else in this example? Okay, Gaurav, there is no pod IP of 3000. IP doesn't stand in 3000. If you're talking about the port number, node port, you can definitely edit as I told you. Alright, in this definition, you can simply modify this port number. Okay, whatever the port you want, but I created the application, right? This is my personal image, and I know this personal image is responding to port number 3000. Alright, as we all know that Nginx listens as port number 80. I know this application is running on port number 3000. Okay, so you cannot change this at the container level, but if you want to change it at this level, you can do that. Fanny, you are asking, please explain on how container port and target port is different. Fanny, I explained that already with this example. Okay, I told you this is my target port, this is my port. All right, the port number that my container responds to is my target port, and the port number that my pod responds to is my port number. I explained you with an example if you heard me. Okay, consider if somebody wants to come to your house, what you're going to do? You're going to tell him that enter in the society from gate number 3000. Okay, and once you have entered the society, you are going to come to my flat, and my flat number is also 3000. Okay, so the target port is the absolute endpoint. Okay, where your application is actually responding inside the container, that is your target port. And if you talk about port, that is your pod address or your society address. Why we gave container port in YAML instead of target port, as they are same? Arjun, if you have if the port numbers are same, okay, if your port and target port both are same, in YAML you don't have to give both if they are same. If they are different, you have to specify specifically. If both are responding to the same port number, you can ignore target port in your YAML. Sarath, you can see my GitHub repository, you might see an example, but it is not a good practice to have a different target port and port number. Okay, we never follow it anywhere. Whether it is your examination, you can do that, but it is never suggested. Whether it is for your examination point of view or for your real life example, for your industry experience, it is never suggested to use a different target port and port number. If you can, you can, but it is not a good practice. That is why you won't see any example in my repo as well for this one. Okay, are you talking about this container port, Fanny? Okay, if you're talking about this container port, this is your absolute address as I told you. Alright, this is the port number of your container, because I know my application is running on this port. Okay, so whenever you define it in the YAML, you tell that your application is running on this port number. This is a part of replica set. This is not a part of your service. Whenever you create a container, you always tell that your container is running at this port number. So this is a part of replica set. If you're going to create a pod elsewhere or for your application, you tell that your application is running at this port number. Node port details can be specified in the YAML file. Akhil, I already created the node port service with the YAML itself. You can see that. Right? This time I created the node port with the YAML format. Gaurav, please correct me if I'm wrong. We define pod port while creating a service, right? Or it gets defined while creating pod. Gaurav, you define that at the port number when you create the node port, because you define the node port to which port it should go to the pod. Okay, a node port, whenever you create the pod takes up the default port number of the container. Okay, by default you can modify it manually if you want, but whenever you create a pod, it takes the same port number of your container as well. And when you expose your pod, you have to define which port number you are going to expose. So that is why you define that in the service request. Finny, if you want to change the container port, you have to modify your image. Okay, because when you were creating your image, then you define your port number. Akhil, 31215 port is node port is not mentioned. It is mentioned, Akhil. Okay, you can see this sample SVC. You can see it is running at port number 31205. Your application is running at 3000, but your service is exposed as port number 31205. Any other question? Any other doubt with the service? Team, if you do understand the node port, a quick yes from all of you. Akhil, yes, 31215 is not mentioned in your YAML, but if you want to define it manually, you can do that. Okay, because I ask Kubernetes to randomly define which node port it wants to give. But if I want to give it manually, I can give that also. And where does it decide? If you have understand all the concept which I have taught you so far, you can understand where I am going to define my node port number. If you want to do it manually, kubectl, edit, SVC, sample SVC. Okay. Under specification, you can give your cluster IP also if you want. Otherwise, it is a job of your VNet, so you don't do that. Under specification, you will give a ports. Under ports, you will give hyphen and node port as whatever the port number you want. So if you want to define it manually, you can define that also manually by defining it into your YAML. Okay, you can see there are ports, right? Here are ports. In the YAML also, under specs you have ports. Alright, under specs you have ports, and I have defined the port number for my application. If I want to give target port as well, I am going to define here. If you want to give the node port or as well of your choice, you can give that also. You can see I have commented it out. Okay, if you want to give, you uncomment this and give your own value if you want. Joydeep, you want me to give the expose command. Okay, Joydeep, let me share. Alright, otherwise everything is there on the Git repo. Still, if you people want me to give the expose command, let me give you. Joydeep, I have shared the command on the chat box to the entire audience. Okay, you can pick it from there. What if I don't want to use the pod port same as container pod? What change do I need to do? Gaurav, for that purpose, this is the command that I have showed you recently. Alright, to expose your pod. Your target port is the port that your container is running on. Alright, if you want to change the port number of your service, you give it 800 here. Okay, the one you want, you can modify it from here. Yes, Fanny, you can use my own image. Okay, that is not a problem. That is an open source image. So if you want, you can use my image. You can pick the complete YAML right from here. You don't have to make any changes. It will be accessible to you as well. Alright, so team, this is the topic that we have just covered about your node port service. Alright, second type of service I'm going to explain you. Second service is called your cluster IP. Services. Okay, so there are two type of services. First is your node port. Second is your cluster IP. Okay, we have these type of service. We have a third type of service also called load balancer, but we are going to discuss about that later, because your raw Kubernetes doesn't allow this. If you are using cloud managed Kubernetes, whether it is your GKE or EKS whatsoever, then only you can use this. Otherwise, it is not supported. So we have discussed about node port. Now we are going to discuss about your cluster IP. Can we define the port through command and through YAML file? Is that correct? Yes, Saurav, you can define it from both the places. You want to define it from the YAML, you can do that. If you want to define it from the command line, you can do that. Okay, so team, the basic difference between node port and cluster IP is that whenever you create the node port, it exposes your application to the outside world. But whenever you create the cluster IP, your application is not exposed to the outer world. Okay, I'm going to show you this practically. Okay, by default, if you don't give any type, by default, if you do not give any type, you will have a cluster IP type of service. Okay, I'm going to create it right away. kubectl svc.yaml. Sorry, my bad. svc.yaml. Alright, so team, what I have done, I'm going to create the service again. I'm going to change the name of the service. Okay, sample svc cluster. Okay, this time I'm going to create the cluster IP. Alright, and if you want to create your cluster IP service, you don't give the type. If you want, you can give the type. If you don't define any type, it will take the default value, and the default value is your cluster IP. Alright, let me create this service now without mentioning any type. I have just commented out the type. kubectl create -f svc. Okay, the naming convention is not valid. Let me modify the name. Sample svc2 I'm giving. Okay, now you can see your service is created. kubectl get svc. Alright, so team, now you can see sample svc2 is created. That is your cluster IP type. Okay, and sample svc is of type node port. Alright, I'm going to have it as describe, and you guys will tell me that what is the difference between these two. Okay, so team, I have defined both. I have described both sample svc and your sample svc2. You guys tell me what is the difference. So team, don't give me answers like that type is node port and type is cluster IP. Okay, don't give me this description. Tell me what else is different. Don't give me type, okay? Alright. Absolutely correct. Okay. So team, all of you are giving right answers. Alright. I'm not going to take the names right now. Okay. Because all of you are giving the right answers. First thing first, that you don't have a node port. Okay. If you don't have a node port, how your application is going to be exposed to the outer world? Okay, so whenever there is a node port, your application is exposed to the outer world. But at your cluster IP service, you don't have the node port. It is completely missing. Alright, so it means your application is not exposed to the external world. Okay, here you can see external traffic policy is cluster. It means you can use any IP of the cluster machines. Okay, it means external traffic policy. That is also not available here. So we understood that node port service exposes your application to the outer world, but your cluster IP doesn't do that. Your cluster IP doesn't do that. So what is the purpose of this? What is the purpose of having a cluster IP if it doesn't expose your application to the outer world? It doesn't make any sense, right? So why do we create it? Okay, Fanny, Akhil, you are right. Arjun, you are also correct. Edureka guest, you are also correct. I cannot see your name. Kapil, absolutely correct. Mosomi, yes. Girish, here to some extent, not exactly. Okay, Joydeep, yes. Okay, so team, I'll explain you directly by the use case. Okay, forget these are the nodes. Okay, consider these are your application pods. Okay, these are your application pods. In the same cluster, you are running your application replicas as well, and in the same cluster, you are running your database pods as well. Okay, so what you need to do, your application should access your database pods internally inside. You have a replica set for your application and you have a replica set for your database pods as well. So what happens, you need the communication to happen inside your cluster only. Okay, the communication between your application pod and database pod is internal. You don't have to expose that. So if you want to expose your database pods to your application pods, you use a cluster IP. Okay, you use your cluster IP. So what will you do? You create a cluster IP so that the communication will happen internally. Your database pods will be exposed to your application pods only. So this is the only difference. Cluster IP is used for internal communication and your node port is used for the external communication. So if you can see here, kubectl get svc. Okay, these three services I created, right? These three services I created, but Kubernetes cluster IP service is also created automatically when I created the cluster, when I bootstrap a cluster, because this is the cluster IP that helps with all the communication inside the cluster. I told you that whether your pod is running on node 1 and another pod is running on node 3, it doesn't matter because internal communication can happen. How that internal communication can happen? With the help of this cluster IP. Okay, that is why we create cluster IP service. All right, so team, if all of this is clear to you, I'm going to delete everything. Let me know if you have any doubts, if you have any question with your node port or cluster IP services. Let me know. I'm going to delete all of them. Rahul, if your database is running outside, if you're using some RDS services or managed database services, all right, in that case, you have to expose your application via node port. Okay, and multiple security constants is also going to be there. So that is a part of security. But if you want to expose anything from outside the cluster, whether it is on the browser, whether you want to expose your pods to an external database, you have to use node port then. Okay. Rahul, I'm audible to all of them. What I said is, if your database is outside to your cluster, then you have to expose your application pods via node port service. Okay, if it is inside the cluster, cluster IP. If it is outside the cluster, then node port. Anil, if you want, you are saying that application to database connection is made through connection strings. So we use cluster IP. So Anil, that is a advanced topic. If you want to connect from one pod to another pod, and that is a database pod, so you have to use a connection string. You are absolutely correct. So what you have to do, you have to pass on some config maps and some secrets to that pod, and then connect it from there. Okay, so for that purpose you should understand about config maps, you should understand about secrets. That is the topic we are going to cover further. But how those pods will be exposed, that we have covered so far. All right, so team, I hope all of it is clear to you. All right, so I know it was a lot to take, so what I'll suggest you, take a break, digest all of it. Okay, take a break, digest all of it, come back after 15 minutes, and after that we are going to move further, and then we are going to see the deployment practical lab. All right, so team, shall I break? All right, so team, come back after 15 minutes. We are going to see the lab on deployment now. See you. I'm back. Team, do confirm if all of you are also back. Only 10 to 12 responses I can see. The strength is around 50 responses from all of you. All right. So team, now once you have understand the concept of your services, now I will take you back to the deployment. All right. Now I'm going to take you back to the deployment. So you do understand the concept of deployment conceptually. All right. First, on a very basic note, I'm going to create a deployment from the command line. Okay. Just for the basic understanding. All right. Syntax is pretty much clear. All right. kubectl create deployment. All right. And then you give the name of the deployment. For example, I'm saying shub dep. All right. And then I have to give the image as usual. Okay, simplest way, I'm creating a deployment. Your deployment is created. kubectl get all. Okay, so team, now you can see a deployment is created as shubdep. All right, this is the name of your deployment. I just created it from the command line. It is giving one by one. Okay, I didn't give how much replicas I want. So if you don't give any replicas, it creates one replica by default. And with that, you can see a replica set is also created. As I told you in the beginning, whenever you create a deployment, a replica set is created at the backend. And whenever a replica set is created, a pod is also created. And you can see one by one the pod is there. Alright. So what you can understand, you can see the naming convention. This is the name of your deployment. Your replica set first has the name of deployment and then alphanumeric string for your replica set. Now see the naming convention of your pod. Your pod naming convention is deployment name hyphen replica set name hyphen alphanumeric string for your pod. Alright. Now consider you want to upscale it. So as I told you, all the functionality from replica set is present in your deployment. First we are going to see that. Alright. We are going to scale it. kubectl command is scale. Okay, kubectl scale deployment. You can give deployment or you can use deploy keyword as well. Deploy is a short keyword for your deployment. Alright, you can use both. Name shubdep. Alright, hyphen replicas. You have to give the replicas like this. Alright, I want 3 replicas. kubectl scale deploy deployment name hyphen replicas. Alright, your deployment has been scaled. kubectl get all. Alright, deployment 3/3 replica set, desired 3, currents 3 and radius also 3, and now you can see 3 pods running. Alright, naming convention is still the same. First your deployment name, then your replica set name, and then alphanumeric string for your pods. Alright. Clear to all of you? generating all in a single go. Now let's take some advanced example from the Git repo. Okay, I have some examples here. Deployment example 1. The DevOps, I want to use a specific image. Let's see, where is it? Alright, so team, this is how you can create your deployment manually from the command line. And if you want to create a deployment from YAML, this is how you are going to do it. Okay, I'm not going to create it right away. You understand the concept. Alright, your API version, your kind is deployment. Metadata in metadata you have to give the name of your metadata. You give labels to your deployment as well. Specs, you say 3 replicas, and also it does have the functionality of replica set. So if any pod is running with this label, will be selected by the selector and will be brought under your deployment. And under template, you give the complete definition of your pod. This is the name of your pod. Sorry, this is the label to your pod, and this is the specification for your container. All right. No these replicas means the total count. It is not plus or minus. You give the total number exactly. Okay. So consider if you want to downscale, how you're going to downscale it. If every time the replicas number you give is plus, then how you're going to downscale? Right. So if I want to downscale, I am going to scale it to 1, so that it is going to have only 1 replica. It is going to have only 1 pod. Okay. So team, now when the concept is clear to you, okay, now we are going to see how you can perform rolling updates and rollbacks. Okay, the main functionality that I told you that deployment have, we are going to see an example for that one. That is going to require quite of a lab. All right, let me take the example for this. Deployment example 3 is for your rolling updates. Okay, first we are going to understand about the concepts what are mentioned here, then we are going to see a lab on this. API version deployment, kubeserve is the name of your deployment. That is all clear to you. All right, under specs I am giving 5 replicas. It means I want 5 replicas running all the time. All right, next is minimum ready second. It means once your pod is created, it is going to wait for 10 seconds to make it live. All right, what strategy I want to type? I want to do the rolling update. Okay, replacing 1 pod at a time is called rolling update. Now, under the definition of rolling updates, you give 2 main definition: maximum unavailable and maximum surge. What is it? Okay, let's try to understand that. So team, whenever the replacement take place, okay, replacement can take place in 2 ways, right? First way is that first your old pod will come down and second pod will take place. Okay, so team, the thing is, when I am doing this replacement, at some point of time inside your replica set, you have only 2 pods. While I am replacing the first one, there is going to be some time when there will be only 2 pods. Even for a fraction of second, there will be a moment then there are only 2 pods when I am replacing it. All right, so at that time what I can say, I can give maximum unavailable. Okay, this is maximum unavailable. It means there is a possibility that I am asking for 5 replicas, but during the replacement there can be a time that there will be only 4 pods. Okay, there will be a situation then there will be 1 number less than the total number. So what I am defining for that, I can say that maximum can be 1 available. If I am asking for 3, there can be a time during the update then there will be only 2 pods, -1. Alright, that is maximum unavailable. So if I'm doing the replacement, one pod will come down and another pod will take place. During the meantime, there will be a gap. So that is your maximum unavailable. So there is one, this is the one way of replacement. What is the second way of replacement? Second way of replacement is I won't take it down. First, I will make another one available. Then I will bring down the first one. Okay. So what is happening in this scenario? In this scenario, there is a situation, there is a time where there are 4 pods running at a time. There will be a fraction of second that there will be 4 pods. There will be all 3 pods of version 1. There will be a version 2 pod as well. Okay, for the fraction of time when I am placing it and taking it down. So this is called maximum surge. It means it can allow maximum number of 1 plus maximum surge. It can allow one more pod inside the deployment for a fraction of second. That is, I am allowing. Okay, so this is about maximum unavailable and maximum surge. Alright, other definitions are same to you. Selector field, match labels, template is the template of your deployment. Alright, sorry, pods. And then I am creating a service as well. Okay, I am creating a service also. Node port service, I am exposing my application with port number 80, target port number 80. Okay, so as I told you earlier, if you don't want to give target port, you can skip it. If it is same with your port and target port. If you want to specify, you can specify them as well. Okay, so now what I'm going to do, I am going to create this deployment and this service. I'll take the raw format. kubectl create -f kubectl get all. Alright, so team, you can see our deployment is created. As of now, pods are not available, so it is showing you 0. In replica side, it is also showing 0 because your containers are getting created. Alright, this is a little heavy image, that is why it is taking some time. Let's wait for it. Alright, so team, you can see all the pods are running. Alright, all the 5 pods are running. You have a kubeserve service. This is the node port IP. Okay, so if you want to use this, actually I told you this is the IP which is never used for the external world. Okay, you use a machine IP with a port number. But if you want to check it on the local, you can curl this IP as well. Okay, because this is an internal IP, it can work internally. Okay, it will give you the response. Alright, and you can see that it is also doing the load balancing. This is V1 from pod D7. It is from VT. It is again from VT. So it is doing the load balancing. Okay, it is always going to this one. Although, no worries. Okay, so it does our load balancing. Now, we want to see the functionality that if we want to update our application, how it is going to work. Alright, so I'm going to have some sessions. This one. And I'm going to say here sudo su-. This is my node 1. And I have a node 2 as well. Let me have this one also. Let's have them side by side. So team, I'm going to show you something very interesting now. Alright, so keep an eye here. First, I'm going to do the curl operation in a repeated cycle on node 1. Alright, so what I'm going to do, I'm going to create a loop here while true, okay, colon, do curl. I'm going to curl the IP of the service. Alright, and I'm going to ask it to sleep for 2 seconds. Okay, do the call operation, then wait for 2 seconds. Alright, then give me a space or give me an enter. Alright, and then this loop should be over. Okay, so it is going to do the curl operation on this cluster IP, this service IP for repetitively, and it is going to wait for 2 seconds after doing it again and again. Okay, so you are getting the responses. This is V1 pod from kubeserve, and it is always going to different pods. Okay, now the requirement I told you, I want to have this pod versions updated. Okay, I want to replace the image for say. Okay, this is the update you are going to do on your application. You are going to update the version. All right, so I am going to change the image of my pod. All right, for that purpose, what I'm going to do, kubectl set command. Okay, if you want to modify the image, you use set command. Set image on your deployment. Okay, what is the name of your service? Service name is kube service. Sorry, what is the name of your deployment? Your deployment name is kubeserve. Set kubectl set image your deployment object name and then the name of your object. All right. App equals to lead DevOps. This was my repository kubeserve. All right, and colon v2. Okay, so it is not right. I'm giving a random number v1 v2. Okay, this is the command that I have. These are the images I do have on my repository. Version 1, version 2, version 3. I have 3 versions of my image on my repository. Before executing this, I am going to do something here as well. Okay, kubectl get rs. Okay, sorry, you cannot do that. Kubectl doesn't work here. All right, no worries. All right, so what I'm going to do, I'm going to set the image here. Deployment name is kubeserve e. Okay, team, you can see that deployment app kubeserve is updated. Okay, kubectl get all. Okay, I'm going to do it on a watch. Kubectl get all. All right, team, now you can see on deployment 6x5 is ready because you have maximum surge of 1. Okay, and now you can see there are another replica set is also created. You can see your old pods are getting terminated, your new pods are coming online. You can see the version update. Some are responding as version 2 and some are responding as version 1. Alright, here you can see previous logs. Earlier it was providing all the output from version 1. Then it started providing from version 2. Then sometime it was responding from version 1, sometime it was responding from version 2. And with time, you can see all of the outputs are coming from version 2. Alright, and here you can see your deployment is again 5x5. There was a time it was 6x5. Alright, and 2 replicas were created. This is your old replica set and this is your new replica set. And again, your pods are here. Okay, so this is the part you have done. Control C. kubectl, another command is rollout history. History, deploy and deployment name. Okay, history. team, this is another command called kubectl rollout history deploy kubeserve. Alright. As of now, I haven't given any message. That is why you can see none. Otherwise, it can show you that currently you have two versions. You have version 1, revision number 1, revision number 2. It means you have two versions. It means you have two replica set at the back end. Alright. Now consider I am going to change it to the third time. Alright. This time I am going to define as version 3. Alright. And as of now you didn't get any message. This time I want to have some message. For that purpose you are going to have as record equals to true. Okay, as of now you can see there is no record. But if you want to record, if you want to have some messages here, you have to set record equals to true. Team, do pay attention. This is important for the examination point of view. Okay, during exam they do ask you that have some records for your deployment history. Okay, you cannot record the history if you don't give this flag. And how you're going to see the output, you have to know this. Okay, kubectl rollout history is the command. And if you want to update, this is how you're going to update it. Alright, I'm doing this. It is updated. Kubectl get all. You can see 5/4. 2 are up to date, 4 are not up to date. I'm getting the third replica set now. Your pods are getting terminated. And you can see the output here. Okay. V2, V3, you can see. Some output are coming from V2, some output are coming from V3. Alright, so you can see all the replicas are replaced. 4 are available, 1 is remaining. You will see sometime 4 will also come online. Your old pods are terminated, your new pods has taken the place. So team, this is called rolling update. Okay, this is called rolling update. Alright, so let's check out the history. Kubectl rollout history deploy kubeserve. Alright, so team, as you can see in earlier one you cannot see any output, but now when you use record equals to true, this command was present here. Okay, so make this a habit. Whenever you do the updation in deployment, always do record equals to true. Then only you're going to see the output in the rollout history. Otherwise, it won't be available to you. Alright, kubectl get all. So team, one question for all of you. Okay, one question is for all of you. When I updated the deployment remained the same. Okay, deployment remained the same. There are no multiple deployments here, but there are now 3 replica set. Why there are 3 replica set? Why it hasn't updated the previous one? Why it is creating a new replica set? Can anyone answer? So team, this is my buggy application. Okay, now there is a question for all of you. This is the second question I'm going to ask. Alright, why it created multiple replica set? Why it didn't update the same replica set? Shiju, Jagannath, Gaurav, you're correct. Edurika, guess you're not. Mohan, you're correct. Absolutely. Anybody else wanna give a try? Yes, Ankur. Akhil, no, that is not the case. Girish, no. Prempal, you are correct. Okay, team, now let me ask you another question. Maybe then you can answer. Okay, now you can see some internal error has occurred, and this is from this pod. Okay, so what is the case? What is happening here? Consider I updated my application to version 3, but that version 3 has some bugs. Okay, version 3 has some bugs. So what I need to do, I want to have the previous version because this is a buggy version. I cannot have it. My clients are going to run away. So what I want to do, I want to roll back. I want to have the previous version. But if it is going to update the same replica set, how I'm going to have the previous version? Right? So I hope now you can answer. If I want to roll back, how can I roll back? Team, if I want to roll back to the previous version, how can I do that? Fanny, no, I don't want to do the edit. Yes, Arjun, you are correct. Gaurav, if you delete the old replica set manually, then it won't be able to go back to the previous version. Ashok, correct. Girish, you are also correct. Fanny, we don't want to do the edit. Alright, so team, if you want to go to the previous version, okay, if you want to go to the previous version, you are going to undo the changes, okay? kubectl rollout undo, okay, I'm going to undo it. Deployment name, kubeserve -2 revision. Okay, so team, this is the keyword. All right, this is the keyword. Now it is up to you to which revision you want to go. You want to go to revision 2, you can do that. You want to go to revision 1 directly, you give the revision number. Okay, if you want to undo, you give the revision number, whichever you want. So I want to go back to the version 1 directly. Okay, so you can see roll back. I'm going to put a watch here. Alright, now you can see that first replica set has started getting populated. Desired 2, current 2, ready 2. Now it has modified 4. Now desired is 4. Your current replica set is only showing 2. Right? Let's see the output. You can see there were some errors from version 3. Now you started getting version 1. And now you're consistently getting your version 1. Because your first version is being populated, all the pods are available, and you are getting all the responses from your version 1. Alright? So team, this is how you're going to do it. Alright? If you want to go to the previous stable version, this is how you're going to do it. Adjudicator guest, you are asking for the commands. Where are all these commands? I can show you that. To Educa repository, there is folder called others. Alright, day 3 and day 4 text. Okay, the init command is also there. Okay, expose commands are also there. These are the commands. kubectl rollout status, kubectl rollout status is here. Alright. You can pause and resume as well. Okay. Delete, deploy. All the commands are here. Okay. Rollout history, undo to revision 1. Okay. All the commands are here. So where? Educa, on your repository, others, day 3 and 4. All the commands are here. Yes, Gaurav, if you want to go from revision 1 to revision 2, you can do that also. Okay, you can do that. Because now it is inside the repository of Kubernetes. Kubernetes is managing all 3 versions. You can simply use undo command and go back to any version, version 1, version 2, version 3. All the versions will be available to you. Alright. So team, deployment is clear to you, rolling updates, rollbacks. It was a big topic, alright. This is one of the biggest topic that runs into continuation, services and deployment. Otherwise, all the concepts are independently running. This was the biggest concept that works collaboratively. your services, and deployment, rolling updates and rollouts. Prempal, there are no other deployments. For example, if you want to ask about role, there is a canary deployment as well. Okay, and there is a blue-green deployment also in Kubernetes. There is a rolling update which is there. All right, but during the examination only, they ask about rolling updates only. Okay, you can have type strategy as rolling updates, you can have the strategy as canary, you can have the strategy as blue green, but in the examination they only ask about rolling updates, and even though in the organization rolling update is the most popular one. All right, team, any other question till now? If not, I'm going to move forward. Team, quick yes from all of you if deployment, rolling updates, rollbacks, and services are clear to you. Instead of rollout, undo, what if, set the images. Sarath, you can set the image as well, but you want to do everything from the command line. Why you want to mess up with the manifest files when all the versions are managed by Kubernetes? In the last version 3, all the users were affecting when rolling update is applied. Yes, Prempal, all the users were affected. Some users were getting the output from version 3, some users were getting the output from version 2. We saw that with the curl operation. Okay, so it is still curling repetitively. So it works like that. All right, so what happens? Sometimes you get an output from version 1, so as many times as you refresh, as many times the user is going to refresh his browser, it is going to see a different output until unless the version has stabilized. But there won't be any downtime. It will always get some output. Shiju, what is pause and resume? You're asking from the commands I have shown you. Okay, so the thing is, consider your 4 pods are replaced, 1 pod is not replaced. Okay, you want to pause it for that time. Okay, your rolling update is taking place, your 3 pods are replaced, 2 pods are not replaced, and you want to pause it for that time. There you use a pause value, and when you want to resume, then you use resume. Anil, probs are defined under your pod definition. So in your deployment, you have pod definition as well. There you can define your probs as well. So you can use all these things. See, all the things that I'm teaching you, you can use collectively. Okay, it is not dependent that you have to use the probs only when you are defining only a pod. Okay, we are understanding about the concepts. You can use all the concept collectively in a singular way. In the continuation to the previous question, is there a way to verify and split the deployment by percentage? Split the deployment percentage? I don't understand, Prempal, what exactly you're asking for. Okay, please ask more clearly. I was not able to understand. So team, as of now, what I'm doing, I'm deleting all of it. kubectl, delete all, hyphen all. Okay, and we are going to move to the next concept now. Oh, okay, Shiju. Okay, I got the answer now. Okay, Prempal, yeah, Shiju understood your question and she answered. Sorry, my bad. So if you want to do it with the percentage basis, okay, how much percentage you want to update? Okay, as of now we have given the values, maximum search and maximum unavailable. If you want to do the deployment on the percentage basis, then you use a canary deployment. Okay, that is not going to come under rolling updates, it will come under canary deployment. team, next topic, next concept. All right, one question to all of you. So team, as of now, with all your understanding, you understood that if you define 5 replicas, okay, if you define 5 replicas, it can all reside on node 1 also. 2 can reside on node 1, 3 can reside on node 2. All right, 1 can reside on node 1, 2 can, and 4 can reside on node 3. All right, it is completely dependent on the scheduler. Okay, you cannot make that call that this pod should go on that node, that pod should go on that node. If you are using some replicas, you cannot define that. All right, if you want to use static pod, that is a completely different story. But consider you want something with which you can place one pod on every node. Okay, if you have asked for 5 replicas, 1 can go on one, 4 can go on another one, 2 can go on one, 3 can go on another one. But what you want one pod should go on every node. And even you don't want to give the replicas number. Okay, you don't want to give the replicas number. You don't want to give 5 replicas or 3 replicas. You want your cluster to reside. You want that one pod should go on all the nodes. If your cluster have 4 nodes, then replica should be 4 automatically. You don't want to give the replicas number. And you want those 4 replicas, one to be running on each node. One should run on node 1, another one should run on node 2, another one on node 3, another one on node 4. Okay, so even if you add another cluster, another machine to your cluster, okay, you add another node to your cluster. So one more replica should be created and it should go on the last one. So your requirement is one pod on every node. So team, can anyone answer? Can we do that? Can we achieve that? With all the concept we have understood so far, can we do that? No, Anil, init container won't work. Grish, how we can? Okay, people who are answering yes, do let me know how as well. No, Anil, I don't want to use static pods. Gaurav, I don't want to do that. Okay, Ankur, you are way ahead of us. Okay, you went to Affinity. Abhinav, you got it. Edurica, guess you think right. Okay, so many people are giving me advanced topics. Taints, alright. Saurav, no, I don't want to do it with static pods. Because with static, I have to log into all the nodes manually. Consider you have 20 nodes. Are you going to log on all 20 nodes manually and do it? Enjoy the place, nothing like custom scheduler. Okay team, so I told you there are multiple controllers, okay? There are multiple controllers. RC we have discussed, RS deployment we have discussed. Next is daemon set. So daemon set is the one that creates one pod on every node. Okay, you don't have to define the replicas, you don't have to manage everything, you just define a definition of daemon set and one pod will be created on all the nodes. Okay, let's see the example for this. Controller. Alright, there has to be some daemon set. Okay, daemon set example 1. Okay, so team, this is the definition. You have to give the kind as daemon set. Okay, the name of the daemon set is my daemon set. I have given some labels as well. Then specs and selectors. Okay, if you want to skip this part, you can leave this. Okay, this is not mandatory for a daemon set. Under template, you can see this is the definition of your pod. The pod names are this. They also have some labels, and then the your container specification. All right, and you can see I can give the limits and requests as well. So you can use all the concepts all together. Okay, so team, in this definition, you can see I have nowhere mentioned the number of replicas. Okay, there is no mention of number of replicas. So let's try to create this daemon set. Kubectl create -f daemon set. Okay, you can see your daemon set is created. kubectl get, the short form for daemon set is ds. Okay, so team, you can see it took it from itself. Okay, I never mentioned 2 replicas, but it kept 2 desired, 2 current, and 2 are ready to update, and 2 available. Okay, I never gave replicas equals to 2. It created 2 replicas at its own. How? kubectl get pods -o wide. Okay, so team, you can see it placed one at node 1 and another on node 2. So this is the feature of daemon set, that it is going to place one pod on every node. Now let's come to the use case. So what is the use case of daemon set? Okay, so team, I'm going to show you one important output and you will understand that. First use case, on the enterprise level, I'll say, consider that you have 50 nodes inside your cluster, all right, and you want some kind of logging enabled. Okay, so what you are going to do, you want to place a Splunk container, a Splunk pod on all the nodes, so that it is going to catch up the logs from all the nodes. Okay, you want to do that, you create a daemon set. That is the enterprise level requirement. Next, kubectl get all -n kube system. So team, now you are going to see everything that I have taught you today. Okay, all the components of your kube system are right in front of you. Okay, so team, you can see core DNS. Core DNS runs as a deployment. Okay, and we have 2 replicas. With that, we have a core DNS replica set as well. Right? So core DNS, this one, is running as your deployment. Okay, core DNS is running as a deployment. Now, kubeproxy and weavenet. Okay, this is a use case. I told you that if I'm using proxy should be running on all the nodes, right? Proxy should be running on all the nodes. That is why I want to have it as a daemon set. I need kubeproxy on every node. I'm going to define it as a daemon set. Okay, weavenet, that is your CNI. Sorry, weavenet is your CNI. So a CNI should also be present on all the nodes. That is why I have created the weavenet as a daemon set. I haven't Kubernetes did. Okay, so now you can understand about all the components. Okay, core DNS, both are running as a deployment and replica set. etcd is running as a static pod, kubeproxy as a daemon set. All right, scheduler as a static pod, weavenet as a daemon set. Okay, so all the concept that we have understood, Kubernetes itself is using the same concept at the backend. Okay, so team, any question with the daemon set and everything that we have understood so far? Any question, any doubt? Everything is clear to all of you? Yes, Shiju, please go ahead. Anybody else? Any other question? What is the use of this service? Ashok, if you have attended my first class, that was third in this complete curriculum. First 2 classes were not taken by me. I took the third class. So in my first class, I told you that VNet is your CNI. Okay, that is your network. I told you Kubernetes doesn't provide its own networking, so you have to pick your own networking. So VNet is a component that provides you networking. We have taken it from there. Okay, Shiju, you are asking that kubeproxy and Calico node or VNet is a daemon set. So why they are running on master as well? Okay, so alright Shiju, you saw that when I created the daemon set, those daemon set were executed on node 1 and node 2 only. That was not created on master. But here VNet and kubeproxy are running on master as well. Why is that so? Okay, that is your question. So the thing is, when you are using a default namespace, okay, default namespace is set up in a way that it is going to only take the instruction from master. Okay, this is a concept of taints and toleration. I can also tell you. Okay, so you have to define taints and toleration. So for kube system namespace, we have defined master as also a node because it is a master level component. It's a system level components. So in kube system namespace, we have defined it in a way that master is also considered as a node. All right, but if we are creating a daemon set in a default namespace or in some other namespace, it is not going to treat master as a node. So that is the story here. And to understand with this in depth, we have to go to the taints and tolerance. We were supposed to cover it today, but I don't think we are going to reach to that point today. Okay. So I hope that answers your question. Kube system namespace treat master also as a node, and other default namespace treats worker nodes as just nodes. All right. So team, next topic is your jobs. Okay. So team, what are jobs? Consider if you want to have some proper operation and then that is run. Okay, this is what we have seen in init containers also. In init containers, what happens? They do their job and they die out. Okay, these are the story of init containers. Prempal, if I had one node in the cluster, then how daemon set are manages among all three nodes? Is the daemon? Yes, Prempal, if you have added a new node, okay, you are going to generate a new token. Sorry, you are going to regenerate the previous token and you are going to execute on it on the worker node. So your new worker node will be added to your cluster. All right. And when Kubernetes will understand that there is one more node, daemon set is going to create it automatically. Okay. Daemon set will be scaled from 2 to 3 and a new pod will be placed on node 3. It will be done automatically. Okay, so team, actually what I was trying to say, that you know the basic nature of init containers. They do some work and they once their job is done, they die out. All right, they pass on some information to the primary container and blah 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 whatsoever, but they are destined to die. Similarly, consider you want to execute some jobs. Okay, consider you want to run a scan. Okay, you want to run a scan on a particular time in your system. So what you are going to do? You are going to do it with the job. If you want to do it on the random basis, you are going to create a job in Kubernetes, and then that job is going to do the work, and then it is going to get die. Okay, then your container will die once its job is done. So for that purpose, we use jobs in Kubernetes. That is your next type of controller. Okay, let's see its definition. So team, the next two topic is job and cron job. So don't ask me about the use case because that is actually not really used anywhere. Okay, this is just a concept that can help you in the examination. They might ask you, but in practical life, it is never used. So the kind is job. All right. We are going to do some countdown. Okay. Back off limit, you can ignore it for now. Metadata is a name. Container, I am going to name the container as countdown. CentOS is the image I'm going to use. I'm going to do the min bash and I'm going to execute this. Okay, it is going to write down numbers from 9 to 1. That is what it is supposed to do. I'll take the raw format. kubectl create -f job. I have created a job. kubectl get job. Okay, you can see this is running from 5 seconds and it is not completed yet. The number of operation you are going to provide, it is going to show you. Okay, completion you can see 0/1. Now the completion is 0/1/1. kubectl get pods. Okay, you can see that countdown pod is 0/1. It was ready for some time, but once its job was completed, you can see the status changed to completed. Okay, so the job pods shows you status as completed once their job is done. Alright, so they runs to completion and their status changed to completed. Now it is a job, you want to see the logs as well. Okay, so you can say the same task I can do with a normal pod as well. So why do I want a job? Because job retains the logs as well. If you want to do the same task with a normal pod, you can do that. But once the job inside the pod is completed, your pod will be deleted. Okay, your container will die out or your container will restart based on the policies you have defined. So once your container is gone, once your container is died, the logs are also gone. But if you have done that with a job, your container will stay there and will have that logs. So what is happening actually, your container has died out, but your pod is still there so that you can catch up the logs. Okay, so if you want to know the logs, kubectl get job, you get the job name, kubectl logs and the job name. Sorry. Okay, you have to do with the pod. My bad. kubectl logs, pod, and the pod name. What is wrong? Okay, kubectl log and directly the pod name. Alright, you saw that countdown happen. This was a task. But if you would have done this with a normal pod, this log was not able to show you because it would have died out or restarted. So if you want to retain the log of some jobs, you use the job type. Yes, Shiju, it is useful for the background task. Absolutely correct. Okay, and with this job will be executed in the real time, right? This job will be executed in the real time. But consider you want to schedule this job. Alright. If you use a job, it will be executed right away. But if you want to schedule a job, that cannot be done with a job. You can do that with a cron job. That is your another kind of controller. Okay. Cron job example 1. If you want to schedule something, you are going to schedule it. Okay, this is another kind, cron job, name of the cron job. Under specs, you have to mention the schedule. Okay, you have to mention the schedule. So you can see, I am asking it to execute every 1 minute. All right. So if you want to know how this formatting is done, it is just a basic Linux concept. All right. It is not a Kubernetes concept. You should know this from your Linux administration or Linux knowledge. Simply check out for the format, how your cron job format is there. It is a Linux concept, not your Kubernetes one. Okay, this is how you define, and what star and what place means what you can see here. Alright, so you can see the example here, execute after every 5 minutes, and we have given the same format, but in the place of 5 we have given 1. Alright, so it is going to execute after every 1 minute. Alright, so about the formatting, you can understand it from the Google. It is a basic Linux concept, not a Kubernetes concept. So what I'm going to do, I'm going to have the raw format for this, and I'm going to schedule a cron job, and it will be executed after every minute. Job will be completed once, but cron job will execute as many times as you want. Create -f this. Alright. So what is happening? It will execute after every minute. What will happen? This is the metadata. This is the definition of your pod. Alright. It is going to, this is the name of your container. This is the image of your container. What it is going to do? It is going to write down the date, and it is going to highlight a message, hello from Kubernetes cluster. And this will be done after every minute. So let's see if it is happening or not. kubectl get pods. Alright. You can see this pod completed its job. kubectl logs and this one. This is the time. At this time, it showed the message. kubectl get pods. Okay, another pod will be live. It might take some time. Okay, you can see this is the definition of your cron job. Team, can you see another pod was created? Okay, difference you can see. 60 seconds is the difference. That is 1 minute. So after every 1 minute, a new pod will be created and it will give you some output. So this is the latest one. kubectl logs pod name. Okay. So this job will keep creating every job after every minute. Okay, after another minute you will see it will be creating another pod for the particular job. Okay, so team, with this these concepts are covered. We have covered all the controllers, RC, RS deployment, jobs, cron jobs, daemon set. Okay, so team, the thing is, your jobs and cron jobs are important for your examination point of view. That's all. Okay, they don't have any much job in the enterprise level, but it is important for your examination. In exam, 90% of chances are there that you will get some question on job and cron job for sure. Okay, there are high chances of getting question from jobs and cron jobs. So you can see another pod is created. Now you can see 4 pods, right? So if you want to delete it, you have to delete the cron job. I'm deleting everything as of now. Alright, so team, now if you have any question from jobs and cron jobs, now you can ask. Kushagra, can we restart the job? Yes, you do have the YAML file with you, right? The number of time you are executing the same YAML file, it will create the job again and again. But it is for the real time. If you create a job, it will be executed right away. It will not be scheduled. But with cron job, you can do the scheduling as well. Prempal, you are asking, can you please create cron job for existing job? Countdown was created. Okay, Prempal, that is just a concept. You have to pass on the arguments. Okay. Also, you have to decide that if you are giving the timer 1. Okay. So the timer 1 has a particular task to do. So if you want to do it repetitively, you have to pass on the arguments only at that place. Okay. The arguments that you have placed here for the cron job, you can replace them with the arguments of your job. Here it is. Okay. Replace this with this and you're good to go. If the pod is removed, then you won't be able to access the logs, right? Shiju, that is the importance of your jobs and cron jobs. Okay. Because pods are not removed until unless you remove them manually. Okay. If you are doing all the things with a container or with a normal pod, your containers dies out inside the pod and you loses all the logs. But with job and cron jobs, your logs are retained. That is why a new topic was present in Kubernetes named as jobs and cron jobs. We could have done the same with the normal pod as well. But we wanted to retain the log. That is why we have the concept of jobs and cron jobs. Team, anyone, anything else? Any question, any doubt? No? No, Gopal, you cannot log into that pod. Actually, I haven't tried that actually. Let's see that. Okay, I actually deleted all of them. kubectl get pods. Okay, let's try to do that. Actually, I haven't done that. So Gopal is asking if the logs are retained. So if the container is also present or not. Okay, let's see that practically. In the meantime, any other question, any other doubt? Okay, so this job is completed. kubectl exec -it, your pod name --bash. Okay, so team, this is what I explained you actually. Okay, the pod remains completed but container dies out. Okay, if you work with a normal pod, in a normal pod what happens, your job is completed by the container, it will die out. So it depends on the policy. If the container has died out, your pod will try to restart it. Alright, but it is not the case with the job pod or cron job pod. It goes to the completion. So your container is completed, your container is removed, but your pod is retaining the logs so that you can check it out. Ashok, what you want me to explain again? Let me know, I will do that. But explain what? Okay, explain the job. Alright, Ashok. Ashok, the thing is, if you want to have some task to be done, okay, for example, at the enterprise level, I am saying that you want to have some task of scanning. Okay, you want to do some scanning on your nodes. Okay, you want to do some scanning inside your cluster. All right, so even you might want to know some count of your pods or something. You want to do some particular task. All right, if you talk about deployment, if you talk about pods, they are working as your application pod. They will be live all the time. Okay, but you want some task to be done. Okay, then those pods are not supposed to live forever. They have to complete a task and then they can die out. So these type of tasks are done by the job. You want to get some work done, get it done by a job. You don't have to create the pod, you don't have to create the deployment. Create the pod, create the job, and then once your job is completed for the pod, your container will be deleted and your logs will be retained. So that is the concept of job. You want to get something done, get it done by a job. You cannot do that with a pod. Okay, like I showed you, I wanted to run a countdown timer. Okay, so once that was done, it was deleted. Where it was? Here. Alright, I created the job. In the job, I wanted to have a timer. That was the simplest example I have given. You wanted to do some scan, you can do that. You can retain the logs. But I wanted to run a countdown timer from 9 to 1. So it counted that, and once it was done, it was completed. Yes, Jagannath, in the meantime, if your container is live, if it is doing the job, you can log into that container. In that case, you can do that. You can have a timer for 99 seconds, and in the meantime, if you want to log in, you can log into the container. Alright, so team, if all of this is clear to you, we can mark all of this as completed. We have defined the controllers. We have done with the rolling updates, rollback, run services. All of this is completed. Next things we wanted to discuss was scheduling, taints and toleration, namespace limits, drain and uncordon, etcd backup, monitoring volume. This was the agenda we wanted to cover. Definitely it wasn't possible to cover all of it. But no worries, we were not able to start with this. We are going to start this with this next week. Alright, so this is the agenda for your next coming Saturday. So team, how was the class for today? Were you able to understand the concept? Today was a big concept that runs into continuation. I tried my best to make it as much clear as I can. Okay, great, excellent, thank you. Ashok, good topic, okay. Do mark your feedback also. And if you feel it was good, do let me know what you want me to do to make it excellent. Okay, as I told you, that is only what counts here. So team, thank you for all your feedbacks. I am getting that. I do read all the feedbacks thoroughly, every single one, alright, and I really appreciate. So keep doing that. It gives me some motivation as well. Alright, so team, we are done for today. Do we need to go through the PPTs as well for examination point of view exams? Gaurav, for exam, you can cover as much as you want. Okay, there is no limit. If you want to go through the slides as well, you can go through the slides. Alright, it is also going to help. And also, if you complete all the things in this repository, then you can consider that you're well prepared for the exam as well. Arjun, for the you're saying heavy topics, can you please send me some labs question for us to practice? So Arjun, if you have went through this repository, everything is here. Alright, everything is here. Troubleshooting scenarios are also there, but we haven't discussed that, so that is why I haven't showed you that. Alright, if you want to know some exam preparation topics are also here. Okay, I have pasted here multiple PDF files. Some README files are also there, weightage with all the details. Alright, some scenario based questions are also there, but I haven't shown you this till now because it covers all the concept. I'm not going to open one PDF and show you all the topics which were covered so far because it contains all the topic. So this is what I have kept for the last, but still if you want to go through it, you can go through it. But if you want me to discuss these things, I'm going to discuss by the end of the session or the course. Imanshu, I have already shared. If you do have this repository, you have to go to the other folder. Okay, in other folder, you have HTML bookmark. Okay, Google it, how to download bookmarks from a HTML file, and you will have the similar bookmark with yourself. From where when we can practice some mock test. Gaurav, for that at least you have to complete the course. Okay, in mock test you will get the question from all the topics, and you don't know all the topics as of now, as per my teaching. So many concepts are remaining. So first you have to understand all the concepts, then you can go for the mock test. Alright, so a quick recap what we did last week. Alright, we studied about your Kubernetes controllers, how many kind of controllers are there, your RC, RS, and your deployment. We talked about your daemon set, we talked about jobs, cron jobs. Alright, this is all we discussed, and we also studied about your services, how many kind of services are there. That is node port and your cluster IP. We understood about all of them. Okay, that is what we did last week. And today we are going to start with scheduling. All right, we are going to see about taints and toleration. We already understood about namespaces, but today we are going to see how we can limit namespaces. We are going to see drain and uncordoning of nodes, etcd backup. We are going to see about monitoring also today, and if time permits, we'll see about volumes as well. Okay, this is the agenda we have for today. Before we get started, if anybody has any question from the previous session, you can ask. Whatever we have discussed so far, anybody has any question? No one? No doubts, no question at all? Okay. So in that case, team, we are going to start with today's agenda. Alright. Our first topic for today is scheduling. Alright. So team, in the basic architecture class, we already studied that we have a scheduler also there as a master component. How many of you remember what is the purpose of scheduler? Anyone? What is the purpose of scheduler? Distribute task as in what? That is not a clear definition. Mosomi, yes, you're right. Shiju, Akhil, Sanjay, yes, you're correct. Ankur, Jagannath, yes. Joydeep, Girish, yes. Akhil, Satish, Himanshu, yes, you are all absolutely correct. Okay, so the job is scheduler to decide to which node your pod should get assigned to. Okay, we have a master and we have a 3 worker nodes as if I am showing you. Alright, so first your request go to the API server and API server ask your scheduler to which node your pod should go to. Alright, but we have also seen that we can force a pod to reside on a particular node as well. Right, we have already seen that. How? With the help of static pods. Alright, we have done with the help of static pods. But there are some criteria based on which we can also ask the scheduler to make the pod go on a particular node itself. Yes, that is also possible. Okay, so for scheduler, we are going to see how the scheduling happens and how we can ask the scheduler to assign a pod to a particular node. Today we are going to see that. Okay, so the scheduler based on the below criteria decides that a pod should go to a particular node. First and foremost is hardware resourcing. My bad. Okay, first is your hardware resourcing. It means how your hardware is configured. Is there enough RAM or there or not? If there enough disk space is available or not? If there are enough CPU cores are available or not? Okay, how your physical server is configured, how your physical configuration of your nodes are configured. So if there is any pressure or not. Okay, that is the first criteria based on which your scheduler decide that which node should be chosen. If any node has any kind of pressure, it means it doesn't have enough RAM, it doesn't have enough CPU core, it has lesser disk space, it is not going to schedule the pod on that node, it is going to choose anyone else. Okay, first is your hardware resourcing. Second is your node selection. Okay, second is your node selection. Third, based on labels also we can define that this particular label should be there if your pod should be assigned to that node. Okay, that is one. Next is ports based on volumes as well. Okay, I'll let you know about the volumes concept as well. We have taints and toleration. And we have affinity. Okay, now we are going to see all of them. First is your hardware resourcing. It means based on your hardware resources, it defines that which node should be chosen. So let's see that also. kubectl get nodes. Okay, we can define any node to see how it behaves. For example, if I'm going to define k node 1, kubectl describe is the command that you already know. Node k node 1. Okay, so it gives you complete definition about the node, how it is like. All right, and here you get all the definition. What are the condition based on which it decides? All right, First, you can see that network unavailable. If the network is available or not, the status is false. It means network is there. It means VNet is available. Next is your memory pressure. That is also false. It means kubelet has sufficient memory. Alright, kubelet has sufficient memory available. Next is your disk space. Kubelet has no disk pressure. Kubelet has no disk pressure. PID. Are there enough process IDs available or not to handle the request? Kubelet has sufficient PIDs. Ready. It means that kubelet is posting ready stated. It means that your your node is available. Your node is available and is ready to take the request. Alright. All the information you get from here. So first was your hardware resourcing. Next is your node selection. You can choose on which node your pod should reside. You can give that in the definition as well. Next is labels. Similar to that node selection, it chose on the basis of labels as well. We are going to see that practically. Next is port. Consider that my application is going to listen to a particular port and that port mapping needs to be done on the node level as well. Okay, so it is going to check that which node have the available port. Okay, for example, if my application listens to port number 80 and that port number needs to be mapped from the node level as well. So it is going to check that on which node that port is available. So whichever node is going to have that port available, it is going to assign my pod to that particular node. Then we have volumes concept. Alright, so volumes I'm going to explain you once we discuss about volumes. Alright, this is the last topic in our agenda for today, if everything goes fine. Otherwise, tomorrow we are going to study about volumes. Next is your taints and toleration and affinity. Okay, so there are some topics that we cannot do anything. Okay, hardware four items: node selection, labels, taints and toleration and affinity. Okay, consider I came with a request that I want to create a pod. Okay, this is your N1, this is your N2 and this is your N3. Okay, so I came with a request that I need to create a pod. Alright, I can give it in the definition that it should go on a node whose name is N1. Okay, as simple as that. Okay, I came with a request for a pod creation and I said that I want the pod to be created on the node whose name is node1. Very simple. You go to some person's address. Alright, he give you the absolute address. Come to house number 83. Okay, then you are going to directly go to the house number 83. As simple as that. Okay, so example we have in the same Git repository. You have to go to the repository, pods and placement. Alright. So this is the first example. Alright, we are going to create a deployment with 2 replicas. Alright. In your pod definition, you see something extra called specs. Under specs, you have something called node name. You have to give the name of the node, and then your pod will be assigned to that node only. Okay. So here it is node 1 and our name is K node 1. So we are going to have the copy of this. Node.yaml. Okay, the name of our node is K node 1. We are going to save it. kubectl create -f node.yaml. Okay, your deployment is created. kubectl get pods -o wide. Alright, so these are the previous jobs or something. Okay, here you can see that kubeserve has created 2 pods 8 seconds ago, and both the pods are created on node 1. Okay, both the pods are created on K node 1 because we gave as a node name specification that you have to go to the node 1. That's all, as simple as that. Alright, next item. Consider your pods are colored a bit. Okay, just take an example. Okay, team, consider you have multiple nodes. Alright, in a cluster we have already 2, but consider in your environment you have 5 type of nodes. Okay, you have 5 nodes. Now next is you want to give a definition that your pod should go on some particular node. You can give the node name directly, but no, you don't want to give a particular node. You want to give some kind of nodes. Alright, consider you have defined some nodes as your production nodes, some nodes as your testing environment node. Alright, so when you are creating some testing pods, you want them to go on the testing node itself. Maybe you have testing node 1, you may have 3 testing nodes, you have 3 production nodes. Alright, so you want them to go only on the testing nodes. You don't want to create your pod on the production node. In that scenario, looking at this diagram, how you can define? Okay, you have one yellow node, you have one green node, and you have 2 blue nodes. So I want my pod to go on some blue colored node only. Okay, my pod should go on some blue color node only. If there are 2, it can choose any out of those 2, but it should not go on yellow or it should not go on green, but any blue node. If there are multiple, it can choose at its own. Okay, there comes the concept of your labels. Okay, you can put labels on your nodes itself. In previous classes, we have seen that I can place a label on my pod. That is what we have seen so far. But we can put a label on node as well. That is allowed, that is possible. I can put a label on my node as well. Alright, for that same purpose, we have another example here. Node selector pod. Okay, in this you give some label definition. This time you can see there is a difference. Earlier we had node name, now we are using node selector. Under node selector, we have something called a label. Alright, so first let me assign a label to one node. kubectl. Just a minute. Yeah. kubectl label node. I want to assign some label to k node 2. Alright, and what label I am assigning? Color equals to green. Okay, now you can see that your k node 2 has been labeled. Alright, if you want to see kubectl describe node k node 2, let me have the grep because it provides me a bigger output. Okay, you can see that your k node 2 has been labeled as color equals to green. Simple. Now I'm going to have this definition and create my replicas. It is also going to create 2 replicas, but it should get assigned to the node who has the label of node selector. That is color equals to green. From here, I am going to take the raw format, kubectl create -f and create. Okay, kubeserve name already exists. kubectl delete all -all. Okay, my previous deployment name was also kubeserve. That is why it is giving conflict error. So before that, let me delete everything. Okay, that's done. Okay, you can see that your deployment has been created. Let's see where your pods are assigned this time. See, both the pods are assigned to node 2 based on the label. You can label as many nodes as you want. Okay, I can have 5 nodes labeled out of my 10 nodes in my cluster. So it will choose out of these 5 nodes only where your pod should get assigned. Okay, so team, any question in your node name and node selector? Is it clear to all of you? Any doubts, any question? Okay, Fanny, you want me to repeat the node name? Node name is simply you have to give the node name. Okay, it is as simple as that. You have to provide on which node your pod should get assigned to. Here I gave labels. In node name, you give the name of the node. You can see I have simply given the name of the node. Under specification, node name equals to node 1. You give the node name, knode1 was in our case. You give here knode1 and it will be scheduled on that particular node. That's all. Sumit, why we have used specific node selector rather than only selector? Sumit, selector works with your pod labels. Okay, you have to provide the difference, and that is how your Kubernetes has defined the naming convention. If you use selector, it is going to check for the labels on your pods. If you give node selector, it will check the labels on the nodes. Yes, Gaurav, you can have multiple node labels. You can give as many labels as you want. Okay, so if it's clear, let's take the next topic. All right. Now, when you were creating the pods till now, a decision was made by the pod. All right. Your pod was choosing the node where it has to sit. Your pod gives the definition that it wants to sit on node 1 in case of node names. When it comes to your labels, again your pod was the one that makes a decision that I will sit on either this node or either this node. Okay, now if you want to give some complex situation, okay, if you want to give some complex condition, for example, looking at the current picture, I want my pod should not sit on blue color nodes. Okay, in the previous example, we asked our pod to sit only on the nodes whose label has blue. Alright, now I want to give some complex situation that my pod should be sitting on node which are not blue colored, which are not blue labeled, or I want my pod to sit either on yellow node or either on green node, but not on blue color node. So you're trying to understand, right? If I want to give some complex situation, some complex conditions, in that scenario, affinity comes into picture. Okay, with node name and node selector, you can give simplest condition, but no, I want to give complex conditions. For that purpose, affinity comes into picture. Alright, let's take an example. You'll understand better that way. Okay, there is an example of affinity. Again, I'm going to create a deployment with 3 replicas. All the other definitions are already clear to you. Okay, now under specs, you have affinity. Under affinity, you have node affinity. Okay, first point first, you have 2 types of affinity. First is your node affinity. Second is your pod affinity. I'll explain you one after another. First, we are going to discuss about node affinity. What is node affinity? Okay, in node affinity, you give complex condition based on which your node is selected, where your pod should be living. Okay. Now, under you have a big string preferred during scheduling, ignored during execution. Okay, I'll let you know about that. Now you can see I have given the weightage. Okay, in weightage you can see I have given 2 conditions. This is my first condition of weightage 80. This is my second condition of weightage 20. It means when the pods will be created, it will try to fulfill the condition with 80% weightage. When the pods will be created, it will try to fulfill the condition which has the higher weightage. If this condition is not able to fulfill, then it is going to go to the weightage 20 part. Otherwise, it will first attempt to make the pod in this condition. Alright, now you can see I have given complex situation. Weightage is 80% and I have given the preference. It means prefer this. If preference is not possible, go to the other one. Alright, so if I haven't given the preference, it means it has to fulfill this condition only. If this condition is not fulfilled, it will keep the pod in pending state. Okay, if I don't give preference, it means it has to fulfill this condition only. It means if this condition is not able to be fulfilled, it is keep the pod as pending state. But I have given preference. First try this, else try this. Okay, consider you want to come to somebody's place. Alright, he instructed you on the roadways. Okay, he said that you have to come straight, after that you have to take a left. Alright, if the left turn is busy, come straight. If the straight way is also busy, if there is traffic, if your left is trafficked, your straight is traffic, take a right turn. Then also you can come to my place. Okay, so that is about preference. You first prefer the left turn if that is available. If there is traffic, come straight. In the similar way, I have given the match label conditions also. Key is zone and operator is in and values are this. Okay, so if any node has zone equals to east or west, okay, you can see if any node has zone either east or west, your pod should get assigned to that node only. If there is no node with such labels, then check for another label where type equals to web. Okay, First, try to fulfill the condition with heavy weightage, that is 80%, that if there is a node with label as zone equals to east or west, assign my pod to that node. If not, if that is not available, try to find a node whose type is web and assign my pod to that node. Okay, so that is based on weightage. Now there is a keyword called preferred during scheduling, ignored during execution. What does it means? It means when my pods are getting created, when it is doing the scheduling, then try to fulfill this preference. Try to fulfill this preference and ignore during execution. Consider while the pods are getting created, I change the label on my node. That is a possibility, that when the scheduler was scheduling the pods, there was a label on a particular node. But when the pods were getting created, you changed your label. So it is going to ignore. If your pods are getting created, it is going to ignore even if you change the label. It is going to check the labels only when you are scheduling the pods. Okay, so this is your first keyword. You can have it in a different way also. Okay, this is your first keyword. Your second keyword that you can use is, apart from preferred, you can use required. Okay, these are the two options that are provided by Kubernetes. First is preferred during scheduling, ignored during execution. So it is going to decide based on the weightage. If you give required during scheduling and ignored during execution, so it is going to check for the proper labels. If the labels are not found, it is going to keep your pod in a pending state. If you have given required during scheduling, so there are two possibilities: preferred during scheduling or required during scheduling. In required, it has to fulfill the condition, otherwise it is going to mark as pending state for the pod. If you have given preferred, it is going to give the preference. If any of the preference is not fulfilled, it is going to assign the pod on any random node. Okay, so that is about preferred during scheduling and ignored during execution. So this is about it. Okay, last part which I want to let you know before showing the practical is, here you have chosen the node affinity. Okay, here you have chosen the node affinity. It means all the labels that we are talking, all the conditions that we are giving are based on your nodes. If I'm talking about the labels, zone equals to east or west, type equals to web or not, okay, these labels should be checked in on the node level if your nodes are having those labels or not. Another thing that you can give here is pod affinity. Okay, this is your node affinity. Next is your node affinity, pod affinity. In pod affinity, it checks if on node 1 a pod is running with such label. Okay, you already have some pod running already beforehand. So consider on node 1 you already have a pod whose label are zone equals to east or west. So it is going to schedule your new pod on the same node where you have a pod with similar label. Okay, that is a little advanced query than node affinity. In node affinity, labels are checked on the node. In pod affinity, your labels are checked on the pods. If any pod has a label of east or west and that is residing on node 3, then your new pod will also get created on node 3. So this is the basic definition. So team, based on the definition, anybody has any doubt? Yes, Girish, we can change the weightage. That is completely up to you. You can give 60-40, you can give 50-50, you can give 30-70. That is all up to you. Okay, or let me show you this example practically, then I'll take your question. Okay, so I'm not going to fulfill any condition from the 80% weightage. What I'm going to do, I'm going to put a label of type equals to web to your node. Alright, kubectl label node. Let's label your node 1 this time. Alright, type equals to web. Okay, your node 1 is labeled. Let's create this deployment with affinity. Kubectl create -f. Alright, your deployment is created. Kubectl get pods -o wide. Okay, so team, you can see all the pods. All the pods are created on node 1 based on the condition you define in affinity. Okay, it tried to find the condition with 80%. If I would have given here required during scheduling and ignored during execution, in that case weightage doesn't mean anything. It is going to check for this condition hardcode. If this condition is not fulfilled, it is going to make your pod at pending state. Alright, so if you would have given here required, but I have given the preference. First check for the higher weightage preference. If not fulfilled, go for the lower weightage. And you can see it has chosen based on your lower weightage, because higher weightage condition was not fulfilled. There was no label with zone equals to east of s. So it looked for the type equals to web, and it scheduled your pod on node 1, which was labeled accordingly. So team, any question with affinity this time? What are the different parameters that we can use apart from weight for node or port affinity? Arjun, it is not port affinity, it is pod affinity, POD, pod affinity. And how can we get the list? So Arjun, these are the only conditions. Okay, I have given all the possibilities in this example. Okay, with key value pairs, you can give multiple operators. Multiple operators are there. All right, where zone in east or west, or you can use the operator equals to. Okay, so these kind of operators you can give. Otherwise, all the things are same. I have already given you how many type of variety is there, different parameters. Here you can use node affinity and pod affinity. Here you can use preferred or you can use required. Okay, so I have already given you the maximum number of possibilities. Then why we need % in required, as it is going with the first one? Grish, no, my pod was created with the second condition. It tried to search for the first condition because the weightage was 80%. If that was not fulfilled, then it is going to check for the lower weightage condition. Okay, Grish, I think you had some confusion. It didn't go with the first one. It went with the second one because it was not fulfilled. I labeled my node 1 as this. Okay, got it. Yes, Girish, if you have given required during scheduling, then this weightage and preference keywords means nothing. Okay, then you don't have to give the weightage, you don't have to give the preference if you are using required during execution. Akhil, I'm not sure what you're trying to ask. Node name I have not seen mentioned in the YAML. We are not dealing with the based on the node name. We are dealing with the labels on your node. Akhil, if you don't mind, can you keep your question written and ask it at the end of the session if you want to get unmuted? Okay, I request you for that if that is possible. Okay, team, please allow Akhil to get unmuted for a while. Okay, usually we don't do that. Yes, Akhil. You can unmute yourself and ask the question.
Yeah, hello, are you able to hear me?
Yes, Akhil.
Yeah, okay. Actually, in the diagram you showed, like we use affinity in order to, I mean, if we don't need to deploy it in the blue color node, and all others node has to be deployed. So that is the purpose of affinity, right? And
In affinity,
we have
you give
mentioned
complex conditions. You can give simple
okay,
condition
so,
with node selector.
okay, so the label type, I mean, the labels might be mapped with the different node. I mean, the yellow and the green node. Am I right?
Yes. Yeah.
Okay, okay. Yeah, okay, yeah. Now it got clear. I got confused, like since it was not mentioned, like just a single statement, how it is identifying as a small dog.
Yeah, that is what I said. If you want to use complex condition, so definitely it is going to be a little complex. Okay, here we are deciding based on multiple factors. We are not simply saying that go on node which has blue color.
So, I mean, if we have the two conditions satisfied, then how it will?
If two conditions are satisfied, then it is going to do round robin. If two nodes are satisfying the same condition, it is going to assign one pod to each of them. Round robin.
Okay, okay, okay.
Okay?
Okay. Yeah, thank you.
Yeah. Alright, Shiju, with required, will it go to the second weightage if the first one is not met? Shiju, if your condition is with the required, then you won't give any weightage. Okay, weightage is only given when you are doing the preference. If you have used required, it means you have to fulfill the condition dedicatedly. You cannot go to first option or second option. Options are only given when you have preference. Okay, consider the layman example. If there is a road to come to my place, okay, I said take the right. If there is traffic on right side, come straight. If there is traffic on right straight as well, come right hand side. Okay, I have given you condition, but consider if there are no multiple roads, there is a straight way, that's all. So you have to come straight way, you don't have any option. Similarly, if you have options, then you give preference. Either take a right turn, either take a left turn, or come straight. If there is only one road, if you want to fulfill only one condition that is required, so you have to be on that path only. Okay, with required you don't give any weightage. With preferred you give weightage, but with required you don't give any weightage. Gaurav, I don't have an example ready with the pod affinity with myself right now. Okay, but if you want, I can provide you an example tomorrow or maybe next week. But right now, I don't have that example with me. Also comment said assign the label to node. So if we are not able to match the label in the node, does it add the label? No, Arjun, you have to put the label beforehand. Okay. It is just for your understanding. I have commented it out. It means if you want this condition to, first of all, you should have some labels assigned to that node. That is about it. Okay. So this is the comment for you to practice. Yes, Kapil, weightage is similar to your pod priority also. Yes, you are correct. Okay, any other question? Team, if it is clear to you, we are going to move to the next topic, that is taints and toleration. Okay, that is a hell of an interesting topic. Let me know if everything is clear to you. Now we are going to move to the taints and toleration. Okay, seems like it is clear to all of you. So we are going to move to the next topic, that is taints and toleration. And before explaining you that, I'm again going to take a layman example. Okay, a layman example. We are going to take a little story so that you understand it better. Alright, so team, a real-time example. Okay, recently we have been dealing with COVID, right? And we have different zones in our area these days. There are some red color zones which has heavily infected people. Okay, we have some yellow color zones also. It means there are some infections but not that bad. Okay, and we have green color zone where there are no infections, right? I'm taking an example of COVID situation, of the lockdown and restrictions in the society. All right, so you have three zones. You have green zone, you have red zone, you have yellow zone. It means the red zone is very critical. It is not suggested for anyone to go in that area, right? If I'll talk about a normal person, let me remove the color now. Okay, consider as a normal person, if I want to travel, as a normal person, if I want to travel, all right, in that case, I can simply go to the green color zone. There are no restriction, right? If I'm a normal person and I want to go to a particular node or particular area, it has to be green zone only, because I'm not allowed to go in the red zone, because there is a severe infection there. I can get ill. So if I want to travel, I can simply go to the green color zone. With some restrictions, I can go to the yellow color zone also, but I cannot go to the red color zone at all. Okay, there are certain restrictions. All right. Now, consider I am another person. All right, I am another person. Based on my profession, I am different from this one. Okay, earlier I was going as a normal person. As a normal person, I was not allowed to go to the red color zone, but I was allowed to go to the green color zone. But now, consider my profession is of a doctor, all right, or my profession is of a police, all right. I am a law and order person, or I am a healthcare person, all right. I am a doctor, I am a police. So, are there any restriction for me to go to the red color zone as well? If I am from law and order, or if I am from the medical facilities, are there any restrictions for me to go to the red color zone? No, right? If I am a police, if I am a doctor, I can go to any color zone. I can go to the red color zone, I can go to the green color zone, I can go to the yellow color zone. There are no restrictions for me. Alright, so what is this? It means that your red color zone is tainted. Okay, your red color zone is tainted. It means your red color zone is tainted. So what does it mean? Anybody cannot come to this area. Anybody cannot come to this area. If anybody wants to come to this tainted area, it should have some particular tolerance associated with itself. Okay, so if somebody wants to come to the tainted area, it should have proper tolerance. Then only he should be allowed to that area. Okay, Now the same example, what I'm going to do, I'm going to taint my node. Technical word is taint. I'm going to taint some of my nodes, and with that a simple pod cannot get assigned to that node. If I'm creating a simple pod, it is not going to get assigned to that node for whatsoever reason. Okay, it will not allow it because that doesn't have the tolerance. I have to give the tolerance to that pod or deployment or replica set. Then only it is going to assign that pod on that node. Otherwise, if the pod doesn't have any tolerance, it will not allow the pod to get created there. Okay, so this was the story time. Okay, that is over now. Now we are going to see this practically, how it actually happens. Toleration pod. kubectl delete all -- all. Okay, so let's see the definition. The example that I had just given you, I'm going to use the same values here as well. Once everything is going to get deleted, I'm going to taint one of my node. Okay, everything is deleted. Now, if you want to taint a node, all right, the keyword is kubectl taint. Okay, taint is the keyword. Taint node. Consider that I'm going to taint my node 2. All right, kubectl taint node 2, and I'm giving a label kind of this. Zone equals to red. Alright, with that I'm going to give a flag schedule. I'll explain you about the flag, but as of now understand that I am marking that as a red zone with the taint. Okay, you can see that your node 2 is tainted now. kubectl describe node key node 2 grep -i taint. Okay, you can see that the node 2 is having taint with zone equals to red. Alright, so what happens here? kubectl run pod 1 image, sorry, -, image. Okay, I have created pod 1. Let's create multiple pods. Okay, so all these pods are the simple pod, normal pods. They don't have any privilege, they don't have any tolerance. Alright, they don't have any special privileges. So all the 4 pods are created. kubectl get pods -n -o wide. So team, can you see all the pods are going to node 1 only? Okay, because node 2 is tainted and all the pods that I have created doesn't have any special privilege. They don't have the tolerance. So that is why they all went to K node 1. Alright, now let's see this example. Under specification, I am giving tolerance. Okay, under specification, I am giving toleration. It means if the zone is equals to red and effect is no schedule, then create the pods. It means this definition is going to have privilege that it can assign the pod on node 1 also and node 2 also. vi-tol.yaml. Okay, that's my definition. kubectl create -f tall. Okay, your deployment is created. Okay, it created all the pods on node 2 itself. Okay, so it created all the pods on node 2, but you have to understand that it can create the pod on node 2 as well, and it can create the pod on node 1 also. Okay, it has the privileges. So it can go on the green zone, it can go on the red zone, it can go on any zone. If I'm a police person, if I'm a doctor, I can go on any zone. Okay, but as of now, it has created all the pods on node 2. Otherwise, it has the privilege to create the pod on node 1 as well. Okay, now before taking your question, I am going to show you one more thing. Okay, that what is no schedule. Okay, apart from schedule, there is another keyword called no execute. So what is the difference? No schedule means, let me explain you with the same example here. Okay, let me explain you with the same example. Consider it is a red zone area. All right. So in the red zone area, there is a no schedule. It means a new person should not go on that node. Does it mean the people already residing there, they have to leave as well? Okay, so team, what I'm asking you, that in the COVID situation, if any zone is marked as red, does it mean the people who are living there, they have to leave as well? No, right? They have to stay there. They cannot go out, or nobody from the outside can come inside. All right. So it is the same as no scheduling. It means the people who are living at that area, they will continue to live there. No new people should go there. Similarly, in no schedule, that if any pod is already running on the tainted node, it should keep on running there. All right. If any pod is running on a tainted node, it should continue to live there. It should not get reside. So that is the condition of no schedule. The another thing is no execute. Okay, if you are going to taint a node with no execute, okay, it means that you have given the red zone as some other epidemic. Okay, it means you have to leave the place. That place is not suitable for living at all. Consider that this region is going to get flooded. Okay, there is a warning, there is a forecast that this area is going to get flooded. All right, so what happens? All the people who are living in that area, which is under the forecast of getting flooded, you have to leave that place. No new person can come inside. Even the people who are living in that area, they have to leave as well. Okay, because the flood is suspected. So that is the condition of no execute. If there is a condition of no execute, it means you should leave that node immediately. No new scheduling is going to happen, but even the pod which are running on that node, they should also leave. They should also not reside. Okay, consider I am going to taint my node node 2 itself with no execute now. kubectl taint node K8s 2. Again, I'm going to taint my node 2 with serious situation. Okay, this is the label I'm giving. Situation equals to serious with no execute. Okay, your node 2 is tainted. Team, can you see all the pods which were running on node 2 are getting terminated? all the pods which were running on node 2 are getting terminated and new pods are getting created on node 1. 4 seconds ago, 4 seconds ago, again 4 seconds ago. So all the pods which were running on node 2 are getting migrated to your node 1 because it is an emergency situation. This is a serious situation. Okay, so all the pods on node 2 will migrate to your node 1. Okay, you can see all the pods from node 2 have migrated to node 1. Alright, and if you want to remove the taint, okay, if you want to remove the taint, how you are going to remove the taint? Alright, you simply put a minus sign or hyphen sign at the end. Okay, in the same command, just give a minus sign at the end. That's all. Okay, you can see that your node 2 is untainted. kubectl run pod 5 -- image nginx. Okay, still pod 5 went to node 1. Okay, but now it allows you to create pods on node 2 as well. Okay, so team, I will tell you the use case of this. Okay, now I'll tell you the use case of taints and toleration. So before I explain you the use case, let me know if you understand the concept or not. I said this because once I asked you to ask question, you ask for the use case. Okay, so if somebody has the question of use case, don't ask it because I'm going to tell you next. Apart from that, if you have any question, do ask me and I'll answer. Any question, any doubt with taints and toleration, team? Is it clear to all of you or not? Okay, let me tell you the use case of this also. Alright, then you might ask some questions. Team, in your Kubernetes, you have already seen that some pods do run on the master node. kubectl get pods -n kube system and -o wide. Okay, you can see that ATCD is a static pod. I can understand. API server is also a static pod. I can understand. Similarly with your controller and your scheduler, these are your static pods. We have a YAML placed at a particular location, so that is why they are running on this node. So again, taints and toleration doesn't come at that place. But in the class, when I explained the daemon set, right, somebody asked me that your VNet or kube proxy is running as a daemon set, but it is running on the master node as well, right? Your kube proxy, it is also running on the master itself. So when I'm defining a daemon set, it is not scheduling any pod on the master. It is scheduling the pods only on node 1 and node 2. Why it is not scheduling on master? Or why your kube proxy is running on master as well? Why your VNet is created on your master itself? Why is that? Even if you create any pods, they are only scheduled on node 1 or node 2. Okay? Team, try to understand this. Consider this is your master now. Right? In your cluster, you have your node 1 and node 2 and you have a master node. Your pods are always getting created on node 1 and node 2. Your pods are never created on your master. What could be the reason? Anyone? You can schedule your pods on only worker nodes. They cannot get scheduled on your master. Why is that? Shiju, yes. Mosumi, yes, you're right. Arjun, correct. Shiju, Yes, Jagannath. Ankur, yes. Grish. Sanjay, no, you are not correct. Arjun, Aditya, yes. Kushagra, absolutely correct. Team, your master node is tainted. Okay, your master node is tainted. That is why no pods are getting scheduled. If you want to have some pods on your master node as well, you have to give the toleration. Okay, Rishabh, I think you got it. Your master node is also tainted. If you remove the taint from your master node, you can schedule your pod on your master as well. Or if you give some toleration, then your pod can also get created on your master as well. Okay, kubectl get nodes. Kubectl describe node master grep -i taint. Okay, team, you can see that your master node is tainted with master colon no schedule. Okay, this is the taint that is available on your master node. So if you want to schedule some pods on your master node as well, you have to give the toleration with this also. Or you can remove the taint, then any simple pod can get created on your master node. Alright, so if you want to see this as well, we can try to see definition of this. Kubectl describe pod name -n cube system grep -i toleration. Okay, you can see this pod has some toleration. That is why it is allowing it to schedule on your master node. Otherwise, it would haven't done that. Kushagra, in your practical experience, you have to give in the key value pair. This feature your Kubernetes is taking by default, so that is why they have used it like this. Okay, otherwise you have to give it in the key value pair. Some functionality Kubernetes has restricted for the users. All right, so this is the functionality is with Kubernetes itself. Team, any question with taints and toleration now? If it is clear to all of you, we are going to move to the next topic now. How do we provide toleration? Arjun, that I have already shown you. Here you can see, under specification of your pod, you give the toleration. Alright, so this topic is also completed. Alright, so from here scheduling is already done. Node name, labels, node selectors, affinity, taints and toleration. These topics are complete. No, Kushagra, you cannot give it in the imperative way. You have to give it in a declarative way. Okay, this functionality is with the declarative syntax only. You cannot give it with the command line. Alright, my pods are deleted. I'm going to create some pods again. Pod 1, pod 2, pod 5. Okay, all the pods are still going to node 1. Why? Let's type node node 1, sorry 2. Still there is any taint or what? Okay, yeah, still there is a taint. I have to remove that taint as well. Alright, the taint is no schedule. Zone is red. Okay, so this taint is also removed. Again, I have to remove some of the pods. kubectl, delete. If you have defined toleration, then pod should be created on tainted node. Always. No, Primbal, it is not the always case. Okay, as I gave you the example, a police person can go to the red zone also, to the green zone also, to yellow zone also. Okay, so a pod with toleration can go on any node, either node 1 or node 2. It has the power. It can go to any pod node. So it is not that it is going to go to the tainted node always. Adjudicator guys, you are asking when do we mark node as tainted? Is it during the patching, etc.? No, it is not related to patching or some schedule downtime or maintenance. It is just like that. Consider you have a node that has some higher configuration. Okay, you have one more powerful node which has good configuration of your CPU or RAM utilization, and you want to keep it reserved for some particular application pods only. Okay, so all the pods are running on the lower configured machine. Okay, all the normal pods will keep on running on the lower configured machine, but once you have some tainted node which has heavy configuration, okay, then you can assign your pod there as taint and toleration. You can give the toleration. So if it is going to check for the toleration that it can go on any node, now it is going to see that this particular node has the highest number of RAM utilization or CPU utilization. It has higher buffer there, so it is going to get assigned on node which is tainted. So it has the power to go anywhere. Primpal, VBNet is running as a daemon set. Okay, daemon set decides that one pod should be assigned to every node if it is not tainted. Okay, so when we created a daemon set, your master node was tainted. That is why it didn't create any pod on master node but created on node 1, node 2. But once you create the daemon set with the toleration, if you have created a daemon set with a toleration, it is going to place one pod on every node, also on the master as well. All right. Now let me show you the next topic with which I was trying to create the pods. Four, three, okay. Team, now you can see all the taints are removed, so there is no place of toleration. You can see some of the pods are assigned on node 1, some of the pods are assigned to node 2. Okay, you can see that. Now, next topic I want to cover is your training and unquartering. Sumit, you're asking, can we taint any node on the fly? Say if the pods are getting created on particular node, is it possible to taint a node? Sumit, you have to pay attention. Okay, that is already covered. Okay, so team, please try to pay attention. All right, I have already answered this question. If you are talking about taints and toleration, it is also, sorry, okay, my bad. Sorry, Sumit, my bad. I covered the topic from the affinity where you do the required and preferred. My bad. So you taint a node beforehand. Okay, so it is also done with preferred during scheduling and ignored during execution. That is a basic nature of Kubernetes. Okay, that is a basic nature of Kubernetes. So if you have tainted a node when a pod is already getting created, and if you have given no schedule, okay, you have to make sure that you have given no schedule. If you have given no schedule and you have tainted a node when a pod is getting created, then it is going to live there. Okay, it is not going to leave it. It is going to get created even if you are tainting the node at the same time, if you have given the no schedule. But if you have given the no execute and a pod is getting created, it will get terminated and it will get created on some other node. You have already seen all the already running pods were also removed when you give the no schedule. Okay, Sumit, I hope I answered you. Sorry, my bad. I thought I already answered that. Alright, team. So the next topic is still some questions left. Okay, still some questions are left. Shiju, are you talking about this one? This example I have commented out. You can try this, no problem. So it is with the same no execute. When I tainted the node from the no execute, I did it from the command line, right? If you want to do, if you have created a pod with no execute as well, so you can go, okay? You have seen when I give no execute, it means all the pods will be migrated to another node also, which are already running. But still, consider the example that I have given you, okay? This is the area where the flood has arrived. It means all the people who are residing in that area, they should leave. But at least somebody has to go there, right? Some helicopters, some army people who are going to do the rescue operation, okay? So even in the flooded area, some rescue operation take place. So some people from the army, some helicopters are going to go there. But still, that place has to be vacated. So all the people who are living there have to leave. All the pods which are running with no toleration has to leave. But still, some pods can go there with the toleration and with the no execute toleration. It means The people for the rescue operation, the people from the helicopters, they can still go in this region. Yes, Shiju, you can create a pod, but again you have to give the toleration with no execute as well. Is it clear? That is the concept of taints and toleration. So if you have taint, you can give the toleration always, whether it is no execute or whether it is no schedule. What happens to the normal pod? That is the difference with no schedule and no execute. Alright team, so finally are the questions over from the taints and toleration? So let me know, then I am going to move forward. Finally, all the questions are over from taints and toleration. Okay, I guess it does. So please hold on your questions now. Next topic that I want to cover is drain and uncordon. Alright, so team, next question from a very practical way. Consider inside your cluster, your manager has asked you that node 1 is running on the old operating system, okay, or all the old version of your operating system. You have to do the patching or you have to upgrade your node. Alright, consider that you have a node and you have to do some upgradation, you have to do some plan maintenance. In that scenario, you have to bring this node down. Okay, in that case, what is going to happen? Your pods will be terminated abruptly. Okay, so as a Kubernetes admin, you don't want to do this. You want to do this in a proper way, right? You don't want to bring your node down completely, assuming that you have a scheduler, you have a controller. If the node is unavailable, your pods will get migrated automatically to other nodes. That is going to happen. But as a Kubernetes admin, you have to take care of some maintenance activity as well, because I told you your master will keep on trying to communicate with your node 1 if it is unreachable. Okay, so there is going to be some memory pressure, some CPU pressure on your master, because it is going to keep on trying that where is node 1, I have to search it for it. So for the planned maintenance activity, you have to drain a node, okay, so that all the pods will be migrated to another node and your master will be available, will be knowing that you have drained your node willingly because of some maintenance activity. In that case, what happens? You do the drain operation. Okay, so simply you are going to drain your node. For example, kubectl drain K node, let's drain your node 1. What happened? There are some pending nodes to be drained, unable to drain this node. Replica set, replica controller, force. Okay, let's try force command. Okay. When you drain the node, you get the message that node 1 is already cordoned. Okay, it means your node has been drained. Use ignore daemon set to ignore, alright. Okay, it is saying that your kube system, kube proxy and weavenet are running as a daemon set. So if you want to ignore it, you have to use this flag as well. Okay, so you have daemon set, that is why it is asking you to ignore the daemon set as well. Now you can see it is evicting pod 1, pod 4 and pod 3 because these were the 3 pods that were running on your node 1. Alright, so if you want to drain that node, they have to be evicted. So you can see your 4 pods are evicted, kubectl get pods. Okay, other pod should get created on your node 2 itself, but it is taking some time, I guess. Okay, you can see that your node 1 is ready, but scheduling is disabled. It means you cannot schedule any pod because your node is drained. So if you want to do some maintenance activity on this node, you can do that. Okay, my bad. So team, if you create a deployment, alright, if you create a deployment, then it is going to migrate your pod. If you're creating a simple pod, it is not going to migrate. It is simply going to evict them. Okay, that is why you see that those pods are evicted simply. Alright, they are not coming online because you created a single pod. If you have some pods running as a deployment, then they are going to get migrated to your node 2. Otherwise, they won't. Alright, and similarly, you have 2 options here. First is your drain, and second is your cordon. Okay, so it is similar to your no schedule and no execute. Okay, it is similar to your no schedule and no execute. Consider if you cordon a node. Okay, what you saw here, that node 1 is already cordon. It means that your node was cordon already. It means no more scheduling will take place. Alright, no more scheduling will take place. It means if you create a pod now, node 1 will not get assigned. Your node 1 will not get assigned because that node is cordon. So if you do kubectl cordon node 1, it means no more new scheduling will take place, but the pods which are running on your node 1 will keep on running. Alright, but if you drain a node, all the living pods will also get removed. Okay, all the living pods will also get removed. So that is what we have already seen. If you want to uncordon a node, so if you drain a node or if you cordon a node, both can be removed. Both can be removed by uncordon command. If you drain a node, you do uncordon. If you cordon a node, again you do uncordon. Okay, it is going to remain the same. kubectl uncordon k node 1. kubectl get nodes. Okay, now you can see your node 1 is ready. Earlier it was ready, but scheduling was disabled. But now your node 1 is ready. Now if you are going to create some pod, it will get created on your node 1. But if you want to train a node, you have to make sure that all the pods which are running on that node 1 should be running as a deployment or something. Otherwise it will be removed. Alright, any question with drain and uncordon now? Gaurav, you are asking, do we need to set up a CNI again for drain node as bsnet has been evicted? kubectl get pods. Gaurav, here is your answer. Your daemon sets are already running. They are not removed. If you remember when we did the draining node, okay, I asked to ignore the daemon set. It means ignoring the daemon set, that daemon set will keep on living on that node. No more scheduling will take place, but it will keep on running. You can see all the pods were evicted, but daemon set were not evicted because it ignored them. Arjun, you're asking what is a mirror pod, why drain command does not work with mirror pods. Arjun, mirror pods are simply your static pods. Okay. Mirror pods are your static pods. So if your pod is running and being managed by your kubelet only, so definitely your kubelet, your API server has no control over it. So draining the node is done by the kubectl command, but a static pod is not managed by kubectl. That is why it will keep on running. There will be no impact of draining a node. All right. Team, any other question from drain and uncordon? Kushagra, you asked earlier, preferred no schedule means that if your node has both the taints, okay? If your node has no schedule taint as well and it has no execute taint as well, so it is going to prefer first no schedule taint. It will take action based on the no schedule taint. That is about the preference no schedule. Alright team, shall we take a break before moving to next topics? Okay, drain on cordon is also done. The topics which are left for today, we are going to see about the namespace limit, how to take etcd backup, and how about monitoring. Okay, these are the topics left for today. I guess we are not going to cover volumes today because it is a vast concept and it also needs to be done in a continuation. So next topic that we have for today is namespace limit. How many of you remember what is a namespace? Team, how many of you remember what is a namespace? Siddharth, Sanjay, Shiju, yes, absolutely correct. Yes, Arjun, these are the namespaces, right? Nobody else? Nobody remembers what is a namespace? Okay team, so as we have already discussed in earlier classes that a namespace is a logical division of your groups. Alright, consider this is your cluster. Alright, inside your cluster you have multiple namespaces. Okay, So you have multiple namespaces. Consider this is your namespace 1, namespace 2, 3 and 4, and this namespace is assigned to me. Okay, this namespace is assigned to a user called Shub. Okay, Shub came to me because I am a Kubernetes admin. So Shub came to the Kubernetes admin and said that I want a namespace so that I can have my own application isolated from all the clusters application. Okay, so as a Kubernetes admin, I said, okay, I'll create you a namespace and I'll give it to you. But there is a challenge that I have to take care as a Kubernetes admin, right? That maybe because of some reason, his application code might have a larger impact, that his code is buggy, his application is buggy, and it can consume complete resourcing of the node where it is going to get placed. Consider I'm going to create a pod, okay, and that pod is going to sit on node 2. And because of it as a buggy application, it can consume the complete RAM of node 2. It can bring node 2 down, right? So as a Kubernetes admin, I have to ask him a question. Okay, as a Kubernetes admin, I'm going to ask a question to Shub that how much utilization that you actually want for your namespace. Okay, so there are two ways in which the user Shub can answer me, right? He can say on the object level that I want to create 4 pods. I want to create 2 replica set. I want to create 1 deployment. I want to create 5 services. Okay, either Shub can answer me in this way, that you can give the object count. Okay, that is one way. Another way is that Shub already knows that his application is going to consume 5 GB of RAM. His application is going to consume 2 cores of CPU. So either Shubham can also tell me that his application needs 5 GB of RAM, 2 core of CPU, and accordingly I can assign the resource. So in a namespace limit, you can give the resource based on 2 trends. Okay, either you can give at the object level or you can give at the hardware level. Okay, on the object level, you can give the resource quota. Okay, the keyword is resource quota. You can give the resource quota based on the object count, 5 pods, 2 replica set, 5 services, 3 daemon set, like that. Okay, or you can create your service, you can create your namespace based on the hardware resourcing, that it needs 5 GB of RAM, 2 core of CPU, like that. Okay, so these 2 examples we are going to see. Okay, examples are again in the Git repository. This comes under security. Okay, as a Kubernetes admin, I have to take care of the security, that how much access the user is going to get on the namespace. Namespaces, resource quota. All right. First, let's take the example of object count demo. All right, so first I'm going to create a namespace. Okay, the namespace is going to be prod. Okay, that is up to you. You can create the namespace as your own choice. You can create the namespace from the command line also, that I have already shown you. Second is resource quota. I am creating a resource quota. This is the kind, resource quota. And what is a resource quota? The name of the resource quota is going to be object counts. It is going to be a part of namespace called prod. All right. And specs are hard limits. Okay, how many pods? It should create only 4 pods. It should have only 2 replica set. It can create up to 10 services. It can create up to 2 deployments and 2 replica set. So this is the definition of your resource quota of your namespace limiting. Let me take the raw format. kubectl create -f this. Okay, your namespace is created. kubectl get ns. All right, your kubectl, you can see now a prod namespace is sitting here. All right. Now I want to check the resource quota. kubectl get resource quota. Okay, if I'm going to give this much, it is going to give me from the default namespace. So team, I'll suggest you one habit. Okay, I'll suggest you one habit. Whenever you give the commands for a particular namespace, always give it beforehand. Okay, in the examination also it is important to remember, because sometimes you miss the putting the namespace, and because of which you get a different output and you lose your marks in the exam. Okay, so always make it a habit to give the namespace before any command, right after the kubectl -n and give the namespace, so that you don't forget about it, because this is a common mistake in the examination. You are asked to give some output, you give the output from the default namespace and you don't give the -n flag. So always put it right after your kubectl command. Okay, so you can see kubectl -n and get resource quota. So what is the resource quota? Deployment. As of now, 0 deployments are created. Replica set 0 out of 2. Pods 0 out of 4. Same with replication controller, and 0 services are created. First, I will create some pod. kubectl run pod 1 and -image nginx. Always remember to give the namespace first, -n prod. Okay, your pod is created. Let's check the resource quota. Now resource quota is consume 1/4. Let me create another pod. Two pods are consumed out of 4. Okay, now I'm going to create a deployment. kubectl -n prod create deploy. Dep is the name I'm giving to the deployment. -image. Any image you can give. Okay, I'm using HTTPD. Your deployment is also created. Now you can see 3 out of 4 pods. Replica set is 1/2. Deployment is 1/2. Alright. So team, if I want to scale my deployment now, kubectl -n prod scale deploy depth equals to replicas. Consider I want 3 replicas. Okay, team, you can see that I already have a deployment. Okay, I'm going to scale it. My pods limits is 3/4. Okay, and I'm creating 3 replicas. One is already there. It is supposed to create 2 more replicas, but it is going to exceed my limit. So team, will this command work? What do you think? Is this command going to work, or is it going to give me some error? Okay, error warning. All right. Ajirika guess. Mosomi, Shiju, Sanjay. Kushagra spelling mistake. Okay. Okay, Kushagra, now you can tell me. Arjun, you can too. Himanshu, okay. All right, Arjun, got it. Okay, team, let's try this. Oh, it scaled. It scaled. Let's see what is happening here. You can see still your pods are 4/4. All right. So how it got scaled to 3? kubectl-n prod and get deployment. Team, what can you see? Your deployment ready status is 2 by 3. Okay, your deployment ready status is 2 by 3. Up to date are 2 and available are also 2. You asked for 3 replicas, but it created only 2. It will wait if I remove any of the pod. Okay, if I remove any other pod, it is going to get 3 by 3. Okay, so it is going to be in the waiting state. If the limit is reached, it is going to show you 2 by 3. But once you have the available limit, it is going to create the third one at that time. Okay, so team, this is the example for your object count limits. Okay, now let's see another example where we have hardware level resourcing. Okay, so again I'm going to create a namespace, team A, development, resource quota, compute resource quota, team A, and your request. This is the minimum request you are going to have. You are going to have a pods with this request. You can have the maximum request of 1 core CPU and maximum request of 1 GB. Okay, it means whenever you create a pod with request and limit, your request cannot exceed for 1 core of CPU. So whenever you create a pod, you can give the request less than 1 CPU. You cannot give a request as 2 CPU. Okay, similarly, you have limits for CPU and limits for memory. You cannot give a limit to a pod which is higher than 2 GB, 2 core of CPU. Okay, and similarly, you cannot have your pod get created more than of 2 GB memory. Alright, can we combine object and resource based quota? Yes, Kushagra, definitely you can do that. Okay, there are 2 types you can use. So all the things that we are studying independently. Okay, we studied about the probs as well. I told you liveliness prob and readiness prob. I showed you differently, but you can use it collectively. Same with the resource quota. You can use them collectively and you can use it independently. Okay, so team, I have shown you the object level. Alright, and this is your resource level. I want you to practice on this one. Okay, there is no difference. Everything is going to be same. You already know how to put limits. You already know how to put requests to your pod. Alright, we have already covered that part. Resource quota I have shown you from the object count. So this is the part I want you to try at your own. If you face any challenge, do let me know. I'll discuss that again in class. But try it from your end once. Shishu, this is your hardware level resourcing. Okay, this is your hardware level resourcing. It means that I am putting the limits on your hardware, that is your CPU cores and your memory utilization. I am putting the limits here. And what are the limits I am putting? I am putting the limits for the request also. Okay, so whenever you create a pod with a request and limit, okay, request is the minimum part and limit is the maximum part. Whenever you define a pod, so I am putting limits on that also. It means if I want to create a pod inside this namespace, I cannot give the request for CPU core more than 1 core of CPU. Whenever I am going to create a pod, the request for CPU should be less than 1 core, and the maximum limit of the pod CPU utilization should be less than 2 core of CPU. Okay, similarly, if I'm creating the pod and I'm putting the request for memory, I cannot give the request for memory for 1.5 GB or 2 GB because the limit is set to 1. So the request, the minimum RAM utilization you can assign to a pod in this namespace is less than 1 GB. and what is the maximum number of RAM utilization that any pod in that namespace can consume is less than 2 GB. Okay, so Shiju, this is your hardware level resourcing. Alright, so team, any question with namespace limits? Is it clear to all of you? Team, is it clear to all of you? All right. Okay, next question. So team, I told you this part comes in your examination as well. It is important for you in the real time scenario as well. Okay, you have a master component called etcd. Okay, there is a component called etcd, and you know it stored the complete details about your cluster. All right, it stores all the details about your cluster in the key value pair. So it is a database. It is a database pod, and it performs a very important role. So it is important that you take the regular backup of your etcd, so that if it gets corrupted or something happens, you should be able to recover it. Okay, so etcd run as a backup, and it is important to take care of it. So how we are going to do that? We are going to see that now, and do pay attention to this because it comes in your examination as well. If you're going to opt for CKA, there are 90% chances that you get the question for etcd backup. 90% chances. Okay, so do pay attention here. First of all, you already know that your etcd runs as a static pod, right? So team, at what location I can find the definition of this? If etcd is running at the static pod, what would be the location to find it YAML? Question for all of you. Gaurav, Arjun, Kushagra, yes. Sanjay, yes, master, but at what location? Yes, Kushagra, you're right. Shiju, yes, static pod, your etcd runs as a static pod. If you remember the naming convention, first the name of the component and then the node name. That was a naming convention of any static pod. Shiju, it has suffix. Okay. Ankur, Edurika guess, Abhinav, yes, you all gave the right answers. Alright. So team, let's go there. etcd, etc Kubernetes manifest. Okay, so you can see you have a etcd YAML here. Alright, so to take the backup of etcd, there are certain values you have to take care. Okay, this is the complete YAML of your etcd name. Alright, it uses multiple certificates also. Okay, so this is a part of security that we are going to cover next week. Alright, so certificates are there with which your components communicate to each other. Okay, your API server communicates to API, your etcd communicates with any other resource. All the communication happens with some certificates. Okay, so the important part that you have to take care on is 3 components. First is your cert file. Okay, this is your cert file. I'm going to put everything on the notepad. You have to take care of the cert file. You have to take care of the key file. And trusted CA. should have these 3 files with you so that you can take the backup of etcd. Alright, and your etcd by default listens to the port number 2379. Okay, this is the default port for the etcd, and this is the IP address of your master node. Alright, and to take the backup of etcd, you should have the utility called etcd-ctl. Okay, you should have the access to etcd-ctl. Whenever you work with kubectl, it is similar utility that etcd-ctl. By default with Kubernetes, you get the version 2 of your etcd-ctl. But to take the backup, you have to have the version 3 for that. Okay, during the examination, you don't have to worry about it. On the machine you will be giving your exam, they will have etcd version 3 with you to take the backup. Alright, but in our case, we have to have the etcd-ctl version 3 also. So on this repository, you have to go to components, you have to go to etcd. Alright, you have to install etcd-ctl version 3. Alright, so you have to execute these commands. These are the standard commands from the official documentation. There is no need to study about it. Alright, during the exam, you don't have to execute all of them. It will be already executed. Okay, you will have the etcd-ctl version 3 with you. But currently we don't have, so we are going to execute these commands. Okay, so your etcd-ctl is already installed. Alright, now to take the backup. Okay, now to take the backup, this is the command you have to take the backup. Let me have it in the notepad. Okay, so team, you don't have to memorize the complete command, but you should know about the format. First of all, you have to use etcd-ctl API version equals to 3. You have to memorize it. Alright, after that, like you give kubectl command, you give etcd-ctl command. Alright, then you have endpoints. In the endpoints, you have to give the IP address of your master machine, that is your internal IP. This is your master, this is your internal IP of your master. I am going to replace it. 2379 is the default port number. Alright, now you can see CA cert file. Alright, this is the trusted CA file, etc Kubernetes PKI etcd CA cert. It has the standard path, you can see. Alright, next is your cert. In cert, it is the same one, server.cert. Alright, then you have key file. Key file is also the same, you can see. And right, where you want to save the backup. Alright, I don't want to save at this location, I want to save it at the temp location, and give the name, whatever the name you want to give. Alright, so team, for your examination point of view, what you have to remember, I am writing it down. Alright, you don't have to memorize the key path. Alright, you don't have to memorize the cert path. You don't have to memorize the CA cert path. You don't have to remember even the IP address. Okay, and this is just a path. Also, you don't have to memorize the path as well, that will be provided to you during the examination. Consider you are in the examination and they asked you to take the backup of your etcd component. Okay, so you have to remember this format. They are going to ask you, you have to take the backup of your etcd. Okay, and they will give you in the question that this is the endpoint, this is the CA cert file. They will give you the cert file also, they will give you the key file also. Okay, they will give you all the details, that what are the endpoints, what is the CA cert, what is the cert, and what is the key file. They will give you all the details, but you have to remember this format, how you are going to take the backup. etcd-ctl API version equals to 3. Then like kubectl, you have to use etcd-ctl, then endpoint, cert, and key, and then snapshot save, and they will give you the location as well, that where you have to save the backup. Okay, so this is what you have to remember, and then they will give you all the values. And with this, I'm going to take the backup now. Okay, you get the message that snapshot saved at etcd location. This is your backup file. So you have already taken the backup of your etcd-ctl. Okay. So if you want to know how to restore the backup, that is not never asked in the examination. Still, if you want to study about it, you can do that. All right. All the etcd operations are here. All right. How to get your pods, how to get the format. All right. How to restore the backup. It is never asked in the examination. All right. Still, if you want to know more about your etcd utility, you can study it from here. All right. This is how you are going to restore your etcd backup if you want to. All right. Team, any other question? Any doubt in etcd-ctl? How it is going to come in your examination, how it is going to help you? Any questions, any doubt with etcd-ctl? Kushagra 2380 port is not being used. I don't remember any component is using that port right now. Yes, Educas, if you're using EKS, no, in EKS it is being managed by your, if you're using managed service, then your master is managed by your cloud provider. So in that case, you don't need to take the backup of etcd. Ashok, you're asking why we need to install etcd-ctl. If you want to take the backup of etcd, you have to have the etcd-ctl utility. Without this utility, you cannot take the backup of etcd. So if we make an error during taking a backup, is there a way to recover? Arjun, I already told you, if you want to recover the backup of etcd, this is how you are going to restore it from the backup. No, sort of. Once you have installed your latest version, that is all. You don't have to execute these commands again and again every time. This is a one-time activity. If you take the backup, if you want to take the backup at multiple times, then you have to execute this command again and again. Otherwise, installation is a one-time job. Okay, Kushagra, as I said, I don't remember if it is being used anywhere. Maybe it is getting used. Okay, you're talking about this, right? So this is about the internal communication inside your cluster. Okay, when your cluster is set up in the beginning, at that time it uses the port number 2380. Okay, initial cluster setup. Gaurav, can we restore the backup of etcd from one master to another? Yes, Gaurav, definitely you can do that. Primpal, how to verify if the backup is done properly? Just a minute. Primpal, whenever you take the backup, you get a proper message that snapshot is saved here. Okay, if you don't get this message, it means the backup has some problem. Otherwise, if you get this message, you are assured that your backup is proper. No, while taking the backup, if we make mistakes, say with cert, can we have to run recovery operation? Okay, Arjun, if you have given any details by mistake which is not right, okay, then you can take another backup and remove the previous backup. If you give any details that is incorrect, then your backup is corrupted. It won't restore it properly. Okay, so you have to make sure that you provide all the details properly, then only that backup will be proper and it will be restored. If you give any details wrong, then your backup gets corrupted and you won't be able to restore it properly. Ashok, you want me to explain the syntax of restoration? Okay. So Ashok, this is the syntax, alright. First, again, you have to give the the version number, then etcd-ctl command. Then you have to use a keyword called snapshot restore. If you want to do the restoration, you have to give the restore keyword. Then you have to give the location of your backup. Alright. Another keyword is initial cluster. You have to etcd restore. This is the IP of your master component. Master node, okay. This IP is going to be a master internal IP, and then you have to use a port number 2080. Okay, so as I told you in the manifest file, 2380 is the port number that is used during the initialization. So if you are initializing your etcd again, if you are restoring, it means you are initializing it again. All right, and then initial advertised peer URL is again going to be same, your internal IP and the port number 2380, and then name etcd restored if where you want to store your etcd backup. All right, this is about your syntax of restoring your backup. So if we create a new cluster, restore this backup, will have the identical to own one. Yes, Kushagra, that will be, but your all the components won't be there, so it is going to put you through some conflicts. Okay, because your new cluster should have all the components also that were running on the previous cluster. So it is going to give you some conflicts. Kushagra, for etcd backup, this is the only option you have. Okay. Ashok, your etcd is a database that stores the value in the key value pairs. Okay, so it takes the backup of that part. Your database has some key value pairs, it has a table structure. That table backup is taken in your etcd-ctl. Team, you don't have to drill down it that much, okay? You don't have to drill it down to that level. This is important for your examination point of view. Otherwise, it is always managed with your managed cluster itself. Okay, at the enterprise level, you are mostly going to work with the managed cluster, whether it is your GKE or EKS. All right, so etcd backup is managed internally. You don't have to worry about that. Satish, if you want to take the backup of another's cluster etcd then you may have to make sure that there is a connectivity between both the masters of different cluster. Okay, You should be able to connect to that. Also, there is some security features. You have to use context. That is a part that we haven't discussed so far. You have to also manage about the context. That is a part of security we are going to cover next week. All right. So if you want to connect to another cluster from your machine, you have to make sure that your contexts are in place. Prempal, is there a command to verify the etcd backup to double sure that backup is not having any issue? Usually we do it in the database backup activities. Prempal, there is a command, but currently that is missing with me. Okay, there is a command. All right, I'll provide you that command tomorrow. Okay, do remind me tomorrow. I'll definitely share the command with which you can have the check of the backup. Kushagra, as I said, port number 2380 is used during the initial setup. Okay, whenever your etcd or other components of your master are getting initialized. Okay, at that time that port is being used. So similarly, when you're restoring your etcd, it means you're initializing your etcd once again. At that time, your 2380 port number is used. Okay. So team, this is all about your etcd. Okay. This is all about your etcd. If there are no more questions, we are going to move to the next part. That is another interesting part, you can say. All right. Namespace limit is completed. etcd backup is completed. Last part for today is your monitoring. Okay. We are going to see how you're going to monitor your components in your Kubernetes. All right. So team, if I talk about on a general level, okay, you have a Linux environment. If you want to see the real-time consumption of your resources, what are the commands that you use? On a Linux box, if you want to see the utilization, current utilization, what are the normal commands that you use actually? Kushagra, yes, got it. Akhil, correct. Rahul, Arjun, Kushagra, okay, got it. All right. So team, the basic command that I'm getting from all of you is the top command, right? If you want to check the real-time utilization. Okay. So can we use kubectl top command? Kubectl top nodes. Okay. It says some error, metrics API not available. Format to get metrics, it is not available. Okay. So it is giving you some metrics is missing. Okay. So what is it? So team, in earlier days, when you used to use Kubernetes, Kubernetes used to come with a heapster. Okay. If anybody of you knows, earlier days, Kubernetes provided you heapster component so that you can have the real-time utilization of your resource. If heapster was there, you could have done kubectl top commands and you get the output. But heapster was removed in the further releases with Kubernetes. After that, Kubernetes provide you an optional item called matrix server. Okay, you can use matrix server so that you can see the real-time utilization. Okay, now it is not a part, but if you want, you can have that part. Let's try to install your matrix server. Okay, your main repository, it is a part of your monitoring. Okay, this is your matrix server. So team, again, this is from the official documentation. If you're going to find it, you can find it on the Kubernetes website as well. Okay, everything is a standard. Nothing is created by me only. I have just organized it at the one place. All right. So you have multiple files here. You have to execute all the files all together. Okay. So what I'm going to do, I'm going to clone this repository on my local. Git clone my repo. Okay, it is cloned. All right. Matrix server. All right. So team, if you want to execute all the script at once, you have to use kubectl create -f and dot. Okay. All the YAML files at the present location will get created. Okay. So you're going to see multiple components are going to get created. Okay. Your cluster role binding. All right. API server, service account, deployment, services, cluster role again. Okay, so multiple components are created here. With the help of all these components, now you can use kubectl top command. Let's try that. Okay, it takes some time. Okay, metric server takes some time because you already know whenever you create some pods, it takes some time. Matrix not available yet. You have to wait for some time. All right. So team, it takes some time to create all the components. We are going to wait for that. All right. In the meantime, if you have any questions, you can ask. So this is the matrix server that you have to install so that you can use a top command and see real-time utilization of your resources. Kushagra, yes, you can namespace the. It depends. Okay, if you want to namespace a matrix server, there are multiple components that cannot be namespace. Okay, you can see multiple components are here. If you talk about deployment, you can namespace it. If you want to have services, you can namespace it. Okay, but you don't know about service account as of now. You don't know about the cluster role binding. These are the things that are at the cluster level. These cannot be namespaced. Okay, so it depends like that. Adhirika, guess, I suppose there is no matrix server installed in EKS. If you want, you can install it, but I don't recall that it is installed by default. Yes, Mosami, if you want, you can have it on the managed cluster as well. So team, now you can see that your matrix server is installed. You can see the real-time utilization of your nodes. How much memory consumption is there, how much memory is there consumed on the percentage level and on the figurative. Similarly with the CPU as well. You can put it on the watch as well. Okay, it shows you real-time consumption. Similarly, if you want to do with the pods, you can do that with the pods as well. Okay, real-time consumption. How many pods are consuming what resourcing. Okay, so this is about your real-time consumption with your matrix server. Okay, so that's all about it. After that, this is a very basic level of monitoring. Okay, at the enterprise level, you cannot depend on the top command simply. You need something more than that. Okay, for the same purpose, Prometheus is the tool that came into picture to provide you monitoring. Okay, on the GUI base, on the dashboard base, Prometheus came into picture to give you a good level of monitoring. Okay, now we are going to set up your Prometheus. Here is monitoring. Alright. Before Matrix Server, you have Prometheus as well. Alright. And there is a file called prometheus.yaml. Okay. It also contains so many items. Okay. So this is going to get created inside a namespace. First, you're going to create a namespace. ConfigMap, you don't know as of now. Alright. A lot many things are there. You create also cluster role that you're not aware of right now. Cluster role binding. Deployment you are going to create. You know about that. What is a deployment? You're going to create some services. All these components are going to get created if you want to work with Prometheus. Alright, let's create it. kubectl create -f prometheus.yaml. Okay, so now team, you can see that your service Prometheus is already created under the namespace of monitoring. Alright, so I have to do kubectl get svc -n monitoring. Okay, you can see Prometheus service is created as a node port. It means that I can use this port number on the web browser with any of the IP. I'll take the external IP of my master. I'll paste it here. I'll use a port number. Welcome to Prometheus. Okay, so team, this is your Prometheus dashboard. Alright, whatever you want to query, you can query from here. You can give your own query or you can use a query that is already provided by Prometheus. Okay, whatever the resource limitation or whatever you want to check, you get a lot of details here. Alright, whatever you want to see, you can see it from here. For example, if you want to see anything related to your pods, you have pod commands here. Okay, this command will be provided here. You do the execute. This is your console output. If you want to see the graph output, you can see the graph output as well. Alright, you can reduce the duration. You can provide the timeline and your graph will be available to you for a lot of components, whatever you want to have it. Okay, kubectl node names. The Prometheus is not a very good tool, team, to be very frank. Underscore node name, kubelet underscore node underscore name, execute. Okay, you can see the node name as well. Alright, you can see the tags also, the labels that we provided. Okay, you can see the instance name as well. Alright, this is your master component, this is your worker node 1. Alright, so all the output, all the type of monitoring, you can do it from the Prometheus as well. Okay, so this is a Prometheus. It reads all the details about your Kubernetes components. Alright, you can see all the graphs, total request, execute it. You can see the graphs as well. Okay, so you can see the graphs just like this. A lot of monitoring you can do from Prometheus like this. Alright, team, any question from Prometheus or monitoring as of now? Primpal, there is no way to take the cluster level backup. Okay, cluster is a combination of your virtual machines from the cloud provider. If you want to take that, it cannot be done by Kubernetes. You have to use some backup utility from your cloud provider. Yes, Adhirika, guess it is a free tool. We are not paying anything to see all this. Sarath, you are asking what is the difference between Kubernetes dashboard and Prometheus. Sarath, Prometheus is used for the monitoring purpose only. Okay, it is going to monitor your resources. It is going to alert you whenever required. You can set up the alerting setup also. Okay, so that can be done by Prometheus. Kubernetes dashboard is something different. You can also manage your resources from Kubernetes dashboard. If you want to create some deployment, if you want to create some pods, you can do that from the Kubernetes dashboard, but that cannot be done by Prometheus. Does it store the metrics or it shows only the real-time data? Kushagra, it stores the data, right? That is why you can see the time frame also, right? It stores the details as well. Gaurav, monitoring part is not for your examination point of view. Okay, during exam you don't get any question related to your Prometheus. Okay, they already provide you metric server install. They can ask you about the resource utilization of any component in the real time. You can do that with kubectl top command, but they are not going to post any question related to Prometheus or something like that. Prempal, your Prometheus interacts with your master only. Okay, there is a component called CA advisor. Okay, when you install your matrix server, there is a component also installed called CA advisor, and this component is installed on all the nodes. Okay, and with the help of your kubelet, CA advisor provide all the details to your master. Okay, and all the details are stored at the master. Your Prometheus interact with the master and get all the details from there. Sanjay, it is not a manual monitoring. You have to set it up once. All right, after that you can set up the alerting as well, that if any certain threshold is reached, then you have to alert. All right, it is all about that. You can set up your monitoring once and then it is going to monitor automatically. Adhirika, guess what do you mean by custom metrics? It is a metric server that is going to do the monitoring. What you want to customize it? You can customize the monitoring from the dashboard from Prometheus if any changes you want. It have all the things that you want to monitor. Akhil, it is CA advisor that is installed on the worker nodes, which provide all the details to master via kubelet. Okay, so Team Prometheus is your monitoring tool, but you can see that graphs are not very proper to see. They're not very delight to the eyes. Okay, so in that case, we use Grafana as well. Okay, so what is Grafana? Grafana is a visualization tool. Grafana is not a monitoring tool. Grafana is a visualization tool. Prometheus monitors, and if you want, you can pass your Prometheus details to Grafana so that you can have a better visuals on your monitoring level. Okay, so if you want to have your Grafana as well, you can have that. Okay, at the same location you have Grafana as well. kubectl create -f Grafana. Okay, you can see your Grafana service is also created. This is your Grafana UI. This is the port number. Let me have the IP. Team Team, welcome to Grafana. The default password and username is admin. Then you can change the password. Alright, after you have that, install Grafana is done, you have to add the source. Okay, your source is going to be Prometheus. It is going to get the details from Prometheus. And you have to provide the URL of your Prometheus dashboard. I'm going to pick it up from here and paste it here. Alright, that's all. You don't have to change anything. Save and data source is working fine. You get this message. After that, you have to click on the dashboard. Alright, now you can see this step is also done. You can create the dashboard. You can add a query, whatever you want to monitor. Okay, all the commands that you can take it from here itself. Take your Prometheus command, paste it here, and enter. Now you can see the output here. Alright, you can reduce the time interval. What kind of visualization do you want to have? And it provides you a lot of settings. Okay, you want to create alerting, you can create the alerting based on your thresholds. Okay, you can reduce the timeline, last 30 minutes, last 15 minutes. You can save the dashboard also, so that it is going to come on your dashboard front page. Alright, you can set the refresh rate, that after how much time your graph should get updated. Okay, so just like this, you have a lot of functionality that you can do with your Prometheus and Grafana all together. Okay, and to be frank, this is a part mostly done by the monitoring team. Okay, as a Kubernetes admin, you are going to set up Prometheus, you are going to set up your Grafana, then the monitoring threshold are set by your monitoring team in your organization. Okay, Prometheus Grafana is not going to help you anywhere in the examination. During your practical experience, you have to set up the dashboard, and the setting up the monitoring and alerting system will be done by your monitoring team. But you should know that how you are going to see everything and all this. Ashok, there are plenty of monitoring tools. Okay, you have Datadog, you have Logic Monitor, you have Nagios. Okay, so it is completely your call what monitoring tool that you want to use. But Prometheus and Grafana are the most widely used if you are dealing with Kubernetes only. Can we use this Prometheus grab data and visualize it in Grafana? Okay, I think this is an old question, Satish. We have already done that. Oh yeah, all of the questions are old. I think I missed it earlier. Prometheus is total manual mentoring, or is it work on the command line? Sanjay, you have seen that if you want to set the alerting, you can set also. Otherwise, if you want to see the manual monitoring, you can also do that with the Prometheus. And if you want to set the threshold, so that it can alert you automatically, you can do that also with Prometheus also. Saurabh, you're asking how to connect with Prometheus and monitoring tool. You want me to explain again? Okay. So you have to come to this repository, Educa Monitoring Prometheus. All right. First of all, you have to go to the metric server. You have to install all these files. Okay, all these components should get created. Metric server should be installed first. Then you have to go to Prometheus and you have to execute prometheus.camel. You have to execute these two steps to have your Prometheus dashboard. How we will start with Kubernetes dashboard. Gaurav, I'm going to show you the Kubernetes dashboard in the 7th class. Okay, it means next Saturday I'm going to show you Kubernetes dashboard. That is a part of security. When we'll discuss about the context and security certificates, that is scheduled for Saturday, coming Saturday. Then I'll show you about Kubernetes dashboard as well. What is a good monitoring tool for K8s cluster? Gaurav, Prometheus and Grafana, as I told you, are the most widely used. Is there a website where we can learn more about Prometheus and Grafana? I am more interested to add various metrics and write custom rules. Arjun, definitely, they have official documentation on their own website as well. All right, so you can go there and study more about it. Okay, this is your Prometheus official website. You can get all the documentation here. And if you talk about Grafana, all right, there is Grafana as well. Everything you can find it on the official documentation. So that data is stored in the container itself or the volumes is mounted for it. Kushagra, all the data is stored with the volumes inside your pods. Okay, that is up to you if you want to create a volume or not. But whenever you create a container, there is a volume inside it. It is not defined properly, that is a different way. But whenever you have some container, you are going to store some data. So definitely some volumes are there. You're not defining them explicitly, that is your call. Akhil, Prometheus collect metrics based on the node exporter installer, right? Yes, Akhil, you are correct. Edureka guess, yes, we can do that. If any node goes down, we can set up alerting for that as well. We can do that. Okay, Saurav, I have repeated plenty of time how to create your dashboards and monitoring. Okay, I'm explaining you once again. You have to go to Edureka and monitoring. Here first you have to install your matrix server. Go to matrix server and create, have all these YAML executed. kubectl create -f dot. Once you have all these files at your location on your server. Alright, once it is done, go to Prometheus and then you have to execute prometheus.yaml. If you want to have Grafana as well, execute grafana.yaml as well. That's all. Can we also centralize containers and put logs in Grafana? Centralized container as in what, Arjun? I'm not sure what you're trying to convey. Centralized container? Yes, Mosami, as of now, your Edureka portal is showing you classes till tomorrow only, okay? But don't worry, once your next week starts, you will see your class 9 and class 10 link as well, okay? As of now, you can see only 8 classes. Next week, you are going to see your class 9 and class 10 link also, that we are going to cover next week. I meant to ask that matrix can be kept permanently by us or it get erased when the container pod series started. Kushagra, if you have used a explicitly defined volume, then it is going to store it. Otherwise, if your pod gets down or gets deleted or gets restarted, your logs will be gone. Your Prometheus and Grafana dashboard output will also be gone. Okay, so as of now, whatever that we have seen practically, it is going to remove it if your pod restart. If you want to store your data, you have to use volumes. We can have logs of all the pods and containers at one place in Grafana. Arjun, Grafana is a visualization tool. All the logs are getting stored in the Prometheus only, and it is just visualizing whatever is stored in Prometheus. Grafana doesn't store anything in itself. It is just a visualization tool. Prometheus is a monitoring tool.
this Grafana can give you details about all the pods. Okay, as I told you that Prometheus has a lot of queries. You can use any query and you can see the output there. Alright, team, I guess this is all we have for today. Okay, we have covered all the content that we were supposed to cover today. Tomorrow we are going to study about the volumes. Alright, so team, how was the class for today? Did you understand the concepts? I tried to give you as many real-time experience or examples I can give you. Great. So team, I do get all your feedbacks and I always appreciate whatever feedback you provide. I read each and every feedback. So keep providing that. It helps all of us. Alright. So we are done with today's content. If you have any question, you can ask or you can stay. If you want to get unmuted, you can do that. Otherwise, we are done for today. You can mark your feedback and leave for today and we'll see tomorrow. Siddharth, how about node upgrade train coordinate activities manage cluster? Is it taken by the provider? No, Siddharth, if you want to train some node, if you want to update some node, you have to do it at yourself. The way I have explained you in the managed cluster also. Because in managed cluster, your master is only managed. Okay, tomorrow we are going to create a managed cluster also. Okay, tomorrow we'll see a managed cluster as well. So in managed cluster, your master is managed by your GKE or your AWS or Google Cloud, but your nodes are managed by the master. You have a command line console from where you can manage your worker nodes. So in managed service also, your master is only managed. You have to manage your worker nodes. If you want to train or coordinate your nodes, you have to do that. Alright team, so I hope all the topics from yesterday were clear to all of you, right? We studied how we can do the monitoring, how we can train and uncoordinate our nodes. We studied about the schedulers, how many type of schedulers are there, how we can schedule our pods, right? We saw how we can limit our namespaces, how taints and toleration work, right? That is all we discussed yesterday. Any doubts, any questions that you have from previous class? We can discuss it now before we start for today's agenda. Any doubts or question for today before we start? Okay, if not, then we can start for today. All right. So team, today what we have with ourselves is today we are going to study about the storages, how we deal with storages in your Kubernetes. All right, we are going to see what is your empty directory, what is your host path, what is PVC, that is your persistent volume and persistent volume claim, what are your storage classes, ConfigMap, secrets, cloud disk, service load balancer, StatefulSet and headless services. Okay, so team, out of all these two odd topics, the cloud disk and service load balancer never comes in your examination. Okay,
Cloud disk and service load balancer never comes into your examination. Why is that? The reason is the cloud disk and service load balancer are a part of your managed Kubernetes cluster. Okay, the cluster on which we are working, we can never use cloud disk and service load balancer. We have to create a managed Kubernetes cluster like your GKE or EKS. Only then we can use cloud disk and service load balancer. Apart from that, on normal cluster you cannot use it. Okay, so as we have this in our agenda, I just wanted to show you, because it never comes in your exam. It doesn't help you with your CKA, but for your practical life you should know about it. That is why I have included this. And for the same reason, we have such topics that you cannot do on these machines. We are going to create a GKE cluster as well. Okay, so team, on your Google Cloud, okay, you have to go to this location, and here you have something called Kubernetes engine. Okay, I'm telling you how you can create a managed cluster. Go to Kubernetes engine and go to clusters. You have to enable the billing. So team, all the topics we can practice on the normal cluster. But cloud disk and service load balancer, we need GKE. That is why I am creating the machine today. Alright, you have to create the cluster. You have to use the GKE standard one. You can close all of this. Okay, first thing first, you can give any name to your cluster, whatever you want. Okay, this is your cluster name. You can choose any region. Okay, any region you can choose. I'm just using it just like that. Okay, and which Kubernetes engine is currently with you? Okay, you get a list here, but as of now you can see only one is visible. That is the previous stable version. Currently your Kubernetes has 1.21 version, but GKE has 1.20. So you can choose this one. That's all. Okay, you cannot see where are your nodes configuration. For that purpose, you have to go to default pool. Click on default pool right away. Alright, and here you get the number of nodes. Okay, I need only 2, I don't need 3, so I have made it as 2. After that, go to nodes. You can choose that your node should have which operating system. Okay, from this list you have to choose the Ubuntu one, Ubuntu with Docker. Here you don't get the option to choose the Ubuntu version. Okay, that is managed automatically at the backend, but we need Ubuntu flavor. What configuration your worker node should have, that we have already seen when we create normal instance. Alright, it provides 100 GB. Okay, that is not required. We need only 10 GB. That would be enough for our practice. Okay, apart from that, you don't have to make any changes. That's all, and you can go and create your cluster. Insufficient region quota to satisfy the request. Okay, it is saying that region quota is exceeded, so we have to change the normal region quota. Just a minute, let's see, where is your region? Cluster basics. Let's change our region to Central F. Okay, it is not length for the quota. Okay, so it took the east one. So team, that was because I already have some VM machines in the same region. That is why it was not allowing me. So you can try different zones or different regions as well. Okay, so it might take a while. Till that time we can start with our agenda. Okay, this is the agenda that we have for today. Alright, so team, let's get started. Team, consider this is your pod. Okay, this is your pod. And inside your pod, you have some containers. Okay, you have container 1. You might have 2 containers as well. Okay, that is completely up to you. But the thing is, consider your application got hung. Okay, you have one pod and you have one container inside. And because of some reason, your container got hung. In that scenario, you have to restart your pod, you have to restart your container, alright, you have to delete your pod and you have to recreate it because it is hung, it is not responding, you cannot troubleshoot it, you have no options. In that case, you have to restart your pod. But in that case, you will get a new pod, you will get a new container and your logs will be lost as well. So you cannot troubleshoot it after you get the restart. Alright, so that is a problem with us. We cannot figure that what is wrong with our container, what is wrong with our application. Is there something wrong with the application code? Is there something wrong with the container? You get no logs once it is restarted. Right? So that is a problem. Okay, to deal with such problems, we have volumes in our environments. Okay, any environment that have containers does have the concept of volumes, whether it is your Docker, whether it is your Kubernetes, everywhere. Okay, you get a concept of volumes. In Kubernetes as well, we do have that. Okay, so it is used for the same purpose. Like, consider that you have a container and you want to write your logs at some location, you use volumes. If you want to share some data, you use volumes, so that even if your container dies out, your pod is restarted, your content has to be remain there. It is not lost. Okay, for the same reason, we have different type of volumes in Kubernetes, like empty directory, host path, PV, PVC, and storage classes are different topic. Cloud disk, these are the storage option, these are the volume options we do have in Kubernetes, and we are going to study about them one by one. First is your empty directory. So what is an empty directory? Consider you have a pod, okay, and this is a multi-container pod. You have 2 containers inside a pod. Okay, we have already understood about the concept of sidecar container, ambassador containers, right? So what happens here? One container is going to do some operation and second container is going to have your application front end, right? So team, that is the case here. We have 2 containers inside a pod, and consider one of your container is going to have something from GitHub repository. It is going to cook your war file, and then it is going to pass your war file to your second container. Okay, consider this container is of your Nginx, which is going to have your web page, and this is some your CentOS container. In CentOS container, you are going to cook something. You are going to clone your Git repository. You are going to create your war file. You are going to build your artifact. That all work is going to be done in your first container, and then your first container should pass on that war file to your second container, right? But how is this going to happen? How they are going to share the data directly? They cannot. At that place, your volumes come into picture. Okay, consider this as being your volume. Alright, so what will happen? Your CentOS container is going to share its content, its war file or any other file to the volume, and that volume will be accessible to your Nginx container as well. Okay, if I take a layman example, consider you work in your organization, right? You work in a team. So if you want to share something within the team, whether it is your outing parties, pictures, videos, all right, you want to share some presentation within the team, what do you have in your organizations for that? So team, what do you have in your organization? What do you have in your team if you want to share some outing pictures, some party videos, or some kind of presentation on anything? If you want to share something within your team, how do you do that? Yes, Girish, Edurika guest, Gaurav, Anil, yes. Rishabh, Satish, Akhil, yes, right? We deal with a SharePoint. We have a shared drive where we upload our items so that everyone can see it. Yes, Joydeep, exactly. Okay, so consider this volume as a SharePoint. Okay, any container can share any content with this SharePoint, and it will be visible to any other container inside that particular pod. And this is called your empty directory. Okay, it provides sharing the content with the containers of a single pod. Important point is, inside a single pod, you cannot share anything with empty directory cross pods. Okay, all the containers on the same pod can share the data with the help of empty directory. No other container from different pod can access it. Okay, so team, let's take an example for this one. It will be more clear to you. Alright, so you have to go to the repository again. Here you have something called storages. Alright, here is an example of empty directory. Okay, we have two examples, you can choose anyone. Now let's try to understand this. What is here? I'm simply going to create a pod. Okay, I'm going to create a multi-container pod. This is the type pod and this is the name of my pod. Under this specification, I'm going to give the definition of containers. You can see I'm going to create one container that is of CentOS. Alright, the name of my container is my volume container 1. It is going to do some echo operation and then it is going to sleep for some time. You can see there is a volume mount. It means I am going to mount a volume inside a container as /demo. Okay, so team, whenever you read the keyword volume mounts, you have to be sure that it is a part of inside container. Volume mounts, it means you are doing it inside the container. So inside the container, you are mounting some volume, and then that mount path is going to be /demo. So if you log into your container, this volume will be visible to you as /demo. And which volume you're mounting? Demo volume. Similarly, in the second container, that is of your Ubuntu flavor, okay, it is also going to do some echo operation and sleep, but the volume which will be visible inside this container will be visible as /demo2. But you can see we are using the same volume, okay, demo volume here and demo volume here as well. We are using same volume, but in first container it will be visible as demo1, in second container it will be visible as demo2. Third container is again your Alpine, okay, we are doing the same operation, but it will be visible as demo3, but it is the same volume, demo volume. But where this demo volume exactly lives, for that we have to define the volume as well, okay. This is a different component now. I am defining a volume. The name of the volume is going to be demo volume, and what type of volume it is empty directory. So whenever you create a empty directory volume, this is the way you are going to define it, okay. Empty directory colon close brackets, closed curly braces, that's all, okay. So team, I am going to take the raw format of this one, and before I start, let's see if our cluster is ready or not. Okay, you can see your cluster is ready. You can click on your cluster. Alright, you get all the details about your cluster. Alright, we can come back. You get 3 dots, you can click on connect. Okay, it is asking you that you want to use it in the Cloud Shell. So yes, I want to use it in the Cloud Shell. We can copy the command it has provided. So team, in GKE managed cluster, okay, in GKE managed cluster, you don't get the access to the master, okay. In GKE cluster, you don't get the access to your master. You just get the output of a Cloud Shell. It provides you a browser where you can run all the commands that you want to run on the master, but it doesn't allow you to manage your master. Okay, you have just a master terminal. Alright, as of now I am working as different user. I want to work as a super user, that is root, and then I am going to paste what I got earlier. Okay, that is the content I have pasted. Now I am connected to my master. So team, this terminal is not very big, it is not good visible. So here you can click open it in a new browser. Okay, so I have maximized it. kubectl get nodes. So team, you can see you have 2 worker nodes ready with you. Okay, you can see role as none. It means it is your worker nodes. So you don't get the output of master node as well, because master hasn't created as a node. It is being managed by Google at the backend. So if you do kubectl get nodes, you get the details only about your worker nodes, not about your master in the managed cluster. Okay, so this is done. Now we are going to create some of our components. I am going to create a pod with empty directory. kubectl create -f. Okay, your pod is created. kubectl get pods -o wide. Okay, currently it is creating your containers. So team, this is your node name. Okay, when we created, the node name was a little better, K-node1, K-node2, we can name it. But when Google creates your nodes, it gives such names, lengthy one. So we cannot do anything with this. Okay, so team, you can see that your my volume pod is created. 3 containers are running inside it and all are in the running state.
So everything looks good here. All right. Now what we are going to do, we are going to connect to our containers inside our pod. All right. So same way, kubectl exec -it. All right. Your pod name -c and your container name. Let's connect with our first container first. My volume container 1. -bash. Okay, so team, now I am inside my container. If you want to see about your volumes, df-h you can do. Okay, you can see a demo mount point is there, right? A demo mount point is there. As of now, it has no content. Okay, so what I'm going to do, I'm going to create a file here. Okay, this is my CentOS. So CentOS file.txt. Okay, so at the demo location, I have created a CentOS file. Let me come out of this container, Control PQ. Let's connect with our second container. Now I am connected to my second container of the same pod. Here my volume was named as demo2. You can see it. Let me go to this location. So team, now you can see the CentOS file that I created for the from the first container is also accessible to your second container. Your second container was of Ubuntu flavor, right? Now let's create a file here as well. Touch Ubuntu file.txt. Okay, now you can see there are two files, CentOS file and Ubuntu file. Let's come out from this container as well. Now I'm going to log into my third container. Okay, it didn't log in. Okay, so team, third container is your Alpine. Alpine is the lightest image you can have. And why it is lightest? Because it doesn't have all the libraries itself. So if you want to log into your Alpine, you cannot log in using bash. You have to use a shell prompt. Okay, so whenever you use Alpine image, always use shell, not bash. It doesn't allow you with the bash. See, I'm logged in. df-h. We have demo 3. Let's go to demo 3. Okay, so team, now you can see CentOS file and Ubuntu file both are present here as you have used the empty directory. Okay, I can come out from this. So team, this is the concept of your empty directory. Okay, it is used for sharing the data across your pods in the same, across your container within the same pod. All right, but the challenge is still a little bit there. Okay, now you can do the sharing, but once your pod goes down, once your pod is restarted, your volume is again gone. Okay, it is going to overwrite it. It is going to clean it up. Okay, so if your pod gets restarted, all the content is gone. It is just used for the sharing purpose within the pods, but it can not store the logs, because once your pod is gone, your volume is also gone, because it is inside your pod. Okay, so if anything happens to the pod, same thing happens to the volume as well. It is only providing you the sharing capabilities, that's all. Now, next part. Still we have the problem, we cannot share the logs. Okay, we cannot store the logs, because if something happens, your logs are also gone. So that also we need to address. To address the same concern, we have the next concept called host path. If we want to have our volume that doesn't live inside the pod, it lives outside your pod. Okay, it lives outside your pod, so that if you store the logs and if you have to restart your pod, your volume is going to remain there.
Okay, there is not going to be any impact. Volume will survive, your logs will survive, only your containers and your pod will get deleted and get restarted. Your logs are going to remain there. So if you want to store your logs outside your pod, you use host path. Host path simply means any location on your worker nodes where your containers are running. Okay. For example, that you have defined a host path of temp/data. Okay, so what is going to happen? All the container logs will be stored at a location called temp data of your worker node where your container is getting created. So if your pod goes down or if you delete your pod as well, your host path is going to remain there and your logs are going to remain there. No impact of deletion of pod. You have the logs. Okay, so that is what you have in host path. Let's see how it practically happens. Okay, we have the last example here. Volume, host path, pod. Alright team, so what I'm doing, I'm just defining the pod. This is the name of my pod. This is the name of my container. I'm using the Tomcat image. So team, if you have used a Tomcat container, you know that this is the logs location. Okay, where the Tomcat stores its log is a location called user local Tomcat log. Okay, so I'm mounting some volume, and I told you volume mounts means that your container will have the volume mount. This is the location inside your container. Ashok, don't worry, I'll explain you again. Let me show you an example, it will be more clear to you. Okay, so earlier what I did, I mounted a volume. Okay, this is the name of the volume and this is the mount path. So this mount path will be inside your container. Okay, this path is inside your container. And what is the volume that I'm mounting? I'm mounting the volume name host path volume. Alright, so this is the definition of your pod. Now I have mounted a volume name as host path volume. I have to create a volume as well. So now this is my volume definition. Okay, under volume definition I have given the name of my volume, that is host path. So what exactly host path is? In the previous example you saw that this is a empty directory in the previous example, but now this is host path. It means this path will be a location at your worker node. And what is going to be path? Temp logs. Okay, a location on your worker node as temp log has to be there where the volume will be mounted to this location. Okay, so team, inside your container you have a location user local Tomcat logs and you are mounting this location as a volume, and the volume you have defined as a host path. Okay, type is directory, it is an optional field. You want to give, you can give. If you don't want, you cannot, you can skip it. Okay, let's take the raw format of this one. I'll copy it. kubectl create -f. Okay, so team, you can see that your pod is getting created. kubectl get pods -o wide. So team, you can see it is in container creating state. It is not created yet. And let me tell you, it won't get created. Okay, let me tell you, it won't get created. It is going to remain in the same state, container creating. Okay, so team, it is not getting created, right? How do I see the issue? How can I know what is the issue? Some of you wanted to do the troubleshooting. Let me know how to troubleshoot this one. Why it is not getting created. Rishabh, Edutica guest, Shiju, you are asking for kubectl log. Kubectl logs provide you the logs from the container. Your container is not getting created itself. How you can check the logs? Kushagra, yes, good one. Kushagra, you gave the right answer. Abhishek, you also. Gaurav, yes, to some extent you are right. Moswami, you too. Jagannath, correct, you are absolutely correct. Aditya, correct. Chandrasekhar, absolutely correct. Satish, yes, you are too. Ankur, absolutely correct. Okay. So team, this is the part where you do the troubleshooting. Okay. You see that your container is creating, but it is not getting created. What is the issue? For that purpose, you have to describe your pod. Okay. Describe will tell you what is the issue. kubectl describe pod name. Okay. Here you get the error. It was scheduled successfully. After that, kubelet was working. Kubelet was not able to attach or mount the volume. Okay. So team, I have given in the description that from your host path, the location should be temp logs. So did we create temp logs on any worker node? Did we create the temp logs in any of the worker node? No, right? We didn't create that. So we have to create that as well. Okay, first we are going to see on which worker node it is getting created. It is R9 GB. Okay, just remember this. Let's go to your VMs. Okay, R9 GB. This is the machine. I'm going to connect to this machine now. Alright, I'm connected. Stream, I have go to temp location. Okay, under temp location you cannot see anything related to your logs. Okay, so what I have to do, I have to create a logs location. mkdir hyphen logs. Sorry, no hyphen. Okay, you have created the logs location. Let's go inside the logs location. As of now, you don't have anything here, right? The location is completely empty. kubectl get pods. So it will keep checking for the volume. Now it will find that volume is there. Now it is going to create your container soon. So team, it is from GKE. GKE is a little slow if you compare with the cluster that you create manually, and if you compare it with the GKE cluster is a little slower with the network. So that's not from our issue.
catch it automatically. Okay, Chandrasekhar, let's watch it. kubectl get pods. No, Siddharth, we don't have to create it on the both nodes. Okay, only on the node where your pod is scheduled. Yes, team, now you can see this container is running. Okay, it was looking for the volume, and once the volume was available on that particular node, you get the running status. It means your pod is created. Okay. Also, if you go to your worker node, team, can you see the content here on your worker node? Okay, you can see these are the logs of your Tomcat container. Earlier you had nothing here. Okay, earlier you had nothing here, but once you mounted the volume inside your container at the logs location, all the logs of your container are placed on your host path as well. Okay, and your container is also running. kubectl get pods. Okay, your both the containers, both the pods are running, and your host path volume is also running. So team, if I delete my pods, will I still be able to see these logs? I have deleted my pod. Will I still have these logs with me? Anyone? Yes, Chandrasekhar, yes, you're right. Your guess, Aditya, Ashok, Ankur, Satish, Rishabh, Masumi. Okay, all of you gave the right answers. Okay, so what I'm doing, I'm deleting my pod. Okay, it will be done in a while. So team, it is the problem with CKA, it is a little slow. We have to wait a lot for many things. Okay, your pods are deleted. Now if I'll do ls here, you can see your logs are still there. Okay, your pod is gone, your container is gone, but the logs are with you. Okay, so team, this is the option that you have with volumes of host path. Okay, you can create your host path so that you don't lose the logs of your application. Okay, team, any question with empty directory and host path, do let me know, we'll discuss that. Any doubt, anything which is not clear to you from empty directory and host path? If it is clear to you, then we'll move to PV and PVC. Empty directory and host path clear to all of you? Shiju, have you created the folder within the specific node? Yes, Shiju, I created a location on the specific node one. In host path, if the Jagannath, good question. Okay, Jagannath, I'll come back to your question a little bit later. Okay, Ashok, I will repeat it. Okay, so Ashok, you understand the empty directory, right? In empty directory, the purpose is to share the content with the containers inside a pod. Okay, but you understand that once the pod is gone, your empty directory is also gone.
Okay, so you cannot store your logs in that empty directory because it is purposeless. Your container is gone, your volume, your empty directory is also gone. So the first issue I discussed today, that you want to retain the logs. Even if you delete your container, even if you delete your pod, your logs should be retained. Okay, that was our agenda. That is what we wanted to have. So the same thing we can achieve with the host path. In host path, what you do, you mount a volume inside your container that corresponds to a location on your server where your container is running. Okay, host path correspond to a location on your physical server that will be mounted inside your container. Okay, consider that I am working, my container is getting created on node 1. Okay, at node 1 there is a location, on node 1 there is a location inside my server node 1 as u01 data files. Okay, and I have placed some data files at this location, and I want these data files to be inside my container as well. So I am going to mount this location as a volume, as a host path inside my container, so that I can see these data files inside my container as well. Also, if anything happens inside the container, if container wants to modify some data files or write some new data file, it will be available on my local worker node as well. Okay, so this is the address of my host where my container is getting created. Okay, on this node I am going to create a container, and then I am going to mount this location inside my container as well so that I can see it. Ashok, is it clear to you now? Ashok, temp log we created on the worker node, if you can see this. Okay, this is my worker node. You can see the address. Okay, the address is R9GB. Okay, if I go to my Cloud Shell, kubectl get nodes, I went to my node directly, and there I created the temp log location. I want to know. Yes, Joydeep, good question. Okay, I'm coming to this question now. Okay, so the question is pending from Joydeep. I have to answer the Joydeep answers and Jagannath answer. Any other question from all of you? Okay, so team, two very good question arrived. Okay, so the question is almost similar from both of them. The thing is, consider you created a pod, okay, and you don't know on which node your pod is going to get scheduled, right? As of now, in my cluster, we have only 2 nodes, right? But there are chances that you might be dealing with 15 to 20 worker nodes, right? There are chances. So what you can do, first you're going to create your pod, okay? It is going to stay in the container creating state for a while. You will see with describe command on which node it is scheduled, and you will go on that node and create your host path, right? That is a lengthy process. You don't want to do it. You don't want to take that much pain. You are creating pod. Your volume should also get created automatically. Okay, it is a pain that I have to check on which node it is scheduled, and then I have to go to that particular node, and then I have to create the path. Or what else I can do? I can create the host path on all 20 nodes. I have to log in on all 20 nodes and create the location. So I won't face this waiting time. My container will be created on the go. So I have to create the path on all 20 nodes. That is also an overhead. I don't want to do that as well. Okay, I have to log in on 20 nodes. That is also a big task. Okay, so still you can see there are some challenges with this. This is the first challenge. Second challenge, consider because of some reason your container got hung and again your pod got restarted. Okay, your pod was restarted, and you know once your pod is restarted it can go on any node. Okay, there is no assurity that your previous pod was created on node 9th. Okay, if your pod was created on your pod was created on node 9th, if it is getting restarted, there is no assurity that it will go on the same node again. Your pod can also get scheduled on the 14th node or 18th node. Okay, so again your location is going to vary. Again you have to create a host path on that particular node. So team, there are still so many challenges with host path. Okay, it is not one of the most feasible options you have in Kubernetes to deal with the volumes. Okay, it is only feasible if you are using one master, one node machine. Okay, only then it is going to be useful, because you're going to have only one worker node. Your pod is always going to get scheduled on node 1. Okay, there is no option of getting scheduled it on any other node. So your host path is only usable when you have one master, one node cluster, and we never use that. So host path doesn't fulfill all your needs again. And to deal with this challenge, we have PV and PVC as our next topic. Okay, persistent volume and persistent volume claim. That is our next topic for today. It addresses all the issues that we have discussed so far. Okay, so team, to make you understand about PV and PVC, let's have a small story time. Okay, we are going to know about a story and then we'll see how your PV and PVC work. A layman example, a layman story. Okay, team, consider this is me. Okay, your trainer. So I'm a trainer. I visit many locations. All right. For to visit many locations, I do the hotel room booking as well. Okay. So what is the story? That I might have to stay in hotels. Okay. In hotels we have multiple rooms. Okay. In hotels we have multiple rooms. All right. So team, if I travel to some location and I want to have some room booking, what do I need to do? Can I directly go to the hotel and enter in my room of my own choice? No, it doesn't work like that. You have to make some reservation, right? And you have a variety type of rooms inside a hotel. Okay, consider this is your one bedroom. Okay, one bedroom. In the second one you have 2 bedrooms. Okay, it is a double bedroom. Some rooms are AC, some rooms are non-AC. Okay, so there is a variety of rooms in any hotel. Okay, so I have to choose accordingly. All right, and I have to make some kind of reservation. Okay, without reservation I cannot go to any hotel and enter in any room. Okay, so for that purpose what I need to do, I need to do the reservation, or simply I have to go to any application, your Make My Trip or any or Airbus, any kind of app I have to log in, right? And in that app I have to set filters. I have to set filters that what kind of room I do want. Okay, depending on my configuration, that I need a single bedroom and it should have AC as well. Okay, it should be an AC room. I have to set my filters that what exactly I need. So according to that filter, I can book a room. Okay, consider I am booking a room based on my configurations. Now, what is the situation? There is a hotel, there are some rooms, and I have booked a room with a reservation. Okay, now I do have the reservation. Can I simply go to the hotel and have that room with me? I do have the reservation. I have went to the hotel And can I simply enter in my room without dealing with anyone? No. There is going to be a first point of contact. There is going to be a receptionist, right? There is going to be a receptionist. There is going to be a manager or someone. Okay, so I have to show him my reservation. Okay, so I made the reservation. I'm going to show that reservation to the receptionist or the manager, whosoever is there. I'm going to show my reservation to the receptionist, and after that, as per your reservation, that manager or receptionist is going to guide you to your room. Okay, sir, this is your room. This is your room number. Go to this one. Or this is your room number. Go to this one. Okay, so he or she is going to guide you that exactly where your room is, exactly what is your room number. Okay, so team, this is the complete process. How you deal with any reservation. Simple enough, easy to understand. Okay, this is the hotel example that I wanted to give you previously. So team, whenever you make the reservation, are the rooms already created or they get created in the real time? When I do the reservation, are the rooms pre-built or they are built when I do the reservation? Pre-built, right? Absolutely. Okay, so the rooms are already there. I have to choose that which room I want to do. So I am going to make the reservation accordingly. Okay, and sometimes it also happens that I ask for a single bedroom. Okay, I ask for a single bedroom, but because of some reason in that hotel, your single bedrooms are not available. They are full. Okay, at the time of reservation, it was there, but when you entered the hotel, it was already occupied. It was not available. So sometimes you get the upgrade also, a free upgrade, right? So what the manager or receptionist is going to do, they say, sir, we don't have one bedroom, so we have upgraded your room to a 2-bedroom. We have given you a promotion. Okay, so based on your requirement, you get your upgrades as well. Okay, so team, this is the basic example of the hotel I wanted to give you before we start with PV and PVC. Alright, now I am going to correspond everything with this. So you already understand that rooms are already created. Now I am going to talk in the term of Kubernetes. Okay, so in this scenario, this is not me, this is a pod. Okay, a pod wants to have some volumes. Okay, in this situation, you will have these volumes to be created automatically. You will have a variety of volumes already created, 5 GB volume, 10 GB volume, 20 GB volume, as per your requirements or as per your expectation. You will get your volumes created beforehand. Okay, even before the pod comes with a request, you will get your volumes created, and these are called persistent volumes. Okay, or simply say PVs. Okay, your persistent volumes are already created with different type of variety. Say 1 GB, your second volume is 2 GB, third is 5 GB, last one is 10 GB. Okay, you already have a variety of different volumes created beforehand, and these are called persistent volumes. Okay, and now you have some reservation. Okay, now pod comes with the request that I need a volume of at least 7 GB. Okay, take an example of 7 GB, or take an example of 4 GB. Okay, let's take an example of 4 GB. So a pod arrived and it asked that I need at least 4 GB of data. I need 4 GB of storage which I can use for my storage. Okay, so this is called the reservation, the request that you are making. It is called persistent volume claim. Okay, this reservation that you are making is called persistent volume claim, or you can simply call them PVC. Alright, so you came with a request that I need 4 GB of storage. Your volumes were already created beforehand. Now you come to the receptionist, and that receptionist is called here storage class. Okay, the part of the manager is being handled by the storage class. The storage class is going to check all the PVs in your cluster. Okay, it will check all the PVs inside your cluster, and it will check which PV should get assigned to this PVC. Okay, the PVC is asking for 4 GB. Okay, so you can see that it cannot assign the 1 GB PV, right? It is not going to be fulfilled. It cannot assign the 2 GB, right? It asks for 4 GB, but this volume has only 2 GB, so it cannot assign this one. If there is some volume, if there is any persistent volume with 4 GB available, it will assign that. But as of now, you can see it is not available, so it is going to assign a 5 GB volume. Okay, it is going to assign a PV of 5 GB because the ask was minimum 4 GB. This is the minimum part. Alright, so that is one part. Now, next part. Okay, so this is one thing. Now consider the hotel example again. Okay, so sometimes you went to a hotel regularly. Alright, so you know that room number 105 is perfect for you. Okay, sometime what happens, you visit a hotel regularly and you know that room number 105 is perfect for you. It has a single room, it is a single bedroom, it is AC, it has a good view from the balcony. Okay, you know everything. So what you understand that you like the room 105. So what you do, you simply go to the hotel and you'll ask for room number 105. Okay, so these persistent volume also have some names. Okay, you can say this is your volume 1, this is your volume 2. Here also we are going to give names, right? This is your volume 3. Okay, you can give the specification in your reservation, or you can simply ask for the room number in your specification. Okay, you can simply go to the hotel and you ask that I need room 105, or simply go to the hotel and you ask that I need volume 103. So it is simply going to assign your volume number VOL3. Okay, so team, is it clear to you? Persistent volume claim and storage class. Theoretically, is it clear to you? We'll see this practically as well. So team, I tried to explain you with the easiest way possible. Okay, the hotel example I gave in all my classes because I find it very connecting with this example. Gaurav, we'll see that. Okay, persistent volumes are created in the real time. Yes, it is. I'll show you this practically. So if the pod wants 7 GB, will it give 2 volumes? Edureka guess, no, it cannot give 2 volumes. Okay, 1 PVC, 1 PV. There's 1-to-1 mapping. Okay, so if the ask is for 7 GB, it cannot go to the 5 GB as well. It will go to the 10 GB directly. Okay, it cannot club PVs. There is always 1-to-1 mapping. 1 PV, 1 PVC. Okay, so team, let's see this practically, then you will understand in a better way. Okay, so as you already understand that persistent volumes are already created first. It means your hotel rooms are already created before you go to the hotel or you make any reservation. Your hotel rooms are already created. So the first thing that you need to create is a persistent volume. So first you create a persistent volume. then you make the reservation, and then you go to the hotel. All right. So first thing you are going to create is persistent volume. Then you are going to create a persistent volume claim, and then you are going to create your pod. This is going to be your flow. Okay, Jagannath, I'll show you. Okay, let's see this practically, team. Your questions are more practical related. Okay, all the questions you are asking are practically related. So let's create a PV, PVC and pod so that you will understand it better. Storages. So as I told you, first you need to create your room. Okay, you need to build your hotel. Okay, so first I'm going to create a PV. So this is the definition of your PV. Okay, kind is persistent volume. The name of my PV is going to be my PV. Storage class I'm going to use standard. Okay, so the hotel manager or the receptionist, I want the standard one. I don't want any other type. So storage class is the same one. This I'll come back later. Okay, capacity storage I'm giving 1 GB. Okay, 1000 MBs. So I need 1 GB of persistent volume. So what I'm going to create right now, I'm creating this volume. Okay. Access mode is read-write once. You can have multiple. I'll tell you that also. Okay. Host path I'm mentioning. Okay. Host path I'm mentioning temp PV data. Okay. So now team, another example from the same hotel one. Okay, so what I happened, I booked room first one. Okay, I need 1 GB, so I have booked this volume. I went to the hotel, I need 1 bedroom, single bedroom. Okay, so now the thing is, once I leave the hotel, okay, once I leave the hotel, what will happen to the volume, or what will happen to the room? Okay, I stayed there for 1 day in the hotel room, and then I left. So what will happen? They will recycle the room. Okay, they will refresh the room. They will remove whatever the trash I have put or something. Okay, they are going to clean the room, and they are going to assign the room to someone else. Right? That is the first scenario. That what can they do? They can clean the room. They can recycle the room and assign it to someone else. That is first scenario. Now consider second scenario. What happened that I asked the hotel that today I'm going, but tomorrow I'm going to come back. So keep the room under my name only. Don't assign this room to anybody else. Okay. So it means I am retaining the room. I have asked the hotel people that tomorrow I'm going to come back. Today I'm leaving, but tomorrow I'm going to come back. So do not assign this room to anybody else. I am going to retain this room. Okay. That is the two scenario. First is recycle, assign it to someone else after cleaning, or second one is retaining. Tomorrow I'm going to come back, retain this room for my name only. Okay, don't assign to anybody else. So these are the two scenario. Now the third scenario. Consider once I booked this room, once I entered this room, I got infected with COVID. Okay, for example. Now the thing is, they cannot assign this room directly to someone else. Okay. They have to sanitize it. They have to make it completely different. Okay, they might have to remove the bed. They have to replace the bed or bed sheets or whatsoever. Okay, they have to sanitize the room. Okay, if it is a pre-built room, consider if you are dealing with tents, they are going to burn out the tent. Okay, they will remove the tent altogether. Okay, so these are the three scenarios. Same scenarios you have here as well. Okay. Either you can recycle the volume. It means if your pod is getting created, it will assign this persistent volume to that pod, and once your pod is deleted, it is going to recycle. It will delete the data of that volume, and it will make that volume available for any other container or pod to use. Okay, that is recycle. You can do the retain also. It means even if your pod is deleted, it is going to be there. Your volume data is going to sustain. Okay, it is going to be there. Third is deleted. It means once your pod is deleted, your persistent volume should also get deleted. Okay, you have these three options. Next is your access mode. You have 3 access mode: read write once, read only many, and read write by many. Okay, it is on the node level. Consider that your volume was created on node 1. Okay, your worker node 1 gets. So what will happen? Only the containers or pod that are residing on that node 1 will have the access to that volume. They can read and do the write operation as well. Or read only many, it means only the node where your pod is getting created, that node will have the access of read write, but if any other pod which is running on another node will have only the read access. They cannot modify the data of that volume on a different or read write many. It doesn't matter where your volume is getting created, all the pods across your cluster will have the read write access. They can read the data and they can modify the data. Okay, so these three definitions you can provide in the access mode. Alright, so team, first I'm going to create this persistent volume. Okay, connection is lost. Let's reconnect. Okay, we have to set the cloud config again. Okay, so let's reconnect it from here first. So team, it has given the timeout, so I have to go and connect again from the Kubernetes engine. I need to have this. Let me save it on the WordPad so that I can have it again and again if wherever required. Okay, so yeah, now I'm connected. I'm going to create the PV, kubectl, get nodes, kubectl, create -f, persistent volume. Okay, your persistent volume is created. kubectl get PV. PV is a short form for persistent volumes. Okay, team, now you can see a persistent volume is created of 1000 MBs capacity, read write only, and the reclaim policy is recycle. Okay, so even if the pod is deleted, it is going to delete the content and make this pod available, volume available for another pod to use. Okay, the status is available. Okay, so in the hotel the room is still available, it is not booked, it is not assigned to anyone. So you can see the status is available. Storage class is standard. Alright, now next is I'm going to make the reservation. Now I have to make the reservation. I have to create a persistent volume claim. Okay, so there is an example of PVC as well. Okay, this is a smaller one. I'm creating a persistent volume claim PVC. The name of my PVC is going to be my PVC. Storage class I'm using standard one. Access mode I need read write once. Okay. Resource request storage 500 MB. Okay. So team, what is happening? That I need only 500 MB. I don't need 1000, but I need 500 MB. So it is going to search out for only the volume of 500 MB. If it doesn't found, it is going to upgrade my plan. Okay, it is going to upgrade my plan. So let's create your PVC. kubectl create -f. Now I have created the PVC. Now I have made the reservation. team, is my voice clear to all of you? Are you facing any challenge with my voice? Kushagra, people are responding that my voice is clear. Maybe some issue from your end. Okay, thank you. Okay, so team, now you can see your PVC is also created. Let's get your PVC. kubectl get PVC. Okay, team, you can see that my PVC is created and the status is bound. Okay, status is bound and it is bound to which volume? My PV, whose capacity is 1000 mi. Okay, but what you asked for? You asked for only 500 mi, but 500 mi was not available. Okay, you went to the hotel and you asked for a single bedroom, but they didn't have that available. So they upgraded your plan. They provided you a double bedroom. Similarly, you can see it assigned you 1000 mi capacity. Okay, storage class is standard. Okay, if I do kubectl get PV now, okay, now you can see the change. Okay, now you can see the change. Earlier this room was available, it was not booked, but now the room has been booked by a reservation. Okay, who has claimed that room? The room has been claimed by my PVC. Alright, so now your PV and PVC are bound together. Okay, the reservation has been made, your room is booked. Now anyone who will come with that reservation, okay, so the reservation has been made. Now if with that reservation I go to the hotel or somebody else go to that hotel, he can enter the room, right? I have made the reservation. If I go myself to the hotel with that reservation, I will occupy that room. Or if I give that reservation to my brother, okay, if I give that reservation to my brother or system to any other of my family member or my friend, he can go to that hotel and he can occupy that room, right? Same thing is going to happen. I'm going to create a pod and I'm going to give that pod my PVC. Okay, your pod will be using that PVC to use a persistent volume. PVC host path pod. Okay, let's understand this. I'm going to create a pod. The name of the pod is PVC pod. It is using Tomcat image and this is the name of my container. Okay, now I am doing volume mount. Which volume I'm mounting? I'm mounting PV volume. Okay, and this volume will be visible inside my container at this location, user local Tomcat logs. I'm mounting the volume. Which volume I'm mounting? I'm volume PV, and it will be visible inside my container at user local Tomcat logs. Now next thing is volumes. I have given the volume mount name. I have to define it also. Now I am defining the volume. The name of the volume is PV, and earlier you used to see what here? You used to see your empty directory, your host path. Okay, now you are using persistent volume claim. I am handing over this reservation to this pod. Okay, what is the persistent volume claim name? Is my PVC. Okay, the name is my PVC. So now I am going to create this pod. Before creating this pod, what was the location of your PV? Let's see that first. Okay, the location was temp PV data. Let's verify if that is available on any of the worker node or not. Okay, I'm already connected with one of my worker node. There is no directory as PV data, right? Under temp. Let's connect to my second worker node now. Okay, I'm already connected with the R9 GB. Let me connect to M38C.
here I'm connected to my second worker node. If I go to the temp location, okay, on both the worker nodes, you can see that under temp location, there is no folder called PV data. Okay, now I'm going to create my pod. I'll take the raw format. I'll copy it. kubectl create -f your pod. So team, your pod is now getting created. When we created your pod with host path, what happened? Your container was not getting created because the location was not found. kubectl get pods. Okay, as of now it is also creating state, right? Same thing happened with a host path. Same thing is happening with your this one also. But you see it was resolved automatically. Okay, you can see this time it was resolved automatically. How? kubectl get pods -o wide. With host path it was stuck. With persistent volume it didn't. It went to M38C. Okay, at that node also the path was not available, right? You can see M38C temp PV data was not created. Now you can see it is created. Okay, with host path you have to create it manually, but with PV and PVC you don't have to. Okay, it is created automatically. Why? Because in host path you provide a path. Okay, that path is manual, but here all the things that you are defining are your Kubernetes its own object. Okay, you have created a PV, that is a Kubernetes object. You have created a PVC, that is also a Kubernetes object. You deal with storage class, that is also a Kubernetes object. You created a pod, again Kubernetes object. All the objects that you have defined, are of your Kubernetes own. Okay, pod, PVC, storage class, persistent volume, everything is your Kubernetes own object, so you don't have to deal with anything manually. Everything will be done automatically. Okay, so wherever the pod is scheduled, whether in node 1, node 2, node 3, node 5, node 10, node 20, doesn't matter, your Kubernetes is going to create that host path on that location automatically. You don't have to worry about it. Okay, so even if you go on that worker node, okay, if I go to my PV data, you can see logs are already updated off your Tomcat container. Okay, so team, this is the concept of PV and PVC. Any question, any doubts? It was a complex topic, I know. I tried my best to explain you with the best examples. Whatever PV of 500 is available, but with different access mode. Okay, Gaurav, you're asking if there is a PV of 500 MI is available with different access mode. It will not assign that 500 MI. Okay, it has to match all the conditions. All the conditions should be fulfilled. Storage with the minimum level, with access mode, it should match. Should the access mode be read-write many if I have to deploy with many pods across the nodes? Okay, Jagannath, another good question. So team, the question is from Jagannath, should the access mode be read-write many if I have to deploy deployment with many pods across nodes? Okay, so team, as of now I have created only one pod, but in the real-time scenario you don't do that. You create a deployment, and in deployment what happens, your pods are distributed across the node. So what will happen? A PV is going to get created on all the nodes where your deployment is placing the pods. No, that is not possible, because you already understood that it is one-to-one mapping. One PV equals to one PVC. So if you are dealing with a deployment where the pods can spread across the nodes, okay, so in that scenario your PV in PVC is also going to create a problem.
Okay, so for that, what you can do, you can have the read many access. That is one way. Another way is you can use some shared drive again. Okay, if you have 20 nodes, you can have a shared mount point, or you can have a NFS. Okay, you can have a NFS. It will be getting in sync with all the 20 nodes. All right, so doesn't matter wherever your pod is getting created, a shared location will be there across all 20 nodes. So it doesn't have to create the path again and again. That shared volume will be available for all the volumes. Okay, so if you want to do this with a NFS, okay, I hope all of you know what is an NFS. It is a shared volume. Okay, it will be attached to all the instances and it will stay in sync with all the machines. Okay, so team, I have kept an example with NFS as well. If you want to practice at your own, it doesn't comes in your examination. Okay, in CK exam they never ask about the NFS. Okay, because NFS is not a feature of Kubernetes. It is a feature of your cloud provider. So if you want to practice at your own, here is an example I have kept for you. You can work with local also, you can work with CKA as well. Okay, how to create your NFS PV, how you to create NFS PVC. Okay, all the examples are here. If you want to practice at your own, you can practice. Okay, it takes somewhere around 30 to 40 minutes. Okay, that is why I am not including this in a session. Okay, it will take a big toll on the time, but if you want to practice, you can practice. All the concepts are same with your PP and PPC. Just you are going to have a shared mount point across all the nodes. Kushagra, you are asking how read-write many works. So Kushagra, I have just given an example. Consider you are creating a deployment. Okay, you are creating a deployment with two replicas. One replica is getting created on node 1, second replica is getting created on node 2. But both are going to use the same volume, right? And the volume will be created only on node 1 or either on node 2. It won't get created on both the nodes. It will be created only on node 1 or node 2. So what will happen, consider that your persistent volume is created on node 1. But you have one pod also living on node 2. It also have to access some data on node 1 volume. Okay, so there you are going to use read-write many. So even the pod which is residing on node 2 will have the access on the volume which is created on node 1. Mosomi, you are asking how to restrict the PVC to be used for a specific pod. Mosomi, it is already restricted, right? You have one reservation, right? PVC is a reservation and pod is a person who is taking that reservation to a hotel. So if I have made a reservation in a hotel, it means I am going to have that reservation with me. It doesn't happen like that. I take the same reservation to the hotel. My brother also took the same reservation to the hotel. My friend also took the same reservation to the hotel. They cannot assign the single room to 3 people, right? So the reservation has to be one only. It is one-to-one mapping. So only one pod can have one PVC and one PVC can have only one PV. It is already restricted. But consider I have booked a double bedroom. Okay, so consider I have booked a double bedroom. So I am going to go to that room as a double occupancy. So I will go with my friend, I'll go with my wife, I'll go with my brother. That is up to me. So that is a deployment now. Okay, your deployment has 2 replicas. I am going to that hotel with the same reservation with a double occupancy. So you cannot, if you are using with a deployment, you cannot have with for the specific pod. But if you are dealing with a single pod, you can specifically limit it to a single PVC and a single PVC to a single PV. Standard storage class uses from master storage. Sarath, I don't understand about the master storage. What do you mean by master storage? Kushagra, you are asking, can we use a different machine apart from the cluster node to create a PV by using a machine IP? Kushagra, that you can do using NFS. Okay, using NFS you can do, or if you want to do it with the cloud disk, you can do with the cloud disk as well. I'll show you over the cloud disk. Kushagra, is it possible to make a PV namespace? Okay, so Kushagra, then PV is always a cluster level resource. Okay, PV is a cluster level resource, but your PVC can be namespace because your PVC is getting mapped with a pod or deployment, and you can know that pod and deployment can be namespace. So important point to notice that PV is a cluster level resource, PVC is a namespace level resource. Sarath, no, it doesn't take the storage from the kube master. It will take the storage wherever your pod is assigned. If your pod is assigned on node 1, it will take the storage of node 1. If your pod is located on node 2, it will take the PV storage from the node 2. It doesn't take anything from the master. Mosumi, you are asking, please explain read write once and read or many again. Okay. Mosumi, read this. Okay. If you have defined read write once, the volume can be mounted as read write by a single node. Okay. Wherever the volume is getting created, if your volume is created on node 1, okay, and you have given read write once, so only node 1 will have the access to read and write. Consider if a pod is created on node 2, your node 2 pod will have no access on the volume which is created on node 1. It cannot read it, it cannot write on it. Okay, so that is read write once. It will be accessible to only node 1. The volume can be mounted with read only by many nodes. Okay, so what happens if your volume is created on node 1? Alright, so node 1 components can read and node 1 components can write as well. But if you have read write many, the node 2, node 3, node 4 component can read the data. They cannot write the data, but they can read. And read it many, all the nodes can write the data which is residing on node 1. Okay, Kushagra, I'll let you know about the storage classes, okay, that we haven't discussed in depth. We'll study about the storage class also in the further session. So team, any question from PV, PVC, storage class, not storage class? I'll discuss storage class later. Any doubts with PV, PVC, host path, empty directory? No? Ashok, you have to pay attention. Okay, you can see that PV was created on node, another node, right? This is my worker node. I'm 38C. This is my worker node. Your persistent volume is created on this node. Okay, so Ashok, whenever you define PV and PVC, the volume is not created right away. Okay, a PV object, Kubernetes object PV is created, but it doesn't take storage of any node. Once you create the pod, okay, once you create the pod, then your PV is created figuratively. Okay, actually, your location will be created once your pod is created. Otherwise, your PV object, your Kubernetes object will be created. It will not consume any data, any storage. It will consume the storage only when you create the room. Okay, so if you have in a hotel you have a room. Okay, in a hotel you have a room. If nobody has occupied the room, the electricity will be cut off. Okay, they will cut off the fuse. The lights and everything, fans will be turned off of a room which is available and not booked. All right. Similarly, a Kubernetes object PV will be created, but it will not consume any storage of any node. Now consider I have made the reservation. I entered the hotel. Okay, I entered in my room. Only then they are going to provide electricity to that room. Only then the power will be enabled for that room. Only then the lights or fans of that room will be on once I enter the room. Similarly, whenever your pod is getting created, only then your PV will consume the storage from the node where your pod is assigned. Okay, so everything will be done on the worker node itself. The scheduler give any preference to the node while creating the pod in regards to PV and PVC. Siddharth, it depend. No, that is not the case. Okay, scheduler is going to put your pod on any worker node based on the scheduler that we have studied in the previous class. A persistent volume or persistent volume claim will be assigned to that node itself. Okay, so PV PVC does not have impact on any scheduler choice. Scheduler will choose the worker node for the pod, and then a persistent volume will be created. It will consume the volume data storage of that particular node afterwards. Prempal, you are asking, can we upgrade the PV site if we need the later stage? Yes, definitely. You know the how to edit the components in Kubernetes. Simply use kubectl edit PV and PV name, and then you can resize it as well. That is possible. Okay, it is again got disconnected. All right. So team, the next concept is we are going to cover is for ConfigMap. Okay. So what is ConfigMap and what is the need of the ConfigMap? Okay. So team, as you are working in IT organization or getting started, okay. So one thing you might be knowing that in any organization you have multiple environments for any particular application, right? Like first is your development environment, second is your testing environment, right? Then you have a pre-prod, okay, and finally you get a production environment, right? This is how you have your environments in any organization for your single application. Okay, now I want to create some pods or I want to create some containers. All right, but what I want to do, consider I am having a Nginx container. Okay, I am having a Nginx container. So I am going to create a container for every environment. Okay, what difference I want? In any Nginx, you get welcome to Nginx, right? You get a welcome to Nginx page. But I want to differ it as per the environments. Like if I deployed on the development, I wanted to welcome to development environment. When I deploy the same container on test, it should get welcome to testing environment. When I do it on the pre-prod, it should welcome me on the pre-prod environment, and when I do it on the production, it should welcome me as a welcome to production environment. Okay, that is my requirement. Okay, I want the container to behave differently on different environments. Okay, so team, now one question to all of you. Should I create a single image or should I create multiple images for this? Should I create one image or multiple images for this now? Okay, great. All of you are giving right answers. Great. Team, so whosoever has answered, all of you have answered correctly. Okay, we are going to use a single image only. All right, because that is the purpose. Why we started using container? Because we wanted to have a singular environment. Okay, we wanted to eliminate the challenge that we used to have that code is working on production, code is not working on production but working on a testing environment. Okay, that is why we come to container environment. So definitely we need a single image only, but still we want that image to work differently. Okay, it should behave differently. So for that purpose, what we have ConfigMap. We are going to pass some kind of configuration to the container so that it can behave differently as per the environments. Okay, we are going to pass on some configuration to this container, which so that it can behave differently in dev environment. We are going to pass on some configuration to this container so that it behaves differently in the testing environment. Okay, so we can pass it using volumes or we can pass it using your environment variables. Okay, we have multiple ways, but the single name that we can do it with is ConfigMap. Okay, it is simply a short form of configuration mapping. Okay, ConfigMap means configuration mapping. So we are going to use ConfigMap to achieve the same thing. All right, so before that, let me connect to my Cloud Shell again, and then I'll show you an example for this. Kubernetes engine. Alright, in the meantime, it is connecting my machine. Alright, so let's go to the storage again. And there's a ConfigMap example. Okay, there are multiple ConfigMap examples. I'm going to take the first one first. Okay, so team, I'm creating a config map here. Okay, first I'm going to create a config map. What is the name of the config map? The config map name is Nginx HTML, and I'm going to store some data. I'm going to store some data in that config map. Okay, so this is a key, index HTML, and it should give me a message of hello config map. Alright, and now I'm going to create a pod. Creating a pod, API version, metadata is the name, container. Okay, I'm using the Nginx image. Alright, now I'm going to pass that config map using a volume. Okay, so till here you have the clear definition of the pod. Now I am again using the volume mount. Okay, so whenever you see the volume mount, it means it is happening inside the container. This is the name of the volume mount. Okay, this is the volume I'm going to use, and I'm going to mount it at a location of user share Nginx HTML. This is the location where your welcome to Nginx HTML page is residing. Alright, so here I'm going to place my volume. I'm giving the read only true. Okay, I don't want any other access. Now I'm going to define the volume. The name of the volume is going to be HTML from CM, the same I'm using as volume mount. Okay, under this now I'm giving config map. Now I'm not giving persistent volume claim. I'm not giving your empty directory. I'm not giving your host path. I'm giving a config map. Which config map? Nginx HTML that I have just created above. Okay, so we are going to take this example. Authorize. kubectl. Let me delete all first. Okay, so it has not deleted the PV and PVC. kubectl get PVC. kubectl delete PVC name. kubectl get PV. Okay, so now you can see the status is again available because now I have deleted the PVC. kubectl delete PV, my PV. Okay, so I have deleted both the PV and PVC. I have deleted the pod. I have a clean environment. Now I'm going to create the config map. kubectl create -f and config map. Okay, so you can see your config map is created. Let's see it. kubectl get CM. CM is a short form. Okay, you can see that Nginx HTML config map is created. You can describe it. kubectl describe CM. Okay, so team, here you can see that it is namespaced. Okay, you can have your config map into particular namespace as well. Alright, apart from that, what is the data? You have a key called index.html, and what is the value? Hello config map. Okay, so with this your pod is also created. Alright, So let's try to log in and see if it is placed or not. kubectl exec-it -bash. Okay, now I'm inside my pod. I have mounted that config map at this location. There has to be an HTML file. Okay, you can see HTML file is here. Okay, and you can see the content has been updated. It is giving you hello config map. Okay, otherwise it used to give welcome to Nginx page. Okay, so that we have achieved. Now next part, I told you that we can give your config map by two ways. Okay, first way was by volumes. We have already seen that how we can pass your config map using volumes, but we can pass on your config map using environment variables as well. Okay, so let's take an example for that also. This is another config map I'm creating. Okay, earlier I passed only one value. That was html.index, and the value was hello from config map. Now I'm giving two values. What I'm defining DB as my MongoDB and app as my app. Okay, I have defined two values this time in my config map. I'm creating the pod name container. Okay, and I want to execute a command. Okay, I want to execute a command echo key value 1 and key value 2. Okay, and I'm defining those environment variables here. What is the name? The key is equal to going to be key 1. Okay, what should be the value of key 1? It should take the value from config map key reference. Okay, it should take the value from config map key reference. Which config map? The name of the config map should be special config. You can see this is the name of your config map. And which value it should pick? It should pick the value of DB. Okay, it should pick the value of DB. So what will happen? The value of DB is my DB, and my DB will be stored at key 1. Alright, so team, you have to understand the flow, right? Now I am defining second key. Okay, I am defining second environment variable. Second environment variable is key 2. From where it should pick the value? It should pick value from config map key reference. Which config map? The name of the config map is special config, and which value it should pick? It should pick the value of app. Okay, so the value of app is my app. So this my app value will be stored at key 2. Okay, team, I understand it is a little boring. I do understand that, but I cannot do anything. This is how the subject is. Okay, so I am going to create a config map using environment variables this time. I'll take the raw format. I'll copy it. kubectl create -f this. Okay, your config map is created and your pod is also created. kubectl get cm. Okay, now you can see special config has been created and it has two datas. Okay, earlier we have one data, now we have two data. We can describe it. kubectl describe pod. Sorry, it is config map. Okay, now you can see it has two data. App equals to my app and DB equals to my MongoDB. Okay, and these values should get pasted in my container. Okay, so team test pod was created and it has only one job, right? If you see this, I just did a echo operation. I didn't get any sleep. Okay, I didn't ask is this container to stay alive. So that is why it treated it as a job. It is completed. Okay, so once your pod is completed, you can see the output as kubectl get logs, kubectl logs, and your pod name. So team, can you see? You are getting the output as my MongoDB, my app, as it was said. Echo key 1 and key 2. And you get key 1 value as my MongoDB and key 2 value as my app. Okay, so team, this is the concept of config maps. You can use your config map using volumes, and you can use your config map using environment variables. So team, is config map clear to all of you? Gaurav, the thing is, you had a key value pair of index.html, okay, and you use it with a volume. Whenever you use it as a volume and you don't give any proper file path, it creates it as a file itself. Okay, whenever you use it as a volume and you don't store a value in a file, so it stores that value as a file itself. Rahul, you are saying how to create a config file using a config map. You can store it with the values like this, the first example that I showed you. Okay, let me show you the first example again, Rahul. Okay, so what happened? I created a HTML file here and I stored some values here, right? So what you can do, you can give here as a config file and you can store all the configuration here accordingly. Okay, it is just a single key value pair. You can use an array, you can use a dictionary. We already understand that how it works with a YAML. Okay, so it is simply a key value pair under data. If you want under data, you can have a dictionary and array so that you can store multiple things, multiple content inside a single file. So that is how you are going to use a config file. Ashok, you are asking what is the use of config map. Ashok, that is what with I started. Okay, I just started with the same thing. What is the use of config map? Okay, so you have different environments. You want your container to behave slightly differently in every environment. You want to pass on some details to the container so that you can identify that this container belongs to a lower environment. All right. So what I said, I should create a container created in the development environment, and it should greet me with welcome to development. Okay, so that I'm aware that this container is of development environment. This container should respond welcome to testing environment so that I can know that this container belongs to the testing environment. So what happens, depending on the environment, depending on your environment, you want to pass some details that is environment specific to your container in any organization. So for that you use config maps when you want to pass some configurations to your container. How can we pass binary data in config map? Kushagra, you cannot pass binary data in a config map. Okay, we have something different for that. I'll tell you about that. Rahul, you said you tried 4 different files. It is giving 4 different configs. So Rahul, if you are giving it just like this, okay, if you are giving it data and then you give the same indentation, it means it is going to have different entries. You have to give it as a dictionary or array like this container, and then you have some dictionary, then it has names. Okay, then environment also have some names. You have to give that config file details like that, not just like a key value pair. Okay, the concept of YAML formatting applies here. Gaurav, you are asking why we use a pipe signal symbol here in the example 1. So Gaurav, that is for the alignment. That is for the next line. Okay, you can also ask that why we have given this hidden sign /h1. So that is for the heading. So that is how your HTML formatting works. Okay, so it belongs to your HTML formatting. Rahul, let me see if any example have that you're asking. This is with database and database URL. Okay, Rahul, actually at this point of time, I don't have an example like that. Okay, these are the commands for the config map. Okay, so as of now, I don't have an example ready with me where I can pass multiple details into a single file. Okay, but yeah, do remind me. I'll try to manage that example for you. Masami, you are asking how to pass certificates in a config map. Okay, so Masami, certificate part we haven't discussed yet. Okay, certificate is a part that we are going to discuss in the next class. Okay, so I'll request you to keep your certificate related question in the next class. In place of in-file values, can we have properties file and directly access it from the YAML? Joydeep, I don't understand your question. In place of in-file values, can I have a property file and directly access from YAML? Sorry, Joydeep, I don't understand your question. Rahul, you want to pass on the TNS entry for the config map for connecting to database. Okay, so Rahul, there are a lot of functionality. Okay, I am here to make you understand the concept. How you utilize it, you can, and that is up to you. Okay, you can use the config map for a variety of job. Okay, so I have made you understand the concept. It is up to you how you're going to use it. So if you want to pass a connection TNS string for that, you can do that. Okay. One more topic I want to tell you before you ask further question on this. Okay. Before you ask further question on this, I want to ask you one question now. Okay. So team, there was a question from someone, Rahul. Okay. He asked something related to Oracle database or something. Okay. So now I have to ask you one question. The question is, can you pass a database connection string, or sometime you have to pass some password as well? Okay, you want to have some environment variables, you want to have some configuration pass that enables you to connect to the database, or where you need to have some password details also. Okay, so can you pass on some password related details or some sensitive data using config map to the container? Okay, some of you gave the right answers. Kushagra, you're right on top. Shiju. Masumi, yes. Ankur, absolutely correct. Okay, so team, we should not pass on any password related details or any sensitive data using config map. And why is that? Because if you're going to describe it, okay, if you're going to describe any CM, get CM. If you get any details in the config map, they are available to get read in plain text. Alright, you can read all the details in the plain text. So anybody can explain your config map and it will get the details and password and other sensitive data. You don't want them to be exposed like that. Okay, so for that purpose in Kubernetes you have some concept called secrets. Okay, secrets are exactly same as config map. The only difference, the details are not visible here like this, and you can do the encryption as well. Okay, in secrets you can do the encryption as well. So it is same. So I have some examples here. All right, for secrets, but let's take an example for secrets from the official documentation. Okay, some examples we can take from the official documentation as well. So storage, use secrets. Kushag, in the binary data, are you asking about this? Okay, so if you want to pass on normal data, you can pass. If you want to pass some binary data as well, you can pass with the ConfigMap as well. Okay, so this is about binary data. As of now, we have provided normal data. Alright, so team, this is your official documentation from where we can take the example of secrets. Alright, for the better understanding. Consider I want to pass on the username and the password. Alright, I want to pass on the username and password into my container using a secret. Alright, so this is being done using base 64 encryption. Alright, so base 64 encryption is usually available with all the Linux environment, whether it is your Ubuntu, Shell, Alpine, or CentOS, Red Hat. Okay, base 64 encryption is available with all of them. So for now, what I'm going to do, I'm going to have my app username. This is my username, and I'm going to have the base 64 encryption for this. Okay, so the encrypted value for my app is this string. Similarly, for the password, this is going to be my password, and I'm going to have base 64 encryption for this also. So now this is my username in the encrypted format, and this is the password for my encrypted value. Alright, now I'm going to create a secret. API version is v1, kind of secret, name of secret is this. You can see this is the username and this is the password as per the encryption. Alright, you can verify. Now what I'm going to do, I'm going to create this secret. Alright, your secret is created. kubectl get secret test secret kubectl describe secret. Okay, so team, when you describe the secret, you can see that the type is opaque, and under data you can see that no values is visible to you. You know that password has been passed, username has been passed. It is giving you what is the string length. It doesn't give you the actual value, it doesn't give you the encrypted value as well. Okay, so we have passed on the encrypted value, but that is also not visible here. It is just giving you the bytes. Alright, so kubectl get secret, we have seen that, we have described that as well. Alright, you can create a secret from the command line as well. Okay, that is a format. Now I'm going to create a pod that have access to the secret. So this is the pod definition. Again, I'm using volume mount. Okay, the name of the volume that I'm going to use is secret volume, and it should get mounted at etc secret volume inside my container. What volume I'm using? The name of the volume is secret volume, and I'm using secret behind it. The name of the secret is test secret that I have just created. So let's create this pod as well. Okay, you can use apply and you can use create. Both will create your pod. kubectl get pods. Okay, your secret test pod is created and it is running. Alright, so if you want to see the value, you can see the value of that by logging into your container. Alright, now you're inside your container. At this location, you have saved your details. So team, you can see etc secret volume, you can see the password and username. Alright. So that is also encrypted. It is not visible to you directly. And if you want to see the actual values, you can see the username. The username is my app. And if you want to see the password, you can see the password as well. So team, why you can see the username and password? Because now you are logged inside the container. Okay. So the beauty of a secret is if you log into your container, then only you can see the actual values. Otherwise, as a Kubernetes admin, I cannot use any Kubernetes or kubectl command to see the actual values of a secret. If you want to see the value of a secret, you have to log into that container. Alright, yes Kushagra, it is a plain text inside a container. The purpose of secret is it should get read inside a container, right? You should be able to read a secret inside a container, but you should not allow anybody else who cannot log into the container that it should read the content. So secret allow you to keep it a secret outside of container. Inside of container, you can definitely see it. Alright, so team, this is the example how you are going to use a secret using a volume. Okay, if you want to use using environment variable, just like a config map. Okay, we have seen an example, a config map, where you can use it using a volume and using an environment variable. Same thing I'm going to do with the secrets also. Okay, this time I'm going to create the secret using command line. Okay, in a imperative way. kubectl create secret. This is a keyword. Okay, you have to create a secret. Generic is a keyword that you have to give. Backend user. Backend user is the name of the secret. Okay, the secret will be named as backend user. From literal. Literals means you have to pass on the value. So team, whenever you create a secret from the command line, you don't give the encrypted format. Okay, you give a plain text. If you create a secret using command line, pass on the values just like that without encryption. So the key is backend user name and the value is backend admin. Alright, so I'm going to create the secret now. Secret is created. Alright, now I am going to create the pod using environment variable for this. Okay, this is your pod definition. Here I have provided environments. The name of the environment is secret username. I have to pick the value from key secret reference. Which secret I have to refer? Backend user and the value of backend username. Okay, I'm going to use this pod. Alright. Now if I want to see the value, I don't have to log into the container every time. Alright. I can simply, in place of bash, I can simply give echo the secret username. Okay. So the value was backend admin. Alright. So team, this is how you use your config map and secrets. Do let me know if you have any question with secrets and config map. But we can also easily decode base 64 encoded data. So yes, Jagannath, you can do that. Alright, you can do that. But when you inside a container, see, the purpose of a secret is to pass some value secretly to a container. So it has to be not visible outside the container, but once you are inside the container, it should give you the actual values. Gaurav, you are asking, we encrypt the values at what level the decryption took place. Okay, Gaurav, that is simply encrypted and decrypted. You pass the encrypted value. Okay, so it will get decrypted because you have used base64. It is an automated process. It is from the Linux environment. Decryption took place automatically. Rishabh, we have already seen even the encrypted value is not visible in a secret. You can describe a secret, you will get a blank area. Okay, when you describe a secret, you don't get the encrypted value, you don't get the decrypted value as well. Anyway, we can avoid doing base64 encryption by ourselves. Kushagra, that is up to you. Whatever the encryption type you want to use, you can use. Okay, that is completely up to you. You don't want to use base64, you want to use any other encryption, you can use that also. Sarath, will secret volume is created as PV in a simple example? No, Sarath, PV is completely different. Okay, PV is completely different concept as a volume. I'm just mounting it as a volume. Inside, when you define a volume, alright, let me show you. Whenever you define a volume, below that you give what is it. You can give my PVC. In the previous example you have seen here persistent volume claim. Previous to that example you have seen here host path. Previous to that example you have seen empty directory. Okay, so it is a way of passing something using volumes. Under volumes, what you have defined, that matters. So a config map is completely different from PV. We should not compare it like that. Joydeep, can we use a PV for secrets? Joydeep, secrets are managed internally by Kubernetes. Again, as I said, PV is completely different concept from secrets. Shiju is not encryption and encoding. Yes, Shiju, my bad, I used the wrong word. Okay, encryption and encoding. It is encoding format, base64. Ankur, majorly it is used base64 only. Okay, but it is not a standard. You can choose anyone. All right, but majority of the use is of base64 only. Rishabh, it is a support from your operating system. Where can we change the encryption type? It is based on your operating system. What encryption or encoding formatting you have installed. Okay, in you can have your encoding installed on your operating system, and you can encode the data using that. It will be decoded automatically. So you don't have to define it anywhere. You should have installed it in your system. That's all. I meant, is it possible if a secret can itself encrypt our plain text to base64? Kushagra, you have given the base64 encoded data and that is being converted into plain text. Okay, so you are asking how to have your plain text to base64 format, and we have seen that how you can do that. There is a command already provided you in this documentation. Right? Okay, so team, is secrets and config map clear to all of you? If so, we are going to move to the next topic. Okay, we still have 3 topics left for today. Sarath, that is a concept of security. Okay, that is what we are going to cover in the next session. Okay, our next session is dedicated to the security, certificates, context, there we are going to see how we can secure our pod. All right. Okay. So team, now we are going to discuss two topics that is completely dependent on your managed Kubernetes cluster. Okay. Cloud disk and service load balancer are the two topics that you can only study with GKE or any EKS or managed cluster. All right. So team, you have understood about the PV and PVC concept, right? PV and PVC is clear to all of you. Now, one thing is, consider I have used an NFS shared mount point, right? Because I wanted to have consistency. So what I have done, I have created an NFS and it is attached to all the worker nodes. So don't you think it is not a cost efficient way of doing things? Okay, because in any cloud environment, whether it is your AWS or GCP, it is a model of pay as you go. All right. So if you have created a NFS dedicatedly, whether it is being used or not, you are going to pay for it. So even if your NFS is not being used, it is going to incur some charges and you have to pay for it to your cloud provider. So that is not a very efficient way of doing it, because you are paying for something that you are not using. In that scenario, your cloud disk comes into picture. Okay, with cloud disk, what you can do, you can create the volume directly on the cloud when it needs to be used. Okay, whenever a pod requires a volume, then only it is going to create a cloud disk. It is going to create a volume directly on the cloud, not on any server. Also, that cloud disk will be available to all the instances, to the complete cluster. Okay, and that can be done only with GKE. So that is why cloud disk is a concept. It is not important for your examination. They never ask about a cloud disk because it is a part of GKE. It is not a part of core Kubernetes. Okay, similarly service load balancer as well. So let's see an example for the cloud disk. Okay, this is the one, CHGCP. So team, this is how you are going to create a storage. All right, this is the API version storage class. Okay, I'm going to create a storage class now. All right, earlier what we did, we use a standard storage class, general one. Okay, that general one, what it does, it create the volumes on the instances. All right, that reception is only allow you to book hotel in that particular room. But if you want to book a room at some other place, you have to deal with another manager, right? So for that purpose, I am going to create another storage class that will be capable of creating volume from GKE Cloud. You can see the provisioner is GCE, Google Cloud Engine. So this storage class will allow you to create volumes directly on the GCP. That is why I have taken this. All right. So what I'm going to do, take the raw format of this. This time I'm going to create the storage class first. kubectl create -f. kubectl get sc is a short form for storage class. All right. You can see a fast storage class is just created. All right, 7 seconds ago. Who is going to provision it? Google Cloud Engine. This volume will be, so this storage class is going to instruct Google Cloud Engine directly to create the volume. Okay, volume on the binding mode is immediate. Whenever the requirement is arise, it is going to immediately provision your volume. All right, and the reclaim policies delete. You can modify it, you can have it as a recycle, you can have it as retain. Okay, that is up to you. But as of now, it is created by a delete one. So now your storage class is created. All right. Now you don't have to create the PV. Okay, that is the part that we are skipping. All right. By creating a storage class, we don't want persistence volume to be created beforehand. Okay, that is the requirement, right? So now we don't have to create the persistent volume. We have to create a PVC right away. PVC storage class fast. Persistent volume claim I am going to create PVC. Which storage class I am going to use, which manager I am going to use is fast this one. Okay, what is my requirement? I need 10 GB. So a 10 GB storage volume will be created on the Google Cloud directly. Let me take the raw format. kubectl create -f and your persistent volume claim is created. kubectl get PVC. Okay, so team, you can see that a persistent volume claim is created and it is already bound. You never created a persistent volume in the first place, but still the status you can see is bound. It means a persistent volume is created in the real time. What is your persistent volume? This is your persistent volume, 10 GB, and this is your access mode and storage. kubectl get PV. Alright, you can see this is the name of your volume, and where this volume is created, it is created directly on your cloud. So team, can you go to storage and you can see a persistent volume claim is already created. Okay, this is from the Google Cloud, GKE. Let's see about the volumes. Cloud storage. Okay, not here. I'm forgetting the name. Okay, it has to be somewhere. I'm forgetting the location exactly. Okay, disks. Okay, thanks Akur. I forgot it. Thanks Ankur. Okay, so team, here you can see the volume is created. Okay, how to verify? You can see the ending of the volume name 4EA5. Alright, 4EA5. This persistent volume is created right away on the cloud disk. Alright, it is not created on any server. So even if the pod gets recreated on any other node, it is not going to impact anyway, because this disk is at the cloud level. Okay, it is not assigned to any particular worker node. Okay, so that is the beauty of this. Any doubts, any question in this? Cloud disk. So let's create this pod as well. Okay, you can use apply and you can use create. Both will create your pod. kubectl get pods. Okay, your secret test pod is created and it is running. Alright. So if you want to see the value, you can see the value of that by logging into your container. Alright, now you're inside your container. At this location you have saved your details. So team, you can see etc secret volume, you can see the password and username. Alright, so that is also encrypted, it is not visible to you directly. And if you want to see the actual values, you can see the username. The username is my app. And if you want to see the password, you can see the password as well. So team, why you can see the username and password? Because now you are logged inside the container. Okay. So the beauty of a secret is if you log into your container, then only you can see the actual values. Otherwise, as a Kubernetes admin, I cannot use any Kubernetes or kubectl command to see the actual values of a secret. If you want to see the value of a secret, you have to log into that container. Alright, yes Kushagra, it is a plain text inside a container. The purpose of secret is it should get read inside a container, right? You should be able to read a secret inside a container, but you should not allow anybody else who cannot log into the container that it should read the content. So secret allow you to keep it a secret outside of container. Inside of container, you can definitely see it. Alright, so team, this is the example how you are going to use a secret using a volume. Okay, if you want to use using environment variable, just like a config map. Okay, we have seen an example, a config map, where you can use it using a volume and using an environment variable. Same thing I'm going to do with the secrets also. Okay, this time I'm going to create the secret using command line. Okay, in a imperative way. kubectl create secret. This is a keyword. Okay, you have to create a secret. Generic is a keyword that you have to give. Backend user. Backend user is the name of the secret. Okay, the secret will be named as backend user. From literal. Literals means you have to pass on the value. So team, whenever you create a secret from the command line, you don't give the encrypted format. Okay, you give a plain text. If you create a secret using command line, pass on the values just like that without encryption. So the key is backend user name and the value is backend admin. Alright, so I'm going to create the secret now. Secret is created. Alright, now I am going to create the pod using environment variable for this. Okay, this is your pod definition. Here I have provided environments. The name of the environment is secret username. I have to pick the value from key secret reference. Which secret I have to refer? Backend user and the value of backend username. Okay, I'm going to use this pod. Alright. Now if I want to see the value, I don't have to log into the container every time. Alright. I can simply, in place of bash, I can simply give echo the secret username. Okay. So the value was backend admin. Alright. So team, this is how you use your config map and secrets. Do let me know if you have any question with secrets and config map. But we can also easily decode base 64 encoded data. So yes, Jagannath, you can do that. Alright, you can do that. But when you inside a container, see, the purpose of a secret is to pass some value secretly to a container. So it has to be not visible outside the container, but once you are inside the container, it should give you the actual values. Gaurav, you are asking, we encrypt the values at what level the decryption took place. Okay, Gaurav, that is simply encrypted and decrypted. You pass the encrypted value. Okay, so it will get decrypted because you have used base64. It is an automated process. It is from the Linux environment. Decryption took place automatically. Rishabh, we have already seen even the encrypted value is not visible in a secret. You can describe a secret, you will get a blank area. Okay, when you describe a secret, you don't get the encrypted value, you don't get the decrypted value as well. Anyway, we can avoid doing base64 encryption by ourselves. Kushagra, that is up to you. Whatever the encryption type you want to use, you can use. Okay, that is completely up to you. You don't want to use base64, you want to use any other encryption, you can use that also. Sarath, will secret volume is created as PV in a simple example? No, Sarath, PV is completely different. Okay, PV is completely different concept as a volume. I'm just mounting it as a volume. Inside, when you define a volume, alright, let me show you. Whenever you define a volume, below that you give what is it. You can give my PVC. In the previous example you have seen here persistent volume claim. Previous to that example you have seen here host path. Previous to that example you have seen empty directory. Okay, so it is a way of passing something using volumes. Under volumes, what you have defined, that matters. So a config map is completely different from PV. We should not compare it like that. Joydeep, can we use a PV for secrets? Joydeep, secrets are managed internally by Kubernetes. Again, as I said, PV is completely different concept from secrets. Shiju is not encryption and encoding. Yes, Shiju, my bad. I used the wrong word. Okay, encryption and encoding. It is encoding format, base64. Ankur, majorly it is used base64 only. Okay, but it is not a standard. You can choose anyone. All right, but majority of the use is of base64 only. Rishabh, it is a support from your operating system. Where can we change the encryption type? It is based on your operating system. What encryption or encoding formatting you have installed. Okay, in you can have your encoding installed on your operating system, and you can encode the data using that. It will be decoded automatically. So you don't have to define it anywhere. You should have installed it in your system. That's all. Is it possible if a secret can itself encrypt our plain text to base64? Kushagra, you have given the base64 encoded data, and that is being converted into plain text. Okay, so you are asking how to have your plain text to base64 format, and we have seen that how you can do that. There is a command already provided you in this documentation. Right? Okay, so team, is secrets and config map clear to all of you? If so, we are going to move to the next topic. Okay, we still have 3 topics left for today. Sarath, that is a concept of security. Okay, that is what we are going to cover in the next session. Okay, our next session is dedicated to the security, certificates, context, there we are going to see how we can secure our pod. All right. Okay. So team, now we are going to discuss two topics that is completely dependent on your managed Kubernetes cluster. Okay. Cloud disk and service load balancer are the two topics that you can only study with GKE or any EKS or managed cluster. All right. So team, you have understood about the PV and PVC concept, right? PV and PVC is clear to all of you. Now, one thing is, consider I have used an NFS shared mount point, right? Because I wanted to have consistency. So what I have done, I have created an NFS and it is attached to all the worker nodes. So don't you think it is not a cost efficient way of doing things? Okay, because in any cloud environment, whether it is your AWS or GCP, it is a model of pay as you go. All right. So if you have created a NFS dedicatedly, whether it is being used or not, you are going to pay for it. So even if your NFS is not being used, it is going to incur some charges and you have to pay for it to your cloud provider. So that is not a very efficient way of doing it, because you are paying for something that you are not using. In that scenario, your cloud disk comes into picture. Okay, with cloud disk, what you can do, you can create the volume directly on the cloud when it needs to be used. Okay, whenever a pod requires a volume, then only it is going to create a cloud disk. It is going to create a volume directly on the cloud, not on any server. Also, that cloud disk will be available to all the instances, to the complete cluster. Okay, and that can be done only with GKE. So that is why cloud disk is a concept. It is not important for your examination. They never ask about a cloud disk because it is a part of GKE. It is not a part of core Kubernetes. Okay, similarly service load balancer as well. So let's see an example for the cloud disk. Okay, this is the one, CSGCP. So team, this is how you are going to create a storage. All right, this is the API version storage class. Okay, I'm going to create a storage class now. All right, earlier what we did, we use a standard storage class, general one. Okay, that general one, what it does, it creates the volumes on the instances. All right, that receptionist only allow you to book hotel in that particular room. But if you want to book a room at some other place, you have to deal with another manager, right? So for that purpose, I am going to create another storage class that will be capable of creating volume from GKE Cloud. You can see the provisioner is GCE, Google Cloud Engine. So this storage class will allow you to create volumes directly on the GCP. That is why I have taken this. All right. So what I'm going to do, take the raw format of this. This time I'm going to create the storage class first. kubectl create -f. kubectl get sc is a short form for storage class. All right. You can see a fast storage class is just created. All right, 7 seconds ago. Who is going to provision it? Google Cloud Engine. This volume will be, so this storage class is going to instruct Google Cloud Engine directly to create the volume. Okay, volume binding mode is immediate. Whenever the requirement is arise, it is going to immediately provision your volume. All right, and the reclaim policy is delete. You can modify it, you can have it as a recycle, you can have it as retain. Okay, that is up to you, but as of now it is created by a delete one. So now your storage class is created. All right, now you don't have to create a PV. Okay, that is the part that we are skipping. All right, by creating a storage class, we don't want persistence volume to be created beforehand. Okay, that is a requirement, right? So now we don't have to create the persistent volume. We have to create a PVC right away. Okay, PVC storage class fast. Persistent volume claim I am going to create PVC. Which storage class I am going to use, which manager I am going to use is fast this one. Okay, what is my requirement? I need 10 GB. So a 10 GB storage volume will be created on the Google Cloud directly. Let me take the raw format. kubectl create -f and your persistent volume claim is created. kubectl get PVC. Okay, so team, you can see that a persistent volume claim is created and it is already bound. You never created a persistent volume in the first place, but still the status you can see is bound. It means a persistent volume is created in the real time. What is your persistent volume? This is your persistent volume, 10 GB, and this is your access mode and storage. kubectl get PV. Alright, you can see this is the name of your volume, and where this volume is created, it is created directly on your cloud. So team, can you go to storage and you can see a persistent volume claim is already created. Okay, this is from the Google Cloud, GKE. Let's see about the volumes. Cloud storage. Okay, not here. I'm forgetting the name. Okay, it has to be somewhere. I'm forgetting the location exactly. Okay, disks. Okay, thanks Akur. I forgot it. Thanks Ankur. Okay, so team, here you can see the volume is created. Okay, how to verify? You can see the ending of the volume name 4EA5. Alright, 4EA5. This persistent volume is created right away on the cloud disk. Alright, it is not created on any server. So even if the pod gets recreated on any other node, it is not going to impact anyway because this disk is at the cloud level. Okay, it is not assigned to any particular worker node. Okay, so that is the beauty of this. Any doubts, any question in this? Cloud disk. Masumi, from where you asking wait for the first consumer? Storage class status. Where exactly? Provisional reclaim policy, volume binding mode, allow volume age. Okay, this wait for the first consumer. Okay, so for this, whenever you use this storage class, okay, first it is going to have a pod first, okay, and after that, a pod will be created, a volume should be assigned, but once you start putting some data at that volume, only then that volume will be created exactly. Okay, so that volume will be assigned. Even when you create the pod, it will wait until unless you write some data to that particular volume. Okay, otherwise it is used internally for your Kubernetes. It is not available for you. All right, you are always suggested to use the standard one, or you can create your own. So this is wait for the first consumer. It is used by the Kubernetes internal processes. They create the volume when and where required immediate basis. Like they will have a volume internally, but it won't consume any space unless you write some data in that volume. Is there any similar service like CloudDisk in AWS? Yes, Ankur, there is. If you have used EKS service, okay, in AWS you have EKS for Kubernetes engine. There you can use the volume as per your choice. Here we have SSD. There we have different type of volumes. I'm not a big fan of AWS, so I don't know all the type of volume which are available there, but you can use that. Okay, for that you have to create the storage class where you have to give the provisioner of AWS. Any open source solution for storage class to create dynamically in a non-cloud environment? Okay, Sarath, that is up to you. If you want to create a non-cloud environment, you have to choose the provisioner accordingly. Okay, so here you can see for the storage classes, if you see the definition, this definition is for the cloud storage for GCP, Google Cloud Engine Provisioner. Okay, so if you want to have provisioner, depending on your environment, you can have to Google it from the Kubernetes official documentation, which provisioner for the you have to use. Okay, we have used for the GKE. If you want to use for AWS, you can simply search out for the provisioner of AWS for storage class in Kubernetes. You can find it there. Rishabh, but here the provisioner for standard is GCEPD. Yes, it is GCPED, but here you are defining the type as PD SSD. Okay, here you're defining the type is PD SSD, so that it is going to create the volume directly on the Google Cloud. Okay, obviously provisioner is going to be GCE. If you are creating the volume also on the VM machine, the provisioner is going to be your Kubernetes itself. Let me show you here. All the volumes that are attached to your worker node 1, worker node 2, all the volumes that are attached on your master, all the volumes are provisioned by GKE itself. Alright, even on the worker nodes, it is provisioned by the GKE, right? So you have to give the type also, parameter. Yeah, EBS can be used for AWS, Joydeep. Okay, any other question till now? Where can we define reclaim policy for the standard PV? So under specification, you have to define it. Okay, Kushagra, if you want to define the reclaim policy, you can see a previous definition of any PV and PVC. So you can see all these type of definitions are given under specification. Your storage class, your access mode. All right. If you see a PV definition as well, you can see the access mode and reclaim policy is under your specs. So you have to give that under specification of your PVC as well. Okay, Mosumi, you're asking how read write once and read and many applicable for the cloud disk. Okay, so if you have multiple pods running on different nodes, okay, so read write once here is going to be defined as a particular pod and a particular deployment. Okay, so if you have created a deployment or if you have created a pod, it will be accessible. This volume will be accessible to that only. All right, one deployment, one PVC, or one pod, one PVC. That is how you're going to do the mapping. If you have given the read write once, that volume will be accessible to that only. But if you have given read write many, so it can be used by different deployment and different pod as well. All right. So team, I guess we won't be able to cover the StatefulSet and headless service today because of the time, because of the questioning. All right. But we have to cover the service load balancer because this is the part that we have to deal with GKA itself. Okay. So team, how many type of services you remember that we have in Kubernetes? How many type of services are there in Kubernetes? Cluster IP node port, right? Okay, I guess Shiju, you have given the load balancer as well. Okay, great. Okay, team, consider you have a deployment, and under deployment you have created 3 replicas. All right, and these 3 replicas will be exposed to the outer world using a service. Okay, and this service will expand across your cluster. Okay, consider these are your nodes, right? Node 1, node 2, node 3. This is your master node. This is your worker node 1. And this is your worker node 2. So if you remember about the services, okay, if you remember about the services, you know that with service, you create a node port, a port number. With this, you expose your pods to the outer world. And how do you expose that? You use IP address of your master world, and you can have the node port. Okay. So here you have the functionality that you can use IP of any of the worker node. Okay, you can have IP2 with node port. You can have IP3 with your node port, right? That is a flexibility you get. You can use IP of any of the machine, whether it is your master machine or your worker node 1 or worker node 2. Now the question arises that what you do, what IP you are going to give to your customer, okay? Or simply you create a DNS entry, okay? www.shub.com. Okay, that is my application URL. So behind that, you have to do the DNS mapping. You have to give an IP as well. So whose IP are you going to give? Are you going to give the IP of your master or your worker node 1 or worker node 2? Because IP of any of the machine is going to work. All right. In that scenario, you need to do the load balancing. Okay. You're going to have a third load balancer that is called load balancer service. Also team, you have to remember that load balancer service is again available only with managed Kubernetes cluster. Whether GKE or EKS, it is not available with a core Kubernetes. Alright, it is only available with this. So what happens if you create a load balancer type of service? So you are going to have a single IP. Okay, you're going to have a single IP, you are going to use a node port, and then load balancing will take place across IP1, IP2, IP3 as well. Okay, a single IP, traffic will be routed with master 1 IP or worker node 1 IP or worker node 2 IP. Alright, so you have a definite endpoint if you do a load balancer service. Alright, so team, I'm going to create a load balancer service only. Okay, nothing much than that. You have to go to the repository. Here you have service network, and here you have a load balancer YAML. Alright, I'm going to create a deployment. This is the name of the deployment. These are the specification. I want to have 3 replicas. Alright, all this definition is all clear to you. Now I am going to create a service. This service has a type of load balancer. Alright, and the port number it is going to use is 3000. So let me take the raw format of this one. I'll copy it. kubectl create -f, and that's all. So you can see your deployment is also created. Your load balancer service is also created. kubectl get svc. Alright, you can see a load balancer, this is the third type of your service, is created. External IP is still pending, and this is the port number for you, 32556. Alright, let's see where it does get created in the cloud. Alright, let's search for the load balancer. Alright, team, you can see a load balancer is created. 1 target pool, 2 instances. It means it will do the load balancing between worker node 1 and worker node 2. Alright, this is the load balancer that has been created. Alright, this is the front end URL, and this is the IP address and port number you are going to use on your browser. Alright, you can see the output is going to come like this. Alright, you can refresh it as many times. It will be load balanced between your 3 ports. Alright, the port number is being used 3000, and if you see here, alright, 3000 is a port number for your external, and 32556 is your node port. Alright, so in the diagram you can see that you have a load balancer service. It create a service node port also at the back end. Okay, a load balancer service also create a service node port at the backend by default. So IP address and node port, it will be used for the front load balancer. It will do the load balancing between these worker nodes, and then it is going to use the service IP of node port and use a node port and distribute your traffic across your pods. Alright, so team, is the service load balancer clear to all of you? It is simply putting a load balancer in front of your cluster. Alright, simply putting a load balancer in front of your cluster. Any question with service load balancer, team? Gaurav, in the local cluster, you have to have a load balancer automatically at your own. You have to create a manual load balancer. Okay, if you are using cloud, you have to create your own load balancer manually on the cloud front. Alright. If you are not using a non-cloud environment, you have to use a HA proxy server. Himanshu, you want to create a load balancer for pods using command line. Himanshu, if you are creating a deployment, you are already doing the load balancing. Okay. If you talk about a deployment, it is itself doing the load balancing between your pods. Why do you want to do it differently when your deployment is doing the same job? No, Kushagra, it doesn't create the cluster IP because that is not required here, right? If you are doing the load balancing on the IP level of your cluster, all right, it means you want to expose your application. So if you're exposing your application, you need only node port. You don't need cluster IP. Jagannath, I have repeated many times, okay, that service load balancer and cloud disk are not a part of your examination because it is your managed Kubernetes cluster, okay. Cloud disk and service load balancer cannot come in your examination because it is not a part of your core Kubernetes. It is a part of your managed Kubernetes cluster. I just wanted to give you a better idea that is going to help you in the real environment. Something more than for your examination. Where does the node port to the port mapping define? Is it default port number 80? Siddharth, that you have to define in your YAML. Okay. So Siddharth, you can see here, when you give the container definition, you have to define at what port your application listens. Okay. This is my application and I know my application, my container listens to port number 3000. So you have to define it at the container port. Akhil, for your examination point of view, you have only two services in Kubernetes, that is node port and cluster IP. Okay, so for CKA exam, you have to remember only two services, node port, cluster IP. If you want to go for an interview or you want to practice in the real-time enterprise level, you have three services, but load balancer is specific to managed Kubernetes cluster. Kushagra, you have never created a cluster IP for other pods, right? All the pods can communicate to each other by the service that is created by Kubernetes itself. Okay, thus you have seen all the kube system pods. All right. Similarly, Kubernetes has a system level service as well. This is your Kubernetes cluster IP service. This helps with all the internal communication. Whenever you create a deployment, all the pods can talk to each other, right? But we never created a cluster IP service. Then how they are communicating to each other with this service? This is always created by default. Even if I delete everything, this service will get created automatically. kubectl delete all -all. Okay, so whenever delete everything, you might have seen that a service is also deleted. Okay, I don't know if you have paid attention to that or not, but this Kubernetes service is also deleted. Can you see Kubernetes service is also deleted? But it is a system level resource. It will get created automatically. kubectl get svc. Okay, it was not deleted. So you can see cluster IP is always coming back. It is just like a system level resource that helps in with the internal communication. Abhishek, you have to understand this. Does job support service and endpoint? Why do you want a job to support service and endpoint? Job is something the pod will do some task and it will die. So where you want to expose that? A job is completed.
Once it is completed, your pod is going to die out. Then where you are going to expose that died container? Nowhere. So why do you want job to support services and endpoints? No point of having that. Kushagra, so if we are defining a separate cluster IP, it means we are isolating those set of pod from the rest of the cluster pod. So Kushagra, that is you're creating a subset of your clusters, okay? You have a cluster IP, it is allowing you for your complete cluster to talk to each other, all the pods inside your cluster to talk to each other, okay? So you are creating a subset inside your major set, so that a set of pods, some database pod should be able to talk to some application pod. All right, you can have this disabled at that time. So that is a part of security, how you can allow your specific pods to talk to each other only. Okay, you can also stop them by talking to each other on across the nodes, across the cluster. Across the cluster, definitely it is not possible. If you want to stop communication between a pod to a different pod on a different node, or you don't want some deployment pods to talk to other deployment pods, you can also restrict that, and that can be done using security that we have in the next session. Okay, so cluster IP is used for the internal communication. By default, cluster IP is already provided. You can also create your own cluster IP, and you can provide a restriction as well that we haven't seen yet. That is the agenda that we have for the next class. Okay, in the next class you can see we have networks, security, context and config files. So team, any other question for today? Alright team, so welcome to the last week of your Kubernetes training. Alright, and second last class. Team, one question for all of you. Actually, I missed that. I don't remember it exactly. Did we cover StatefulSet and headless services in the last class? Rahul, what templates you are talking about? There's nothing like templates in Kubernetes as such. Girish, last week we worked on GKA cluster, right? So there you got a terminal, and then that was the only master node you have. And the thing is, in managed cluster, you don't have access to your master node. You just get a terminal. All right. Similarly, same case it's with AWS EKS. All right. Not much difference. Setting up is a difference. That is all. Otherwise, all the commands you are going to execute, and all the commands, all the objects will keep working on EKS. Everything will be same. Only setting it up is going to be different. Rahul, you want to make YAMLs files automate. We have already covered that, if you remember. I have told you with the dry run, right? If you remember, I have told you what are the dry runs, how you can create a dry run -o YAML file. Dry run equals to client and -o YAML. You get a template. You get a output. How you can create a YAML file. Okay, it is just like that. So if you're asking about that template, we already covered that. Gaurav, you're saying on GCP master and slave node configuration, I exposed an Nginx deployment using node port service, but it was not accessible using master IP, node IP with node port. Okay, Gaurav, what was the error you were getting? Or the page was not loading, or you got some error or something? Okay, so for that purpose, what I'll suggest you to do, you have the node port, kubectl get services, alright. There you get the details about the services you have created. Describe the service, node port service, describe it, and also do the curl operation on the cluster IP of the IP of your service. Okay, if you get kubectl get services, you will get the name of your node port service and you will get an IP also for your node port service. Try to curl it from the command line. Alright. If that is the case, if the curl is happening, it means your service is created properly and it must be accessible on the browser. What difference can be there then when you created the servers? Alright. When you created the servers, chances are there that you didn't allow HTTP and HTTP access at that time. Alright, that is one possibility. And I suspect that is the only reason because of which you are not getting it on the web page. Alright, because if curl operation is working on the cluster IP of your service, it means everything is set up properly. If you are not able to access from the browser, it means your servers don't have the access to the open internet. Okay, the curl operation on the cluster IP was working and I have allowed HTTP and HTTP access. Gaurav, did you try it again after cleaning up the setup and doing it again? Okay, do that also. Apart from that, I'll suggest you to do one thing more. Alright. You have all your master IPs, all the servers, all the nodes, either your master or worker nodes component, do have Docker installed. Alright, simply create a Nginx Docker container with Docker command. Okay, with Docker command, create a container of Nginx on any of the machine. Alright, what will happen? That will create a container on the same node. You will have the local host there. So what will happen? You will expose a node. You will expose a port number to that also. Alright, so if you have seen my first class, you will get all the details how to create a single Docker container. Then when you create an Nginx Docker container with Docker, you will expose a port number as well. So use that port number and use its own machine IP address and try to access it from the browser. Alright, so a simple Docker container, if it is working from the browser, it means something is missing from your Kubernetes setup. If that also is not working, it means your servers don't have access to the open internet. Also, when I use this load balancer service, the IP allotment was remain in pending state for more than 15 minutes. Seems something not good with my GCP. Gaurav, 15 minutes is a long time. It was not supposed to take that much time. Alright, if it take that much time, you have to describe the bot, and in the event section, you will find out what was not going well. Okay, from there you can do the troubleshooting. Alright, so team, as you all have confirmed that your stateful sets and headless services were not covered in the last class. Okay, sometimes when I take multiple patches, I do forget few things, that what was covered and what was not covered. That's why I double check with you people. So that was not covered. So first, what we are going to do, we are going to cover your stateful sets and headless service that was supposed to be done in the last session. but it was not done. So first we're going to cover that. After that, we are going to move to your networking concepts. All right. It means we are going to talk about your security, not network exactly, but securities. All right. In securities, we'll discuss about your authentication and authorization. We'll talk about your certificates, roles and role binding, cluster role binding, kube config, context, and then we'll discuss about security account and security context as well. Sorry, service account and security context. All right. So team, this is the objects we are going to cover today. All right. So we'll try to cover it all today itself so that we don't have to stretch on the last day, and we can have a good session on troubleshooting and important question discussion and tips discussion on examination. All right. So we'll try not to leave anything. All right. So this is what we are supposed to do today. Sorry, Gaurav, you say what we should do when our nodes doesn't have access to internet. So Gaurav, in that case, you I think I have told you earlier as well. First is your HTTP and HTTP access should be there. You should have access to all cloud APIs that I have also shown you in the earlier classes. All right, these are the two sections which are important. Apart from that, you should have a firewall rule that should have access to 0000/0 IP. All right, that is, I'm just telling you for the practice purpose, not for the enterprise level. Definitely they have their own set of rules, but for your practice purpose, you should have a firewall rule in place that allow access from open internet, and that should be applicable to all the nodes that you have created. And two things that I told you: HTTP and HTTPS access, and access to all cloud APIs. Alright team, so shall we start with today? Okay, yes Gaurav, that is a possibility. Okay, in one of my session I have also shown you to create the firewall rule as well. That is as far as I remember. If I'm not remembering correctly, do let me know. If you don't know how to deal with the firewall, I'll show you that also. Okay, tomorrow you can let me know. I'll show you how to create a firewall rule also. Okay, so team, shall we start with today? With the topics that we have today? Any question you can ask before we get started? Okay team, so let's get started. First thing first, you do have a cluster as you always had. Alright, in that cluster, consider you want to create a deployment. Alright, if you're dealing with a normal application, if you're just dealing with an application, so what happens that you create a deployment with multiple replicas, right? So what is happening here, if you have asked to create 5 replicas, so what happens, all the 5 replicas are created on the single go. Okay, I'm not telling you anything new, I'm just telling you what we have already seen and discussed. If you have asked for 5 replicas, all the 5 replicas will be created simultaneously and they will be available at the same time. That is a general nature of your deployment. Right? Now, consider you have some database pod this time. In the first scenario which I told you, that is an application pod. So application pods are stateless in nature. What is stateless in nature? They have a WAR file and it will remain in that way. So you will have a application, it will be a web-based application or any kind of application. It is going to remain constant. Its state is not going to get changed. State is not going to get changed. It means it is stateless in nature. It means even if one pod goes down and new pod will be taking its place. All right. So there is nothing like there will be some updates in the previous pod, and the new pod should carry that updates also. Because in application pods you have a jar and war file. We don't update it like that. If we do update, we directly upgrade your deployment. Right? Now, second scenario, consider you have some database pods. Alright. Now, what I'm doing, I am having some database pod. Alright, I do have the replicas. Alright, so I am having 5 replicas. In database pod, what is the basic nature? That in a database, you will have some data. Alright, or with data, you are going to play around. You are going to delete some rows, you are going to insert some rows, you might update some rows. Alright, so updates are always going to happen. Consider if I'm creating a database pod with deployment, if I want to have 5 replicas. Alright, so what will happen? All the 5 pods will be coming online at the first time. Alright, and one thing also we have seen earlier, that if a user is trying to access its application, I have shown you that maybe first time the user will connect with pod 1. Alright, so what it did with database pods, the user connected with pod 1 and it did some updates. Alright, it updated some rows. Now the user refreshed the browser. Alright, once the browser was refreshed, he got connected with pod 4. Okay, fourth pod was now serving the request. Now, does the fourth pod have the updates from the first pod? Does the fourth pod has the updates that he made on pod 1? If I'm talking about the deployments. No, of course, right? So deployment is a big failure if I talk about your database pods. Right? Deployment is a big failure if I talk about your database pods. Again, same case, if consider this pod goes down. Alright, one thing I can do that with volumes, I can have all the pods in sync, but still there might be a chance that once a pod is deleted, another pod will take its place. It might not be at the same state that earlier pod was supposed to, because deployment creates the pod with the definition. It doesn't take all the values from the previous pod. Right? So team, these were the challenges that I wanted to get addressed. If I talk about database pods, I don't have anything in Kubernetes that helps me with this. Alright. Then comes the concept of stateful sets. Alright. Stateful set is almost similar to your deployment. Alright. In stateful set, you also define the number of replicas. In deployment, you also mention the number of replicas. Now I'm going to tell you the basic difference between these two. If you create a deployment, all the pods comes online at the same time. In deployment, you ask 5 replicas, all the 5 replicas will be coming online at the same time. But if I talk about a stateful set, that is not the case. In stateful set, what happens? First, your first pod comes online. Once it is running, then your second pod will be coming online. After that, third pod. After that, fourth pod. After that, fifth pod. One pod at a time comes online. Okay, so stateful set, whenever you create a stateful set, one pod will come at a time. Next thing, the naming convention difference. The naming convention in deployment, it is always alphanumeric string, some gibberish string at the end, right? But if we talk about stateful set, the naming convention is defined properly. Alright, the first pod will be addressed as pod 0, second pod will be addressed as pod 1, third will be pod 2, pod 4 and pod 5. This is the naming convention is going to be there if you create a stateful set. Okay, that is not present in the deployment. It is always some alphanumeric gibberish string. Okay, Two difference discussed, one more difference. All right. Consider in a deployment, if one pod goes down, another pod will take its place. All right. Again, no updates are going to be there, and there is no specific order as well. All right. In deployment, we have seen all the pods are equally capable of serving the request, and it can go round robin. The user can connect to any pod in deployment. But in database stateful sets, in stateful set, if one pod goes down, consider pod 03 was brought down. All right. So it is not like it will take another place or something like that. All right. All the pods will remain in the same order. If pod 03 went down, pod 03 only will take its place. Okay. Naming convention is also going to retained. All right. And it will take its own place as well. All right. So this is the difference. Another one is whenever the user connects, there can be two operations, right? In a database pod, you can either write or you can either read. All right, these two operations can be done. If you talk about writing, in a stateful set, the user always connect with pod 0. Okay, whenever you want to do the write operation, the user always connect to pod 0. That is defined, that is the rule. All right, but if the user do the read operation, it can connect to any pod. If the read operation is taking place, it can connect to any pod. That is okay. If any write operation is there, it will always connect to pod 0. Now, why is that happening? Because in a stateful set, what happens? Let me tell you. Alright, so looking at this image, you can now understand the pods are connected in a particular order. Alright, consider you did some write operation on pod 0. Once the pod 0 have those changes, it will make those changes in pod 1. Alright, once the changes are made in pod 1, the same will be reflected in pod 2, and then it will pass on the changes to pod 4, 3 and pod 4. Okay. Now the pods will take the responsibility to make all the pods in a stateful set in sync. Okay, this is how it goes in a stateful set. Okay, now let's see a practical example. After that, you will be more clear about it. Alright, so team, also one important thing to note that it never comes in your examination. Okay, I have rarely seen the questions with this. Alright. But still, I just want to tell you for your own practice. Really comes, it is not like it doesn't come anyways. It might come, but haven't seen these questions very regularly. Alright, so here you have to go to the controllers. Alright, here is a folder called stateful sets. Alright, if you want to have some description, you have here. Let me take a simple example of this one. Okay, so first what I'll do, I'll take the raw format and I'll create both things. I'll create a stateful set and I'll create a service also. I will tell you what kind of service it is. Let me connect to the machine first. this was a cluster. kubectl get all. Let's see if we have anything or not. Okay, just an init pod we have. Alright, that is okay. Alright, so team, what I'm going to do, I'm going to create a stateful set. kubectl create -f. Okay, that is not what I wanted to copy. Control C. kubectl create -f YAML. Team, pay attention. kubectl get pods. Team, can you see it is getting created in order? DB0, DB1, DB2, DB3, DB4 and DB5. Okay. First pod was created in this seconds ago. Now DB6, DB7 creating containers. Alright. So team, all the pods were created one at a time. Alright. Let me show you the definition also. I missed that part. Alright. So simply API version kind is always there. Metadata, you have name. Okay. The name of the pods are going to be DB. Under specification, I have given 8 replicas. I have created a service also with this. Select a match labels, Redis. Okay, I'm having Redis containers. Here is a template and here is a specification of the container. Alright. So team, you can see with the time duration also. Okay. See the age. Alright, you will understand that DB0 was created first and DB7 was created last. And we have also seen that they are created one at a time. kubectl get pods. Alright, 88 seconds ago, then 80 seconds ago, 73, 70, 68, 66, 62 and 60. One pod was created at a time. Now what will happen if I make any changes? If I want to update anything in my database pod, the change will be made to database 0 first, okay? Just like it was created. In the same way, the way it was created, in the same way it will pass on. First the changes will be written to DB0, then DB1 will catch those changes, then DB2, then DB3 and in the same order, okay? One pod will be updated at a time and in the same order. Now, as I told you, if I'm going to delete one pod, another pod will be created at the same place. It will not take any other place. Alright, so it's not like if DB04 was deleted or terminated, so what will happen, the order will change and another pod will take the last place. No, that is not the case. It will take its own place always. kubectl delete pod and DB-4 for say if I'm deleting. Alright, I deleted that. kubectl get pods. Alright, you can see that DB04 was again created 3 seconds ago. Alright, so it always take the same place. It never mess up with the order. Okay, because in stateful set, order is very important. That is only what matters actually. Alright, so team, if I want to access my database pods in a stateful set, alright, can I use a normal service like your node port and cluster IP? No, that is not the case. Alright, why? Because what I told you here, you can have either a write operation and you can either have a read operation. Alright, in read operation what will happen? You can connect to any pod, but with write operation you will connect always with the main pod. Okay, DB0, you will always get connected to DB0. Alright, so team, with a normal service, you can say if I'm using node port, we have seen the nature of node port. What happens whenever you hit the browser? Alright, sometime it goes to pod 5, sometime it goes to pod 10, sometime it goes to pod 2. There is no order whatsoever. Alright, so we need some different service that will help us achieve the right operation, because it always has to be done on DB0. Alright,
For that purpose, we create a service that we call headless service. Okay, that is why stateful sets and headless services are always called together. Okay, they are always called together. Now let's see the definition of this. Okay, so as for your understanding, headless service is no different, but it just solves the purpose of writing always to the DB0. Alright, because you know write operation is still the same. You can read from any of the pod, but write operation will be done on only pod 0. That can be achieved with headless service. And this is not the third type or fourth type. I'll tell you the difference, what you can do with the service that it will make as a headless service. Alright, you can see API version is V1. We have service called kind as service. You have the metadata. Alright, this is the name of the service. Under specification, you give the port number, where to expose. Alright, then you mention the cluster IP. Alright, you mention that cluster IP should be none. Okay, you should get cluster IP equals to none. Whenever you define this, it means that you are defining a headless service. Okay, headless service you can consider as it doesn't have the head. Alright, it means it doesn't have the IP. So whenever you create a headless service, this is the one that is going to identify that it is a headless service or it is a normal service. Let me show you here as well. kubectl get svc. Okay, so team, if you do remember from my previous classes, if you create the cluster IP, you always get an IP, right? Whenever you create a node port service, you again get the cluster IP. Alright, if you remember from the last class, when either you create cluster IP or either you create node port, always IP is always assigned. Okay, IP is always assigned. But how to create a stateless service? Headless service. In headless service, you have to mention cluster IP equals to none. Then Kubernetes is going to understand, okay, he wants to create a headless service. Alright, so team, this is the concept of stateful set and your stateful set and headless service. Is it clear to all of you? Any doubts, any question with this? In stateful set, consider a 4 cluster application, not a DB. Okay, 4 cluster application, all 3 are running while scaling down. How will I ensure that the pod which goes down is not processing any requests? Rishabh, that is, I think we have discussed in previous classes. Okay, I think not in this class, sorry, my bad. Alright, so Rishabh, you are asking if you are talking about some application pod and you have downscaled, so what is going to happen? Alright, in that case, see, Kubernetes has a basic nature. It waits for 30 seconds to gracefully bring down a pod. Okay, whenever you delete a pod, Kubernetes try to gracefully shut it down for after waiting of 30 seconds. If it was not able to gracefully shut down after 30 seconds, it forcefully shut it down. So what happened during that 30 seconds? During that 30 seconds, no new connections are made. That is one thing. Consider if a previous connection is already made for more than 30 seconds, it will be terminated abruptly. Alright, so what will happen? For a second of time, you will see that your application is not available. So what you usually do in that case, you hit the refresh button, and once you hit the refresh button, your application is always visible. Alright, so whenever you hit the refresh button, your request will go to some available pod. Alright, that is what happens when you create the application deployment. That is the case. Corey, you are asking how we can access the database when we don't have the IP. Gaurav, we never use the IP exactly. Alright, if you remember, then if we are using node port, alright, we use a node port number. We have never used the IP address. IP address is used for the internal communication. If you use cluster IP, then it is for the internal communication. Again, you never define the IP anywhere. Alright, so IPs are never used if you use a service. We never use it. Alright, so that is for internal purpose. So you don't have to give no cluster IP so that Kubernetes understand it is headless. So it has to solve the purpose of writing to the main pod, and then it will write to the different pod. So if you are going to describe it, let me describe it also. kubectl describe svc Redis. Alright, you can see you still have the endpoints. It is not like that you don't have the endpoints. Alright, it means this server will divert the traffic to your pods. Alright, it will divert the traffic. It does have the endpoint. It doesn't have its own IP. That is the only thing. And that is how it is defined as a headless service. Otherwise, it will fulfill the purpose with which it is created. Ashok, you are asking what is the use of headless service? Okay, that is what I started with. Alright, this is the most basic definition I gave earlier. So Ashok, the thing is, if you want to achieve this, it is something different. Alright, if you do the right operation, it should always get connected to DB0. Alright, and if you want to do the right operation, it should connect to any pod, just like what happens in deployment. Alright, but you want to achieve this, that if you are doing the right operation, it should be done only on DB0. Alright, that can be achieved with a service called headless service. Okay, that is how Kubernetes has defined it, that it is called a headless service. Headless service will allow you to do the right operation on DB0 only and do the read operation from any other pod. Alright, and how to identify if a service is headless or not? You will assign cluster IP equals to none. Okay, whenever you define cluster IP equals to none, it means you will have a headless service. It will not contain its own IP address, and it will solve the purpose of your headless service. It means writing only on pod 0 and not writing on any other pod. But if it is read, it can do from any pod. Alright, so that is the use of headless service. Okay, sure, Kushagra, I can do that. kubectl get pods -o wide. Alright, here it is. You want to verify the port number, IP addresses. You can see that. Okay, 1036.04, 1036.04, 1036.05, 1036.05. Alright, and you can see plus 5 more. It means you have all of them. Alright, endpoints are not listed in order, but you don't have to worry about it. It will always go to DB0 itself. Okay, so many questions. All right. Arjun, can you please repeat why headless service is created here? Is it just to it is just so that first pod has write capability? Arjun, absolutely. Okay, because when you connect to some pod, service plays an important role. Sarath, I just gave you an example of volume just to make you understand. Alright, otherwise it has no relation with volumes or something. Alright, that is what I just wanted to explain you. Otherwise it is not related to volumes in any way. Saurav, you are asking if there is chance of database down, so can we take the backup? Saurav, we are having multiple replicas here. Okay, so what happens if you create a database? You have a data guard setup also, okay, so that you have real-time replication, and that is your backup strategy. If your primary goes down, you will connect to the secondary one. Alright, same thing we are having here. We are having 7 replicas. Alright, we are having 7 replicas. 1 may get down, 2 may get down, not all the 7. Alright, so this is itself a backup strategy. Okay, we don't want to have any other backup strategy. We always have 7 replicas right here. So we will always have some backup. Gaurav, maybe a basic question, but suppose we have an application that wants to connect with a Redis DB using connection string. We need to mention in the connection string in the server address. Gaurav, for that purpose, what you can do, it depends on what kind of database you are using. All right, you might be using MySQL or Redis or Oracle. Oracle is not available in the pods, but yes, MySQL and Redis is also the one. So if you talk about MySQL, I don't have much experience with Redis. So you have MySQL connection string, MySQL -h hostname -u username -p password. All right. So that is a connection string. So what you can do, you can pass on that string. All right. You can pass on that string to your application pods with the help of ConfigMap and secrets. Okay. So that is how you are going to pass your connection string to the application pods. In host, you can mention the pod IP, right? Or you can use the IP of where your database is running. If you're running your database on RDS in AWS, on if you're using your database. So it is not important that you always use database pod. You might be having your database at the backend with RDS services or a standalone database server. All right, so that is also the chances. So you can pass on those details using ConfigMap secrets to your application pods. Prempal, how fast pod will be in sync for reading values post any write operation happens, and what about the read and write operation at the same time? All right, so Prempal, you have already seen that pods are very fast. All right, if you do the reboot, it doesn't take even a second, just a fraction of a second. Mostly dependent on how heavy your application is, it takes fraction of a second. So the write operation is so fast. When I created these pods, okay, when I created these pods, you can see that out of 7 pods, 8 pods, 7 pods were created within a minute. Okay, first pod was created 12 minutes ago. Otherwise, if I take minute wise, 6 pods, 8 pods were created in the same minute. So it is so fast. If you have given multiple replicas, they are created in the same minute. So same happens. Even the lesser time it takes to do the write operation, it gets in sync just like that. Much more faster than the creation itself. How is it able to identify the record level updates and sync pods in all nodes? If or is it deleting and recreating every time when the write operation happens? Okay, Anil, that is an internal process completely. All right. So it is like how you are asking that you have a database. All right. You have a MS SQL database. You have a RDS database, any Oracle database. You are running a command update row number and like that. So now you are asking how the update is happening at the backend. All right. So this question is just like that. So how the replicas is taking the place, whatever you executed on DB0, once it is done, it will be executed on DB1. Once it is done, it will update the DB2. All right. So it is not going to terminate or recreate it again and again. Updates will be made in all the pods in order, one at a time. All right. And how it is done, it is completely internal process. All right. Any other question? Any other doubt with StatefulSet and services? Siddharth, you mentioned that in case of MySQL, you can give pod 0 host name as a connection string. So assuming it is retaining the IP along with the name. Okay, Siddharth, that is the example I gave on the higher level. As I told you that you might be having your database at the backend. You might be using your MySQL database as your RDS services or a standalone database. Okay, that is how I gave you. All right. So yes, if you want to give that also, you can give. If you can use the service also, you can use service also. In the connection string, you can pass on the service name. All right. So service name will be used. All right, and it will divert. It will first write it down on DB0, then it will write it down on DB1, and in the same order. Anil, you are asking, does it have any limitation of numbers of concurrent operation? Anil, practically no. All right. It always get dependent on the configuration that you have for your node and your pods. All right. It all comes back to your CPU utilization and RAM utilization. If they are struggling, then your write operation or concurrent operation will struggle as well. If your RAM and CPU cores are not struggling, you won't have any struggle with the number of concurrent processes. Okay, so it always bring down to the CPU and RAM utilization. All right, so team, this was supposed to be a small topic. All right, and we have already given 85 minutes to this. Is it possible to show a little demo to connect pods using headless service, one write and one read maybe? Okay, Siddharth, so that is going to take time. All right, so we have seen that how it works. All right, so all the read write operation are done by the database admins. If you have your application will be accessed by the third party users. If you're talking about the Kubernetes administration, all right, you just have to create the services and pass it on to the application team. All right, you don't actually do the read and write operations. So as a Kubernetes administrator, you don't have to worry about that. Also, in the examination purpose, as we are here for CKA, Certified Kubernetes Administrator, it doesn't ask you to do the updates like this. All right, so also Siddharth, we have to cover a lot of content as well now in 2 days. All right, so I hope you understand that. Can you please let us know we will be able to see the recordings of today's and tomorrow's class? Yes, Finny, all the things will remain the same. Okay, the 9th class and 10th class will behave in the same manner how it worked in the last 8 classes. You will get all the recordings, you will get all the details just like that. No difference. All right, so team, let's quickly move to the next topic. All right, now we are going to come to the security concept, how your security works and how you can secure your Kubernetes cluster. All right, first thing first, we have authentication and authorization. So team, how many of you know the difference between authentication and authorization? Tell me, what is the difference between authentication and authorization? How they are differ with each other? No one? Okay, Siddharth, got it. Masumi, okay. Arjun. All right. Girish, okay. Siddharth. So Gaurav, what you have defined what? Okay, you have given 2 words. So which is authentication and what is authorization?
Arjun, Sumit, okay, Joydeep, Rahul, Wasami, Rish Prasad, Rahul, Ankur, Sumit. Okay, so many of you. Okay, so team, all of you have given the right answer almost to some extent. All right. So team, as you have already said, I'm going to write it down the same. All right. What is authentication? Authentication asks you, who are you? Okay. Who are you? So it means it is going to check that if you are supposed to be here or not. All right. Or simply it asks for your username and it asks for your passwords. All right. It authenticates you. Okay. It allows you, it checks you, who are you, you are supposed to be here or not, or what is your username and password. That comes under authentication. All right. For example, if I take a layman example, let's take an example of this webinar only. Okay. You are here on this webinar. I'm also here in this webinar. All right. Because we are the authentic user. We have been authenticated. All right. You went to your LMS portal. From the LMS portal, you logged in with username and password. Then you are authenticated and then you are allowed to be in this session. That is why no other person is there in this session. Right. Only we are here. Anybody cannot be here in this room. All right. So that is authentication. You can authenticate it. All right. You can allow and not allow it. So first is your authentication. Now what is your authorization? Authorization defines what you can do. Okay. What you can do. All right. So classic example is role-based access control. Okay. I hope most of you know about what is a role-based access control. We define what user can do what. All right. We'll discuss about RBAC also in details in today's class. All right. But I'm just giving a one word right now. Role-based access control. We define that this user should be allowed to do this. All right. So taking the same example that we have here. All right. I am also in this webinar. You are also in this webinar. It means we all are authentic user. Okay. We have done the authentication. That is done. Now let's talk about the authorization. So the thing is, I am the trainer. All right. So I do have some different privileges than you have. All right. I have the power to mute you and unmute you. You can also unmute yourself, but you cannot unmute me or mute me. All right. So I have some greater authorizations. I can mute you people. I can unmute you people. All right. I can see all of your message. You cannot see all other messages. Right. I can see name of all the candidates. You cannot see the name of other candidates. All right. So that comes under authorization. I have higher authority and then you people. All right. So authorization gives you that what you can do exactly. Okay. I'm here sitting doing more things with this webinar tool than you can do. So it is all comes down to authorization. All right. So team, this is your authentication and authorization. I hope you understand that. Okay. So how you can do the authentication? How many ways are there to do the authentication? All right. We are going to understand about that. A very basic one you have already seen. Okay. You can have username and password. All right. That is one way. Another way, say you want to do it with username and token. Okay. You can generate token and you can use that token. All right. Next, you can use certificates as well. Certificates. All right. You can do the authentication using certificates as well. Okay. And last is you can use service accounts. Okay. With all this, what you can do, you can do the authentication of a particular user. All right. So understanding about all of them. Okay. Understanding about all of them. If we talk about the Kubernetes, in Kubernetes, we
don't use the username and password and username and token for authentication. All right. In Kubernetes, we don't use these two manners. We can use that, but it is never suggested, and it is never comes in your examination also, because Kubernetes understand that we always use other ways. We use server certificates and we use service accounts. Kubernetes itself doesn't suggest you to use username, password, and tokens, but it has given the functionality. But they always stand by your certificates and service account. Alright, so we are going to understand how your certificates works and how your service account works. Alright, so certificates are consider, if we understand about certificates are nothing. It is a two-way communication with which you get some public key and private key and you get authenticated user. Alright, so I will try to explain you certificates in depth so that you can understand it and never forget about it. Alright, so this is the important part. I'll let you know in detail from the scratch. Alright, I know security concepts are a little boring and mundane. I'll try to make it as fun as possible and make you understand the core concepts. Alright, consider a team if I go some to banking websites. Alright, consider I visit this website. Alright, this is a ICICI Bank website. Alright, but how do you know that this is an authentic website? Okay, you simply come here and you do your login details and you just log into your bank account. Alright, but do you rely that this is an official website? This is the authentic website. Alright, how do you know about that? Alright, for that purpose we need certification authentication. Alright, so if you see that whenever you open some official website, okay, some authentic website, you always get this log button. Alright, what does it give you? Connection is secure, your information, for example, is private when you are in this website. Alright, and you can see that certificate is valid. Cookies are 18 use, you don't have to worry about it. You can see that certificate is valid. Alright, so for the authentic website, you will see this message that certificate is valid. Alright, consider you have LMS portal. Alright, in LMS portal also you can see that certificate is valid. Alright, and you can see the certificate is issued by GoDaddy. Alright, you can see it right here. Similarly, you can see in the ICICI Bank website as well. Valid certificate. It has been issued by DigiCert. Alright. So team, these are the certificates that allows you the secure connection, and how it is done at the backend, I'm going to explain you that. Alright. So team, pay attention. Alright. I'll get you all the details from scratch. Consider this is my web browser. Alright. This is my web browser. And this is where your ICICI Bank application is running. This is your ICICI Bank application server. Alright. So what you do, you connect to this web server via internet, right? That is what happens. You type www.icicbank.com. Alright. Your request went to this server. Okay. And you get the response. This is your browser. And this is your server. Alright. So team, now what happens if you use HTTP website? Okay, if you use HTTP website, so what happens that all the details that you pass to this server are in plain text. Alright, so if I'm going to log into this website, alright, I will pass my username, I will pass my password also. Okay, but if this website is not secure, if it is HTTP, following HTTP protocol, alright, my username and password will be transferred to the server in plain text. Alright, so that is risky for me. Why? Because if some intruder or some hacker wants to hack when I'm transferring the details, it can hack in and it can get my username and password details. So he can also go to the website and use my account. Okay, he can get all the details about my account. So that is why we never use HTTP. Okay, I have already written HTTPS. Whenever you use HTTP website that is following HTTP protocol, it means all the details that you are transferring to the server will be given in the plain text, and that is not what we want. Okay, so that is why we always follow HTTP protocol, and HTTP protocol always follow your two-way handshake. Alright, and it provides SSL certificate authentication as well. Alright, how HTTP connections are actually established, let's try to understand about that. So team, whenever you give some request to the website, okay, whenever you give the server some request, okay, that I want to log in, alright, you give some details, you try to access this server. When I did www.icic.com, okay, a request went to that server. When that server saw that a request is coming from a browser, okay, it will transfer its certificate to this browser. Certificate to this browser. Okay, the certificate to this browser will be transferred. That is why I can see all the details here. Alright, I can see all the certificate details. How I am seeing this? Because the server has responded to my request. Server has responded to my browser with the certificate. Alright, along with this certificate, it has also transferred its public key. Okay, it has also transferred it a public key. Okay, what is the purpose of public key? Public key allows you to transfer encrypted data to the server. Certificate is used for the authentication that my browser now trusts this website. Okay, that we have seen. But now I am going to give my username and password details here, right? I want to give my username and password details. They should also not get transferred in the plain text because intruder can hack it. For that purpose, your server shares the public key to the browser. Alright, now the browser is going to send the data encrypted with public key. Alright, now the data will be transferred using public key encryption. Okay, now server has to decrypt it. How the server is going to decrypt it? Server is going to have a private key that will be associated with the public key. Okay, encryption is done by the public key that was provided by the server. Now server got the encrypted data. Alright, now server has its own private key. Okay, and that private key only decrypt the data. Consider that you're transferring your data using public key, your data is encrypted. Your intruder has hacked and it has taken those details. Okay, that what username and password you are transferring, even in the encrypted way, it will try to hack it. But how he's going to decrypt it? How it is going to find it out what exactly the string is? He should have the private key. If the user doesn't have the private key, he will not be able to decrypt the data. Alright. So once the connection is established, now I am going to log in. I will pass on my details. Those details will be transferred to the server with the encryption of public key that I have received along with the details of this certificate. And at the server level, it is going to decrypt it, and then they are going to authenticate me and provide the authorization to access my own account. Alright, now what is your public key and private key? What is your public key and private key? Okay, it is always confusing. Alright, it is always confusing, so I'll try to make you understand about this. What is a public key and what is a private key? Okay, so team, consider that public key is not a key. Public key is a public lock. Okay, I'm just giving you a basic examples for your understanding. Consider that your public key is not a public key, it is a public lock. Alright, and you can open that public lock using private key.
All right. So consider team again basic layman example. Consider I'm going somewhere. All right. I live in my house alone and I am going somewhere. So what I'm going to do, I'm going to lock. All right. I'm going to put a lock at my door. All right. So once I have left, I'm going to put a lock at my gate. So team, that is a public lock. How it is a public lock? Anyone who will cross my house will be able to see that lock. All right. Anybody crosses my house, he or she will be able to see the lock because that is a public lock. Anybody can see it. Anybody who's crossing my house, he will see that this gate is locked and he can see the lock. Similarly, the public key that has been transferred to the browser, it will be available to the intruder as well. Intruder can also have that public key. All right. He can also see that it is encrypted data, it is encrypted using a public key. All right. So public lock is visible to all of them. But can anybody open that lock? Nobody can unlock it because they don't have the key for it. Okay, I locked the door, so I have the key. So nobody can open the house. Okay, nobody can open the public lock. Nobody can decrypt the data of public key until and unless they have the private key. Then, okay. So if I have put a lock on my gate, if I give the private key to one of my friend, then he might able to come and open the lock only when I have provided the private key as well. Otherwise, private key is with me. Nobody can open the lock. Nobody can open the public lock. Only I can. Okay. So team, till here it is clear to all of you. Okay. This is the very basics of your certificates. Certificate connection, secure connection, SSL connection. This is the very core basic of it. Okay, I wanted to explain you. It has nothing related to your Kubernetes as of now. All right, because we are going to use certificate, I wanted to have a basic understanding how your certificate security work. Okay, that is why I'm giving so much time on this. All right, team, please confirm if it is clear to all of you how certificates are transferred, how your public key and private key works. Any question, any doubt till now? Let me know. I'll repeat again. It is an important part. Okay, so if you are clear, next point. Next point. So team, your browser is authenticating the server based on the certificate, right? Your browser has verifying the server with the certificate. All right. Then the server is authenticating the browser using public key and private key, right? But consider that intruder is sitting right here. Okay. What he did, he created a fake certificate and it provided that fake certificate to me. That can be a possibility. Intruder can sit right here in between and it will give me the fake certificate. How I am going to verify that this certificate is authentic or not? Okay, because I am doing it with the certification only. If the certificate is not valid, how am I going to justify it? Right? In the same way, if I take a layman example, if I'm going to some organization for the interviews, all right, they're going to ask me for my degrees, all right, they're going to ask me my graduation and post-graduation degree, all right. So what I can do, I can print my own degree also, right? I can print my own degree of graduation and post-graduation. I can give it to the hiring people, all right. But how they are going to verify that this certificate is valid? The degree I'm showing them, how they are going to make that it is authentic? So team, how we are going to do that? I went to our organization, I showed them my degree. How they are going to verify if this is an authentic website, this is an authentic certificate or degree or not? Arjun, to some extent you can say. Rishabh, yes, kind of. No, Arjun, not DNS. Masumi, absolutely correct. You got it. Anil, absolutely correct. Okay, so team, if I have printed my own certificate or I have printed my own degree, if I have a degree, if I have some certificate, it must be from some universities or something. All right, I have done my graduation. It must be from some university, right? So the university has issued me that degree. If I have actually gone to that repository, so there is an authority. Okay, the university is the authority that validates that my certificate is authentic. Okay, so it is the responsibility of the university. They give the authenticity that yes, this degree is authentic, you can trust this. All right, similarly here also we have something called CA. Okay, we do have something called CA. CA is certificate authority. Certificate authority validates that the certificate that you are receiving is authentic one or not. All right, CA authorities lies with the browser. CA lies with browser. All right, so browser have all the little details that if a certificate is coming from this location, can I authorize this certificate or not, if it is valid or not. So all the browsers have their own CA inbuilt, certificate authority, who can validate that this this website with this certificate is authentic one. Okay, it can be trusted. So we have CA authority with all the browsers inbuilt. Alright, so team, conceptually we have understood about the basics of security with certificates. Alright, as of now we have understood about the basics of security. If it is clear to all of you, then only we can proceed further. Akhil, you asking what basis CA certificates are issued. CA is a certification authority. It validates it. CA doesn't create its own certificate, it validates the certificates. Okay, so you can consider it as a repository. Okay, in the repository you have details about all the genuine certificates and it cross checks from there, and then it is going to verify that yes, this certificate is validated. You can trust this certificate. Alright, Akhil? Alright, so team, if you have the understanding of Kubernetes cluster, Saurav, you're asking certificate authorities approve that this site is verified. Is that correct? Saurav, I will make a little correction. You said certificate authority approves that this site is verified. No, little correction required. Certificate authority approves the certificate that comes with the site. Okay, so if I say that this is a certificate with Edureka LMS portal, GoDaddy. Okay, so what happens? CA authority has a CA authority for GoDaddy Secure Certificate Authority as well. We have GoDaddy Certificate Authority. All right. So this website is giving you details that GoDaddy is the issuer. All right. So it goes at the backend to the GoDaddy and it verifies, is this a genuine website? Do you have this certificate for this website? And then GoDaddy is going to confirm that yes, this is an authentic website, you can trust this. If this website has a certificate from my side, I take the responsibility, yes, that it is an authentic website. Okay, so certificate authority approves the certificate that comes along the website. See, cross-check the namespace provider. Akhil, we are not talking about the namespace right now. Okay, namespace has no relation to CA right now.
Alright team, so if you have understood, shall I move forward? So I have just written here public lock just for your understanding for the example. Otherwise it is a public key and it is a private key. Alright, how you can identify that if it is a public key or private key, how you can identify that. Alright, with the naming convention you can understand that. Alright, so for public key, if I'll talk about the usual extension of a public key ends with .cert. Alright, .cert you get, or otherwise you get PEM. Okay, PEM is another extension that you can see behind a public key. Alright, and similarly with private key, if I talk about the extension, the extensions are usually .key, alright, or it is like -key .pem. Okay, if you want to identify by the naming convention, you can understand like this. Usually the public keys come with the extension .crt and .pem, and private key comes with the extension .key and -key .pem. Alright, that is for the identification purpose. Now team, let's understand about something called your Kubernetes. Alright, now you are towards the end of the session, so I expect you answer this one. Alright, let's see how much you prepare for your examination. If I connect with my cluster, which components are there, which component I get connected to directly? Okay, to which component I got connected directly whenever I do kubectl? Gaurav, Kushagra, correct? Mosomi, Arjun, Anil, I'm asking to which component it gets connected. Okay, I'm not asking about which node. You run a kubectl command on master only. So it always gets connected with master if you're executing that in a master. Rishabh, no, not right. Ankur, correct. Siddharth, correct. Chandrasekhar, you have not written it properly. Akhil, no, wrong. Editor guest, I cannot see your name. Himanshu, correct. Alright, so team, most of you have given the right answer. Some of you who haven't, you have to prepare well for exams. Ankita, correct. Okay, so team, if you remember your master node component, you have API server. API server is the one that connects with all the components. Okay, you have etcd. Alright, you have scheduler. With scheduler, you have a controller manager. Alright, these are your master node components. Alright, whenever you execute some command with kubectl, it comes to your API server directly. Alright, it always comes to your API server. Okay, that is clear now. Alright, so team, I told you all the component inside talk to each other via API server itself. If etcd wants to talk, it talks to API server. Scheduler wants to talk, it talks to API server. Controller manager wants to talk, it talks to API server. Alright, so again, communication is happening inside your cluster also, and we need security there as well. Alright, we need security there as well. So they all have their own public key and private key and certificates. Okay, all the components come with your certificates. If you talk about API server has its own public key and private key. Scheduler has its own public key and private key. Same with etcd, same with controller. All the components have their own public key and private key. Alright, and when they communicate with each other, they share those keys and have the authentic connection just like that. Okay, just like this. Consider this is your API server and this is your etcd. Okay, so if they're talking to each other, they will share their public key and they will decrypt the data using private key. So inside your cluster also, whatever the communication is happening, it is also secured by certificate. Alright, and certificates provide you the highest level of security. Let me show you that right in the cluster. Okay, so this is the Kubernetes cluster on which we are working. All right, you remember the manifest location, etcd Kubernetes. All right, manifest. All right, all your masternode components are here only. Right, all your masternode components are here only. So consider if I talk about your API server. Let's see the API server definition here. Alright, so team, these are the basic details, that what is the API version, what is the kind. Alright, you have some metadata. Alright, you have some labels. You have defined it in the proper namespace. Alright, after that you can see a lot of commands here. Alright, you can see a lot of commands. API server has the most number of commands. Why? Because it communicates with everyone. Alright, so API server always also has some IP at the backend. Alright, authorization, you can say it can do the authorization using RBAC. Alright, you have client CA file. This is your certificate file, certification authority file. Alright, after that you can see etcd certificate file. It has the certificate file for your etcd. Alright, and this is the this is the client key for etcd. Okay, a public key and private key. Same if it wants to communicate with the kubelet on worker nodes, it has the keys for that also. Alright, proxy is also running as a pod, so if it communicates, again your keys are in place. Alright, so all the components definition you can see the definition of all the commands. You will see the certificates. Always certificates are used to communicate, and where those certificates are there, go one directly back. There is PKI, okay, public key repository. Go to this folder. You will see all the keys. All right, you can see that API server has its own public key and private key, right? Kubelet communication with kubelet component connection with API server, key and certificates are there. All right, for proxy it also has certificate and keys. Same with proxy and same for etcd. All right, and etcd has its own complete repository of your certificates as well. All right, so team, all the certificates are here, right? All the certificates are here, and I told you there is a certification authority as well that validates all the certificates. Okay, so API server is coming with its own certificate. All right, kubelet is coming with its own certificate. All right, they have own set of public key and private key. They have certificate as well. Now who is validating those certificates here? Who is validating the certificates here? Here what we had certification authority. Similarly in Kubernetes cluster also you have certificate authority. Okay, you have the certificate authority that validates that all the certificates with which we are dealing are authentic. We can verify that as well. Okay, CA authority. CA is the one that authorizes all the certificate that they are validated. Okay, Kubernetes has its own inbuilt CA. Alright, so team, all the components you can see how they are communicating with each other, how API server is talking to scheduler, how controller manager is talking to scheduler, how etcd is talking to scheduler. Alright, but how your kubelet is working with API server. Alright, so team, this is a question for you. Alright, how your kubelet is working talking to API server. The answers comes from the bootstrapping of cluster. When we bootstrap a cluster, if you remember how we did it, you can answer it how kubelet talks to API server. You can simply answer it now, if you remember how we bootstrapped it. Anyone? Siddharth, no. Masumi, no. Ankur, no. Nobody has answered me correctly. No, Arjun. That is a network. Okay, I am talking how they are authenticated. Abhinav, absolutely correct. Okay, one right answer so far. Okay, Gaurav, so did we ever set up public key and private key for kubectl? Only one right answer, team. No, Himanshu. Aditya, no. No, not that case. I'm asking what we did in the bootstrapping class. Okay, when we initialize a cluster, what we did that time, so that your API server was talking to understanding kubectl commands. No, Anil. Team, if you remember, when we bootstrapped the cluster, we executed some commands, we created some directory, and we moved the config file, right? Siddharth, correct. Kushagra, correct. Now you're right. All right. So I told you, remember what we did in the bootstrapping cluster, right? Yes, Himanshu. We moved the config file. Okay, we created the config file. So you remember when we were able to give the commands with kubectl get pods without making the directories and moving the config file, we were getting error. If you remember, connection refused was the error what we were receiving because your API server was not listening to kubectl, because kubectl was not authenticated at that time. That is why your API server was not addressing all the requests that was coming from that kubectl. Then what we did, we moved your kube config file. Okay, in the home location, we created your kube config file. .kube. Alright, we have a config file here. Let's see what is there in this config file. Okay, so team, here you can see there is a API version, there are cluster as well. Alright, and see here you can see that certificate authority data. Okay, so this is base 64 encoded value of your certificate. Alright, this is simply your base 64 encoded value of your certificates. With the help of this only, he is able to communicate with the API server. Alright, this is the IP of your master node and this is the default port number of your API server. Okay, my bad again and again. Alright, so this is the default port number to which your API server listens, and this is your master node IP address. Alright, and this is the name of your cluster that is given by default by the Kubernetes. Okay, Kubernetes, whenever you create a cluster, it gives the default name. Alright, under here you can see something else as well. Alright, here you have the cluster name and here you have the username as well. Okay, so the username was never created, we never created that. Okay, but whenever you bootstrap the cluster, a default namespace is always created, and similarly a default user is also created. Okay, Kubernetes admin is the default username, is the default user with which you are executing all the commands. Okay, all the commands that we are giving, kubectl get nodes, kubectl get pods, kubectl create, kubectl run, all the commands that we are executing, those commands are getting executed by Kubernetes admin user. Alright, so you can create your own users as well. Okay, you can rename your cluster. That is all we are going to see today. Alright, but with this, he is able to connect with the API server. This is the CA authorization details, and if you come back a little bit, you can see the client certificate data. Alright, with all these certificate details. Okay, this is the certificate data of the user, Kubernetes admin user, whose data is this one. Okay, so this certificate of the user called Kubernetes admin is validated by this certification authority. Okay, and that is why once we had our config file, we were able to communicate with API server. So all the components talk to each other via certificates, and the kubectl talks to API server also via certificate. We have some user and we have the certificates for that. Okay, so next thing, how we are going to set it up at our own. Okay, what are the steps are going to be to have our own user and have all the certificates generated. Alright, so consider if I want to have a user who wants to talk to API server, like what we have already seen. Alright, so first of all, you're going to create a user. Alright, how you're going to create a user? For that, first you have to generate the keys. Okay, first you have to generate the public key and private key, right? If you talk about the server, alright, whenever the server was provisioned, a public key and private key was generated, right? So same thing, what I'm going to do, I'm going to generate the keys for my user. Alright, after that I'm going to raise a CSR. Alright, what is a CSR? CSR is the certificate signing request. CSR is certificate signing request. Whenever you create a request of CSR, then only CA authenticate your certificate. You have your certificate, you have to get it validated from the university where you were studying. Alright, the university issued you a degree. Alright, but you saw that there is no stamp, there is no validation, then you'll go back to the university, you'll say that you have to authorize it. Alright, you have to raise the certificate signing request. Then only the university is going to stamp the cert degree so that now it's validated. Similarly, whenever you generate the keys, alright, you get it authenticated by CA user. CA, alright, for that purpose you have to raise the CSR. Alright, so once the certificate signing request is there, you have to sign the request also. Who? CA has to sign the request as well. Okay, once you do all this, then you will have a user created for yourself. Okay, once you do all these things, then you have your user created, and then your authentication part is done. Okay, then your authentication work is done. Authorization work is still not done. You have a user, and now that user is authentic. Once you generate the keys for the user, you raise a certificate signing request. The CA authority of Kubernetes will validate and sign that request. Then you will have a user to connect to the cluster. But what he can do with the cluster, we'll talk about that in authorization. Alright, in role-based access control. Alright, but if we set up Kubernetes on remote machine, it would require some certificate, right? Yes, Kushagra, you will require the certificate as well. Alright, so team, in the first class I also told you that if you want to bootstrap your cluster, you have two ways. Alright, you have two ways. One way is your hard way, and second is your KubeADM way. Alright, so KubeADM is the one that who takes the responsibility of all the certificates. Alright, so if I go to etcd and Kubernetes and PKI, alright, you can see so many certificates are there, so many public and private keys are there. KubeADM takes care of all of this. If you do the hard way, you have to create all the certificates. You have to create your certificates. You have to get them signed. You have to have some CA's authority. Alright, you have to do all of this in the hard way. But with KubeADM, it has been done automatically. Okay, so team, yes, I know it was a lot of theoretical part. I tried to make it as easy as possible to make you understand. I hope you understand whatever we have covered so far. Anybody has any doubt? Team, clear to all of you? Yes, no, maybe, anything? Okay, few responses. Yes, okay, alright. Alright, so team, now I'm going to talk about the authorization first, okay? Then we'll start with the practical lab, okay? Team, very few responses. only got 5 to 6 responses. We have 40 candidate strength today. Okay team, so let's get started. All right. One more small concept I want to explain you here, and then we'll see everything practically. All right, everything will be done practically afterwards. All right. So team, by all these 3 steps, okay, by all these 3 steps, you will get a user created for you. Okay, with all these 3 steps, your user is created now. All right, out of these 3 steps, you have 2 more steps. All right, you have done the authentication, now you have to do the authorization. All right, now you have to do the authorization, and for authorization in Kubernetes you have something called roles and cluster roles. Okay, you have roles or you have cluster roles. All right, and you have roles binding and cluster role binding. Alright team, so once you have your user created, now you have to do the authorization, and an authorization in Kubernetes can be done using these 2 ways. You can create a role or you can create a cluster role. Alright, and then you bind that role to a user or you bind that cluster role to a user. Alright, so first I'm going to show you a little bit what is a role and cluster role, what is a binding, role binding and cluster role binding. Alright, so if I go to my node and if you do kubectl API resources, okay, so this is the basic command we have used many times. Resources, alright, and consider now they have there are 2 type of resources, right? One which can be namespaced. Namespace equals to true. Alright, so team, these are the list which can be placed inside a namespace. Alright, if you talk about pods, if you talk about PVC, okay, these are namespace level resources. Daemon set, deployment, replica set, stateful set, okay, these all can reside inside a namespace. Alright, and there are some resources that cannot reside inside a namespace. Alright, and those are called cluster level resource. Okay, all the false component are cluster level resource. Okay, so if you talk about namespace itself, it is a cluster level resource. All right, if you talk about nodes, this is a cluster level resource. If you talk about persistent volumes, PVs are namespace, PVC are namespace, but PV is cluster level resource. All right, because it can get created on any node. All right, so team, this is the difference between your namespace component and non-namespace component, cluster level resources and namespace level resources. So consider you want to create a role that has privileges, that requires privileges that is on namespace level. All right, consider I want to have some access, I want to have some access only on pods. I want to see how many pods are there. Okay, I want to see what are the number of deployments are there. All right, I want to fetch details related to pods and deployment. I want to create name pods and deployment. I don't want to create any namespace. All right, in that case we are going to create a role. Okay, because role is always namespace level. All right, consider if I'm talking about roles, so I'm talking about namespace level objects. All right, and if I'm talking about cluster role, all right, I'm talking about cluster level resource. All right. So let's see the difference. What is the difference between these two? All right. Consider I want access on your pods. All right. Or I want access on your, as I said, deployment. All right. I want to have access on RC, RS. All right. If I want to have access on these type of objects, and these can be namespace, so I'm going to create a role for it. Okay. I will create a role that will have access on pods, deployment, RC and RS. All right. But consider I am a Kubernetes administrator. Okay. So these access you are going to give to some developers. All right. Just for example, you have some developers in your team, all right, who wants to create some pod and deployments. So you will create a role for them. All right. You will create a role because they should have access only on namespace objects, pods, deployments, services like this. All right. But cluster level resources. Consider inside your team you have another Kubernetes admin. You are also a Kubernetes admin, and you have another person who is Kubernetes admin, and you want to give him cluster level resources. All right, maybe limited than you. All right, consider you have experience and there is a fresher, so you don't want to give complete access on cluster, but you want to give some access that is on cluster level. All right. For example, if you want the namespace permission, all right, that the user should be able to create some namespaces, all right, or the user should be able to create or see some persistent volumes. All right. So in that case, you're going to create a cluster role. Okay. This is called cluster role. All right. So team, consider with all these definition. Okay, I have these roles. I have pods management, deployment management, RC and RS management. I have created a role here which is named as developer. This is the name of my role. All right, this is the name of my role. Similarly, I have created a role for namespace and persistent volume also, and that is a cluster level role. So I say that this is our admin role. All right, I have created two roles. The developer roles have some access on pods, deployment, RC and RS, and we have a admin role. Admin role has access on namespaces and persistent volume. All right. Now consider a person named Ravi. All right, a person named Ravi is in a developer team. Okay, a person named Ravi is from a developer team. He wants to have access on the roles. All right, no problem. What we can do, we can give him access. Okay, the arrow is not coming properly. Never mind. All right. So I created a role and I assigned that role to Ravi. All right. So what is happening here? This is called role binding. This is called role binding. It means assigning a role. Assigning a role to a username. Assigning a role to a username is called role binding. Similarly, consider that I am a Kubernetes admin. All right, I am a Kubernetes admin here, and I want also some access on the cluster role, and I want admin role. So I am going to assign a admin role to myself. All right, and this will be called cluster role binding. All right, and this is called cluster role binding. Whenever you create a cluster role and assign it to some username, it is called cluster role binding. Whenever you create some role and you assign that role to some user, that is called role binding. All right. So these three parts are your authentication and these two parts are your authorization. All right. So team, if this is clear to all of you, conceptually, we are going to see this practically now. Everything from the scratch. We'll start from generating the keys. We'll first create a user, we'll authenticate that user, and then we'll create your cluster role binding, roles role binding, and then assign that to the particular user who is authenticated now. We'll provide authorization. Everything will be seen practically. Conceptually, any question, any doubt till now?
Okay, great. So as I always say, there are only two scenarios. If you don't have any question, you understood everything, or you don't understood anything. So I hope first one was the case that you understand everything. All right. So team, now we are going to do lab on this one. All right. We'll go to security. All right. Under security, you have RBAC. Okay. So team, all the things that you need to do, that how to create a normal user RBAC. Okay. You have a MD file for that here. All right. How to create a certificate signing request you have here. All right. So all the things are here in Edutica security RBAC. All right. And I have made this a little more easier for you. All right. Here is a history file. Okay. All the commands are provided here to create everything from the scratch. All right. You can simply copy paste the commands and you can understand what is happening. All right. So I have created all this so that you can simply copy paste the command, because the commands are very different here. That is why I have everything here. All right. So first, as we have already discussed, all right, first we are going to have a user and generate the keys for it. All right. Then we'll raise CSR and then we'll sign the request. First, we are going to do these things. All right. For that purpose, first simply I'm going to create a directory here. All right. I'll just create a simple directory. Okay. Under home, I have created a prod user. All right. This is going to be my username. All right, team. So this is going to be my username now onwards. And I have placed a certificate folder inside it. All right. After that, I'll go to this folder. Home prod user cert. All right. As of now, there is no content here, completely blank. All right. Now you can see that I am generating the keys. Okay. I'm generating the certificate with OpenSSL. All right. You want to use any other utility, you can use it. All right. But OpenSSL is also fine. All right. So what I did, I used OpenSSL to generate my certificate. All right. To generate my key. Okay. And this is going to be the name of my key. And I'm using 2048 bits. All right. So with this, you can create your keys. All right. Let me have it here. All right. Then you list. You can see the prod user key is there. All right. You can cat it also. Okay. So you can see that this is the begin of your private key. All right. If you see the diagram that I shown you. All right. First, for the authorization, I have generated my private key. Ashok, no, that is not the port number. Okay, this is not the port number. This is your bit encoding. All right, because you generate your keys, they are encoded. All right, so we have done 2048 bit encoding. This is not a port number. We are generating the keys right now. All right, so team, first thing is done. If we can see, generate the keys. We have generate the keys. Now the next part is raise our CSR. Okay, certificate signing request. All right. So team, this is the command again with the OpenSSL. So team, this is again up to you. If you have used the OpenSSL certificate, you have to raise a request with it only. If you have used any other SSL certification tool, you have to raise accordingly. All right. So we are using OpenSSL here. So you can see the keywords OpenSSL request. I'm just requesting a new with key. Which key? Prod user key. You will have an input as key prod key, and what you will get out, you will get a CSR. Okay, you will get a certificate signing request. All right, and this is just a subject. Okay, it contains the details. It is optional. If you want to give, you can give. If you don't, you can skip it. All right, it is just providing you the details. All right, which organization you are from, which username you are, what is your username, to which organization you belong. All right, so prod user is a username. DevOps is your organization. All right, so whenever you raise a certificate request, all right, you ask the authority, you give the details. Okay, I am this person, I'm from so and so university. Alright, so you studied from a college, and if you went to the university directly that I have my degree, you want to sign it. So you give details also, right? That this is my name, I'm coming from this college. You provide all that details. So this is that only. So now I am going to open a SSL with this command. Alright, you get a warning. That is okay, no problem with that. That is alright. You can see a prod user CSR is raised. Alright, a certificate signing request has been created. Alright, if you want to read the content, okay, you can have the content in the base encoded format. Okay, so I'll have the base encoded format of this prod user CSR. Okay, you can see this is your base encoded string. I am going to copy it somewhere. Alright, I'll let you know why I am copying this, but let me copy this thing. Alright, so this is my key. Sorry, this is my certificate signing request in base encoded format. Alright, so team, now you have to raise a CSR as a Kubernetes object. Okay, I have just created a file. Okay, I have just created a file as of now. Certificate signing request has been raised as a file, but you have a CA authority of Kubernetes itself. So you have to create the CSR in a Kubernetes object. Kubernetes has an object called CSR. So you have to raise the CSR as an object there, not as a file. Alright, so you have to come back and then you'll go to RBAC directory. There is a YAML called certificate signing request. Alright, you can see the kind. The kind is certificate signing request. So this is a official object of Kubernetes. This is a API version. Metadata, this is the name of my user. Alright, specs group, system authenticated, and request. This is your base encoded, base 64 encoded CSR value. Okay, so I have to update this only. I'll copy this and I will have it in the notepad. Alright, now I am going to paste it. So team, you have to copy paste it very carefully. Okay, even a single space can mess it up. Okay, so be very careful. Be very careful before doing it. Alright, so I have pasted this base encoded CSR file value into CSR object of Kubernetes. Let me have this file with me now. vi csr.yaml vi this. I'll save this one. kubectl create -f CSR. Okay, so you can see that certificate signing request of prod user is created. Alright, if I'll do kubectl get CSR, okay, you can see that prod user has requested a certificate signing request. Who is the requester? Kubernetes admin. Alright, so you have to create the user, and as an administrator you have to request the certificate signing request. It is not the one if consider a developer came to you that he wants to get a user created and he wants to have the user with proper authorization. Alright, so on the behalf of that user, as a Kubernetes admin, you have to raise the CSR. Alright, and that is why you can see the status is pending as of now. Alright, the status is pending. So CA is going to authorize this now. Sorry, authenticated. So let's go back to the history file. Alright, so team, this is the command with which you approve the CSR. kubectl certificate approve prod CSR. Okay, sorry, you have to change the name. This is not the prod. You have to use the name itself. Prod user.
This is the name of your CSR. Okay, now you can see certificate signing request is approved. All right, now it is approved. See, the status has changed for prod user. It is approved and it is issued. It is approved and it is issued. So what we have done so far, we have generated the keys, we have raised the CSR, and the certificate signing request is also signed by Kubernetes itself. All right, so your user has been created. Now you are authentic to give any commands from this user. All right, we are going to use context for that later on. Okay, we'll see that later on, but just if you want to try some command with this user, okay, if you want to try some command with this user, from here only you can say kubectl get nodes. All right, kubectl get nodes with as user. All right, hyphen as prod user. Right. Okay, so team, you see that you get an error. Okay, error from the server. Nodes is forbidden for user, prod user. Prod user cannot list the resource node in API group as a cluster scope. All right, so team, what have you seen? Your user is created. Okay, your user is created. It means authorization is done, but sorry, authentication is done, but you haven't set the authorization. All right, you have created the user, but you have not defined what this user can do. Okay, you haven't given that also. So now, once the user is created, we are going to see how we can provide your access accordingly. All right, so team, I have created the CSR using a YAML file. Okay, I have created the CSR using a YAML file. If you want to create, you can sign the request like this only. This generate a cert file. All right, so team, now I am going to create a role. Okay, kubectl create a role, and this is your role name. Okay, this is your role name. So if you are talking about roles, you have to remember that you are talking about namespace level resources. All right, so what you can give verbs that I can get, I can list it, I can watch it, and I can create it. All right, I get access to get, list, watch, and create. What resources? I can create pods, I can watch pods, I can list pod, I can get pods. Similar with services as well. I can list the services, I can list, watch the services, and get the services and create the services. Okay, you give that in resources. For which namespace you are talking about? Now we are talking about namespace level resource, so definitely we have to specify the namespace as well. So as of now, what I am doing, I am just doing it for the default namespace. All right, so by taking this, I'm going to create a role. Okay, you can see a role is created. kubectl get roles. All right, a role is created. You can describe it. kubectl describe a role. All right, so you can see what are the resources and what are the features you have to do. Okay, you have access to pod resources, you have access to services requests, service. All right, what you can do, you can get list and watch and create. All right, so this is about the details. Your role is created. Consider now you want to have the YAML. All right, I created it from the command line, but consider I want to have it from the YAML. Okay, so I think Rahul, you asked about the template generation. So again, I'm showing you that also. Okay, dry run equals to blind. All right, and then -o YAML. All right, so team, you can see how you are going to define it. This is your API version. Then you have kind, metadata. You can say the name and the namespace you have to give. What are the rules? In rules, you can say resources. You have the access to resources called pods and services. And what you can do, you can get, list, watch, and all this. All right. So team, what I'm going to do now, I'm going to create a deployment. All right, let's try that.
kubectl create deployment dev test, alright, hyphen image nginx. Alright, so your deployment is created. If I do kubectl get pods and kubectl get nodes, sorry, not nodes, deploy. Okay, so as a normal user, as a Kubernetes admin user, you can definitely see all this, but consider I want to see this using prod user. Kubectl get deploy hyphen as prod user. Okay, so team, as a prod user, you are forbidden. Okay, you are forbidden. You cannot see the details of a deployment. If I do same as prod user, but in place of deployment, I am listing the pods. Okay, why it is not authenticated? It should be done. Team, right? It should be done. Anybody can tell me why it is not happening? Absolutely. Mosami, Kushagra, Joydeep, Gaurav, absolutely correct. No, Anil, no, that's not the case. Alright, team, I haven't given the role to the user as of now. Alright, I have created the role, I haven't created the role binding. Okay, first I have to do the role binding. I have to give this role to this user, then only this user will have this role. Alright, so you have done the role, you have to do the role binding as well. Okay, now I am creating a role binding. Kubectl create role binding. This is the name of the role binding. To whom you are binding this rule? You are binding this role to prod user. Which role? Prod admin. Alright, you have to execute this as well. Alright, now your role binding is created. Okay, now your role binding is created. So now let's try those commands again. Kubectl get deploy, again you are forbidden. Kubectl get pods. So team, now you have the role binded to the user called prod user. Now you can get the rest. Earlier you were not able to, right? Because creation of role is not enough. You have to do the role binding as well. All right. So team, this is how you have created the role and role binding, right? This is how you have created the role and role binding. All right. So for now, what I'm going to do, I'm going to delete it. All right. Also, if you want to see other namespace objects, you can see. All right. You can get the pods from default namespace. But if you want to try to get the kube system, okay, kubectl -n kube system get pods as prod user. Forbidden. Why? Because you had access given only on default namespace. If you list the pod of kube system, you won't be able to see that. Alright, so team, we understood about the role and role binding. Now I want to show you the cluster role and cluster role binding. If you don't want to get confused, for that purpose, I am deleting the role and role binding I have just created. Alright, because I am going to assign the cluster role to the same user. That is why I have deleted your role and role binding. Alright. So team, whenever we talk about cluster roles, some of the cluster roles are already created. Alright, when I did kubectl get roles, I had only one role which I created. But if I do with kubectl get cluster roles, okay, you can see so many cluster roles are already provided by Kubernetes. Alright, so team, just hold on for a few more minutes, okay. Once we are done with the cluster role and cluster role binding, then I'll take your question. Alright, so some of the default cluster roles are already created. Some is your view operation. all right, so that you can see all the cluster level resources. You cannot modify it, but you can view it. All right, so I'm going to use this one only. I'm not going to create a row cluster role like I created the role. I'm just going to use a normal one. All right, if you want to describe a role, you can do also. All right, we have already seen how to describe a role. Now I am creating a role binding. kubectl create cluster role binding. Okay, the name of the cluster role binding will be ABCD. All right, to which user I want to assign? Prod user. Which cluster role? I am just assigning the view permission. All right, he can see the cluster level resources, but he cannot create or modify anything. kubectl create cluster role binding ABCD to which user? Prod user and the cluster role. Okay, your cluster role is created. All right, now if you want to get the details, you can get the details of all the namespaces. All right, you can see this: Prometheus, Grafana, Matrix Server, default namespace, Cube System namespace, monitoring namespace, prod namespace. All right, you get the details from all the namespaces about all the objects. Why it is permitting you? Because you have the cluster role to view anything. All right, you can view any namespace content, but can I create anything in any namespace? All right, so let me try that. I want to create a Nginx pod 1 in Cube System. Forbidden. Prod user cannot create resource pods in API group in the namespace of Cube System. Cube System, I cannot create any object. All right, let me try to create in the default one as prod user. Again forbidden, because I have just a cluster role that allows me to view the resources. I have no permission to create any object even in the default namespace. So if I execute all these commands with the prod user, the role binded to that user matters a lot. All right, so team, we have seen all of this. All right, we have seen all of this. All right, any doubts till this point of time? All right, we have understood how to generate keys, how to raise a CSR, and how to sign it. All right, then we have also seen how to create a role. Cluster role is also going to get created in the same manner. How we are going to bind the roles and cluster roles. All right, so we are at this point. If anybody has any question to whatever I have told you, let me know. I'll explain again. Can we bind a system user? Like instead of using as prod user, we just name a system user, assign a role. Gaurav, yes, absolutely. Okay, the username is just a keyword for identification. All right, you can see the prod user. I haven't created the user on the OS level or anywhere. All right, you can give ABCD, you can give your name, you can give Gaurav, you can give Shubh. That is no problem. It is just a string. Username is just a string. You can have it the way you want. How to restrict someone to use a particular user only? Kushagra, I didn't get it. You want to restrict a user for a particular user itself? How does that work? I'm not sure. If you want, if you're trying to say that I have used as hyphen prod user, I can create another user and I can give hyphen another user. All right. If you're talking about that, I'm going to come on that part right now. All right. Once you have understood all this, how to use these users actually. Okay. That is the next part I'm coming to. That is the next part I'm coming to. How these users are getting used actually. That is the next part I'm coming to. How these users are getting used actually. Ashok, you are saying how can I check what are the users are binding to specific role? Okay, so Ashok, you have cluster role and roles. We have already listed that. All right. Similarly, roles binding and cluster role binding are also an object of Kubernetes. You can describe them also. Okay, kubectl
get, let me have the object name from here. Role binding. I have just deleted it, so I might not have that. Let me have the cluster role binding. kubectl get cluster role binding. Okay, you can see this many of cluster role binding are there already in place. All right, but this is the one which I created, right? So you can see that ABCD cluster role binding is there. All right, and this was created 4 minutes ago. If you are going to describe it, you can describe it. So this is the cluster role binding, and what are the role you have, it is mentioned here, and you can describe this also. kubectl describe, just a minute. Describe cluster role binding ABCD. All right, this is the cluster role binding. All right, and to which user it is assigned. This is how you can check it out. All right, so team, any other question till now? Any other doubt to the whatever we have covered? Team, quick yes from all of you if you do understand. If not, do let me know, I will repeat. If I give access to someone to the master node and they can use and execute a command, what is the purpose of having the functionality done? Kushagra, yes, that is the case. Okay, so you never give access to the master node to any user. Okay, why we are creating users? Because I want to access it from some third place. I don't want to give access to my master node. That is what I'm going to show you later. Himanshu, how to see which user has deployed which pod instead cluster if they have many users with the same role. Alright, Himanshu, for that purpose you have to manage some other kind of monitoring. Alright, but if you are going to describe that, you can describe the pods. Alright, so let me show you that. kubectl get pods, or let me get the deploy first. I hope its definition is going to the shortest one. kubectl describe deploy dep test. Name slitter, rolling update. Okay, that is a part of security context. Okay, so I will tell you that later on. Okay, so I will answer your this question also. Okay, how to find out which user created what. Okay, for that purpose you have to understand the security context. Sorry, not security context, service account. Alright, we'll see how token also work. Tokens are also there in Kubernetes. Alright, so I can answer that question a little bit later. So Himanshu, I guess that is okay with you. Kushagra, I'll tell you now, okay, have some patience. Okay, I'm asking you the questions from the content I have covered. Okay, I'm coming to that part, how to execute the commands from another node. Arjun, okay, you want a high level reputation, all right. How we can target user of specific nodes and pods. Anil, as I just requested all of you, please ask the question from the content that I have covered so far. Okay, because I am going to show you everything once it is clear. Okay, you are asking advanced questions that yes, you have understood whatever I have taught now, but how I am going to use it? These are your questions. So I will show you that. But whatever I explain, if that is clear to you, then only I'm going to move forward. All right. Okay, so Arjun, a quick repeat for you. All right. We have already seen that we need to have a user and we need to have some RBAC. All right. Our purpose was to have authentication and authorization both. So to have the authentication, you have to have a user. All right. You have to generate the keys for that user. Once the certificate is generated, all right, your certificate needs to be get signed by someone also. That is your certificate authority. All right. And certificate authority we are using here is of the official Kubernetes itself one. Okay, so we can raise a CSR. All right, we'll have a CSR file. Then we are going to have base encoded format of that CSR file, and we are going to place that in an object called CSR of Kubernetes itself. Okay, Kubernetes has its own object called certificate signing request. So you have to create a YAML for that, and there you are going to have base encoded CSR file value. All right. After that, you have created SR, CSR, your certificate signing request is raised. Now your Kubernetes has to sign that request. Once these all tasks are done, once all this task is done, it means your user is created, your authentication is done. Now you have to give the authorization. In Kubernetes, you have two ways of giving the authorization. You can create roles if you want to give permission to a specific namespace. But if you want to give access on the cluster level resource, you have to use cluster roles. If to a particular role, namespace, you use roles. All right. So if roles are there, you have to do role binding. If you have cluster role, you have to do the cluster role binding. It's not like you have created a cluster role and you are doing role binding. That is not possible. All right. So team, if this is clear to all of you, we are going to move forward a little bit. Okay, if it is clear to all of you, we are going to move a little forward now. All right, so team, this is part is done. Now, as I told you, you have your Kubernetes admin as a main user. All right, we have already seen that in the kubeconfig file. All right, we have another way to see that also. kubectl config view. Okay, this is also there in the repository, so you don't have to worry about it. All right, kubectl config. All right, as of now, what I have done, kubectl config view. That is what I am doing. All right, so team, here you get all the details in a YAML format. All right, so team, what is the name of your cluster? It is Kubernetes. All right, which user you are using? Kubernetes admin. All right, and then with the name of the cluster and with the name of the user, collectively they are called as context. Okay, collectively they are called as context. Username @ cluster name. Collectively they are called context. So what is a context? Context just allow you to connect to a particular node. Okay, so if anybody of you have connected to some databases, okay, so I have worked on Oracle databases and MySQL databases. So just to make you understand about that, I can tell you in Oracle database, if somebody of you has worked, so how is your connection string is SQL plus, then you give the username /password @ database name. All right, in MySQL you have -h host name, then you give -u username and -p for password. All right, in Kubernetes you give the username and @ cluster name, because we don't use password, so you don't need to give the /. You are using certificates. That is why username @ cluster name. All right. So context defines that which user is connecting to which cluster. All right. And you get the details that this is the current one. You can have multiple contexts also. All right. So Kubernetes admin @ Kubernetes is connecting to this one. All right. So team, now the next part is consider, due to security reason, like we are already discussing about the securities in Kubernetes, I don't want anybody to access my worker master node. All right, Kapil, I showed you the command for that also. All right, let me show you again. All right, when you do the kubectl get CSR, all right, you get the status, if it is approved, if it is issued, if it is expired, you get all the details. All right, so team, please hold on for your question. Okay, I'll ask you to ask question, then post your question. All right, so because of flow breaks. All right, so team, now you don't want anybody to access your master node directly. All right, you don't want anybody to access your master node directly. So what you want to do, you want to have a jump server. All right, so I am creating a jump server. Okay, a complete blank vanilla machine. All right, so what you don't want anybody to access your master node. You want to have a jump server from where the user will connect to the master node. All right, you don't want access given to anybody for your master node. So this is what I'm going to do now. I'm creating a clearly blank machine. All right, a small one will also work. Change this one to Ubuntu 18. Select, allow full access to all cloud APIs, allow HTTP access. Okay, nothing new. You have already seen that in the first class. All right. So team, if you understand all the concept till now, you understand that your kubectl utility is required to use your cluster. All right. All right, and kubectl has some config file. With that config file, I can access my Kubernetes cluster. All right, so it is all dependent on your config file, because config file has all the details about your cluster. It has the certificates, it has everything. All right, so what I just need, I need a config file so that I can connect from another node as well. Okay, I can connect from another node as well. Let's see how we can do that. Okay, so you see that this machine I just created right in front of you, so it doesn't have anything. All right, what I am going to do, I am going to place the kube config file here also. All right, at the home location, again I am going to create a directory mkdir.kube cd.kube, just like I have on the master node. cat config. Okay, this is my complete file. Again, you have to be very careful by copy pasting it. All right, just to understand, you have API version. All right, you have mentioned the cluster, you have the cluster certificate. All right, here you have the name of the cluster. All right, this is the IP address of your master, and this is the API server node port number. You have the cluster name. All right, you have the username, you have the context, you have the current context. Okay, all the details are here. The username certificates are also. So you do have everything with you. Okay, you do have everything with you. I'm going to create same file here. vi config. So team, question for you. I have created this config file. If I do kubectl get pods, will I able to get the outputs from here? Kubeadmin is a user created. It has the admin level privileges. I have placed its own config file in this machine. Will I get the output here? If yes, why? If no, why? Gaurav, user is already created. Okay, in this config file, I have placed the detail about the user, about his own certificate. So we have the authentication, we have the authorization. Kushagra certificates are present. In the config file, you have base encoded value of certificates. Okay, so certificates are also present. Siddharth, You got it. Okay, Siddharth got the right answer. Anybody else? Arjun said yes. Okay. Prempal again, right answer. Gaurav, I don't need kubelet. Mosami, absolutely correct. Okay, so team, let's try. It's not working. It is saying that snap kubectl first. Okay, so definitely if you are running some kubectl command, you should have that client also. Okay, so let's download that also. I'm not going to install anything. I'm not even going to install Docker or something. I'm simply going to install your kubectl. Install. All right. I'm just going to update the repository and I'm going to install only your kubectl. Okay. First, let me have the dependencies first. Just updating it. Alright, I'm just installing kubectl, no other component at all. Alright team, now tell me, I do have kubectl installed. Will it work now? Kubectl get nodes. Will it work now? Mosami Prempal, right? Enter. Mapping values line 2. There is some error in the line 2. Let's check it out. 1 minute. Kubectl get nodes. Yeah, some error is at line 2. vi config. Okay, I didn't get the complete output. Let me have the kubeconfig file once again. Alright, yeah, it is an issue with the browser. When you get the terminal from the Google Cloud, you cannot copy everything just like that. Okay, so till here I have copied. Let me paste everything here. From kind to this. And at last, this part. Alright, so this is done now. Let's see if it is working fine or not. Alright, done. Team, it is working. kubectl get nodes. Alright, so team, now you can connect to your master cluster from a testing machine. Okay, you can connect to a cluster from a testing machine. You don't have to give the access to your master node. kubectl get nodes. Alright, kubectl get pods. Alright, you can get all the details from your testing node. Alright, so team, now you can see that I have created a context, I have created a config file. Alright, consider from this testing machine only. Okay, I want to connect to my production cluster. I want to connect to my testing cluster and production cluster and QA cluster and pre-prod cluster. Okay, can I put multiple config file at this location so that I can connect with all the clusters? Is it possible? Can I create multiple config files here? Prempal, no, wrong answer. Mosumi, yes, you are right. Arjun, okay, you think so? Kushagra, absolutely correct. Anil, you are also right. Absolutely correct. So team, if you are going to create multiple config files, okay, if you are going to create multiple config file, how you are going to define which config file you want to use? All right, whenever you give kubectl command, how it is going to identify that which config file they have to follow. Okay, so we don't create multiple config files. Okay, we always use only one config file. What we can do is we can create a multiple context. Okay, I just told you about the context, how context works. All right, under context you can see it is a list. Okay, it is a list. You can have multiple contexts. You can give multiple cluster name, you can give multiple username as well. All right, so if I'll go here, I can create multiple username and multiple cluster. All right, consider, let me show you this diagrammatically. All right, consider team, this is your this is your production cluster, this is your testing cluster, this is your development cluster. You have 3 Kubernetes cluster. This is your prod, this is your dev, and this is your test. You have 3 cluster. Now you have multiple users as well. Just a minute, please. Yeah, sorry. Consider you have multiple users as well. All right. You have Shubh. All right. You have Ravi. All right. You have Naresh. Okay. You have multiple users as well. All users have their own level of roles and role binding, cluster role and cluster role binding. All right. Now you want to connect. Consider Shubh want to connect with dev server, dev cluster. Ravi wants to connect with prod server, prod cluster. Naresh wants to connect with test cluster. So you can manage that with the help of context. Okay, you can create the context accordingly. That Shubh should always connect with dev server, dev cluster only. Ravi should always connect to test cluster only. Naresh should always connect to prod cluster only. You can do that using context. All right. So let me show you that here. All right. Consider I'm creating some dummy values here. Okay, just a minute. Okay, I'm going to have some dummy values. Cluster saying I am giving a prod cluster name. All right, username is I am giving as Shubh. All right, and the name I am defining for this context is Shubh @ prod. All right, and I have to define it as a list also. Hyphen context. Okay, so context is a list. This is your one context, and this is your another context that I have created. All right, and you can see that your current context is Kubernetes admin. You have to set your current context. I'll save it here. All right, so team, I have created your context. Let me list them. kubectl config get context. Okay, I think I messed it up again. There's something at line number 30.
All right, let's go to line number 30. Okay, it is about the new entry only. Okay, I haven't put the columns at the end. My bad. It is done. Team, can you see now you have two contexts? Okay, now you have two contexts. Kubernetes admin @ Kubernetes, that is your first context. Second context I have created as Shub prod, cluster is prod, and name is Shub. And you can see the current one also. Okay, the current one is marked with start. So if you want to change the context, all right, if you want to change the context, you can do kubectl use context. Okay, kubectl use context. Which one? I want to use this one. Okay, I have to give config also. kubectl config. Okay, switch to the current context. Alright, now you can see that my current context is this one. So team, if I do kubectl get pods, will I get the output now? Right, it's a dummy one, so it is not going to give you output. All right, because your Kubernetes is your API server will not identify it. No keys are identified, no certificates are generated, no certificates are signed. All right, so nothing is here. So your API server will refuse the connection. Your API server will refuse to answer to this command. Okay, because it is not a value even though. All right, so if you want to switch the context again, you can switch it. Alright, again I'm going to use the default one. Alright, so team, you can create users, alright, and after that you can give those user details in the kubeconfig file and you can choose your context accordingly. So team, I hope now you are able to have the complete picture how we use it. Alright, we create a jump server, alright, we create a jump server. Consider a developer came to me that he said he wants to have a namespace with the privileges to create pods. Alright, that is a requirement with which a developer came to me. Alright, so I'll say okay, alright, I can do that. What I'll do, I'll create a jump server. I will not give him the access of master node. I will create a jump server. Alright, where my master is running, I'm going to create a user for him. I'll generate the keys of that user. I'll generate a CSR. I will sign that CSR. Alright, after that, the developer asks me that he wants to have the access on pods. Accordingly, I'm going to create a role. I'm going to bind that role to that user. Alright. After that, I'll place the kubeconfig file in this location on the jump server, but in the place of default user, I'm going to put the details of the user that I have created. Okay. So the user, the developer will access this jump server, will come here, will do the kubectl commands, and he will have the access only whatever I have defined on the master node. Alright team. Understood to all of you? With all this, we have covered stateful sets and we have discussed all the concepts of security, authentication, authorization, certificates, role cluster, role binding, kube configs, context. This is covered by us. Okay, all of this is covered by us. We are remaining with two topics now. Siddharth, you're saying let's assume that your dummy prod cluster is actually present, but I guess still you won't be able to do that because same CSR role binding needs to be created. Is that understanding correct? Yes, Siddharth, absolutely correct. Okay, by mistake you might have given the context details accordingly, right? There are chances that there is a cluster of prod, there is a user called Shub, but it doesn't have the role and role binding. So definitely you won't get the output.
Gaurav, I have already showed you. All right. I have to put the content of the prod user. I have just given the dummy values right now. But if you want to give the details about the prod user, then you have to give the details of what I'm saying about the certificates also. Okay. So when we created the user, you had the CSR. All right. If I'll go to my master node, and which command I used to have that. Just a minute. Here we are, and security history file. All right, at this location you have your certificates on master node. This is my master node. All right, you have your private key. All right, you have your CSR. You have to put these details. You have to put these details in this YAML as well. All right, you have to give the context and you have to give the certificate values also. Okay, I haven't just put the certificate details, otherwise everything is already done. Then can you please show us how do you configure multiple contexts with multiple certificates in Jump server? Okay, Siddharth, let me tell you that. All right. So Siddharth and Gaurav, I think this was a question from both of you. Okay. So as you can see, that context is a list. All right. You see that context is a list. Under context, you can define multiple contexts as I have defined. This is one context. This is another context, which is the current context I have given here. All right. Now, if you want to have multiple cluster as well, you can see that clusters is also a list. Okay. Clusters is also a list. So under cluster, you have to give your cluster CA certificate details. Okay. I showed you where your CA resides. Your CA resides at etc Kubernetes PKI. Okay, from there you are going to have the CA authority data, all right, base encoded format. You are going to have that in this cluster, another next detail, all right, and you are going to have your API server, your master node IP address, and the API server port number that is going to be default 6443, but the IP is going to get changed, all right. So similarly, you are going to have, if you want to connect to two cluster, you are going to have two entries here like this. One will be your cluster and second will be your server. All right. So you can set multiple cluster details here. All right. Now talking about the user details. All right. You can see that users is also a list. All right. User is also a list. So you have to give the name of the user. All right. And you have to give the certificate details of that user also. Okay. And we have already seen how to have a base encoded format. The command is already provided you in the Git repository. Prempal, is there any way to connect to cluster without copying config file on the Jump server? Prempal, how can you connect to any server without authentication and authorization? If you're not going to move the config file, how you can connect to a cluster? Authentication and authorization is the main thing. Yes, Siddharth, absolutely, you got it. Yes, Gaurav, the way I created another entry, you can remove a previous entry also. If you want to remove this entry, you can just comment it out and remove it totally from the kubeconfig file. Kushagra, you want to know about external name service. All right, so Kushagra, if it is okay, can we discuss about that tomorrow? Okay, because we already have some topics remaining from today's class. Yes, there is an external service name. It is never used, honestly speaking. In my complete experience, I have not used it any enterprise level, and in the examination also, they don't give the question with this. Can we create service account and add users to it so that we can create certificate for any service account instead? Anil, that is what I wanted to show you with the remaining topics. All right. The service account we are supposed to discuss. Okay. So team will take some time. All right. We are going to extend a little. Security context we can do tomorrow, but I want you to understand about the service account today itself. Okay. Because it is all related to your security. The flow breaks because that is the reason I kept the all security content on a single day. Alright, so team, what is the service account? Certificates, you understood that certificates allows you one component to talk to each other. Alright, now, but if you want to have, and also important thing, I'll show you the dashboard also. Okay, so if you do a little overtime, I'll show you the dashboard also today. Alright, so team, consider where your service accounts are used. With all the communication, you can see that I have used certificates, but consider that if you're using bots, alright, consider as I went to the ICICI Bank website, it has a small prompt at the corner with the chat option. Alright, for example, if I show you HDFC, there is something called EVA, right? So this is an artificial intelligence. It is a bot. All right. You will get some details. It will fetch that details from its own cluster. All right. Consider I want to know about credit card services. All right. So what this bot is going to do, it is going to check inside the cluster and give me the details. All right. So certificates are used to authenticate the user, and service accounts are used to authenticate some automation. All right. Or you can say artificial intelligence. So if you want to give some details across artificial intelligent objects, you use service accounts to communicate between application without prompting username and password. Absolutely correct, Prempal. All right. So team, with this, I am going to show you something with the dashboard also. All right. So team, what is a Kubernetes dashboard? Kubernetes dashboard allows you to do all the operation from the dashboard on the UI. All right. Not on the command line. Everything you can do from the dashboard also. So what is happening? Dashboard is also a UI. All right. You are going to give some permission. You are going to create something from the dashboard. It will be created on the node. You do kubectl get nodes on the dashboard. All right, so it will get authenticated via a service account and connect to your command line cluster and get the details from there. So if you talk about that, there your service accounts come into picture. All right. So team, service account, again, I'm telling you, it is not important for the examination point of view. All right. I'm just giving you for your own good. All right. I want to show you the dashboard as well. That is why I'm covering this. Otherwise, it is not important for exam. They never give you dashboard or service account in examination. All right, so team, I'll come to the dashboard. Under dashboard, you can see I have insecure dashboard also and secure dashboard also. Insecure dashboard you want to use, you can use it. All right, so it will not use any authentication. It will simply give you the details on the dashboard. But I want to use a secure one because I want you to understand about the service accounts. All right, so you can see this is a YAML. I'm going to create a namespace. I'm going to create a service account. So team, what is a service account actually? Under Kubernetes, kubectl get SA. All right, you can see a default SA is already created. All right, let's describe it. Kubectl describe SA default. All right. So team, with our service account, our token is already connected. Okay, you can see this token is with every place. All right, this token is in a place of everything. If I do kubectl get pods and I describe a pod, kubectl describe pod name. All right, so team, I described the pod and I had this token. This is the default service account. It has a token of PM8GK. All right, in this definition, you can see that somewhere. Where is it? Where is it? Here it is. Okay, you can see the mounts. You can see it is having a Kube API access PKM7P. Okay, so whatever the resource you are creating, it is using the secret, it is using the service account. All right, it always uses that. So along with this, you can see this is the token. Okay, you can see this is the token, but you can see that mountable secret also. So with the same name, a secret is also there. All right, kubectl get secret name. All right, you can say a secret is also created along with it. All right, let's describe the secret now. Kubectl describe secret and secret name. All right, so team, this is the end token. This is the end token of your service account that actually uses. Okay, so you can see, understand the hierarchy. You have a service account. With service account, you have a secret created, and under secret, you have a token. This is a complete hierarchy of your service account. All right, let me go back to normal location. All right, and you can see all the objects are going to get created. I am creating a service account here. All right, I am going to expose the service because I want to have it as a dashboard. Then I am creating a secret also. Okay, so you can see everything that I have shown you are going to get created. I am creating secrets here also. Multiple secret for multiple components, multiple secret. I have used config file, ConfigMap. I am creating a role also. Okay, because secrets also need roles, right? By that only they are going to get the details from the cluster. You have a cluster role. We have a role binding, cluster role binding. All right, now we are creating a deployment. All the objects are there that provides you the complete dashboard, and there is no component left in this YAML that you don't know about. All the components in this YAML, you have understanding about all of them. kubectl create -f and done. Okay, so you can see your namespace, service account, services, secrets are created, config maps, roles, role binding, deployment, services, and this. All right, kubectl get all -all. Okay, -all was there. Let me get the services only. SVC -all. Okay, anything wrong I'm doing? No. Just give me a minute. Okay, thanks Arjun. That slipped my mind. Thank you. Alright, so team, this is your stateful set, this is your replica set. I am looking for a service. Alright, you have a service for Kubernetes dashboard. Alright, so I am going to use a node port of this one on this one. Let me see what I'm looking for. I'm looking for my master node IP. I'll paste it here and I'll get the port number 30522. Okay, so it follows HTTPS because we are talking about the secure connection. Advanced. So team, this is a secure connection, that is understood, but the certificates are not CA authorized. That is why it is asking you, do you want to continue or not? All right. So team, it is asking you to have the token. All right. It is asking for you to have the token. Let's see where I can find a token. All right. kubectl get SA. All right. You can say Kubernetes dashboard. All right. I'm going to describe it. kubectl describe SA and the SA name, Kubernetes dashboard. It has a secret. Let me describe the secret. kubectl describe secret and secret name. Alright, so team, this is the token that you have to provide there. Okay, this is the token that you have to provide here. Then only you are going to get the sign up. Alright, so team, welcome to the Kubernetes dashboard. Alright, you can see this is about the default namespace. You want to see of any other namespace, you can see Kubernetes dashboard namespace, you can check it out here. Alright, all the objects you can see what are created. Alright, CPU utilization, memory utilization, workload, how many pods are there, how many deployments are there, how many replica sets are there. Alright, you can see about the replica set details. Alright, this is your replica set for say. Alright, this is your maximum search, maximum details. All the details when it was created, you get all the details from here. Okay, all the details you get it from here. Consider I want to scale my deployment. Okay, this one, it has as of now 1/1 pod. Click on the 3 dots, scale. Okay, consider I want 3 replicas now. Okay, I want to have 3 replicas. I'll scale it. Okay, so on the command line, if you want to see kubectl get deploy. Can you see dep test has been scaled to 3? All the things that you can do from the command line, you can do it from the dashboard also. Okay, these are your number of pods. Alright, how much your pod is consuming actually. This is your RAM utilization, this is your memory utilization, and how it is fetching all these details because your metric server is installed. Okay, so you can see all the details here. You can edit anything, you can create anything. Alright, this is about your services. If you want to make some changes, edit your service, delete your service, everything you can do that. Alright, so team, this is all about your dashboard. So today you have seen your dashboard as well. Okay, so team, any doubts related to your service account? Prempal, you asked that how to prepare a project and submit in Edureka LMS. I'll request you to confirm that with the support team. Okay. As for my understanding, you have the project, you do the use cases on your cluster. All right. Have a screenshot of that, paste it in a notepad or somewhere, and then submit that document. That is my understanding, but I'll request you to double check it with the support team. Mosumi, you're asking what is a mountable secret? Mountable secret is nothing but a normal secret. Okay. Mountable is a keyword written because it is used by all the components inside the cluster, and that secret is mounted on a service account. That is why it is showing you mountable. Otherwise, it is just like a normal secret. How to control read-write access of volumes using roles and service account. Okay, Mosumi, I think I have already told you. For example, if you want the access limitation on a persistent volume is a cluster level resource. So if you give any user a cluster level resource, you can define it that he should not have the access on persistent volume, or he should get the access only of getting the persistent volume, not creating, not deleting. All right. And if you want to deal with namespace, you have persistent volume claims. All right. You can create a role in for persistent volume claim, that if anybody wants to list it or delete it or create it, so you create a role and create a role binding corresponding to that user. So that's how you're going to do that, Masumi. Sir, can I create a pod from the dashboard? Rahul, absolutely you can do that. Okay, here is a plus sign. All right, on plus sign you create. If you want to give a YAML format, you can give a YAML file here. Okay, if you want to upload a file, you can upload a file also. All right, from here. If you want to create right from the command, all right, I give a name. Okay, testing app, container image, I am using Nginx. All right, number of pods I want one only. Service, I don't want to create any service as of now. Deploy. Okay, so with this you can create any object. All right, you can provide the YAML text here. You can have a file uploaded, or you can create it from the command line itself. All right, so if I show you on the dash command line kubectl get pods, 20 seconds ago a testing pod was created. Okay, you can see it was created as a deployment. All right, it is created as a deployment, but that doesn't create any problem. All right, because it was providing you to provide the number of replicas as well. So if you want to create a single pod, you can create it as a deployment also, no problem with that. Ankur, that is the question I was not expecting, honestly. Okay, you're saying that this dashboard didn't ask for the username and password. I told you what are the ways of authentication. There are 4 ways of authentication. Okay, username and password, username and token, and you have your certificates, and you have service account. These are 4 ways of authentication. All right, and I told you in Kubernetes we always follow certificates and service account. So we logged into this dashboard using a service account. All right, I can log out, and you can see I am providing a token. With that token, I was able to log into this dashboard. If you don't have this token, how you log in? That is a alphanumeric long string. It does provide you a security. If you miss any one character, you won't be able to log in. All right, let me give you any gibberish here. Okay, I'm just typing gibberish. Let me sign in. Okay, it says invalid credential. So I have to make sure that I am providing exactly correct details here. All right, this is where is it? This is a token. Okay, and this is a token of your service account. You give that detail, then only you will be able to log into your cluster. Otherwise, you won't be. Okay, so if you want to use kubeconfig file, you have to give the kubeconfig file also. You can do that also. Okay, the config file, you can browse it from the local machine. All right, consider I have a kubeconfig file of Kubernetes admin. All right, so token is used by service account. If you want to use service account, you use token. If you use certificate, you use kubeconfig. All right, in kubeconfig, you have the config file. You place it on your local machine, download it on your local machine, then browse it, select that file, and then you can log in to the dashboard using kubeconfig certificates. Okay, Sarath, that is how you're going to do that. Sir, if I have to create a development for dev and a testing at the same time, will it be possible for the dashboard? So I have to change the labels in YAML. Rahul, I didn't get it. So if I have to create a deployment, okay, you have to create a deployment for dev and testing at the same time. Will it be possible from the dashboard, or I have to change the labels? Okay. So Rahul, what you want to create a deployment, all right? So you can have a YAML file here, all right? you know in a YAML you can create multiple resources at the same time, right? If you see this YAML file, okay, if you see this YAML file, I am creating multiple objects, service account, and see I am creating multiple secrets, 1 secret, 2 secret, 3 secrets. All right, all the 3 secrets are getting created in a single go. If I copy and paste it here, if I copy it and paste it here and upload, it means it will create 3 secrets in parallel. Okay, I hope this was your question. In place of secret, you can give your deployment definition. Okay, what's wrong with him? Alright, in order to restrict dashboard access in terms of Kubernetes object, I guess I need to restrict the role of the particular service account during the cluster role binding. No, Siddharth, if you're talking about the cluster role and cluster role binding, what I have created in this YAML are used to fetch all the details about your cluster and see it on the dashboard. Okay, the cluster role I have created, with this YAML, I have given the permission to create the resources from the dashboard. Alright, but if you want to restrict the access of dashboard, you have to keep the YAML file with you properly. Alright, or consider you can have the multiple dashboard. You can have a multiple dashboards of the same cluster. In some, you give all the roles and responsibility with cluster role and role binding. Alright, in some dashboard you can limit the access, and you can vary, you can change those dashboard access using the port number, because you will see that always a new service is also created with a new dashboard. Okay, so yes, by that way you can also restrict the access. Alright team, any other question till now? Everything is clear to all of you? Any doubts, any question? So team, with this I will be concluding today's session here. Alright, I'll be concluding today's session here. Security context is a small topic, I can cover it tomorrow as well. Alright, today we are already 25 minutes late. Alright, so team, I am getting all your feedbacks and I really appreciate all of it. Alright, so keep doing that. We are done with today's topic. If you have any questions, you can stay. Otherwise, you can leave today's session and mark your feedback. And tomorrow we are going to meet for the last time, where we are going to discuss about everything troubleshooting and your examination tips. Everything we'll cover tomorrow. Okay. Yes, Anil, I'll provide you all the content about your mock papers and CKA questions, what kind of questions comes. We are going to have a good discussion on examination point of view. Okay, we'll do that. Arjun, you won't get the mock exams actually, alright? You won't get exactly that, but I will try to give you as much as content I can give. Today we are going to wrap it up, alright? After today, you will be ready to take the examination of CKA. So team, please confirm if you can see my screen and if I'm audible to all of you. Yes, Ashok, ask a big question if you have. No, Ashok, for interview you don't have to remember the commands, alright? Yes, but basic commands idea you should do have. Alright? Like how you can list the pods, kubectl get pods, okay, basic commands you should have. How to create a service from command line, kubectl expose is the command,
all right? And if you're going to write the YAML, what are the mandate fields? It is API version, kind, metadata, and specs. And if you want to scale a service, so kubectl scale deployment name -- replicas equals to 5. So all the basic commands you should be knowing, all right? So that comes with practice only. If you're going to an interview and you are showing your experience that you do have experience in Kubernetes, so definitely somebody will expect that you should know basic commands. Okay. So team, anybody else wants to ask anything before we start with today's class? Agenda is right in front of you. Team, I'm audible to all of you, right? I got only one response today. Okay, great. So team, nobody has any question, right? Ashok, let's discuss that by the end of the session, alright? Because to discuss on the interview, if you want to start a discussion on interview, we can have a complete session for that, and even that won't be enough. Right? Still, if you want to prepare for the interview and if you want me to give a one-liner, you should have your core concepts very strong. Alright? Today we are going to see the troubleshooting. Alright? So from there you can get an idea that your core should be strong, your concept should be clear, your basic should be clear, how the Kubernetes is architectured, and if you want to troubleshoot, how you can troubleshoot. It all comes down to the basic architecture, how much clarity you do have at that area. Alright, so we'll discuss that thing by the end of the session as per the time permits. Alright team, so I think we can start for today, right? First thing is that we left on which yesterday, alright? Security context was left from yesterday's class, alright? So first we are going to go over that, and after that we are going to move to the networking part, right? So to be very honest, security context is hardly 5-minute topic, alright? It doesn't have much time for that. So team, what is security context? Security context is nothing like, for example, if I give you a basic idea, I'm using my laptop, right? I'm using my laptop, Windows laptop I do have, alright? So what happens whenever I am working on it? What I do all the things with the administrator account. Alright, whenever you are using your laptop, you always use administrator account. Alright, but consider you want to hand it over to somebody else for a few hours. Alright, if you want to hand it over to someone for a few hours, what you do, you'll lock your administrator account, and what you'll do, you'll open a guest account. Right?
so that if somebody wants to use your laptop, he will be using guest account. So team, don't we do that? Isn't it that the case? Yes, no, maybe. Isn't it? So team, come on. Are you sleeping or what? I'm not getting responses enough today. Didn't had your coffee? So team, today is the last class, alright? So definitely topics are going to get a little complex. If you won't respond, I won't be able to help you. The session has to be interactive. Okay. So team, few of you said yes, right? So whenever you're using your laptop and if you want to give it to someone for some few hours, so what you do, you always have a guest account so that he can use it and he won't have the complete permission of your laptop, right? That is what we do. Similarly, in your servers and containers, all right, consider your system administrator of your organization. So you are responsible to take care of all the servers, all right? Again, in that server also, you have a Linux server, all right? So what you'll do as a Linux administrator, you will have the super privileges, all right? And the person who are from other team, for example, a person from database administrator team came to you that I want access on this server. So what you will do, you will create a user and you will provide that user access to that particular database administrator, so that he will log into that machine with that username and he won't have the complete access. All right, he won't be having super privileges. Okay, so team, these are the two use cases that you have seen on daily basis. Same thing we want to have it for our containers as well. All right, same thing we want to have for our containers as well. So team, what happened by default whenever you create a container? Okay, kubectl run pod1 -- image nginx. All right, your pod is created. kubectl exec -it pod1 -bash. Okay, so team, by default, whenever you create a container and you log into that container, you are entered as a root user. All right, you can see I logged into the container. All right, by default, the user I get is a root user, and I don't want anybody to have the root access inside my container. That is my requirement, because he can go inside the container and he can mess it up. So what are my expectations? I don't want to give a root access to anyone inside my container, even if I'm that person. All right, if any other Kubernetes administrator is there, I don't want to give that much access. All right, so how we are going to avoid it? To avoid that, security context is something that comes into picture. Okay, security context helps you with that. So let me show you an example for that one real quick. All right, it comes under security, and then we have security context. All right, consider it is my pod where I don't want to give root user access. All right, so here is an example. Run as non-root prod. All right, so team, you can see the definition. It is API version 1 and kind is pod. This is the name of my pod. Under specification, I'm going to mention security context. Okay, under specification, you mention the security context. In the security context, you can say that run as non-root.
is true. Alright, so I'm asking it not to run as a root user, run it as a 405 user. Alright, let's have a raw format. I'll copy it, kubectl create -f. Okay, my pod is created, kubectl get pods. Okay, so many things are running. Alright, kubectl exec-it and the name of my pod -bash. So team, you can identify, alright, whenever you have the root access, you get a hash, alright. Whenever you don't have the root access, you get something like that, $sign or what. Or if I do ID as well, okay, you can see what is my user ID. My user ID is 405. Group ID is root, that is okay. I just asked for the user, alright. So I don't have the root user access at this point of time. Alright, similarly, I have multiple examples here. Alright, the type of variety you can have for the users inside your container. Alright, like if you want to have a pod which has read-only access, so you cannot make any changes in the pod configuration. You have that also. Okay, you have set the volumes, and you will have only the root read-only access in the root file system. Alright, in the root file system, root/, you won't be able to do any changes. Okay, it will have only read-only access. Similarly, multiple cases are here. Alright, multiple cases are here. We have multiple examples. Alright, whatever you want to have, you can do with your pods and container. Alright, so team, security context is nothing, just managing the access you give to the container. Alright, that's all about your security context. This is this much only. Alright, we don't have much in the security context, that is all about it. Ashok Sahu, I have just given a name of the user. Alright, 405 is just a name of a user. You can give XYZ, ABCD, Rahul, Shuk, Ashok, whatever you want to give, you can give. It is just a username. Alright, UID means username. If you saw earlier, it was root. Okay, earlier it was UID equals to root. It is just a unique ID. Alright, 0 is a unique ID for root. Alright, and 405 is a unique ID for guest account. Okay, so team, clear to all of you? I told you this was the smallest topic in fact. Alright, so team, now we are going to start with today's agenda. Alright, your last class agenda. Alright, and we are going to start with the basics of networking. Alright, we are going to start with the basics of networking. So don't worry, I'm not going to start right away from the Kubernetes networking. I'll show you a basic idea of basic networking and then we'll jump into Kubernetes. And this is mostly a theoretical part. Okay, so kindly try to bear with me. There will be theoretical part much on the networking side first. Okay, so team, consider I have multiple laptops, okay, or multiple systems. We have C1, C2, C3, C4, alright, and consider this laptop wants to talk to this laptop. Alright, they want to communicate with each other, computer 1 and computer 2, basic layman language. Alright, two systems wants to talk to each other. In very basic example, layman example, how do they communicate with each other? What is a technical term in networking with which they can talk to each other? Eka, Anil, yes, I got your answers. Okay. Okay, Rishabh, yes, that is true, but how? Prempal, yes, you too. But what do we need for that? Okay, so team, the thing is called switch. Okay, you need to have a switch if your two computer wants to talk to each other. All right, same thing happens with C3 and C4. If they want to talk to each other, they are also going to have a switch with them. All right, again switches here. But consider if they want to talk to the other one in a crossway. All right, consider your computer 3 wants to talk to computer 2. All right, or your computer 1 wants to talk to computer 4. All right, that could be the case. How they're going to communicate crossly? In that case, we need something called router. All right, then we need router. All right, so team, this is very basic networking if we talk about, all right, very basic networking, no rocket science. All right, now let's come to containers. All right, let's come to container. In a container, all right, in a container, we have something called CNM, okay, container network model, right, with which they can communicate with each other. I'm talking about the containers right now. All right, I'm just talking about the container. Container means we are talking about Docker containers. All right, consider on the same machine. On the same machine, I have two containers. All right, on the same machine, if I talk about, I have two containers. Being on the same host, they can definitely talk to each other. All right, both the containers are running on the same host. Definitely, they can talk to each other. But how they can talk to each other? What is the networking terminology that allows them to communicate with each other on the same host, being on same host? All right, so that is called Docker Zero Network. If I have installed Docker on a machine, I am creating Docker machines, so all the containers on the same host will have a Docker Zero network with which they will be able to communicate with each other. All right. Similarly, if I talk about Docker Swamp, okay, if I talk about Docker Swamp, now you understood that your pods, containers can happily talk to each other inside a same host. All right, in the same host, that is possible. But consider now if you have Docker Swarm, okay, on Docker Swarm again you have a cluster of machines, all right, and again you want your pods to talk to each other across nodes. Okay, now you need this communication as well. Okay, this container should be able to talk to container which is residing on a different node. All right, for that purpose, if I talk about Docker and Docker Swarm, you have something called overlay network. Okay, overlay networks are there that helps with the communication of inter-node communication in Docker and Docker Swarm. All right, so team, this is the basic of networking in your Docker Swarm.
Alright, because Docker has its own CNM. But consider I don't have my own CNM, right? Do we have CNM in Kubernetes? Do we have CNM in Kubernetes? Correct? No? Right? Team, just allow me a minute, please. 1 minute. Alright, yes team. Okay, so in Kubernetes, if I talk about I am creating a cluster in Kubernetes, definitely I won't be having this overlay network, at least. Alright, other things I might be having, because definitely on all the nodes, there is a Docker 0 network because Docker is created there. Alright, so if I talk about Kubernetes, I am not having CNM, I am having CNI. Alright, and that was completely up to me which container networking interface I am picking. Alright, Flannel, Calico, VNet, and plenty of are there. So it is again up to me. So team, in the examination as well, it is completely up to you, whichever you want to use. Alright, so as we have used VNet, you have seen how we can use it. Alright, so it is the easiest one. So that is why I suggest you to have a VNet with you during the examination. Alright, so team, now I'm going to show you practically how many networks we do have in Kubernetes if we talk about your CNI. Alright, like Docker 0 network, overlay network, how many networks we have with Kubernetes. This is my master node. Alright, simply give IP-A, IP space A. Alright, now let me show you how many networks you do have. Alright, first network is your loopback address. Alright, first one is your loopback address. What is a loopback address? Loopback address is the same address with which your host comes back to itself. Okay, this is a default IP which is given on every node. Alright, so if you want to do like localhost.com, alright, on laptop, if you do that, so it comes back to its own address. So that is called loopback address. I completely understand that you all must be knowing about this one. Very basic thing, not even a networking concept properly. Alright, after that you can see a third one which is called Docker 0. Okay, so this is Docker 0 network because a Docker has been installed on this machine. Alright, apart from that, you can see a VNet network also. So what all these networking are doing, they are simply providing the IP addresses to your objects. Alright, if I talk about Docker 0, Docker 0 helps with providing the IP addresses to your containers. Alright, and this is your CIDR block. If I create a Docker container, it will have the IP in this range only. Alright, this is a CIDR block. Similarly for Weave, okay, you can see the VNet. This is what we had as a CNI. It has its own CIDR block. So all the pods which will be created using VNet in this cluster on this particular machine will have the CIDR block. Okay, it will vary from this node to worker node 1 to worker node 2. Okay, it will keep on varying because a VNet pod is there on every machine, if you remember. Right? And if you talk about the other one, okay, like this one and this one, so these are related to the pods that are currently running. Okay, whenever you create a deployment or whenever you create some object in Kubernetes, alright, they create their own network as well, because as you already know, you have a deployment. Alright, in deployment you are asking for 5 replicas, so those 5 replicas should be able to talking to each other. So definitely they also need some kind of network within the deployment. Alright, so you can see these network as that. Alright, so team, is it clear to all of you? Clear to all of you? Service network. Alright, basics. Alright, so team, this is some of the theory that you already understand. Alright, some of the theory on basics of networking. Alright, since a Kubernetes cluster consists of various nodes and pods, understand how to communicate them is essential. Alright, networking models support different type of open source implementation. Alright, so we already know that it allows a variety of CNIs. These are all open source implementation. Alright, a Kubernetes networking model on the other hand natively support multi-host networking in which pods are able to communicate with each other by default. Okay, so you know that on whichever node the pod is getting created, they will be able to talk to each other. So that is already provided us through by default. Kubernetes follows an IP per pod. Okay, we also know that if a pod contains multiple containers as well, if it is a multi-container pod, then only we support only IP per pod. There is only one IP per pod. No matter what, how many pods are running inside your container, how many containers are running inside your pod. Alright, there is always one IP per pod. An IP address is all the containers in a single pod shares the same network namespace and IP address. Alright, containers in the same pod can therefore reach each other ports via local host and port number. Alright, so the number of pod, consider if I have two pods inside my, consider I have two containers inside my pod. Alright, so simply both the pods can reach to each other using local host. Alright, they can simply say 127.0.0 and .1. Alright, and the port number. Like this, they communicate inside a pod. It is not recommended to communicate directly with a pod via its IP due to pod volatility. Alright, so now if you want to communicate with the container, we never suggest you to have the IP of the container. Alright, instead use the Kubernetes services which represent, I was trying to say that whenever you want to access your pod, alright, we never suggest you to use the IP. Alright, we always create a service to communicate with our pods, because we know all the IPs that are present are internal. Alright, services get their own IP addresses. Alright, we have seen whenever we create a service, IP address will be assigned to that also. Alright, so team, all the description that is mentioned here, you have seen all of it. Alright, nothing new is it. A small part that you don't know is your DNS for services and pods. Alright, so what is DNS for services and pods? So team, the thing is, whenever you type www.google.com, okay, whenever you type www.google.com, what it is? Isn't it a DNS entry of any web server? Alright, consider you entered www.google.com. So what actually happened? This is our DNS name. Alright, at the backend there has to be a IP. Alright, so www.google.com is simply a DNS name. Alright, at the backend DNS resolution take place. DNS resolution consists that your name, the DNS entry, the human readable characters you have provided at the backend, it should have some IP address. Okay, and that IP address is used to reach out to the server, because your servers are identified with the IP address. Okay, they have an address in IP ranges. So these are your DNS name. Alright, in Kubernetes, if we talk about services and if I talk about pods, they also own some DNS name, alright, for the internal purpose. Like if I want to access www.google.com, that is for me. Okay, so Google has created it like this so that it will be easy to remember for the users. Simply type www.google.com and you will have the website. They don't want their customers to remember the IP addresses, okay, because numerical string is hard to remember as compared with the name. Alright, similarly in Kubernetes also, not for the cluster, not for the customers. Alright, DNS names are created for services and pods so that Kubernetes can help them communicate inside the cluster. Alright, if one object wants to talk to another object, alright, for that purpose we get DNS name assigned to pods and services so that they can communicate with each other easily. Alright, so if you remember, I can show you that again. kubectl get pods -n kube-system. Okay, there are still two pods that we haven't discussed on. Okay, we haven't had a long discussion or much discussion on these two pods. Core DNS, these are also your master level resources. Alright, you can see two core DNS pods are there always running. Okay, so what is the purpose of these pods? They provide naming convention for your pods and services. Alright, a DNS name will be assigned to your pods and services. Now let me show you another thing. Alright, Kubernetes provides its own DNS services to resolve domain name inside the cluster. Alright, in order for pods to communicate with each other. This is implemented by deploying a regular Kubernetes service which does name resolution inside the cluster. Alright, and configuring individual containers to contact the DNS service to resolve DNS name. Alright, so these are the internal DNS names. Alright, let me explain you practically. Alright, so team, now I am taking a little example. Okay, don't consider them as a node now. Alright, they are not the nodes, they are namespaces. Alright, consider this is my NS1. Alright, and this is my NS2. Alright, I have two namespaces, I can have it. Alright, so you can say that I have a pod running inside this namespace. Alright, and I have a service created along with it. Similarly, on your second namespace, I have a pod, and similarly, I have another service. Two different namespaces, two different pods in different namespaces, and two different services on two different namespaces. Alright, that is what we have understood so far. And accordingly, consider you have another pods running outside your namespaces, that is your DNS pods. Alright, you saw core DNS, they are running in the third namespace kube system. Alright, system level resource, core DNS. So what we have DNS here. Now, consider team that you have some file on your laptop. Alright, you have some files on your laptop. Okay, so this is your complete laptop. So consider your resume is residing on your D drive, or it is maybe residing on C drive. Alright, so if you do have to reach the path, alright, you have some naming idea about it, how to reach to a particular path. You go to C drive / abc cd, alright, / program file / something. Okay, so you have a complete path for it. Alright, you have a complete path. In Kubernetes also, alright, in Kubernetes also we follow some naming convention. Alright, so first the naming convention start with your cluster local. Alright,
cluster local is simply like your my computer. All right, on your laptop you have my computer. Now you have my computer. After that you have some namespaces. All right, so like if you want to go to program files, first you'll have C drive and then / program files. In Kubernetes you have the cluster name. All right, this is your cluster local. And consider if I want to talk to namespace 1, so the naming convention will go like ns1 dot cluster dot local. Similarly, if I'll talk about ns2, it will be ns2 dot cluster dot local. Right, team? Making sense? And now consider if I want to have the address of these pods and services. All right, so it will again have something. It will again have something like, for say, if it will have some service name. All right, it will have some service name. All right, and then it will have ns2, and then it will have cluster dot local. Okay, so team, this is how you do the naming convention, right? Now let's see the practical example for this also. Okay, let's try to do this practically. Okay, here is an example, DNS test MD. All right, so team, the same example I have given you, I'm going to create it. All right, I'm going to create an Nginx pod and Nginx service in testns namespace. All right, so first I'm going to create a testns namespace. All right, my testns namespace is created. Now I am creating a testns. In the testns namespace, I am creating a pod. All right, I am creating a pod, and this is my image. All right, in the same command, I am exposing it also. Okay, I am exposing it also at port number 80. All right, I am creating a service and I am creating a pod in a single shot. Okay, done. All right, my Nginx pod and Nginx service is created. So if I want to list kubectl -n testns get all. All right, you can see one pod is running with Nginx name and one service is running with Nginx name. All right, good. Now consider I want to create another my Nginx pod and my Nginx service in default namespace. All right, so in default namespace, if you want to give -n default, you can, otherwise you can skip that also. All right, again I'm creating it in the same way. I'm creating a service and I'm creating a pod in a single shot command. That is also done. All right, so now I'm going to validate both of it. kubectl -n testns get all -o wide. It is kubectl. All right, so this is about your testns namespace, and kubectl get all -o wide. Okay, I am having a lot of things. Let me delete everything first. Let me clean up the system. All right, it will have a lot more things otherwise. Okay, so my system is clear. kubectl -n get ns sorry, ns is not test ns get all. All right. So I deleted everything, but my pods in test ns are still there. All right, that's good. Let me create the default one also. -o white. Alright team, so you can see Nginx pod and Nginx service is running in testns namespace and in default namespace. My Nginx name pod and my Nginx named IP service is created. Alright, that's all. So if I show you what I am doing this is your test ns. Alright, and this is your default one. Alright, so team, any doubts till here? Okay, as of now we haven't done much, we are just trying to understand the basic networking concepts. Alright, very basic things. Alright, so team, now I want to know about the naming convention of this. Alright, now I want to find out what are the complete DNS name of these objects, whatever I have created so far. Alright, for that purpose you have some DNS pods just to resolve the namings. Alright, just to resolve the namings. Alright, so team, during exam they might ask you the complete full DNS name. Alright, complete name resolution they want. Alright, so in exam they do ask you that. They provide you an image also to find out the name. Alright, they provide you the image also to find it out. Alright, but if you want to use my image, you can use this image also. Okay, this image also provide you ns lookup. Alright, and they will also give you the image to use. You can use anyone. Alright, you can use anyone. So to do the ns lookup, I am creating a pod with this image. Learn DevOps, NetShoot. Alright, so I'm going to create it and I'm going to log into this container right away. Alright, so team, you can see my prompt has changed. Alright, it is a bash prompt. Now I am inside this container. Okay, DNS test. So what is the purpose of this pod? I can test the service names. I'll do cat etc resolve.conf. Okay, how the naming convention are resolved. So team, can you see how it goes? First, cluster local, as I told you. Alright, now if I want to talk about the service comes with service.cluster.local. Alright, or you can search like test ns if you talk about the test ns namespace, then services, then cluster local. Okay, so team, this is how you do the naming resolution. Okay, this is how it is going to resolve the name. Alright, let's see about that. So if you want to have the complete name of a service that is running inside your test ns namespace. Alright, if you want to see the full name, ns lookup. Alright, and then you have what? This is your service name. Alright, and then you have namespace name, and then you have the object type. Alright, so team, this is how you are going to give the names. Alright, again I am repeating it. First your object name, then your object namespace, then your object type. Alright, so I have a Nginx named service in test namespace, and what is its objects type is service. Nginx dot test ns, then the type svc. So you can see the complete name of it. Okay, at the last you have the cluster local. Alright, then the type of object, then namespace name, and then the object name.
Alright, and you can see the IP address also of this one. Alright, if I can let you check this Nginx service. Alright, what is your IP? 100, 246 and 201. 100, 246, 201. Alright, consider, now I want to check the full name resolution for my another service. Alright, I want to check for this one. It is running in the default namespace. So what I am going to give? NS lookup. Alright, the name is my Nginx. Alright, my Nginx namespace is default namespace. And what kind of object it is? Again, service. Full name resolution. Object name, object namespace, object type, and then cluster local. Alright, my computer. IP address you can verify 102.222. 102.222. Alright, so team, I guess you understand about this now. Alright, if you talk about services, how it goes. Object name. Alright, namespace, then object type, alright, object type, and finally your cluster local. So team, now I want you to tell me, okay, now I want you to tell me if I want to do the name resolution for your pod, how I can do that. Okay, you have seen how I can do with services. How can I do it with the pod? You guys tell me. So this is, we are using a DNS for service which is inside Kubernetes cluster, but what we are connecting to service outside the cluster with DNS name. Rahul, as of now, we are just trying to understand how your networking happens inside the cluster. Okay, if you are talking about from outside the cluster, you know that. Alright, you have a node port service, it will be exposed. Alright, you can use it from the any IP machines and you will have the node port. Cluster IP is definitely not accessed from outside the cluster. We are just checking how the DNS name resolution happens from inside the cluster. Okay, so team, I want you to give me the complete string. Alright, like if I was doing the NS lookup for your service, so what I did nginx dot namespace and svc. If I want to NS lookup for pods, what I am going to give here? Okay, what I am going to give here? Type it out. Okay, great answer, Ankur. Anybody else? Okay, Rishabh, Anil, Himanshu, Arjun. Arjun, you never mentioned the object type. You never mentioned the object type. Okay, so team, most of you answered correctly. Okay, let's try it if it works or not. Alright, as per our current understanding, I assume that. Alright, NS lookup. Alright, consider I am looking for the testNS pod. Okay, what is the name of my testNS pod? testNS, the name is Nginx. Dot namespace testNS object type pod. Alright, that's all. No, it cannot find it. Server can't find it. Okay, let me try for the another namespace. Okay, on another namespace, how it is going to be? NS lookup. The name was my Nginx. Default dot pod. Still not working. Okay, so team, what is the thing? If you deal with services, the naming convention follows name, namespace, and object type. Okay, it is followed for services only. But if you talk about pods, top pods has different kind of naming convention. Okay, they uses IP. Okay, they uses IP. Now, if I want to do the test, I want to test the pod DNS. All right, there is a rule that has defined by the Kubernetes. All right, to form the pod DNS, get the pod IP first. All right, and replace dots with hyphen, and then add namespace name and then pod. As simple as that. All right, so whenever you want to do it with the pods, you have to give the IPs. All right, you have to give the IPs. That is how it is arranged. All right, so let me do that. NS lookup. All right, first I'm going to give the pod name. That is going to be my IP. Let's have it. All right, so about the test NS pod IP is this. Okay, and it is asked to replace the dots with hyphen. Let me do that. And then namespace name, test NS, and then you give the type, that is pod. See, now it is doing the naming resolution. Okay, you get the address and you get the name also. Okay, pod.cluster.local. Similarly, we can do with the another one also. All right, what is the IP of my Nginx pod? Okay, my Nginx pod IP is, did we do about this only? Okay, so let me do with the, let me verify it. All right, 106 test NS 106. Okay, I mismatched. All right, I mismatched. Hyphen, then default, then pod. Okay, so team, this is how your naming convention are resolved. All right, in examination you might get question from this part. All right, they will say that this pod is running in so and so namespace. All right, this pod is running, this service is getting created in so and so namespace. Have the full name resolution. All right, in that case you have to create a pod with the Learn DevOps NetShoot image. All right, or they might also provide you an image. You can use that image and have your complete naming resolution taken in place. All right, so team, any question, any doubt in pods naming resolution, services name resolution? Any doubts here? All right, we have covered security context, basics of networking and DNS test. Any doubts, any question here? Anil, the pod which I created was from the NetShoot image. Okay, the purpose for which that image was created to have the naming resolution. You will get another image in examination. Kubernetes does provide their own image to do the naming resolution. If you want to use my image, NetShoot, Learn DevOps / NetShoot, you can use that also. Okay, it is just for the naming resolution. Okay, team, if it is clear to all of you, give me a quick yes so that we can move to the troubleshooting part. Anil, everything in the Git repository. All right. You have to go to your Git repository, service network, DNS test.md. All right, where it is, where it is. This one. So Anil, it is here.
Okay, so team, now we are going to move the troubleshooting. All right. Now we are going to move to the troubleshooting part. How we can do the troubleshooting inside our cluster. All right. So we'll start from the very basic one. All right. I'll ask you questions. You answer me. All right. So team, this troubleshooting session has to be interactive. Okay. I need answers from all of you. Then only it is going to help you in the examination. All right. You have to think over it how to solve a particular situation. Control PQ, kubectl, get pods. All right. So team, see that your Nginx pod is running. All right. One of your Nginx pod is running. -o white. All right. So if I do ns lookup, not ns lookup, sorry, my bad. Curl operation. Okay. I'll curl the IP. Okay, you're getting the output with welcome to Nginx. All right, it runs on default port number 80. I'll give port number 80, and I suspect there is a page also. Sure. Okay, let's try that. So it is not found. All right. So team, starting with the very basic troubleshooting, I want to check the logs of my container. Okay, I want to check the logs of my container. Maybe a dumb question. In Cloud VM, we add DNS while deploying VM nodes. Is that not so? Then why deploy DNS pod? Okay, Arjun. In VMs, we are not dealing with VMs right now. We are dealing with Kubernetes. All right. In Kubernetes. So Arjun, what is the difference? Whenever you create a virtual machine, okay, whenever you create a virtual machine, you can use its external IP. And then you can access it from the outside world. All right. You can see I created a virtual machine. It had one internal IP and one external IP. So VMs are configured in a way that they will have two IPs, one external and one internal for outside world also. But if we talk about pods, pods have internal IPs only. Pods doesn't have the external name. All right. For that purpose, we create services. So it is a collective efforts of pods and services to expose your application, and that takes help of DNS. All right. So VMs are different with the pods and services that we are discussing. All right. So team, for troubleshooting, I got only two answers: Anil and Edureka guest. Risha, Bankur, Prempal, great. All right. So team, now I'm getting good answers. All right. So if you want to troubleshooting, your first troubleshooting starts with kubectl log command. Kubectl logs my Nginx. All right. Yes, you were absolutely correct. Okay. I'm getting the outputs from where I access. All right. So team, during exam, what type of question can come from this part? All right. So they will have you a pod given. All right. They will have you a pod given, and they'll say a pod is running there. All right. And find logs, find the error when there was 404 error. All right. And save the output in a file. Save the output in a file. All right. You can do that. Kubectl logs. All right. I will grep 404 error. All right. And I will direct the output it to faucet temp/error file. Okay. So in exam, they might ask you that you have a pod, grab the 404 errors and place the output in a file. You can do that. If I'll cat temp and error file. See, all the errors that you had with 404 will be saved to a file. Okay, very basic one. Okay, so team, from here it starts that you can grab the error, all right, and you can save the output in a file. Okay, so team, for the further troubleshooting, what I'm going to do, I'm going to pause my screen. Okay, I'm going to pause my screen. Let me do something, and then I'll ask you what I did and how it is going to help. Okay, let me go here and here.
Alright, so team, I think now you can see my screen. Just a minute, please. Okay, so team, what I'm doing, kubectl run. I'm creating a pod 1 -- image nginx. Okay, so team, what I have did, I created a pod kubectl get pods. So team, the status of your pod is coming like this. Alright, the status of your pod is coming as pending. Pod is created, container is not getting created. Alright, so team, now you tell me. Okay, how do I start my troubleshooting? All of you. Great answers. Alright, describe. Describe is going to be your first approach. If something is not happening, try to describe it. Describe pod 1. Alright, so team, I did the describe as per your suggestions. Okay, but in the describe, you can see there are no events. Okay, there are no events itself. Now what? Think about it. Edureka guys, the pod is in pending state. Container is not created. What I'm going to do exec with? Exec will take you to nowhere because your container is not created at all. Team, think about it. Okay, Abhinav, kubectl get nodes. Okay, good. Prempal, you can do the logs only when container is created. Alright, logs are fetched from the container. Your container is not created at all. How you can do the logs? How you can do the exec? Check YAML, storage class is not ready. Okay. Alright team, so first approach, I'll tell you what you can follow. kubectl get pods. Alright, it is still in pending state. So whenever your pod is not getting created, it is in pending state. First thing what you did, you check the describe. Alright, what is the first step in the events? Okay, you know the architecture, you have seen the events log multiple times. What is the first thing that comes in events? What is the first action that happens inside the cluster whenever you request a pod? Yes, Arjun, absolutely correct. No, Rahul, you're wrong. Ganapati, yes, to some extent. No, Gaurav, no. Mosumi, yes, but by whom? Okay, you are reaching there, Mosumi. Okay, so team, the first event that happens is your team. Let me show you of this one. Okay, you don't remember. Some of you do remember now. All right, but not all of you. kubectl describe pod by nginx. Team, what is the first event that happens? So many of you are telling the image pull. No, first thing that is done is scheduling. Okay, team, you have to pay attention. What is the basic architecture of Kubernetes? Right? The basic architecture tells you first the scheduling will take place. After that, kubelet will pull the image on the worker node. First is scheduler. Alright. So next thing, if you cannot see any events, alright, you go with the architecture. Okay. So team, for troubleshooting, stick with the architecture. What happens at what time? So let me get the output of kubectl get pods -n kube -system. Okay, let's see what is happening here. So team, what is happening to your scheduler? scheduler is failing with crash loopback. Okay, so what I did, I intentionally corrupted your scheduler. Okay, I intentionally corrupted your scheduler. Alright, so where your scheduler YAML is, scheduler runs as a static pod, you all know that. So I'll go to the static pod location, manifest. Alright, ls vi cube scheduler. So team, anything is wrong there? Right? So what I did, I intentionally corrupted my scheduler YAML. Okay, I intentionally corrupted it. So let me make it right. Alright, so I fixed the error. Alright, now you can see that scheduler is working. Scheduler is working. kubectl get pods. Okay, it is currently still in pending state, but it will get scheduled. Okay, you can see that it is scheduled, then only you are getting the creating container. Alright, now it is in running state. Okay, now it is in running state. kubectl describe pod 1. Okay, so team, first step that happens if you do not see any logs, you have to check for the scheduler or all your master components. Alright, alright, so team, I'm going to pause my screen again. Okay, I'm going to give you another use case. So team, if we talk about troubleshooting, there are endless scenarios. Okay, we do have endless scenarios, but I'm trying to show you a few. Alright, so that you understand how you do the troubleshooting, how it goes. Okay, what approach you take. That is what I'm trying to show you. Alright, so team, in the meantime, you can tell me that if I want to create a static pod, how do I do that? Okay, the next troubleshooting scenario is coming from static pod. So in the meantime, you can tell me how to create a static pod. Okay. Okay, so team, I have resumed my screen now. You can see my screen. Okay, so team, most of you have answered me correctly. Alright. Couple in mainframe we can create static pod. I don't understand this. Okay, so team, this is my worker node 1. Okay, I'm coming on worker node 1. So kubectl run. Let me have this command from here. Okay, kubectl run pod 1 -- image nginx. Alright, -- I'm just having the output for this. Okay, die run equals to client and -o YAML. What I'm giving. So team, this is a YAML. Okay, this is I want to get created on node 1 as a static pod. cd etc, as all of you have told me, Kubernetes and manifest. Okay, vi pod.yaml. Okay, I'm saving it. Alright, so team, now how I'm going to verify it if my pod is created or not. How do I verify if my pod is created or not? Alright, kubectl get pods I'm going to do from the master node. Alright, but if I want to verify it from the node 1 itself, Docker is installed there, I can do docker ps, right? Docker ps grep pod 1. Okay, it is created. Okay, just a minute. Just a minute, please. Okay, so team, what is happening? I just restarted my kubelet once. Alright, I just restarted my kubelet once, and I place a YAML file here. Alright, a YAML file is here. So team, your pod is not getting created. Okay, your static pod is not visible here. Docker ps grep pod 1. Okay, this is the earlier one. Alright, so ignore this one. You cannot see the pod 1 keynote 1 now. Okay, your YAML is there. Your YAML is there at etc Kubernetes manifest location, but at this location you cannot see your pod. Why your static pod is not coming? You tell me now. Arjun, you are well prepared for the exam, honestly speaking. Okay, great answer. So are you, Gaurav? Correct answer. Team answers. Okay, my static pod is not coming online. I have placed the YAML at etc Kubernetes manifest location. Why it is not coming up? Help me with the troubleshooting. Okay, Ankur, you are saying check the kubelet status first on the worker node. Alright, good one. Service kubelet status. Good approach. Okay, so Ankur, you gave the right approach. You know that static pods are always managed by the kubelet. Alright, so this is how your troubleshooting should go. You place a YAML file. Your kubelet is working or not? That is you have to check. Your kubelet is working now. Now what, Ankur? Team answers. You will get these kind of troubleshooting scenarios in exam as well. Okay, so you cannot say quite. Where, Rishabh? Where it can't read conf file. Ankur, which service you are talking? Okay, Docker service, Docker PS command gave the output, so Docker is working also. Kubelet agent enabled, present, conf. Okay, okay, got it. Actually, a question panel was placed at this area, so that is why I was not able to see, unable to read. Alright, so yes, right, Rishabh. Team, did I ever tell you that etc Kubernetes manifest is a default location for your static pod? Is it always remain the same, or it picks it from somewhere? Is etc Kubernetes manifest location is a default location, or this value is picked from somewhere? Team, answers. No, Saurav, I never told you this is the default location. No, Kapil. I never told you that this is the default location. Yes, this is a default location in a way, but this value is getting picked from somewhere. I showed you that also. Okay, when we studied about the config files, when we studied about the static pod, I clearly told you from where this value is getting picked. Yes, Eka, absolutely correct. Prempal, right. No, Mosumi, from the YAML you cannot help it. Okay, so I told you, team, I told you that Kubelet has all its libraries. Kubelet has all its libraries at var library and Kubelet location. Okay, here are your all libraries, and here is a config file as well. Alright, here is a config file as well. Alright, I told you, you have to come down and there is a static pod path. Okay, you have to come down to this config file and there is a static pod path. You can see that is ZZZ. Okay, it is not the right value. That is why your static pod is not created. Okay, your static pod path is not given properly. Alright, so this is not the default location. Alright, this is not the default location. You can change it. So team, consider in exam, they might ask you, create a static pod. Alright, they ask you create a static pod. You will go blindly to etc Kubernetes manifest location and place a YAML there. Alright, but your pod will not come up. Then you are going to troubleshoot it this way. Alright, you will check that even if your etc Kubernetes manifest location is still the default one or somebody has modified it. Okay, so I'll save it. Alright, I'll restart my services. Service kubelet restart. Alright, team, your static pod is coming online now. Okay, see, your static pod is now online. Your static pod is online now. Alright, Gaurav is showing I faced one scenario where Kubernetes is using C group as systemd, but Docker is using. Is that serious scenarios? Kubelet is not working fine. What is the best approach? Gaurav, during the installation process, okay, during the installation process, I told you to have one step. Okay, sorry, that was not with this batch. My bad. Alright, so Gaurav and team, what happened recently, version 22, alright, Kubernetes etc Kubernetes version 22 has arrived. Alright, so let me show you here. kubectl get nodes. Alright, when we started, alright, then the version was v1.21. Okay, now with the latest version has arrived 22. So if you are going to have the installation step, let me show you that. This is your install. Alright, some steps are modified. You can see this file has been updated 9 days ago. Okay, this file has updated 9 days ago. readme.md. Alright, so now during the installation process, you are making that your Docker should also run with C driver group at systemd. Alright, now after you install the Docker, you have to create a daemon JSON file, place this output in that file and restart the Docker. After that, you have to install your kubelet, otherwise it is not going to work properly. Okay, this is something coming with version 22 of Kubernetes. Alright, and the version 22 has been launched, I say 2 or 3 weeks back. Alright, so team, let me pause my screen again. I'm going to pause my screen again. Okay, I'm going to show you one more scenario. Okay. All right, just a minute. Okay, so team, my screen is visible to all of you now. All right, I have resumed the stream. Consider I did kubectl get pods, kubectl get nodes. So team, I'm not getting the output now. Sarat, I do have in the Git repository how to upgrade your cluster. All right, I already have that in my Git repository. You will see that somewhere. All right. Otherwise, I'll let you know by the end of the class. All right. Okay, Mosumi, you say that I checked the kubelet services. All right, but it doesn't have anything to do with kubelet. All right, your kubectl should be working. That is a client. But still, if you want, I can show you. So team, till now, whatever I have told you, any doubts in that? Gaurav, I'll tell you about Ingress and Ingress. Okay, I'll tell you about it. Can ALB in AWS can be used in place of Ingress controller for path-based routing? Joydeep, no, that you cannot do. Okay, ALBs are used to do the load balancing when you have your application on servers. Alright, here we are talking about Kubernetes. If you have your application deployed right away on the servers, on the EC2 instances on your AWS machines, then you can use ALB for path-based routing, but not here. Okay, so Gaurav, you were asking what is egress and what is ingress. Okay, so team, there are network policies as well. Okay, there are some network policies as well. What is the purpose? With network policies, you can limit the communication inside your cluster. Okay, with egress and ingress, it is a small topic, so I can touch base on this one. All right, so what happens? Consider you have an application deployment and you have a database deployment. You can have the communication between them with the help of cluster IP. We have already established that fact. But now consider you want to limit the communication between these two only. All right, you don't want your database. You have to give the specific pathing also. All right, consider, let me show you with a diagram. It will make you understand better. Okay. All right, so team, you can see that this is your application deployment and this is your database deployment. Application deployment, DB deployment. All right, so you want the communication to happen in this direction only. Okay, you want the communication to be happening in this direction only. All right, your app should be able to reach to DB. All right, and your app should only give the traffic to DB. Your app should not be able to give traffic to any other deployment. And about your database deployment, you want the traffic coming inside your database deployment. It should not send the traffic outside anywhere. It should not receive the traffic from any other deployment. It should receive the traffic only from app deployment. And app deployment should be sending outward traffic only to DB. Alright, these kind of rules you can set with egress policy. Alright, you can set it with your network policies. This one. Okay, let me show you some of the YAMLs so that you can understand. It is for allowing all egress and all ingress. It won't allow understand you. Egress net policy YAML. Okay, so team, this is the network policy. I am setting up the egress rule. Okay, what is the egress rule? Under specification, you can see I am defining for web application. Okay, web deployment. All the pods with labels app equals to web. Egress, alright, it means it should outsend the traffic. Egress is for outsending traffic, ingress for incoming traffic. Alright, egress is for outgoing traffic. I am defining a egress setup that web should only send the traffic to the pods where label is equals to app equals to DB. Okay, all the pods with app equals to web label should send the traffic only to app equals to DB pods. No other way. Alright, so this is about your egress. Okay, this is about your egress. Let's see what is ingress. Alright, here I am defining the opposite rule. All the pods with app equals to DB should have incoming traffic from the pods who has a label app equals to web. Alright, so team, this is about your egress and ingress rule. Egress defines how your traffic outgoes and ingress defines how your incoming traffic should be. Okay, that is all about it. Sarath, Gaurav, so this is about it. Yes, Joydeep, if you are using EKS, then you can use ALB. Alright, you saw that all the example I am showing you right now, we are everything doing on your manually created cluster. If you are using EKS on AWS, then you can use ALB. Then you can do, right? Alright, so team, with this I'm going to conclude the ingress topic as well. Okay, I'm going to conclude the ingress topic as well. Now I'm going to show you something on your what is remaining, Helm. Okay, HP is done, ingress is done. Now Helm. Okay, so what is a Helm? So team, another use case first. Alright, so team, how many of you have worked on Ansible? Okay, let me frame my question in a different way. How many of you don't know about Ansible? How many of you have not used Ansible? Okay, basic knowledge, not use Ansible. Alright. Okay, so I was about to give you an example on Ansible. Let me think of any other example. How to explain you about Helm. Alright, let me make you understand about this in this way. Alright, consider team that we have seen the installation of Kubernetes, right? We have seen the installation of Kubernetes. So with Kubernetes installation, I told you there are two ways. One is a hard way. Alright, one is a hard way. Second is the kubeadm way. Right? That is what we have seen. Now, if you understand that hard way was a actual hard way, you have to install all the components manually one by one. Alright, you have to create all the components one by one. But with kubeadm, what happened? With kubeadm, all the components were created automatically. All the certificates, all the deployments, all the pods, all the daemon set, all the components were created automatically. Okay. Similarly in Helm, similarly for Helm. Okay. What happens in Helm? Helm is a marketplace. Alright. Consider that on Kubernetes, I want to deploy an application.
Okay, and there is a general application. For example, if I want to have Jenkins, okay, Jenkins is a CI/CD tool. All right, I want to deploy the service of Jenkins on Helm. Okay, I can also deploy the application of WordPress. All right, so if you want to create a WordPress or if you want to create a Jenkins application on the Kubernetes on microservice architecture, so what you have to do, you have to create your namespaces. All right, you have to create your namespaces, you have to create your deployment, you have to create your role binding, you have to create your services. All right, all the objects you have to create manually. Okay, all the objects you have to create manually. But with Helm, it is called a marketplace. All right, you can simply have all the definition. All right, and you can create your service on a go. All right, so this is your official website from where you can see all the definitions. All right, this is the marketplace from where you can package. All right, artifact.hub, search your package whatever you want to. Okay, I want to have Jenkins. Okay, so there is a Jenkins. So team, you can correspond this to a Docker Hub as well. Okay, with a look and feel, I just understood about the another example. All right, consider that you want to have a Nginx pod, so you can use an Nginx image directly. Otherwise, if you go with the normal way, so you have to have a Nginx, CentOS container image or Ubuntu container image. You are going to download that container image. You are going to create your container. All right, once your container is created, you are going to install Nginx over there, and then you come out to the container, and then your container will be a Nginx container now. All right, so that is one way. But Docker Hub is a marketplace. There are already images that have Nginx installed in it. So why do I have to take that much pain? That first I create the image of Ubuntu, then I create the container, then I install the Nginx. I don't want to take that pain. There is a marketplace. I can have simply an Nginx container from there. All right, why take that much pain? Simply with all your application in Kubernetes, there are some general level application that can be used on a general level. So one of it is your Jenkins. All right, consider if I want to install Jenkins in Kubernetes cluster. First, you can see all the commands will execute from Helm. All right, so first you need to install Helm. All right, so this is the commands to install your Jenkins, but commands start with Helm. First, you need to install your Helm on your machine. So Helm is not a part of Kubernetes. All right, it is not officially from Kubernetes. You have to install another thing for your Helm. All right, good. There is a folder called Helm. All right, there are some details about your Helm, and this is for the installation. All right, I have to execute these commands to install your Helm. All right, and let me change the mode to 777. All right, let's give the complete permission to this file. Triple seven. Okay, now execute it. All right, so you can see that your Helm is installed. Okay, your Helm is installed. All right, so there are multiple operations with Helm as well. Okay, so team, Helm is also a big topic. I'm just giving you a basic idea. All right, so don't think that now you have become the expert of Helm. It is just giving you basic ideas. All right, Helm itself is a big tool. All right, you can have multiple commands like kubectl commands. You can have all the commands with Helm also. Helm history, Helm list. All right, Helm repo. All the things you can see with Helm. Okay, I'm just giving you a basic idea. And then you have Helm Jenkins. All right, so these are the commands that you need to execute. All right, for this purpose I asked you to have the CKA. Okay, I executed all the commands on my normal machine. Let me connect with my Kubernetes cluster. Manage one. Connect. I'll copy this one, run in Cloud Shell.
So team, why I'm using GKE? Because when you are using Helm, alright, many objects are getting created, alright, you have your PV, PVC, Cloudless, many objects are getting created, alright. So that is why I'm using this. I don't want to create all the objects manually. I want to get it created automatically. Authorize. Alright, it is done. kubectl get nodes. Alright, you have 2 node cluster. Now let me install Helm here as well. I need to install Helm. Okay, Helm is already installed in this one. Okay, my bad again team. I had to execute it here. chmod 777 get Helm. If it doesn't give you the permission, try to do sh. Okay, so with this you can see your Helm is installed. Alright, now I'm going to have your chart ready. Okay, in Helm it is called Helm charts. For Jenkins, first I need to get the repo from the Helm hub. Alright, I'm just adding the repo. Then I'll install the repo. Then you can do Helm list. Alright, so team, you can see that your Jenkins is dashboard is created. Alright, the username is going to be user and a password has been created as a secret. Alright, so if you want to get the output of this password, you can do this. It gives you command as well to find out the password. Alright, so let me have this password with me on the notepad. Alright, so let's see if all the things are created or not. kubectl get all -- all. Okay team, I'm really sorry, I'm doing the same mistake again and again. I have to execute all the commands on your Cloud Shell. Extremely sorry. The thing is, I'm very much used to do the Alt tab. Install Jenkins. You can see the Helm list. One release is already there. I'm going to echo the password from the Cloud Shell this time. No mistakes. Echo $this. Alright, so this is going to be a password. Let me have it here. Notepad. kubectl get all -- all. Okay, these are your replica sets, services, daemon sets. Alright. So team, here is your services. Alright.
A load balancer service is created. I want to modify it. I don't want to have a load balancer service. I want to have a node port service. Alright, so let me modify this one. kubectl, edit, svc and svc name. Alright, I want to change the type of the service. Here it is. Load balancer, I am changing it to node port. Node port. Okay, Jenkins job is edited. kubectl, get svc and this one. Okay, so team, now you do have a node port. Okay, this is your port number. Let me have the IP of the machine. Alright, you have to go to the VM instances. Take any of your worker node IP, copy it, paste it in the browser, colon, and then your port number. Team, you are getting the Jenkins dashboard. User. Alright, and this is your password. As simple as that. So you saw that we just dealt with the Helm. Alright. Alright, you understand that whenever you create some microservice or your application, you create a lot of components. You create deployment, replica sets, bots, services, ConfigMap, secrets. A lot of things are created. Alright, you have to take care of all of them. But some of the applications are general purpose, so you can use the Helm chart and have it on your Kubernetes cluster. Alright, so team, this is how you use your Helm. Alright, whatever application you want to do, you can use. Alright, you can search it on the marketplace. Alright, I have some example on the Git repo as well if you want to practice. Alright, there is AWS Helm also, Ghost Image, WordPress. Alright, so many examples are here. So you can practice at your own. Alright, so team, now if you have any question with Helm or any other question, you can ask. No Anil, license is not required for Jenkins, alright, because everything is already in the Helm. Okay, license is already there. Secrets are also already there. Okay, everything is managed by it. Rahul, in Helm I am stuck how to create a template with multiple deployments is to be created. Can you be able to give idea on this? I have pod 1 and pod 2 using two different images, and how can I use template and charts? Alright, so Rahul, if you want to have the idea on chart, there is a folder called charts. Alright, and you can have the complete chart of Grafana, Prometheus, and from here you can take the example. Okay, from the Helm marketplace you can simply download it, but if you want to create a chart manually, so Rahul, this is an example. Prometheus, you can see the template. This is how you're going to create your chart file. Okay, in Helm, most important part that you create a chart.yaml and values.yaml. Under that you have the templates. Alright, so you can see that, for example, if I open a service, okay, server service. So team, can you see how the YAML is written? Okay, you have the APS version, you have the kind, but under metadata you have given condition very differently. Okay, your values are getting picked from the values file. Alright, annotation, labels also you can see that app from where the value is getting picked, Prometheus.name. Okay, it is coming from the charts. Okay, some values comes from the chart.yaml, some values come from the values.yaml. Okay, otherwise you can see the structure is same, API version, kind, metadata, labels, alright, specification, cluster IP, alright, all the things are same, but the way of passing them is different. Under templates you place all the YAMLs. Alright, in chart.ms you define the values. Alright, what is the API version? App version is this. What is the version? What will be the name of the chart? Prometheus. Alright, so this is how you can create the chart. So Rahul, if you want to have an idea, you can go through these charts. It will give you the complete picture.
Yes, Himanshu, definitely you can. Prempal, what is intermediate container? I don't understand exactly what kind of container you're talking about. Yes, Rahul, in this example, only one pod is getting created. Alright, you can have multiple pod definition under templates. You can have a deployment file. Alright, let me see if a deployment file is there or not. It has to be there. Alright, this is a deployment file. Okay, here if you want to give multiple replicas, you can give the multiple replicas. Alright, and this is one definition of your deployment. Have multiple definition. Once your definition ends here, put 3 hyphens and give a different deployment definition. Arjun, you're asking installing using Kubernetes for exam. Do we have to install Docker? No, Arjun. Docker is by default installed in the examination machine. All right. So in exam, you don't have to install Docker. Docker is always going to be there. Okay, team, just a minute, please. Okay, Prempal, intermediate containers, if you're asking in the Docker context, okay, so it is about the Docker files. All right, you have a Docker file. It is a config as code, you can say, or infrastructure as a code, you can say. All right, you write the Docker file. In Docker file, you give the definition that what image you are going to use, what operations you are going to perform in this container. All right, you add multiple layers on your containers. All right, so if you understand about Docker file, you are asking a question from Docker, so that is why I am asking, giving the answer in a Docker context. So consider that you are creating a Docker file. In Docker file, you have mentioned multiple steps. First, that download a CentOS container, all right. Then create a container. Then install Nginx in that container. Then you have to install a new index.html file, all right. So you have mentioned 4 to 5 steps in a Docker file. All right, so in a Docker file you have given multiple files. Now you are going to create a Docker image from that Docker file. You are creating a Docker image from that Docker file. So you have given 5 steps. So all the 5 steps will be created on intermediate containers. All right, like you first say that from image CentOS. So CentOS image will be downloaded and a container will be created. All right, then you wanted to install Nginx. So that you are going to install Nginx on that container. All right, you are going to install that Nginx on that container, and then our image will be formed and that container will be deleted. All right, then if you have given next step, that create a new index.html file, then new container will be created with the latest image and index.html file will be updated. Again, that container will be terminated and image will be created from that. All right, so for all the steps, intermediate containers are created. All right, all the containers which are getting created and deleted to give you a end image, those are called intermediate containers. So Prempal, I hope that answers your question. Rahul, you are asking how to pass on different values for different deployment. Okay, there is you having problem. So Rahul, do you have the complete understanding about the chart? That is the first question. All right. So if you want to provide different values, you can see that if else condition can be worked here. All right. I think that is mentioned in charts or values.yaml. Somewhere I know it is here. Just a minute. I guess it is in templates. See, Rahul, now this is your answer. Alright. See under specification. Alright. Here you can give if else condition. Alright. You give the replica value. Alright. Pick this number of replicas if value of server strategy is this. Okay. Depending on the strategy you have defined, you are defining the number of replicas. Alright. So based on your application name, you can choose different image. Alright. Give two definition of deployment exactly in the same manner. Alright. And then you can give the if condition. If you have given the string like this image will be picked and this deployment will be created for application 1. And if you have given the naming convention differently, alright, pick the different name. If the name is different, then choose different number, different type of image and create a different deployment. Alright. So Rahul, this is how it is going to be. Otherwise, if you want to have a very specific answer, alright, I cannot give you that specific answer on the fly. Alright, you have created a charts, you have good understanding about this. That is really good, but until unless I take a look on those charts myself, I cannot give you the specific answer. Eka, you're asking, can we still have access to the current Git repo? Yes, Eka, this repository is always going to be there. Alright, you don't have to worry about it. This repo will remain always. 1 year, 2 year, lifetime, this repo is always there. Yes, Arjun, steps are given there. Alright, I'll give you some idea on the steps as well. Not steps, but about your exam. That is what we have given. Okay, great, Rahul. Good to see that. Okay, so team, today don't leave the webinar until unless I asked you to. Alright, today is the last class. Alright, I'm going to give you some important tips as well. Alright, so do not leave the webinar until I asked you. I'll just take few minutes more. Alright, hardly 2 to 5 minutes. Alright, so team, all the topics that we have covered so far. Helm is also completed. Now let's talk about your exam. Alright, let's have some discussion on your exam. Alright, so team, first thing first, your exam is going to be proctored. Alright, the most important point, your exam is going to be proctored. Whenever you register for your exam and you start giving your exam, there is going to be a person on the other side. Alright, he will ask you to keep your webcam on. Alright, and you have to sit in a empty room. Okay, there should not be interference during your examination. Earlier the examination was of 3 hours. Now your examination is of 2 hours. Alright, number of questions has also reduced. Alright, but the exam is proctored. You have to have your room clean. You have to sit in an empty room for 2 hours. There should not be interference at all. Alright, you can have your water bottle or basic things without any labels or sticker over it. Alright, and your proctor may ask you to show the complete room. Alright, with the webcam, your examiner, your proctor could ask you to show the room overall. Alright, in the beginning of the class as well and during the end of your class, or also in the middle of the class. The proctor can ask you anytime to show you the room. Alright, so you have to make sure that your room is clean and empty. Alright, you should not have any gadgets around you. Alright, another laptop, if it is there, another desktop is there, so it should be powered off. Alright, you should not have your mobile phones allowed. You can have your water bottle with you, so basic things. Alright, during the exam you can go for a washroom break or loo break. Alright, that is allowed. During the exam you can go, but the timer will not stop. Alright, so if you're away from the screen, if you're not in the room for some time, that is all okay. You can leave the room, you can go to the washroom, but the timer will continue to go. Alright, that thing. In exam, you cannot open the normal notepad. Okay, if you want to write something, if you want to write some YAMLs or copy paste something, you are not allowed to use any notepad of your own. Okay, during exam, they provide you their own notepad. You have to copy paste anything if you want there only. Do not use your own notepad. Also, no other application should be open on your laptop during the exam. Okay, they will ask you to close all the application, all the tools and anything. All the things will be closed during your exam. In the exam, you will have a window where you will be performing your exam, you will have a cluster from where you're going to connect. And very important point in the examination, always use the context, all right? Because you get a jump server. They don't give you the complete access on the master node, all right? You are getting the access on the jump server. So they can ask you different question from different clusters, all right? So based on your output, they will judge that you have used the context or not, all right? And don't worry about the context format. They will always give you the complete command. Use this context and do this, all right? They always do that. So complete command will be there. So you have to make sure that you are choosing the right context. Otherwise, you will get the different output and your answer will be false, all right? Make sure you use context thoroughly. And as I told you in the beginning as well, you are not allowed to open any extra tab, all right? You cannot open Google, you cannot open anything. It is really important that you have your bookmarks ready with you, all right? So that with opening an extra tab, only one extra tab is allowed to you, all right? From there, you can choose the page where you want to go for your exam, all right? There's a cheat sheet also I have placed in the YAML. Your bookmarks, all right? So there are so many commands that can help you for your examination as well, all right? So many commands are there which way you can use in exam. So only one extra tab can be allowed, and only official Kubernetes website you can open there, all right? And about your exam, I have already shared with you that CNCF is the one who is conducting the examination now, all right? This is your examination page, certification, CKA, all right? Here you can register for your exam, all right? You can have some training also for exam. You have the cost of $375, all right? And you get 2 attempts in this, all right? So maybe because of XYZ reason, if you didn't make through in the first attempt, you can attempt again, all right? And validity for this course is 1 year. After you have paid this price, you can have 2 attempts within a year, not after the year, all right? And all the details about your examination is given, all right? Cluster architecture installation weights 25%, all right? Workload scheduling takes 15%, service networking takes 20%, storage 10%, troubleshooting is now 30% with the maximum weightage, all right? So it is important that you give your focus on troubleshooting thoroughly, all right? And for your examination preparation as well, I have a lot of content in the Git repository, all right? For example, you have examples, all right? In examples, it is for your application. You can deploy a complete application. Consider that you want to have Spring Boot Mongo app, all right? All the components are here. You can create persistent volume, then persistent volume claim, all right? All the objects that can create it to have your Spring Boot application is here. So this is for your practice. Again, for exam preparation, okay, I have multiple use cases in these 5 CKA file, all right? For example, if you'll see any, what kind of question comes in the examination, all right? You have some tips and tricks also. How to take your etcd backup, I have already discussed about this, all right? No need to memorize the command. How you can deal with it, I have told you that also, all right? So this is for your tips and tricks. These 5 documentation are for that. You can go through them, all right? Pod scenarios, how many pods issues can be there and how you're going to resolve it. Okay, there is a text file. So these are the use cases. What problems can happen with pods? Problem with pod YAML. Okay, find out what is wrong with this definition. All right. So team, these are all for your own practice. Okay. For troubleshooting, also there is a folder. All right. Node issues, network issues. I have already shown you this one. Okay. And somebody asked me how to update the cluster. All right. So team, I don't remember who asked me how to update the cluster. There's a folder called update cluster. All right. Here you can see how you are going to update your cluster, update.txt. All the steps are mentioned here to update your cluster. All right. All the steps are here. Nothing new. Everything is known to you. How to use your kubectl version, how to take the backup of etcd. All right. How to take the backup of all this. Everything is here. Follow these steps thoroughly and you can update your cluster as well. Arjun, yes, you can use your Chrome, you can use your Opera, that is okay. Okay, choose your browser at your own, but there should not any other browser open. All right, there should not be any other tab open. Only one tab is allowed for official Kubernetes website. Can we use additional monitoring during exam? Ika, what kind of additional monitoring you want? Metric server is going to be there. Okay, metric server will already be installed. Okay, so in examination you will get the monitoring question related to top commands only. All right, that give the top commands for these pods. Find out which pod is consuming maximum RAM. Okay, find out which pod is consuming maximum CPU. These type of questions you get, and you can find it out with the top command easily. Anil, suppose we have gone through all the exam for your repo, and what is the percentage cover? Anil, if you have covered this complete Git repo, you can clear your exam in the first attempt very easily. Okay, honestly speaking, if you have gone through all the examples in this Git repo, you are well prepared for exam. Can we take a notebook in our K8s notes next to your laptop during exam? No, Kushagar, you are not allowed to have a notebook with yourself. All right, only official Kubernetes website and a blank notepad that they are going to provide you. In a browser tab, they are going to provide you a notepad for copy pasting, but no notebook and everything you can continue have with you. Arjun, I'll honestly say that this Git repo is enough for your examination preparation, alright? But still, I cannot give you any other idea right now. Alright, if any website lets you practice, you can simply Google it, how to practice for your CKA exam. Alright, there will be multiple links, but I haven't used any of them anytime. Gaurav, you're asking how many questions are there. I guess now they have reduced the number of questions, and it is from 20 to 24 questions now they give, as per my understanding right now. Okay, I must have seen that somewhere. Exam prepare. Okay, number of questions were earlier 20 to 24 questions. Now they have 18 to 19 questions. All right, 2 hour duration is this, and now you get 18 to 20 questions. Passing percentage is also reduced. Earlier it was 74%. Now it is 66%. All right, and the results are out in almost around 36 hours. All right, they need at least 36 hours to evaluate your answers, and they then they publish your results. Anil, total how many questions will be there, multi answers or single answer based lab? Anil, as I told you, it is not a MCQ type of question. Okay, you don't have to take something, you have to practice it. Okay, they are going to give you a scenario and you have to perform some operation. They are going to ask you to save the output in some files. All right, so after that they are going to evaluate what you have saved in the files. So it is not a step marking or something. Either your answer is correct or it isn't. Ika, as I told you, on the machine where you are giving the exam, you are not allowed to have any other laptop or desktop powered on. Okay, so even if you have a laptop or desktop in your room, it has to be in powered off state. Gaurav, as I said, I don't have any mock tests available with me because as I told you, it has a subjective exam. All right, you have the use cases, you have the scenarios that you have to create a pod, you have to name a pod, you have to rename. All right, you have to get the output of top command. So these are commands that you have to execute, and the same use cases I have already provided you in my Git repo. All right, so the way questions are framed, they are there. How to answer those questions you already know now. You have understand everything about the Kubernetes. So I don't have any mock tests available with me, but all the preparation content is already here. Eka, I will recommend you to have only one monitor. Okay, keep the other one in the powered off state during the exam. There is no need to have two monitors, and it is also not recommended. For examination point of view, you just have one. Arjun, the Kubernetes exam is CKA exam is being taken care by CNCF only. Eka, how do we measure how we are ready for the exam? Eka, I have given the use cases. I am repeating multiple time. Alright, I am repeating multiple time. In the exam preparation, you have multiple files here. They have all the questions. So consider if you are capable enough to answer all the questions, you can consider you are well prepared. No, Gaurav, during the 2 hours of exam, you are not allowed to have your mobile as well. Okay, keep your mobile powered off state or keep it in another room. Okay, nobody should enter in your room also during the examination. Okay, so team, during exam also you can skip a question for some time and you can come back to the question later on. Okay, so don't get stuck on a single question if you're struggling with it. Alright, skip that question for that duration, move to the next question. Alright, so there may be chances that the later questions carry more weightage and you are more confident with that. So you can skip the question for the particular duration, and after that, once you are done with all the questions, you can come back to the questions where you have the issues. No, sort of no negative marking.